Are you ready to elevate your coding skills to enable you to develop fully functional web applications and websites? Welcome to Full Stack Web Development, your gateway to building dynamic and interactive websites from start to finish. Think of the websites you use daily: browsing an online store, checking social media, or booking a trip. All of those websites were built by developers who understand how to structure information and design interactive features. In this course, you'll use the same tools as those developers, including HTML, CSS, JavaScript, and more. Your journey begins with an introduction to HTML, or hypertext markup language. HTML forms the backbone of every website, defining its structure and content. From simple text to complex layouts, HTML is where it all starts. In this course, you'll learn how to create well-structured HTML documents, ensuring that your web pages are not only presented in an organized and accessible manner to users, but also understandable to search engines like Google, Yahoo, DuckDuckGo, and others. Every HTML document follows a specific structure. It starts with the doctype declaration, which ensures that browsers interpret your code using the correct version of HTML. The HTML tag wraps all the content. The head section holds crucial information like meta tags and links to style sheets, and the body section contains the page's visible content. Understanding these elements is the first step toward building effective and well-structured websites. While HTML is essential for building a web page's structure, it's CSS or cascading style sheets that makes it visually appealing. As per the W3C Consortium, the group that controls web standards, CSS should be responsible for every visually appealing element, from colors, fonts, and layouts to responsiveness. This ensures that your website automatically adjusts its styles to be visually appealing on devices of different sizes, such as phones, tablets, and desktops. In today's world, where mobile usage is rapidly growing, understanding how to create responsive designs with CSS is more important than ever. You'll learn 3 main ways to apply CSS to your HTML code. Inline styles make quick and specific changes directly within your HTML elements. Internal style sheets apply styles to a single page from within the head section. Finally, external style sheets enable you to link one CSS file across multiple pages, providing consistency across your entire website. After learning how to structure and style your website, the next step is adding interactivity. JavaScript is a scripting language that enables websites to respond to user actions, validate forms, create dynamic content, and more. By mastering JavaScript, you'll be able to build interactive and engaging websites that keep users connected and involved with your content. All the code you have learned, like HTML, CSS, and JavaScript, runs on the browser, also known as the front end or the presentation layer. Web development doesn't stop at creating front-end interfaces, though. To be a full-stack developer, you must also understand how to write code that is not visible to the user on the browser, but runs on the server. This is known as back-end code. In this course, you'll explore a Model View Controller or MVC architecture, a robust design pattern that separates your application's presentation, logic, and data layers. On the back end, you'll work with tools like Spring and Spring Boot to build and manage scalable, secure web applications. These frameworks are widely used in the industry for their reliability and ease of use, making them an essential skill for any web developer. You'll also explore security features, such as user authentication and role-based access control, ensuring your applications are safe and secure in today's complex digital environment. Modern web applications rely on leveraging web APIs to communicate between the client and the server using something called Restful API. This course explores the creation of RESTful services, an essential technology for building scalable, maintainable applications. You'll learn how to design APIs that allow applications to interact seamlessly, whether retrieving data, submitting forms, or processing transactions. Plus, you'll gain understanding of advanced concepts like Hateoas, or Hypermedia as the engine of application state, helping you design more intelligent and flexible APIs. You'll also examine Amazon's cloud offerings, including how to use services like Amazon Web Services or AWS to host and manage your applications, create Lambda functions, and use databases on AWS. AWS provides industry-leading cloud computing platforms, and skills in cloud deployment are highly sought after in today's job market. From virtual servers known as EC2 to scalable storage known as S3 to RDBMS servers known as RDS, you'll gain hands-on experience with the tools that power some of the world's biggest websites. To put everything you've learned into practice, the course culminates in a final project where you'll build a fully functional dynamic web application. This will showcase all your skills, from HTML and CSS to JavaScript, API development, and security. The final project will be an invaluable addition to your portfolio, demonstrating your ability to create a scalable, user-friendly web application from start to finish. Full-stack development isn't just a skill. It's a pathway to creativity, problem-solving, and innovation in today's digital world. It enables you to share your ideas and applications with a global audience over the World Wide Web. Let's get started. In this project, you'll combine all the skills you have learned so far, along with the new skills in Course 5, in order to create a working, full-stack application that enables any user of the web application to manage their pending tasks, which is often referred to as a to-do task. This web application will enable the creation of to-do tasks with a due date, as well as tracking and marking them as done when the tasks are completed. Since the web application will be personalized, meaning that every user can view and manage only his or her tasks, a secure system is envisioned. You will be using Spring Boot security to provide access to a person's own to-do tasks, only after a username and password combination is used to log into the web application. In short, you will integrate front-end and back-end development skills with security features to showcase your ability to build real-world solutions. Let's walk through the key highlights of your web application. First, users will start on the homepage. From there, they can either log in if they have an account or register for an account. If users don't have an account, they are prompted to register by providing their details and creating a password. Once registration is successful, users are redirected to a login page with feedback that registration is successful. If not successful, they are redirected to the registration page with appropriate feedback. If the user is redirected back to the registration page, the feedback might represent an error when registering, like an attempt to use an already existing username. The login page will allow users to enter their credentials, such as their email or passwords, in order to use the features of the web application. Upon successful login, the user is redirected to a personalized dashboard. If the login fails, an error message is displayed. Once logged in, users land on the dashboard. Here, they can view their tasks, organized into pending and completed categories. The tasks that are due on the current date are highlighted on the top of the dashboard and are color-coded based on priority. Red for high, yellow for medium, and green for low for greater visibility and focus by the user. Let's explore the functionality of the items your dashboard will contain. Users can click on the Add Task button, which brings them to a form where they can enter the task's title, description, due date, and priority. After submitting, the task is saved and displayed on their dashboard for the user to view. Users can also edit their existing tasks if they are not marked complete. When editing a task, the task editing form is pre-filled with the task's current details, allowing users to make quick changes. Users can also delete tasks that are no longer required, ensuring their to-do list stays up to date, or mark each task as completed. Finally, each user's data and task is securely managed using Spring Boot security. This ensures that only logged-in users can access their tasks and data. Users can also change their passwords so that they do not get stuck on the same password, which is deemed to be a safe practice. However, to change their password, they must be logged in and they must provide their existing password. The entire web application will be made visually appealing using CSS. You'll work with primary, secondary, and tertiary color schemes to implement in a variety of ways, which is a way of presenting pleasing colors to the user, which you will learn more about in Course 7. For example, you'll use the primary color for prominent sections like the to-do list, title, and logo, buttons such as Create Task, and links such as hover states for interactive links. You can use accent colors for features like error messages and delete buttons. The project will use Maven as its build tool, which will enable you to leverage the Maven-based structure for the Spring Boot project with Timeleaf as the template engine for rendering dynamic HTML views. Using Maven will also allow you to pull in dependencies and libraries using a file known as pom.xml with fewer manual configuring dependencies. Together, HTML, CSS, JavaScript, and Timeleaf will enable you to build a web application where you can dynamically generate and manage the content shown on the web application for managing the tasks. By the end of this project, you'll have built a complete to-do list web application, combining all the skills you've learned from front-end design to back-end logic. Are you ready to begin learning and putting your skills into practice? Let's get started. You're planning to build a new house and your mind is full of exciting ideas. You're thinking about the interior. How many rooms will you have and their uses? How will you decorate them? And what are the furniture choices? Of course, the house needs to be built before any of these ideas can become a reality. It will need to have a solid structure, including foundations, walls, and a roof. In the same way, when designing a web page, you envision its look and purpose. But before you can make these ideas a reality, the web page needs a solid foundation and framework. Hypertext Markup Language, known as HTML, provides this. HTML structures every web page, guiding the browser to organize and display content. Whether you're adding text, images, or links, HTML is the blueprint that makes it possible. In this video, you'll learn the purpose of HTML, the structure of HTML documents, incorporating tags, and interpretation by browser. Let's get started. Hypertext Markup Language allows users to navigate between web pages easily through links, shaping the foundation of the web. HTML uses tags to instruct browsers how to display content. Over time, HTML has evolved. The latest version, HTML5, introduces new features like audio, video, and enhanced mobile support. These updates make building interactive, dynamic web pages easier for everyone. HTML isn't a programming language like Java, C++, or Python. It's a markup language. HTML tags mark page elements arranged hierarchically. Like keywords in programming languages, HTML tags define the structure of your content. So, since tags are important, how would you recognize them? Tags are written within angle brackets, like the HTML tag. Most tags have a corresponding close tag with a / prefix to the name, such as /HTML. Every HTML document follows a clear hierarchy that helps browsers display content correctly. Some tags have opening and closing pairs, while others, called empty tags, have only one tag with a /, like BR/, indicating no closing tag. As you can imagine, it is important that your page is properly displayed. Adding the !doc_type HTML tag to your HTML document tells the browser it is a HTML5 page. Let's explore how you can do this. First up is the doctype declaration. The doctype declaration is placed at the beginning of a HTML document to inform the browser that it should interpret the page as HTML5. This ensures consistent rendering across different web browsers. In VS Code, create a new file and name it index.html. Place this !doctype HTML declaration at the top of every HTML page. It is not a HTML tag, but an instruction to the web browser about the version of HTML the page is written in. It tells the browser this is a HTML document. This ensures that the browser interprets and displays it correctly. Without it, older browsers might default to outdated HTML standards. Next is the HTML tag. Think of this as the container for everything on your webpage. It wraps around all your content, indicating that everything inside is HTML code. Notice an opening HTML tag at the start and a closing /HTML tag at the end. Every HTML document consists of two sections, head section and body section. Let's explore each section starting with the head section. Inside the HTML tag, enter head tag to insert head section. This part of the document contains all the behind-the-scenes information about your web page, like the page, title, meta information, and links to style sheets or scripts. Note that the closing head tag is automatically inserted. In the head section, enter the title tag to define what will appear in the browser tab when someone visits your page. Type in "My First Web Page" as the page title. It doesn't appear on the page, but is important in user experience and search engine optimization. Next up is the body section. The body section is where your web page's visible content lives. Everything you want your users to view will go here: text, images, buttons, or videos. Below the /head tag, enter the body tag, and notice the /body tag is automatically inserted. For instance, here the h1 tag displays "Hello World" as a text with certain pre-formatted attributes such as font size. In the Explorer view of VS Code, right-click on the index.html file and then select Show Preview option. Ensure the live preview extension of VS Code is already enabled. A preview pane opens on the right side of the VS Code editor. It shows the preview of how your HTML will appear in a browser. Double-click on index.html in its folder to open it in your computer's default browser, such as Chrome or Edge. Now that you've observed the effect of using HTML tags, keep in mind that there are many more to explore. You'll learn more in the upcoming videos and readings. How are HTML tags interpreted by a browser? When you're adding HTML tags to your document, you should consider how they are processed and interpreted by the browser. The browser acts as a translator and recognizes tags like h1, p, and img after transforming your code into a styled and interactive web page. And there you have it. In this video, you uncovered the purpose of HTML, structure of HTML document, incorporating tags, and interpretation by browser. Understanding HTML will help you turn your ideas and insights about your website into dynamic, impactful content. Whether you're building a simple web page or developing a complex web application, HTML provides the essential structure to bring your vision to life. Lists have played an essential role in human culture, from ancient inventories carved into stone to the task lists managed on phones today. These unsung heroes help us organize information, prioritize tasks, and present details clearly. In the digital world, HTML lists serve the same purpose, allowing us to structure and display content effectively. In this video, you'll be introduced to the two main types of HTML lists, unordered and ordered. You'll learn how each one works, when to use them, and how to create them. Let's start with unordered lists, which are used when the order of items doesn't matter. For example, in a grocery list with vegetables, fruit, dairy, and beverages, the order isn't important. You might organize the list by store layout, but the sequence still wouldn't be crucial. In HTML, unordered lists are created using the UL tag, which starts the list, and then \UL to close it. And each list item is wrapped in li tags. Now let's walk through how to create this list in VS Code. First, create a new file and name it index.html. In the head section, give it a title like My Shopping List. Next, in the body, add a heading using the h2 tag to label the list. For example, unordered list. Start and close the unordered list with the appropriate UL tag, and you'll notice VS Code suggests the closing tag automatically. So that's convenient. To list the items you need to buy, wrap each one, vegetables, fruits, dairy, and beverages, in li tags. Once you've added everything, save the file or risk forgetting what you need to buy. To display the final list, right-click on the file name in the Explorer and choose Show Preview. which then reveals the full list of items in your browser. Notice that because the order doesn't matter, HTML automatically adds bullet points to each item. Neat. But what if the sequence of items in a list is important, like the steps for keeping the pantry stocked? This is where ordered lists step in and provide more structure. If you want to show the actual steps for preparing to go grocery shopping, like first checking the pantry, then making a list, visiting the store, and finally unpacking groceries, you need the items in a specific order. In HTML, it's UL tags for unordered lists and OL for ordered, and both use LI for individual items. The VS Code is also similar. If it isn't already, open index.html and add an H2 tag in the body section to give your list a heading. This time you'll go with ordered list. Start the ordered list section with the OL tag, and the closing one will be auto-suggested. Next, wrap each item in LI tags in order from top to bottom. You'll keep it simple with check the pantry, make a list, visit the store, and unpack the groceries. Save the index.html file and open it using the browser preview. The list displays with numbers, not bullets, in increasing order, prefixed to each item. This format is ideal for instructions, steps in a process, or tasks that need to follow a specific sequence. What if you want to break down each item in the list further? This is where nested lists come in handy. To nest a list inside an existing one, simply place another set of UL or OL tags inside a list item. To do this on the groceries list, you can expand it to include subcategories with more details. In this example, use nested list as the heading so it's clear. Under vegetables, wrap carrots, spinach, and potatoes in the UL tags. You're using UL because the order of the items doesn't matter. Similarly, under fruits, you'll add apples and bananas. Once you're done adding what you need, save the index.html file and open it with browser preview. This will render your new nested list in the browser on the sidebar. By default, unordered lists use bullet points, but with a bit of CSS, you can customize them to any symbol you like. Lists are vital tools in web development that make it easy to organize content logically. To recap, use unordered lists when the order of items doesn't matter, like grouping related items or categories. Use ordered lists when you need to show a sequence such as steps in a process. And don't forget you can nest lists to create a clear hierarchy and add more detail when needed. Mastering these list types enables you to create clear, well-organized web pages that enhance both usability and navigation for your users. You already know that each web page has its own address or URL. This is the long string of characters that appears in the address bar at the top of the browser window. Imagine if you had to type that in every time you wanted to go to a new page on a website. It wouldn't be an enjoyable or speedy experience. And what if you made a mistake and had to start all over again? Luckily, you don't have to do this because you can browse pages easily by just clicking on hyperlinks. Whether you're building a recipe page, a shopping site, or even a blog, understanding how to create hyperlinks to let the user navigate is essential. This video explores hyperlinks, which are a fundamental HTML concept. You will learn how to create a hyperlink that would take a user to a different section on the same page, another page on the same website, or to any external website. Hyperlinks are essential for effective web navigation. They enable users to seamlessly move between pages, access additional resources, and explore interconnected information. As a developer, adding effective hyperlinks to your web pages contributes to a positive user experience. They can also promote content accessibility. Hyperlinks are also crucial for search engine optimization, known as SEO. A search engine examines a website's link structure to establish its relevance and authority. Well-implemented hyperlinks help to improve a website's visibility and search engine rankings. So how do you create a hyperlink? You can use a HTML tag called an anchor tag to create a hyperlink. An opening tag, left angle A, right angle, is placed at the beginning of a piece of text. A closing tag, left angle / A, right angle, is placed at the end of a text. The text or content placed between the two anchor tags becomes clickable. By clicking on it, the user can navigate to another location or web page. The browser is redirected to the URL assigned to the href attribute of the anchor tag. The href attribute in a link or anchor tag tells the browser where to go when you click the link. It's like the address that the link points to on the web. This attribute is the most commonly used attribute of the opening A tag inside the angle brackets. It specifies the destination where the link will navigate. The href attribute value can be an absolute URL such as http://example.com. Alternatively, it could be a relative URL such as about.html that points to a specific file or page within the same website. Let's put this into practice in the shopping list website that you've been working on. It consists of a home page, a registration form, a login page, and a page that presents a list of available items. The website has files called index.html, registration.html, login.html, and shoppinglist.html. Let's begin by opening the shoppinglist.html in the VS Code editor. It contains the list of items available for the user to buy. You would like to provide links for the user to go to the other pages. Place the cursor just above the page heading, add a left angle A, right angle tag to create a hyperlink for the home page. Set index.html as the value of the href attribute by typing a href equals quote, index.html, quote, inside angle brackets, home, closing A tag. The browse view of the shopping list shows a link to the home page. Note that the home word is underlined in blue. Place the mouse cursor over home. The status bar at the bottom shows the URL of the index.html. Clicking on the link displays the home page in the browser. You would also like to have a hyperlink on the home page to go back to the shopping list. Towards the top of the home page, insert a hyperlink to the shoppinglist.html. To do so, in the document called index.html, use VS Code to type a href equals quote, shoppinglist.html inside angle brackets, shoppinglist closing A tag. You will often need to create internal links within a web page so that users can navigate directly to specific sections or elements of the page. The ID attribute of the anchor tag provides a way to link specific sections within a web page. First, you need to create a section within your web page that you want to be linked to. Then you assign a unique ID attribute to the section. Once this has been done, you can create a hyperlink at any other location within the same page that points to this section. To do this, set the href attribute of the anchor tag to the ID attribute of the target section, prefixed by the hashtag symbol, which is used for anchor IDs, followed by the value of the ID. When the anchor link is clicked, the browser navigates to the corresponding section within the web page. Now let's explore adding these types of links to the shopping list website. You already have the list of items available in the shoppinglist.html. Now let's add a paragraph as a description of the apples item. Inside the p tag, assign apples as the ID attribute. This paragraph can now be linked to the li in angle brackets item, apples in the list of fruits. To create a hyperlink around the word apples, use the anchor tag with its href attribute set to #apples, the ID of the paragraph below. Type inside angle brackets lia href equals #apples. Apples closing A tag, closing li tag. When opening the page, shoppinglist.html is opened in the browser. You will see a hyperlink around the word apples, pointing to the internal hyperlink. Click on the link. The browser scrolls down to the paragraph describing the item apples in the shopping list. You can also use #top to create a hyperlink to take the browser to the top of the page by typing inside angle bracket h2, a href #top, back to the top of page, closing A tag, closing h2 tag. You can assign the URL of any external website to the href attribute of the anchor tag. The link takes the browser to the specified external URL. You may want the external website to open in another tab of the browser instead of the current tab. For this purpose, set the target attribute to quote_blank quote. This statement creates a hyperlink to Amazon's homepage. Inside angle bracket A, href equals https://www.amazon.com/target equals _ blank closing Amazon closing A tag. Ensure that the live server extension is installed in VS Code. Right-click on the shoppinglist.html file in the Explorer view and select Open with Live Server from the menu. The page should open in the default browser. Hover the mouse over Amazon, which displays a link to Amazon's homepage. When you click it, it will open in a new tab. In this video, you've learned a great deal of useful information about hyperlinks. You've learned how to create external links to other websites, internal links within the same page, and even how to open links in a new tab. The knowledge you've gained here will be useful to you in the future when you develop websites. By bringing the key skills covered here into play, you will be able to design and build dynamic, interactive, and user-friendly web pages. You're on a coffee break at work and taking the opportunity to do some quick online research. Your car insurance is close to its renewal date and you're searching for a better deal. And if that great deal is out there, you need to find it quickly because you have to be back at your desk in 10 minutes. The first company website you open contains only blocks of detailed text. The information you need is buried in paragraphs of information and lists of different car makes and engine sizes. Don't have enough time to go through all of that, you mutter, as you hit exit. The next company website you open has a home page that doesn't have a lot of text. What it does have is a picture of a smiling driver in a car that looks just like yours. The words "quick quote" are printed underneath. You click on it straight away. But why is an image more effective than text? First, it presented the key message, getting a quotation, in an easy-to-find format. The combination of the picture and the two words meant you could make a quick connection and get to where you wanted to be in a short space of time. And the appearance of the car and the smiling driver created an important emotional connection. Because images enhance a user's experience, it is essential to understand how to insert an image into a web page. In this video, you'll learn how to add images to web pages using HTML. You will also discover how to set their dimensions, how to provide alternate text for accessibility, and how to add titles to offer extra context. Once you have identified an image that you want to incorporate into your web page, you need to embed it in the HTML document. You use the img tag element to do this. The img tag HTML element embeds an image into the document. This tag actually creates a holding space for the image linked to the page. This is the basic syntax for the img tag. Here, src is the mandatory attribute, specifying the URL of the image to be displayed. The src attribute of the img tag in HTML is compatible with various image formats, including JPEG, PNG, GIF, and SVG. Remember your shopping list website. Users would probably find it easier to use if they had an image of an item as well as a name and description. Let's explore how to do that. Let's first add 3 fruits, apples, mangoes, and bananas. Use H2 heading for this. Below each heading, add a descriptive paragraph. In this specific example, lorem ipsum text is used as a placeholder. The page preview shows the item heading and description. Now add the image of apples below the heading. Note that this image is in the same directory. Type img src equals apples.jpg. When the page is opened in the browser, an image is displayed between the heading and the paragraph. Keep in mind that the image you use can come from outside of the current directory. In that situation, its full URL must be given. The src attribute is mandatory, but there are other attributes that you should also consider. An important attribute that should always be included is the alt attribute. This is specified inside the img tag. The alt attribute provides an alternative text description for the image. This is important in 2 situations. If the image cannot be loaded due to an error, this alternative descriptive text can be displayed. Its other important function is to aid accessibility. As a developer and website designer, you should always remember that images are not accessible to all users. If a user finds an image inaccessible, then the alternative text description provides vital information. The old attribute can be added to the img tag as old equals with the alternate text enclosed by quotation marks. Another very useful attribute is the title attribute. It provides text that will be displayed as a description or additional information when hovering over the image. The title attribute can be added to the img tag as title equals quotation mark, title close quotation mark. Let's explore adding those two attributes to an image on the shopping list. First, let's add an image to go with the description of bananas. Use the alt and title attributes in the img tag. Type img space src equals bananas.jpg. Alt equals image of bananas. Title equals bananas. Open the page in the browser now. It should display the image between the heading and the paragraph. If the mouse pointer hovers over the image, the title is displayed. By default, the browser displays an image at its original size. As a result, it may not align with your design. This can also lead to unexpected, oversized or undersized images and may affect the performance. The img tag also supports width and height attributes. You can specify the dimensions of the image in pixels. This attribute is important to control the size of the image on the page. The values must be integer. In this example, the width of an image has been defined by adding width equals 400 to the img tag. Let's add an image below the heading for mangoes. Use the width and height attributes to specify the image size in the img tag. Type img space src equals mangoes.jpg. Width equals 400, height equals 220. You can use height or width equals auto to maintain the aspect ratio. If you now open the page in the browser, it should display the mangoes image between the heading and the paragraph. The image is sized according to the dimensions specified. This video has shown you how to use the img tag to add images to your web pages and how to specify an src for the image path. You learned about the importance of adding an additional text description using an alt attribute, which ensures that the images are accessible to all users. You now know that width and height attributes can be used to control dimensions, and a title attribute can add hover text. As you progress in your development career, the skills you've learned in this video will help you take your design skills to the next level. Adding images will give your web pages more impact. Knowing how to use these attributes correctly will make those images more adaptable, informative, and accessible. You've enjoyed a quiet half-hour of downtime browsing your favorite online store. There are several items in your shopping basket. You proceed to checkout, ready for that final click to buy and make a payment. But wait, how does the website know who you are, where to ship your order, or how to process your payment? This is where web forms come in. When you click to pay, you're presented with a form where you can enter all the information that the website requires, such as name, address, contact information, and of course, payment details. A form allows the website to collect this essential information. You've probably come across many of these forms in today's internet-driven world. Whether it's registering for an email service provider, placing an order, or even subscribing to a newsletter, forms transform a static website into a fully interactive experience. So how do you create these forms? The answer is with HTML. In this video, you will learn about the basics of HTML form. You'll explore frequently used form elements such as text and password input types, multi-line text inputs, buttons, and drop-down menus. You will use all of these elements to create a registration form for the shopping list website. Before doing this, let's start by examining what an HTML form is. The HTML form, sometimes called a web form, is the main point of interaction between a user and a website or application. The form allows users to enter data, which is generally sent to a web server for processing and storage. A web form is made up of one or more form elements, such as single or multi-line text fields, drop-down boxes, buttons, checkboxes, or radio buttons. The first step is to create a form using the form tag. This tag defines the area where the user input will be collected. Every HTML form can be configured with one or more attributes. Here are the most important. The action attribute defines the URL location where the form's collected data should be sent when it is submitted. The method attribute defines which HTTP method to send the data with, usually GET or POST. The enctype attribute specifies how the form data should be encoded when submitted. By default, the encoding type is set to application/x-www-form-URL encoded. All the characters are encrypted before sending to the server. It converts a whitespace into a plus symbol and each special character into its hex value. Alternatively, it could be set to multipart/form data, which is useful when you need to upload a file with the HTML form. It could also be set to text/plain. This is not recommended, as the form data is sent without any encoding at all. When set to hashtag, the action attribute of the form indicates that the browser should stay on the same page when the submit button is hit, when submitted with the post method. Let's explore adding this form tag to your code. In VS Code, create a new file and name it as registration.html. Place the cursor below the body tag and type form space action equals hashtag method equals post and press enter. The closing form tag will be rendered automatically. The label tag in HTML is used to provide a descriptive label for an input element. It helps improve accessibility by associating the label with the input field. The for attribute in the label tag should match the ID attribute of the associated input element. This allows users to click on the label to focus on the input field, improving usability. The most important and most commonly used form element is the input element. The input tag specifies an input field where the user can enter data. HTML5 supports various input elements, and the type attribute of input tag is used to define the type. Here are some examples. A text field creates a single line field for text input. Password allows text input with obscured text for security. Email offers validation for email addresses in the text field. Number enables input for numeric values, with arrows for increasing or decreasing values. Checkbox produces a box that can be checked or unchecked. And radio, which creates a button that can be selected as part of a group. Let's add some of these to your registration form. Below the opening form tag, insert a text input element for the user's name. The ID of the element is name, so the for attribute of the associated label is also name. Use another text type input for username, with its ID as the user ID. The password type input element is provided to let the user choose the password to be used for login. The user is asked to provide their email address in a text field of email type. The HTML5 provides built-in validation for the email address format. The text area tag renders a multi-line text input control on the form. It is often used to collect user inputs like addresses, comments, or feedback. A text area can hold an unlimited number of characters, and the text is rendered in a fixed width font. You can also specify the size of the area by the cols and rows attributes. You need to define the name attribute to reference it after the form is submitted. The ID attribute is needed to associate the text area with a label. Let's add a text area control in the registration. This text area element will allow the user to enter their correspondence address. Set the ID as well as the name attribute to address. This will be used to configure the label for the text area. Define the dimensions of the text area as 5 rows and 30 columns. The select element is used to create a drop-down list. It is most often used to let the user select one item from a list of available options. The option tags inside the select element define the available options in the drop-down list. The name attribute is needed to reference the selection after the form is submitted. The ID attribute is needed to associate the drop-down list with a label. Let's add this to the registration form so that the user can choose one of the available registration categories, premium and regular. The ID and name of the select tag is category. Inside the select tag, provide 2 option tags to hold the premium and regular categories, which the user can choose from. Finally, your registration form will need a submit button. An input element of type submit is rendered as a button. When it is clicked, the browser submits the form to the URL mentioned in the form's action attribute. The value attribute of the input element with type equals submit is a string that is displayed as the button's label. If you don't specify a value, the button will have a default label, submit. The submit button is usually the last element in the HTML form, just before the closing form tag. Let's place an input element with submit type in the registration form. Okay, now that all the desired form elements are positioned, save the registration.html file and open it in the browser preview. Enter data in the name, username, and password fields. Note that the password field masks the characters entered with asterisks. There is also Get a Preview button on the right side of the password field, which reveals the password. As you type text in the email field, the browser prompts you to enter it in the correct format. A drop-down list of categories is presented with two options for you to select. While the Submit button is available, it will not do anything if it is clicked, as there is no back-end processing provided here. You'll learn more about back-end processing later. This video has provided a comprehensive explanation of form elements and guided you through the construction of a registration form. Well done. You now have a complete registration form containing text fields, a text area field, a drop-down, and a submit button. It's a simple yet functional form for registration, which you can incorporate and reuse in many different situations. In subsequent lessons, you will learn how to style these forms using CSS and how to handle the data with JavaScript. You've always enjoyed reading blogs, so you've decided to make a leap and create one yourself. It will have a header with your blog's title, a navigation bar, some individual blog posts, and a section containing closing information at the bottom. Naturally, you want this layout to be organized, accessible, and easy for search engines to understand. But how do you achieve that? That's where semantic HTML tags come in. They tell browsers, search engines, and assistive technologies how to read and interpret your layout. In HTML5, structural semantic tags such as header, footer, article, and section give specific meaning to each part of your page. This video explains how to create this blog layout using these semantic tags, so your structure is both organized and accessible. Tags such as div and span are non-semantic as they are generic containers for flow content and don't convey any meaning about that content. For example, the div tag defines a division or section within a web page. The span tag is an inline container used to group and style text or elements within a document. You've already become familiar with one type of semantic tag. Tags that are often used, such as H1 and P, are content-based semantic tags. They convey meaning about the content, such as text being either a heading or a paragraph level. You've already decided that your blog will have a title at the top and copyright and other information at the bottom. And of course, between these will be a series of individual blog posts. Which semantic tags would provide this structure? The header tag is usually used for introductory content, which is usually at the top of the page. You could use this to position your titles. Next, you would need an article tag, which represents a self-contained piece of content, such as a blog post. Finally, you can use the footer tag for the closing or supplementary information. As your blog grows, you can use a section tag to group related content into thematic blocks within the page. This would help to create a better experience for the reader. If you also include a nav tag that specifies a navigation menu, you can guide users where to go. Have you ever hovered over a book title on a web page and had the author's biography appear in a sidebar or in a call-out box? You can create this kind of dynamic effect and have content appear in this way by using the aside tag. You can also employ another semantic tag, the main tag, which is used to mark the primary content of the HTML document and define its core functionality. This results in better accessibility and readability. So, now that you're more familiar with some of the common semantic tags, why should you consider using them? These tags improve the structure, accessibility, and SEO of your pages, helping search engines and assistive technologies understand the page's layout and content. SEO stands for Search Engine Optimization, which affects your website's ranking on search engines. Semantic HTML helps improve SEO by making the content more identifiable to search engines. Semantic HTML also improves responsiveness and interacts smoothly with screen readers to improve accessibility for all. In general, semantic tags improve readability for all users. The tags help structure and organize your code to keep everyone on the same page. Let's explore how you can include some of these tags for best effect. Begin in the VS Code editor and open a new folder. Create a new file named index.html for your blog. Inside the body tag, you're going to create different sections using semantic HTML tags. First up, let's add a nav tag inside the header tag. Create a navigation menu having hyperlinks to other sections in the blog page: Home, About, and Contact. Next, add the main tag, which will contain your core content. Inside main, add a couple of article tags to represent each blog post. The article tag is ideal for independent content that could stand alone like a blog post. Each article tag wraps a blog post with a title and content. By using article, you can tell browsers and search engines that each of these sections is a standalone piece of content. Next, let's add a footer tag to the end of the page. The footer is typically used for content like copyright information, social media links, or any additional information you want to display at the bottom of the page. Here, the ampersand copy is an HTML entity that renders the copyright symbol. By adding a footer, you signal to browsers that this section contains closing or supplementary information. It's usually the last thing on the page and helps users know where the content officially ends. So there you have it. By using semantic HTML tags such as header, footer, article, and section, you have created a blog layout that's easy for both users and search engines to understand. This video has demonstrated how semantic tags work. It has explored how semantic tags can be used to create and identify different content elements. It has also provided a practical example of using them to improve the structure of a web page. As you move forward in your development career, you should continue to apply the knowledge and techniques you've gained here. They will help you to create content that is accessible to all audiences and easy to maintain. This will ensure that the web pages you design are easy to find and easy to read, which will keep users coming back for more. You've just started your own company and need to build a website. The content is all there, but the page looks plain. The text feels unorganized, images are misaligned, and everything seems clumped together. It doesn't look polished or professional. So how do you transform it into a website that stands out? This is where CSS, or Cascading Style Sheets, comes in. CSS lets you control the look and feel of your webpage by adding colors, fonts, spacing, and alignment to create a clean and professional design. Think of HTML as your website skeleton, providing structure, while CSS is the style that dresses it up, much like choosing the right outfit for an important event. CSS ensures your content is well organized and visually appealing. This video will focus on the role of CSS in web design, the different ways CSS can be applied using inline, internal, and external style sheets, and how CSS separates design from content, making web development more manageable. CSS is a style sheet language used to control the look and formatting of a web page written in HTML. While HTML handles the structure like headings, paragraphs, and images, CSS focuses on the page's appearance and layout. CSS enhances web pages by adding design elements such as fonts, colors, layouts, and spacing. It also separates content from presentation, making it easier to manage the design without altering the core content. For example, if you need to update the color of headings on 20 pages, using external CSS allows you to make the change once in the style sheet and apply it instantly across all pages. There are 3 main ways to apply CSS to HTML, each suited for different scenarios. Inline CSS applies styles directly to an HTML element using the style attribute. It's useful for quick one-off changes to specific elements. However, relying too much on inline styles can clutter your HTML and make maintenance harder, especially when styling multiple elements. Internal CSS is placed inside a style tag in the head section of the HTML document. This method keeps styling separate from the content, but within the same file. It helps apply styles to a single page without impacting others. Internal CSS offers more organization than inline styles and works well for small websites or single-page applications. External CSS is written in a separate .css file and linked to the HTML using a link tag element. This is the most efficient approach for larger websites, as it promotes reusability and consistency across multiple pages. External style sheets make it easy to apply global changes, like updating fonts or colors with minimal effort. Let's say you're creating a blog for your website with basic HTML and CSS. You want to keep things simple, so instead of creating a separate CSS file or using internal CSS, you decide to style your text directly within the HTML elements using inline CSS. For instance, on your blog's homepage, you want to write a short introduction about yourself and make the text blue, your favorite color. Here's how you do that using inline CSS inside the blog.html document. The h1 tag displays your blog's title, Welcome to my blog, using the browser's default styling. The p tag below it contains your introduction. This time you add the style attribute to the p tag with an inline CSS rule, color: blue, semicolon. When viewed in the browser, the introductory paragraph will display in blue, giving your blog a personal touch without extra CSS files or complex setups. You now move on to start designing a simple web page for your company's online newsletter. You want all the paragraph text to appear in green to give the page a consistent, polished look. Instead of adding inline CSS to each p tag, internal CSS keeps things more organized and easier to update. Here's how you'd structure the newsletter.html document using internal CSS. The CSS rules go inside a style tag in the head tag section. The rule p, curly brace, color green, semicolon, curly brace, closed, ensures every paragraph on the page displays green text. This internal style sheet will consistently style all p tag elements across the page, making it easy to maintain a cohesive design for the newsletter. If you need to update the styling later, you can do so in one central place, and it will affect all paragraphs automatically. Your company website is starting to look more polished and professional, but it still feels a bit flat. To stand out from the competition, you decide to create a homepage, a services page, and a contact page. As you now know, inline CSS works well for small tweaks, and internal CSS is great for single pages. However, when building multi-page websites, you need external CSS. External CSS manages styling across all pages in one central place. Here's how you'd structure the home.html document using external CSS. In this example, the link tag with rel equals style sheet and href equals styles.css inside the head section of the homepage .html connects the page to the external style sheet. The CSS rules define the paragraph text in red and the heading text in navy in a separate styles.css file. By adding the same tag to other pages, such as services.html or contact.html, the design remains consistent across the site. In this video, you explored the role of CSS in web design and the 3 key styles for applying it: inline, internal, and external CSS. With a solid grasp of CSS, you now have the tools to enhance any web page, whether a simple blog or a complex business site with multiple pages, ensuring it works well and looks great. Your company's website is coming together. You've structured the content with HTML and added basic styles with CSS. But now it's time to refine the details, ensuring every element looks exactly how you envision it. This is where CSS selectors and properties become essential. In this video, you'll learn how to use element, class, and ID selectors to style specific HTML elements and apply essential CSS properties to control color, fonts, spacing, and more. CSS selectors are patterns that target and style specific elements in the HTML document. They tell the browser which elements to apply CSS rules to based on their type, class, ID, attributes, or position within the HTML structure. Properties define how those elements should look or behave. Selectors are essential because they allow for precise styling, helping developers control the appearance and layout of elements on a web page. Let's dive into the main types. An element selector targets all HTML elements of a specific type by their tag name. For example, you would use the following CSS to style all p tags or paragraph elements with blue text. The p selector targets every p tag in the document. The curly braces group properties and values, known as the declaration block. Inside, color is the property, blue is the value, and the semicolon ends the declaration. Without the semicolon, the browser assumes it's the last property. What if you only want to style certain elements, not all paragraphs, but just a few? This is where class selectors come in handy. Classes allow you to label multiple elements and style them consistently without impacting others. For example, this HTML snippet creates two paragraph elements, one with a special class attribute and one without. The class, my class, applies unique styling to any element it's attached to. In this case, one paragraph gets that special styling while the other does not. The same class is also used on a div tag element, ensuring it shares the same look and feel. The following CSS code targets all elements declared with the my class attribute. The class selector is defined by a dot followed by the class name. It applies the rule to every element, with the class, my class, setting the font size to 18 pixels. Sometimes you need to style a single unique element, such as the main content area of your homepage. That's where ID selectors come in. IDs are intended for elements that appear only once on a page, making them perfect for specific styling needs. For example, the following HTML code creates one div element with a unique identifier, main content. The following CSS code targets the element defined with main content ID only. ID selectors, identified by the hash symbol, target individual elements. Here, the hashtag main content selector applies a light blue background and adds 20 pixels of margin around the content. Using IDs ensures that unique elements stand out while maintaining a clear structure. Your company decides that adding a blog would be a great way to give the website a personal touch. To make it look clean and readable, you decide to apply different CSS selectors, element selectors, class selectors, and ID selectors. Each one targets specific parts of your blog to create a polished design. The blog.html page contains several HTML elements. Let's go through each. The body element acts as the main container for all visible content. The h1 tag is a top-level heading that displays the blog's title, My Journey into Web Development. The div with an ID of main content wraps the main content. This ID helps style it as a unique section. Multiple p tags hold different sections of text. The first paragraph introduces the blog. The second paragraph explains the importance of CSS selectors. The third paragraph provides a note, using the highlight class to draw attention. The fourth paragraph encourages readers to stay tuned for future updates, again using the highlight styling to make it stand out. Now let's look at the CSS applied through internal styling. The element selector applies styles to every p tag element on the page. This sets the text color to blue, changes the font to Arial, and applies a line height of 1.6 to make the content more readable. Every p tag inherits these styles, ensuring consistency across the blog. Class selectors are used when multiple elements need the same style. The third and fourth paragraphs in the blog use the highlight class to stand out. The .highlight class gives the elements a yellow background, bold text, and 10 pixels padding. Padding refers to the amount of space added inside an element, between its content and its border. You can reuse this class for other elements that need the same styling. The ID selector styles unique elements. In the blog, the main content section holds the core content. This sets the background color to light blue, adds 20 pixels padding, a solid blue border, and a 20 pixels margin below the section. Since IDs must be unique, these styles apply only to this section. The blog.html web page, including the CSS code, is displayed as follows. When the blog.html page opens in a web browser, several styles are present. All the paragraphs appear in blue text, using the Arial font with consistent line spacing. Paragraphs with the class highlight stand out thanks to a yellow background, bold text, and 10 pixels of padding. The main content section features a light blue background, 20 pixels of padding, and a solid blue border, creating a clear visual separation from the rest of the page. This example shows how element class and ID selectors work together to effectively style different parts of a web page. Now that your company's website is coming together, CSS selectors allow you to refine its design efficiently. Element selectors apply styles across all elements of a specific tag. Class selectors allow you to target multiple elements with shared styles, and ID selectors let you customize unique sections. In this video, you learned how to use these selectors and properties to target HTML elements, ensuring a polished, consistent, and maintainable design. With these tools, you can style your site precisely and flexibly, just what's needed to make it stand out. You open a web page you've never visited before and discover that it contains large amounts of printed text. To your dismay, the font, which is the style of the letters, is very ornate with lots of embellishments. The characters are all very, very small. They're also light-coloured on an equally pale background. In this situation, do you think you would feel motivated to continue reading? Choosing the correct font, font color, and font size is crucial to creating a visually appealing web page and ensuring that users have a positive experience. In this video, you'll learn how to style text using various font properties and text alignment techniques to enhance the look and feel of your web page. It can be difficult to make a choice from a list of hundreds of different fonts. However, you should consider two things: the type of content and the type of audience. This way you can choose an appropriate font that will have a positive impact on your design. Different types of fonts are suitable for different types of content. Let's explore some of these. First, serif fonts. These are decorative fonts containing additional strokes on the letters. Examples are Times New Roman and Georgia. They work really well for formal content. Monospace fonts have equal width characters, which makes them perfect for displaying code. A common example of monospace is Courier New, which is great for technical content. Would you like the text on the screen to appear as if it were handwritten? Cursive fonts mimic handwriting and can add a personal touch to your designs. Brush script is a popular cursive font. Finally, do you want the text to appear decorative or themed? If you do, choose a fantasy font, such as Impact, which would be perfect for elements that need to grab attention. Of course, you can mix and match fonts to emphasize the message in the content. For example, you could use sans serif for a more modern look, and serif or sans serif for areas where you require a more traditional feel. Using a different font for headings and body text can emphasize the hierarchy of headings and improve readability. Selecting the right font with the font family property can significantly elevate your website's design. Let's explore an example. You're building a personal portfolio webpage to introduce yourself, showcase your skills, and describe your services. Initially, your portfolio.html document will display with default HTML styling, meaning the text is unstyled, lacks alignment, and has no visual enhancements. It will look plain and basic. Let's step through how you could add instructions to improve the appearance and add the required styling changes. Your current portfolio page has been produced by this HTML document. When viewed in the browser, your portfolio.html document displays your content without cascading style sheets or CSS styling. Your web page text has a modern and more readable font. You decide to change the font family property to change text appearance and align it with your website's design. To do this, you apply this code inside the opening style tag, closing style tag element. In this code, body targets the entire web page content, and the font family property sets the font to Arial. Next, you decide to use the font size property to adjust the size of headings 1 and 2 text. Initially, the font size of headings is decided by the web browser based on the HTML element type. By using CSS, you can ensure all browsers use your chosen size and font instead of the default format. Here, heading 1 or H1 is set to 36 pixels, and heading 2 or H2 is set to 28. Paragraph text is set to 16. CSS allows the use of different absolute measurement units. You can specify which one to use by adding letters. px indicates pixels, in is inches, cm for centimeters, and mm for millimeters. If you add the initials pt, this indicates that the measurement unit is in points. There are approximately 72 points in 1 inch. You decide to emphasize the importance of some text by making it thicker and more attention-grabbing. To do this, you adjust the font weight property, which allows you to control the boldness of the text. You can set values like normal, bold, or even numerical values for more control. To make the inspirational quote on your portfolio stand out, you decide to style it in italics. The font style property can be used to italicize text or set it back to normal. Adding this line ensures that block quote uses font style italic. Next, you specify the alignment of the text elements using the text align property. Here, the paragraph text, indicated by the P, is aligned to the left. This code ensures that heading 1, H1, is centered, giving it a balanced, prominent position. The signature is aligned to the right for a stylized personal touch. Next, you decide to create a neat and professional appearance by using the article element with text align. Justify property to evenly distribute the text across the element's width. The text decoration property is used to underline, overline, or strike through text. In the portfolio, you have added a hyperlink to give users an easy way to contact you. By adding this code, you ensure that the Contact Me text and any other hyperlinks are underlined using text decoration underline. As always, you should consider the audience when styling your text. You decide to increase the space between the lines to create more open, readable text. The line height property controls the spacing between lines of text. Here, the paragraph elements represented by the P are set to a line height of 1.6, which sets the space between lines to 1.6 times the size of the font. The letter spacing property adjusts the space between characters, enhancing readability or adding stylistic flair. In this example, the H1 element has a letter spacing of 2 pixels. Your code now contains the amendments you needed to change the styling of the content in the portfolio. By changing the font family, font size, text alignment, text decoration, line height, and letter spacing, you have improved the appearance of the portfolio document. In this video, you learned how to style text using CSS font properties and text alignment. You explored how to adjust the font family, the size, weight, and style, and how to control text alignment. Additionally, you covered extra text styling options like line spacing, letter spacing, and text decoration. All of these techniques will be useful tools in ensuring that your web content is readable and appealing to users. Keep experimenting with these properties to find the best combination that elevates your design and expresses your personality. Think of arranging items on a shelf, sometimes aligned side by side, other times stacked top to bottom. Now imagine having the power to rearrange and space them effortlessly, no matter their size or shape. That's precisely what Flexbox, or CSS Flexible Box Layout, offers for web layouts. This video introduces Flexbox, a powerful tool for building responsive and adaptable designs. You'll learn how Flexbox simplifies the alignment, spacing, and organization of web elements. Flexbox easily arranges and aligns web elements inside a container, no matter how much space is available. Items can align horizontally, stack vertically, or space themselves evenly, adapting to different screen sizes without breaking the layout. In CSS, a container refers to any HTML element that holds other elements. These inner elements are called child elements, and they inherit layout rules from the container. Let's break down 4 key Flexbox properties. The display flex property activates Flexbox for a container. When set, all direct child elements become flexible, allowing you to easily align and arrange items like images or text. The justify content property manages the horizontal spacing inside the container. It controls how space is distributed between items along the main axis. In this example, space between ensures the items are evenly spaced across the container. The Align Items property handles vertical alignment. This centers all items vertically, making the layout look balanced. The Flex Direction property controls how items are arranged in a Flex container. The default value is row, meaning the items align horizontally. Switching to columns stacks the items vertically. In this example, the items now stack vertically instead of aligning side by side. Seems tricky? Let's break it down to show just how easy it can be by walking through the structure of Cafe Delight, a small independent coffee shop's webpage, before applying any Flexbox rules. This HTML document outlines the key sections on the webpage: the menu, image gallery, and customer testimonials. Let's break down some structural issues that become evident when viewing this layout. The menu items and testimonials are listed vertically, but since there's no alignment or spacing control, they will appear as a basic list without much structure or organization. All images align in a row, but don't wrap properly on smaller screens. So you've explored what it looks like in a HTML document, but how about on the actual web page? The design struggles with responsiveness, meaning it doesn't adjust smoothly to different screen sizes. As a result, elements can become misaligned or awkward gaps might appear, especially on smaller screens. Additionally, the sections lack alignment control. Without centering or distributing the elements evenly, the layout feels unbalanced and somewhat disorganized. The spacing between elements is also quite limited, making the page feel cramped and harder to navigate. These issues affect both the usability and visual appeal of the web page, especially for users on mobile devices. Using Flexbox makes it much easier to control the layout and alignment of web elements. Let's start by improving the menu section. Applying display flex to the dot menu container allows for better control over how the items are positioned. In this example, setting Flex Direction column ensures the menu items stack vertically, and Align Item stretch ensures they expand to fill the available space, making the layout more readable and consistent. The image section also benefits from Flexbox, especially when it comes to creating a responsive layout. Enabling FlexWrap ensures that images automatically move to the next line when there isn't enough space on the current row, preventing overflow issues. Additionally, setting Justify Content Center ensures the images remain centered within the container, giving the section a clean and balanced look. Flexbox helps align and organize the testimonials, making the section more visually appealing. Setting Display Flex on the dot testimonials container allows for better control over spacing and alignment. Using Flex Direction column stacks the testimonials vertically, and Align Items Center ensures they are centered within the section, resulting in a more polished design. Let's update the CSS in the cafe.html document to bring these improvements together. With Flexbox applied, the layout immediately becomes more polished and balanced. As shown here, the adjustments ensure better alignment and spacing across all sections, creating a cleaner and more visually appealing design. Notice how each section now flows more naturally. The images are centered and wrap neatly when needed, preventing overflow issues. Testimonials are aligned consistently, giving the content a more organized structure. Even the menu, with items spaced evenly and aligned perfectly, feels more readable and easy to navigate. It looks much better, right? But remember, these enhancements don't just improve the page's appearance, they also improve the user experience. In this video, you learned how to use Flexbox techniques to transform Cafe Delight's webpage into a responsive, adaptive layout. These methods are essential for building modern, flexible websites that look great on any device. You're browsing the web on your smartphone while waiting for your coffee. You open a beautifully designed website, but when you try to read the content, you have to zoom in and scroll sideways just to view everything. Frustrating, because you know you opened the same web page on your tablet and it looked perfect. If the web page looks perfect on one device but messy on another, then it hasn't been designed responsively. So what does this mean? Responsive design is an approach to web design that ensures the website automatically adapts to different devices to present the best viewing experience to the user. It ensures that web pages look good and function well on a variety of devices, from smartphones to tablets to desktops. In this video, you'll explore the essentials of responsive design, focusing on how media queries can help you adjust layouts based on screen size, ensuring that your web page looks good on mobile phones, tablets, and desktops. The very basis of responsive design in CSS are media queries, which allow you to apply styles based on device characteristics like screen width or resolution using the @media query rule. They allow you to conditionally apply styles based on device characteristics like screen size, orientation, or resolution using the @media rule. You can adjust layouts, font sizes, and other styles to ensure your site looks polished on every device. A key element of responsive web design is breakpoints. They are important because they mark specific points where a website's layout and content should adapt to a different screen size or a different device. If you define breakpoints using @media, you can change the web page design at specific screen widths. For example, this CSS uses a media query to change the text color of p tag elements from black to blue when the screen width reaches 600 pixels. That example only modifies the color, but media queries can change any CSS property based on the screen size. In order to have media queries work correctly on mobile devices, you need to include a viewport meta tag in your HTML. This tag tells the browser how to display the web page by controlling its size and scaling. Without it, even with responsive styles, the page might not display correctly on mobile screens. For instance, the text may appear too small or the layout might not fit correctly on the screen. In this code, the meta tag provides information about the web page, and the name equals viewport defines the viewport settings. Content equals sets the viewport width to match the device's width, and the initial zoom level to 1.0. This ensures that the content fits the screen and is readable without zooming. You've created a welcoming web page for Sweet Treats Bakery, which specializes in cakes, cookies, and pastries. Let's examine how the page currently appears on different devices and how you can adapt the code to overcome any issues so that the page appears the same on any device. The welcome.html includes a Welcome to Sweet Treats Bakery heading. It also defines 4 main sections displayed in 4 columns across all devices. Each column contains a heading and descriptive text underneath. The 4 columns are Our Products, Special Offers, Visit Us, and Customer Reviews. Each of them contains a description. Currently, all the sections are displayed in 4 side-by-side columns on every screen, including mobile devices. While these appear clearly on standard screens, on smaller screens, this 4-column layout may feel cramped, squishing the content horizontally and making it difficult to read and navigate. However, there is a solution. Media queries can be used to adjust the layout based on the screen size. This will enhance the user experience across devices. Here are some guidelines for applying the media query. For large screens, such as desktops, all 4 columns can be shown side by side. You can maximize the widescreen by applying a media query targeting screens 1024 pixels wide and above. But what about smaller and more portable devices we all use every day? For medium-sized screens such as tablets, you could display 2 columns side by side to more effectively utilize screen space. Do this by using a media query for screens with a minimum width of 601 pixels and a maximum width of 1023 pixels. For small screens such as mobile devices, you can stack all columns vertically for easier reading and navigation. To do this by applying a media query targeting screens 600 pixels wide, or by making this the default setting. By adjusting the layout for different screen sizes, you ensure the website is user-friendly and visually appealing on all devices. Let's fix this issue for Sweet Treats by modifying the CSS for responsive design. Let's start by stacking the columns vertically for small screens by considering a base style. By using default HTML styling settings, each section, header, content, and footer will naturally stack vertically, creating a clean, linear flow for content on narrow screens. In this base style, the .content class utilizes flex direction column to stack elements within the content area, ensuring a vertical layout with space between sections, gap 20 pixels. This approach maintains readability and consistency on smaller devices. Next, adjust the layout to display two columns side by side for tablets with screens that are at least 600 pixels wide and a maximum of 1023 pixels. This code adjusts the layout so each content section takes up half the width, with space between columns. For larger screens starting from 1024 pixels and above, you want 4 columns side by side. This can be achieved by giving each column a width of 25%, minus spacing 20 pixels. Here's the complete solution with media queries applied. To switch between different views, mobile, tablet, or desktop, and test media queries in your web browser, first open Developer Tools by right-clicking on the page and selecting Inspect. Click on the phone tablet icon at the top left of the Developer Tools panel to toggle the device toolbar. The base styles define the common design elements that apply to all screen sizes. At the same time, they optimize the initial layout for smaller screens, 600 pixels or smaller, where columns stack vertically. Once the screen width reaches 601 pixels on a device such as a tablet, the columns are arranged in 2 columns side by side. However, on desktop screens, which are 1024 pixels and wider, 4 columns are displayed side by side. Well done! Because of these adjustments, customers can comfortably view the Sweet Treats Bakery information on any device. This can only be good for business. In this video, you learned about responsive design and the importance of making your web pages look good on various devices. You explored how to use media queries to apply different styles based on screen size and how to implement the viewport meta tag for responsive behavior. By applying these techniques, you'll create a more user-friendly experience, making your website adaptable to all devices and ensuring that your content shines wherever it's viewed. Have you ever visited a website, hovered over a button and noticed it smoothly change color? Or watched images slide effortlessly into place as you scroll down? These experiences are created with Css Transitions and Animations. In this video, you'll learn how to build basic CSS transitions and keyframe animations. Get ready to bring life to your web pages and create a more engaging user experience. CSS transitions make changes feel smooth by easing between different styles, while animations allow you to choreograph more complex sequences of movements and transformations. A transition might be as simple as a button slowly changing color when hovered over. Animations, however, can handle more complex sequences, like moving an element across the screen, changing its color midway, and fading it out at the end. To build these effects, it's important to understand the key properties involved. Let's start by exploring the key properties of CSS transitions. First, transition property defines which CSS property will change, like background color, which adjusts the element's color, or transform, which modifies its shape, size, or position. Next, transition duration controls how long the transition takes, whether it's 0.5 seconds for a quick effect or 2 seconds for a slower one. Transition timing function controls the speed of the transition, determining whether it moves smoothly, quickly at the start, or eases out towards the end, with values like ease, linear, or ease in, out. Ready to take it a step further? Now let's explore the key properties of CSS animations. At keyframes outlines the different styles an element will go through at specific points in the animation. Animation name links the element to the correct at keyframes rule, while animation duration defines how long the entire animation takes, whether in seconds or milliseconds. Animation timing function controls the speed of the animation over its duration, allowing for different pacing styles. As with transition timing function, common values include ease, linear, ease in, ease out, and ease in out. Then there's animation delay, which adds a pause before the animation begins. This can be useful when sequencing multiple animations. If the animation needs to repeat, use animation iteration count. You can specify a number or use infinite for continuous looping. For even more control, animation direction determines whether the animation plays forward, backward, or alternates between the two. Animation fill mode specifies how styles are applied before and after the animation runs, while animation play state allows you to pause and resume an animation whenever needed. Now that the key properties are clear, how will they look in action? Here's a simple example that brings these transition properties to life. In this example, you've created a box that changes its background color, size, and position when hovered over. Transition property is set to background color and transform, meaning both the background color and the element's transformation will animate when the box is hovered over. Next, transition duration is set to 0.5 seconds, so the changes will take half a second to complete, creating a smooth visual effect. Finally, transition timing function is set to ease in out. This means the transition will start slowly, pick up speed in the middle, and then slow down again towards the end. Let's explore how these transitions come together. Notice how the box smoothly changes color and shifts position when rolled over. These effects help enhance interactivity, making the design feel more responsive. Great job mastering transitions. Now let's take things a step further with CSS animations. Here's a basic example that demonstrates how different animation properties work together. In this example, you've created a simple animated box that changes its position, color, and size using key animation properties to control the effect. The animation is defined with the @keyframes rule. This is where the sequence of changes is set, starting with a specific position, color, and size, and gradually shifting to new ones as the animation plays. In the .animatedBox class, the animation name property connects the box to the move and grow keyframes. Animation duration is set to 2 seconds, meaning it takes 2 seconds for the box to complete one full cycle from start to finish. Animation timing function is set to ease in out, so the movement starts slow, speeds up in the middle, and then slows down again at the end. There's also a 1 second delay added with animation delay, so the animation waits a moment before it begins after the page loads. Animation iteration count is set to infinite, meaning the animation will keep looping continuously. To create a back and forth effect, animation direction is set to alternate, which makes the animation reverse direction after each cycle. The animation fill mode property is set to forwards, ensuring that the box keeps the final styles from the last keyframe after the animation completes. And finally, animation play state is set to running, meaning the animation starts immediately, but this can be changed to paused if needed. Let's explore how this animation works in practice. This is a great example of how combining multiple animation properties can add movement and polish to a design. This video covered the core concepts of CSS transitions and animations, 2 powerful techniques for enhancing user experiences on the web. Transitions allow elements to respond smoothly to interactions, while animations offer greater control over complex style changes. Using these techniques helps you build more engaging, user-friendly applications. Subtle effects like these guide attention and make interactions feel smoother. Try experimenting with them in your own projects to see how even small changes can make a big impact. While HTML structures your content and CSS defines its appearance, it is JavaScript that injects life into the static, making your web pages not only visible, but also responsive and engaging. Today's web pages and applications are brimming with interactive touchpoints, buttons waiting to be clicked, forms validating input in real time, and tooltips that appear at the slightest hover. These interactions are no longer optional. They are integral to the modern web experience, inviting users to actively engage with the interface. In this video, you'll learn how JavaScript turns basic front-end design into a dynamic interactive environment. First things first, what is JavaScript? JavaScript is a powerful scripting language predominantly used in web development to create dynamic interactive features that engage users in real time. Unlike programming languages designed for standalone applications or systems, JavaScript is typically embedded within websites to enhance the user experience. It operates directly in the browser, meaning that each time you visit the web page, your browser is executing the JavaScript code. This enables interactivity without needing the page to reload. JavaScript is both beginner-friendly and indispensable in modern web development. And alongside HTML and CSS, it forms the backbone of the web. HTML lays the foundation, structuring the content of the web page, such as paragraphs, headings, and lists. CSS defines the appearance, styling everything from fonts to colors and layouts. And it's JavaScript that breathes life into the page, adding behaviors like clickable buttons, animations, and interactive content that responds to user input. JavaScript is crucial in web development because it empowers developers to create complex dynamic behaviors on web pages that transcend the limitations of HTML and CSS. For example, JavaScript can instantly validate form data before it's submitted, preventing errors and streamlining user input. It can help seamlessly update page content in real time without refreshing the entire page, as seen in continuously updating social media feeds. And browser-based games and visual effects wouldn't be half as captivating without the interactive elements JavaScript brings to the table. Ultimately, JavaScript is critical because it brings a level of responsiveness that keeps users engaged. Some examples will help show how JavaScript adds interactivity. First, JavaScript can track user actions. Whether it's typing into a form, clicking a button, or hovering over a specific element, and react accordingly. Another way JavaScript leverages interactivity is form validation. Imagine filling out a form and forgetting to enter your email address or entering an invalid one. Rather than submitting incomplete or incorrect data to the server, JavaScript can instantly flag the error, guiding you to correct it before submission. JavaScript is also pivotal in updating web page content without requiring a full page reload. Social media feeds are a prime example. New posts or comments appear seamlessly as they arrive without disrupting the user's experience. As you'll soon learn, this is done using a technique called AJAX, which stands for Asynchronous JavaScript and XML. It enables parts of a page to update with new data from the server without needing to reload the whole page. As a final example of JavaScript's power, if you want captivating visual effects like animations, fading content, or smoothly moving elements, you'll be turning to JavaScript. And don't be mistaken, these effects do more than just beautify a web page. They enhance user engagement, making interactions more immersive and appealing. To get a sense of how JavaScript works in practice, let's consider a basic HTML button and how JavaScript will handle the action when it's clicked. The HTML here includes a button element, which users can click. When the button is clicked, it triggers a JavaScript function called displayMessage. The displayMessage function then changes the content of a paragraph element, which is located just above the script tag. It updates the paragraph marked with the ID message to display the text, "Hello, JavaScript is working." This simple example shows how JavaScript reacts to user input, modifying the content of the page dynamically without reloading it. As a result, the user sees the text update instantly without the page needing a refresh. The bottom line is this: JavaScript is an essential tool in modern web development. With the versatility it offers, developers can validate forms, build interactive maps like Google Maps, create dynamic web applications, develop browser-based games and animations, and so much more. As you begin your journey with JavaScript, you'll quickly discover just how powerful and fun it can be. If you're interested in web development, game design, or even building simple websites, mastering JavaScript will unlock endless possibilities. Happy coding! JavaScript is everywhere. Whether you're building websites, developing apps, or automating tasks, JavaScript powers the web. This video covers the basics of JavaScript, focusing on variables, data types, and performing basic operations. Let's start with variables, which you can think of as containers for storing data values. Like in other programming languages, JavaScript uses variables to manage information throughout your code. To declare variables, JavaScript provides 3 options. Remember, this example uses the JavaScript file named declare.js. The first and original way to declare variables was with var, which is either function or global scope. Variables declared with var can also be redeclared and updated. Second, the let keyword, introduced in ES6, is block scoped. This means that variables declared with let are only accessible within the block where they're defined, such as within a loop or function. Third, also introduced in ES6, const, short for constant, is used to declare variables that cannot be reassigned. However, objects or arrays declared with const can still be modified. Let's understand how declaring variables work in code with an example. Here's a snippet from a JavaScript file named declare.js. This file contains a function called declare variables, where my name is declared using var, meaning it can be redeclared or updated later. Age is declared with let, making it block scoped and more secure for specific blocks of code. Country is declared with const, which cannot be reassigned. To run the declare.js file using HTML, include it with the script tag and its src attribute in a HTML file, for example, declare.html. You can then trigger the declare variables function by clicking a button with the onClick attribute. Now run the code and check the output. First, open your project folder in VS Code. Then, install the live server extension from the VS Code marketplace. Open the declare.html file, which already includes your JavaScript file, using the script tag. And right-click the declare.html file and select Open with Live Server. Your browser will open the web page. To see the JavaScript output, right-click on the page and select Inspect. Finally, go to the Console tab and click the button labelled Click to Invoke JavaScript. The output will appear in the console like this. Done. What makes JavaScript variables powerful is their flexibility. They can store various types of data such as numbers, strings, and booleans. JavaScript is also dynamically typed, meaning you don't need to specify a variable's data type when declaring it. The type is determined by the value assigned. The basic data types in JavaScript include numbers used for numeric values, both integers and floating point numbers, strings used for text, enclosed within single or double quotes, booleans, logical data type that can only be true or false, undefined, a variable that has been declared but has not yet been assigned a value, and null, which represents the intentional absence of any value. Let's explore these data types by creating a JavaScript file named datatypes.js, which contains a function called invokeDataType. This function declares all the basic data types and prints their values to the browser console. In this example, number value is automatically recognized as a number. String value is a string indicated by the quotation marks. Boolean value is a boolean with a value of true. Undefined value is undefined, since no value has been assigned yet. And null value is explicitly set to null, representing no value. Now include the datatype.js file in the datatypes.html file using the script tag with its src attribute. Then use the onClick attribute on a button to invoke the invokeDataType function. Now just run the datatypes.html file using the Open with Live Server option and view the output in the browser's console. Now that you understand variables and data types, let's explore basic operations in JavaScript. Like other programming languages, JavaScript supports common arithmetic operations and string manipulation. Let's start with common arithmetic operations, which include addition, subtraction, multiplication, division, and modulus, which returns the remainder of a division. Here's a function named arithmetic operation defined in the JavaScript file arithmetic.js. It demonstrates the basic arithmetic operations on two numbers and prints the results to the browser console. In this example, you perform basic operations like addition, subtraction, multiplication, and division. The modulus operator returns the remainder when dividing num1 by num2. Include the arithmetic.js file in the HTML file arithmetic string.html using the script tag. Invoke the arithmetic operation function when a button is clicked using the onClick attribute. And now simply run arithmetic.html using open with live server and view the output in the browser's console. The last operation is string concatenation. This is the process of combining two or more strings into one. In JavaScript, you can concatenate strings using either the plus operator or template literals, introduced in ES6, with backticks. In this example, the function string concat is defined in the JavaScript file string.js. It demonstrates two ways to concatenate strings. The plus operator combines first name and last name into full name with a space in between. Template literals provide a more readable way to concatenate strings by embedding variables directly within the string using backticks. To run the code, include string.js in the HTML file string HTML using the script tag. Invoke the string concat function on the button click using the onClick attribute. Finally, run string.html using open with live server and view the output in the browser's console. And there you have it, a concatenated string. Understanding variables, data types, and basic operations is key to using JavaScript effectively. Whether you're calculating values, manipulating text, or handling user input, these core concepts are the foundation of JavaScript programming. With this knowledge, you're ready to start building interactive web pages and dive into more advanced JavaScript topics. Have you ever wondered how a web page updates instantly when you click a button or fill out a form? These instant changes happen because, behind the scenes, the browser is constantly updating and interacting with the page's structure. When a browser loads a web page, it creates a live model of the HTML document in memory, called the Document Object Model, or DOM. JavaScript can then manipulate the DOM to change elements on the page in real time, making web pages dynamic and interactive. In this video, you'll learn how to use JavaScript to interact with and modify the structure of a web page by working with DOM elements. Technically speaking, the DOM is an interface that allows JavaScript to interact with the structure of an HTML document. It represents the entire web page, including elements like headings, paragraphs, images, and links, as objects that can be accessed and modified by JavaScript. So, as an example, for this simple HTML document with tags for the head, title, body, and so on, in the DOM, each HTML element is represented as a node in a tree-like structure, like we have here. The hierarchical structure allows JavaScript to access and modify each element or node in the DOM. This DOM tree enables JavaScript to access, modify, add, or remove elements, allowing dynamic changes to the web page without needing to reload it. JavaScript can access and manipulate DOM elements using several methods, which can be grouped into three main tasks. You can select elements using specific methods. Document.getElement by ID selects an element by its ID. Document.getElements by class name selects all elements with a specific class name. Document.getElements by tag name selects all elements with a specific tag name, such as p, div, and so on. You can modify elements to change their content or styling. Inner HTML changes the content inside an element. Style modifies the CSS styles of an element. Set attribute changes the attributes of an element. And you can create and remove elements to add new content or delete existing content. JavaScript can create new DOM elements using document.createElement, add them to the DOM using methods like appendChild, and remove elements using removeChild. One of the most common ways to manipulate the DOM is by changing the text or HTML content inside an element. JavaScript provides several methods to do this, with one of the most popular being document.getElementById. Let's walk through an example to see how it's done. This code is for a web page with multiple buttons that, when clicked, change the background color of the page. In terms of the HTML structure, notice here the web page has multiple buttons, each corresponding to a different color. When the button is clicked, the change color function is triggered, passing the respective color as an argument. To achieve this, JavaScript function updates the background color of the web page. The change color JavaScript function accepts a color parameter and sets the background color of the body element using document.body.style.background_color. This function is triggered by the onClick attribute in each button on the HTML page. When a button is clicked, it calls change color with a specific color value. So, when the red button is clicked, you get this change. The same goes for green, blue, and yellow. In this video, you've learned that by selecting, modifying, and updating DOM elements, you can create dynamic and interactive websites that respond instantly to user input and events. This is crucial because it enables web pages to provide a seamless, real-time experience for users, allowing content and styles to change instantly based on interactions without needing a page reload. With these skills, you're ready to bring your web pages to life and make them truly interactive. Every effective program is built on smart control, deciding when to take certain actions and how often to repeat them. In real-world applications, this capability is crucial for tasks like validating user information, managing inventory, or automating routine calculations. In this video, you'll learn how conditional statements and loops in JavaScript give you this flexibility, enabling you to create dynamic, responsive programs. Managing decision-making in a program is essential. Conditional statements such as if, and else allow you to execute certain blocks of code only when specific conditions are true. For example, in a voting application, conditional statements can determine whether a user meets criteria to proceed. This program is set up to verify eligibility based on whether the user is 18 years or older. If this condition is true, the program outputs "you are eligible to vote." If the condition is false, meaning the user is underage, it outputs "you are not eligible to vote." You could also use else or else if statements for alternative conditions. For example, an else if statement could check if a user is 16 or 17 and display "you are almost eligible to vote." If not, an else statement outputs "you are not eligible to vote." Just as conditional statements control the flow of a program based on specific conditions, loops provide another form of control by allowing you to repeat a block of code multiple times until a certain condition is met. This is particularly useful for tasks like iterating through lists or performing repeated calculations. One of the most commonly used loops in JavaScript is the for loop, especially useful when you know the exact number of repetitions. The for loop needs 3 elements to run effectively: a starting value for the loop variable to initialize it, a condition that keeps the loop going as long as it's true, instructions to update the loop variable after each iteration. For example, this loop starts the counter at 1 and continues running as long as the counter is less than or equal to 5. After each iteration, the counter is incremented by 1. The loop then prints the current iteration number, resulting in the following output. A real-world task can demonstrate the challenges that conditional statements and loops are designed to solve. Imagine you're creating a program to calculate and display a student's grade based on their average marks. To achieve this, a program can use a loop to process marks and conditional statements to assign a grade. First, we define an array of marks representing the scores of 5 subjects. A for loop then iterates over the array, adding each subject's mark to the total. Once the loop completes, we calculate the average by dividing the total by the number of subjects with marks.length. Using if, else if, and else statements, the program assigns a grade based on the calculated average: A for an average of 90 or above, B for between 80 and 89, C for between 70 and 79, and F for an average below 70. The program then outputs the average marks and assigned grade. With the right conditionals and loops, it's set up to automate calculations and handle basic decision-making. In this video, you've learned how conditional statements like if and loops like for are essential tools that control the flow of JavaScript programs. If statements allow you to execute code based on specific conditions, while for loops handle repetitive tasks like iterating through arrays. Together, these constructs enable you to tackle practical problems, such as calculating grades based on a student's marks, as well as filtering data, managing inventories, and validating user inputs in real-world applications. With your experience in Java, you're well equipped to apply these concepts in JavaScript, bringing powerful logic and control to your code. Form validation is an essential aspect of web development. It ensures that users enter the required information in the correct format before submitting data. JavaScript enables client-side validation, enabling you to check input values and provide instant feedback to users without reloading the page. One common validation task is checking whether required form fields are left empty and displaying an error message if they are. In this video, you'll explore examples of how to use JavaScript for simple form validation with an empty input check, how to validate a user's password and confirm it in a registration form, and gain an understanding of how JavaScript processes these validation steps. It's time to get started. First, let's examine how to use JavaScript to validate form inputs. To validate a form field, you can check if the input value is empty or does not meet specific requirements when the user tries to submit the form. This prevents incomplete form submissions and improves data quality. To gain a better understanding, let's explore an example. Let's create a form where the user is required to enter their name and email. If either field is left empty, JavaScript will display an error message and prevent form submission. First, the index.html file contains the form's HTML structure with links to the CSS and JavaScript files. Next, the style.css file defines the CSS styling for error messages, making them red in color. Finally, the script.js file contains the JavaScript validation logic that checks if required fields are empty and displays error messages. The final output should display like this. Now let's explore a real-time example that demonstrates validating a user's password and confirming it in a registration form. This example checks whether the password and confirmation password fields match and meet specific length requirements. If they don't, an error message is displayed. The requirements are as follows. First, the password field should not be empty and must have at least 8 characters. Next, the confirm password field must match the password field. And finally, error messages are displayed if any of the above conditions are not met. The HTML file is used for form structure. The CSS file is used for error message styling. And the JavaScript file is used for validation logic. Let's examine the process in more detail, starting with the HTML structure. The form contains 2 password fields, one for the user's password, ID equals password, and one for confirming the password, ID equals confirm password. Next to each field is a span, with the class error to display validation messages. Next is the CSS styling. The dot error class styles the error messages in red, making them visible and easy to notice. And finally, there's the JavaScript validation logic. The validate form function is triggered when the form is submitted. It retrieves values from the password and confirm password fields. It first checks if the password is empty or has fewer than 8 characters and displays an error message if either condition is true. Then it checks if the confirm password value matches the password value, showing an error if they don't match. If either check fails, return false prevents the form from submitting. Here's how it works. When the user fills in both password fields and clicks register, the JavaScript function validate form is called. This function performs 2 main checks. It ensures that the password is at least 8 characters in length, and it confirms that both passwords match. If either validation fails, an error message displays next to the offending field or fields, and the form doesn't submit until the errors are corrected. In this video, you learned that validating form inputs using JavaScript enhances user experience by providing immediate feedback, reducing submission errors, and ensuring data integrity. By using JavaScript to check for required fields, input length, and matching values, developers can create responsive, user-friendly forms. In this example, password validation not only improves security by enforcing a minimum length, but also prevents user frustration by confirming both fields match before submission. Mastering client-side validation equips developers with essential skills to build interactive and secure web applications that align with user expectations and streamline the data entry process. With these essential JavaScript validation skills, you're ready to improve data accuracy and user experience on your forms. By applying what you've learned, you'll build forms that not only prevent errors, but also provide a smooth, interactive journey for users. Congratulations on completing this foundational module in front-end development. In this module, you've laid the groundwork for front-end development by creating interactive and responsive web pages with HTML and CSS. These skills are fundamental because they shape both the look and structure of any web application, ensuring your pages are not just functional, but also intuitive and engaging for users. Let's take a moment to reflect on the key concepts and techniques you've gained in this module and why they're vital to your future as a web developer. You began by learning the fundamentals of HTML, the language that structures every web page. From crafting simple headings and paragraphs to building more complex elements like lists, links, and tables, you've seen how HTML forms the backbone of web content. Each tag serves a specific role, whether it's creating a list, adding links, or organizing information. These foundational skills enable you to structure any web page in a way that's not only logical, but also accessible and engaging for users. Next, you expanded on these basics by incorporating images and forms into your web pages. Images bring your content to life, making it visually dynamic, while forms enable essential user interaction. You learned how to use the image tag to embed images and designed intuitive forms using form, input, and button tags. These tools are essential to creating interactive, user-focused websites where visitors can seamlessly engage with your content and submit data. But building a web page is more than just content. It's also about style and creating a positive user experience. That's where CSS comes in. You learned how to style your HTML elements using CSS selectors and properties, transforming basic page structure into something polished and visually appealing. Whether you're selecting the right colors and fonts, aligning text, or adding background images, CSS enables you to create pages that are not only functional, but also aesthetically engaging. With inline, internal, and external style sheets, you also discovered how to organize your styles efficiently, ensuring that your code remains clean and manageable. As you progressed, you moved beyond aesthetics and tackled responsive design, ensuring your web pages look great on any device, whether it's a desktop, tablet, or smartphone. Using media queries and responsive techniques, you ensure that your layouts seamlessly adapt to different screen sizes, delivering a smooth and consistent experience across platforms. And of course, layout plays a huge role in the user experience. You gained valuable insight into the CSS box model, mastering how to control spacing, margins, borders, and padding to create well-balanced and structured designs. From there, you advanced to more sophisticated layout techniques, using Flexbox and CSS Grid, powerful tools that enable you to build flexible and responsive web layouts. These techniques are essential for creating visually dynamic and intuitive pages that respond effortlessly to any screen size, giving users a consistent experience no matter how they access your site. In the final part of this module, you added interactivity to your web pages using JavaScript. This is what brings your static HTML and CSS to life, allowing you to create dynamic and responsive user experiences. You started with the basics of variables, data types, and functions, which are essential for performing operations and managing data. From there, you learned how to use functions and handle events like button clicks, making your pages more interactive. A primary focus was on DOM manipulation, where you changed the content and structure of your web pages in real time based on user input. You also implemented form validation to ensure data is input correctly before submission, improving user experience and data integrity. By adding these skills to your toolkit, you've equipped yourself to build highly interactive, dynamic websites that respond seamlessly to user actions. This module focused on front-end development, equipping you with the skills to structure content with HTML, style it with CSS, and add interactivity using JavaScript. You're now able to build web pages that not only look great, but also engage users effectively. As you continue through this course, these foundational skills will be essential as you dive into back-end development and learn how to integrate your front-end work with robust, scalable applications. Congratulations once again on completing Module 1. Keep building on what you've learned, and you'll continue growing as a full-stack web developer. Picture yourself at a restaurant. You place an order and your meal arrives swiftly, thanks to a well-organized system. Similarly, Java server technologies efficiently power web applications, managing tasks behind the scenes. The client-server model is like placing an order at a restaurant. You're the customer and the kitchen is the server. As the client, you request food from the server by ordering from the menu. The kitchen processes your order, prepares the food, and delivers it back. This interaction works smoothly because you and the kitchen understand the menu and the ordering process. A client, whether it's a web browser on your PC, smartphone, or laptop, requests services or data from a server. On the other hand, a server is a machine or software that provides services or data to clients, such as a web server hosting websites. Bear in mind, one of the most widely used server-side programming languages is Java. To start, let's discuss Java server technologies. These are a set of Java tools and frameworks that allow developers to build dynamic web applications. These technologies help create web apps that can interact with databases, process user inputs, and generate real-time content instead of serving static HTML pages. You'll cover the three main technologies: Java Servlets, Java Server Pages or JSP, and Spring or Spring Boot. In this analogy, the waiter acts like a servlet, taking your order and sending it to the kitchen. The kitchen, like Java server-side technology, processes the order using ingredients, similar to how a database provides the data. Java Servlet is Java's first ever server-side web technology. Servlets are Java classes that run on a server and handle client requests. They basically handle the behind-the-scenes logic of web applications. When a user sends a request, the servlet processes it, interacts with the database if necessary, and returns a response to the user's browser. Let's explore how it works. First, the user sends HTTP requests to the web server. Next, the server gathers data from the database and creates a web-friendly HTML response. Then the response created by the servlet is sent to the client browser through HTTP response. A Java servlet supports all the client-server protocols, but is often used with Hypertext Transfer Protocol or HTTP, a set of rules for web communication, such as requesting and delivering web pages. Let's take a moment to go over a few things you need to know about Java Server Pages or JSP. JSP or Java Server Pages helps create dynamic web applications. It's an extension of servlets, offering more functionality and flexibility for building web pages with both HTML and Java. JSP is also an HTML-based compilation code, and a JSP page consists of HTML tags and JSP tags. A JSP is slower than a servlet, because the first step in the JSP lifecycle is translating it to Java servlet code and then compiling it. And finally, JSP only accepts HTTP requests. In this instance, the client navigates to a .jsp file, and the browser sends a HTTP request to the web server. If the JSP has already been compiled, the web server returns it. If not, the request is sent to the JSP engine, which is identified by the .jsp extension. Then the JSP engine converts the JSP file into Java servlet code. Next, the JSP engine compiles the Java code into a .class file, which is then passed to the servlet engine. Once that's done, the servlet engine runs the .class file, generates a HTML response, and returns it to the web server. And finally, the web server sends the HTML response back to the client's browser. In the restaurant analogy, Spring is like the entire restaurant management system. It coordinates everything from taking customer orders, communicating with the kitchen, handling ingredients from suppliers, and managing staff efficiently. As applications grow, managing servlets and JSP pages directly can get complicated. That's where Spring and Spring Boot come in to make things simpler and more manageable. A framework provides the essential infrastructure needed for developing applications. The Spring Framework, specifically, is a Java platform that takes care of this infrastructure, allowing you to focus on building your application's features without worrying about the underlying complexities. Spring Framework has several features, making programming Java quicker, easier, and safer for everybody. With Spring, developing web applications has become quite easy compared to the classic application programming interfaces or APIs, Java Server Pages or JSP, Java Database Connectivity or JDBC, and Java Servlets. Spring Framework adopts new techniques to build enterprise applications, such as plain old Java Object or POJO, aspect-oriented programming or AOP, and dependency injection or DI. Specifically, Spring Boot builds on the Spring Framework. It's an open source Java tool that speeds up the setup, configuration, and running of applications, making it ideal for web apps. Think of Spring Boot as a powerful combo. It combines the Spring Framework with embedded servers, meaning everything you need is built right in. Not only does it give you flexibility, but it also helps you write less code, making it one of the simplest ways to build a web application. Spring Boot also makes it easy to launch applications. You can package your entire application, including a small built-in web server, into a single file and deploy it with minimal configuration. This ease of deployment makes Spring Boot a popular choice for modern Java web applications. Let's check out some real-world examples using Java server technologies for the large-scale applications you interact with daily. Websites like Amazon and eBay use Java server technologies to manage user sessions, process orders, and interact with large databases. Platforms like LinkedIn rely on Java to manage the dynamic content you see when you log in, such as your newsfeed, profile updates, and connection requests. To sum up, Java server technologies like servlets, JSP, and Spring Boot drive dynamic web apps. Spring Boot simplifies development, allowing for quick, scalable apps. These tools are key for handling user requests and managing data effectively. Remember the restaurant analogy in the previous video? You gave your order to the waiter and they passed it on to the kitchen. The chef prepared your meal and the waiter served it. Each part, waiter, kitchen, and your meal, played a role. They worked together seamlessly. This is just like how software development works with MVC architecture. MVC, or Model View Controller, divides an application into three interconnected parts: Model, View, and Controller. Each part handles a different aspect of the app's development. The model is the backend that contains the data and logic. It stores data and its related logic. The model is also responsible for handling requests from the view and controller and for updating itself. It is primarily used to keep program instructions or logic separate from the application data. The view is the front end or the interface the user interacts with. It displays all or a portion of the data provided by the model in a user-friendly way. The controller is the brain of the application. It handles interactions between the model and the view. It processes requests, retrieves data from the model, and updates the view. The controller transfers a command to the model to update itself. It also manages the HTTP requests raised by the user and the view. Let's break down this MVC architecture process. First, the user makes a request through the view, like a web page or app interface. The view then sends the request to the controller. The controller handles the request and decides what data or operations are needed. It then communicates with the model. Subsequently, the model interacts with the database to retrieve or manipulate data. And, once the model has the data or result, it sends the data to the controller. Next, the controller passes the data or result to the view for presentation. Finally, the user is presented with a response. This separation of concerns is the strength of MVC. It helps developers manage complex applications by breaking them into smaller, manageable components. By keeping the front end and back end separate, MVC makes web applications scalable and maintainable. Each part can be updated independently. For example, let's say a user requests a list of students through a web interface. That request is sent to the controller. The controller then asks the model for that list. Following this request, the model retrieves the data from the database. Next, the model sends the retrieved student list to the controller, which then sends it to the view to present it. Finally, the view formats the list as HTML for the browser and then sends the response back to the user, concluding the request-response cycle. This request-response cycle happens smoothly because each part, model, view, and controller, works independently but communicates through well-defined interfaces. MVC architecture makes maintaining code simpler and allows for easy expansion. Since each component, model, view, and controller handles different tasks, they can be worked on at the same time. This division helps reduce the complexity of applications. That being said, MVC isn't the best choice for small applications. The structure can be harder to read, modify, or reuse, and developing with MVC can add unnecessary complexity when working on smaller projects. In summary, MVC is a game changer for keeping your code clean, organized, and scalable. As you take on future projects, MVC will not only streamline your workflow, but also boost your application's performance, making development smoother and more efficient. Imagine you're running a coffee shop. Everyday customers come in to order their favorites: espresso, lattes, pastries, you've got it all. But keeping track of everything, that's another story. You need a way to organize the details of each product, like its name, price, and maybe even a unique item code. So, how would you do that? Well, in Java it works the same way. You organize data using a model class. Today you'll dive into creating a simple model class to represent a product, kind of like the items on your coffee shop menu. By the end of this video, you'll know how to manage the data of your products and keep your app just as organized as your coffee shop. Just like running a coffee shop, you have to organize your data when building an application. One popular way to do this is to use the MVC pattern, Model View Controller. The model is like the back end of your shop. It manages and organizes your data, in this case, your products. The model is only concerned with storing and processing data, such as your coffee shop items, names, prices, and IDs. It doesn't handle how the menu appears to customers. That's the job of the view. Let's think about how you might represent each product in your coffee shop using a model class. A model class is like the blueprint for your products, defining all the essential details, such as the product's ID, name, and price. To start, you'll set up a Spring Boot project. Spring Boot makes it easy to build Java applications and has a specific structure that helps you organize things, including your coffee shop products. By now, you already know how to set up a new project with Spring Initializer. So, let's create a new one with Maven as the build tool, Java as the language, the latest stable version of Spring Boot that is not a snapshot, com.coffeeshop as the group, menu as artifact, coffee shop menu as the name, and a brief description of your choice. The package name is automatically set using your group and artifact name. Remember to select the packaging as jar and the latest stable of Java, such as 21. Also, don't forget to add the Spring Web dependency. Now click Generate, and Spring Initializer downloads a compressed file with your new project, named menu.zip. Unzip it and open it in IntelliJ. Observe that Spring Boot organizes files in a specific way. The main folder contains an SRC directory, where all your Java code goes. Inside SRC, a package structure holds your models, controllers, and more. In this folder, you'll find the main application file, Coffee Shop Menu Application, which is the starting point for running your app. Now you're ready to create your model class to represent each product on your coffee shop menu. Think of each item on your coffee shop menu as a product. It has a unique ID, a name, and a price. In Java, a model class helps define these details clearly, so you know exactly what information each product will hold. Okay, let's create a new package called model to store your data structures. Right-click on the com.coffeeshop.menu package, select New, then click on Package. Without deleting the package name already present in the resulting pop-up, name your package as Model. Then press Enter to create it. Next, right-click on the model package and create a new class named Product. After that, create 3 private fields in the product class representing the ID, an integer value, the name, a string, and the product's price, a double value. Each of these fields represents information about a product on your menu, such as an espresso or croissant. From here, define a parameterized constructor to initialize these fields when creating a new product. Right-click inside the class and select Generate. From the resulting pop-up, select Constructor. Then select all the fields and click OK. This constructor ensures that each product has an ID, a name, and a price right from the start. Moving on, let's add getter and setter methods to the product model class. Right-click inside the class again, select Generate, and this time select Getter and Setter from the resulting pop-up. Then select all the fields and click OK to generate the getter and setter methods for them. Getters and setters allow you to access and modify the values of these fields from outside the class. Think of them as a way to update or retrieve details, like changing the price of a coffee item. Great job! Your product model is now ready. Time to test it by creating a few products representing items on your coffee shop menu. Open the coffee shop menu application. Inside the main method, after line 10, start typing product. IntelliJ suggests importing the product class from the model package. Press Enter to accept. Name the product Espresso and initialize it with the values 1 for the ID, Espresso for the name, and 2.99 for the price. Now let's create another product called Croissant and initialize it with the values 2 for the ID, Croissant for the name, and 3.49 for the price. Next, add println statements to display the details of both products, getting the getter methods for each field. Once that's done, run the application and wait for the Spring Boot project to start. Notice the last 2 lines in the Run window, which print out each product's details, like displaying items from a digital coffee shop menu. This output shows the details of each product you created, verifying that your model class works as expected. You can add more items to the menu by creating new product objects. Model classes, like your product classes, are key to keeping your data structured and organized in Java applications. By defining fields, constructors, and getter-setter methods, you ensure your data is well organized and easy to manage and update. In a Spring Boot application, this model class lays the groundwork for the data layer, allowing it to seamlessly interact with other parts of the app, like controllers and views. This setup is crucial because it ensures your app runs smoothly and can scale efficiently. Having a strong foundation like this saves you time and effort when adding new features or managing changes in your data. Opening a new cafe is a daunting experience. The customer experience needs to be excellent and without glitches. Therefore, you have to anticipate any problems that might arise by putting yourself in the customer's shoes. Quality checks are thus essential. For example, shelves should be stocked, prices displayed, and every item in the right place. The store needs to be in perfect condition for a lasting first impression, right? In software development, the Spring Validation Framework does something similar for your applications. It's the quality check that ensures any data coming into your app is complete, correctly formatted, and ready to be processed so your app runs smoothly and error-free. Although the Spring Validation Framework simplifies checking the validity of incoming data, you must follow and define specific rules. For example, if you have a form where users must enter their age, the validation framework can enforce that only valid numbers within a specific range are accepted. The mistake is caught in time if a user tries to enter text or an unrealistic number. To enable validation in your Spring Boot project, start by adding a validation dependency to your pom.xml file. Spring Boot provides several annotations from the jakarta.validation.constraints package, which you can use directly on fields for validation. First, the @NotNull ensures that a field or array is not null, though it can be empty. Second, the @NotEmpty ensures that a field or array is not null and is also not empty. Third, the @size specifies a minimum or maximum length for a field. And fourth, the @min enforces a minimum value for a numeric field, while @max enforces a maximum value for a numeric field. Let's get back to the coffee shop menu project to add all the validations to the controller file. If we try to violate the input field constraints, the custom messages will be displayed like this. In this video, you explored how the Spring Validation Framework supports data integrity in applications. Through simple annotations, automated error handling, and customizable messages, Spring Validation makes it easy to apply rules to user-provided data. This approach results in cleaner code, a more secure application, and an enhanced user-friendly experience. With Spring Validation in place, you can trust that all data entering your app is thoroughly checked, like a well-prepared store ready to welcome customers. Imagine you're setting up a new office. Traditionally, you'd have to find a building, buy furniture, install lighting, and configure the internet before you could even start your actual work. This process is time-consuming and distracts from your real goals. Now, picture a service that provides a fully furnished, ready-to-use office where you can walk in and get to work immediately, with no setup required. Spring Boot offers a similar approach for Java applications. Before Spring Boot, building a Spring project required extensive manual configuration, which was tedious and time-consuming. Spring Boot simplifies the entire process by offering pre-configured templates and an automated setup. It allows you to focus on building your application without worrying about all the underlying setup and configuration. Before Spring Boot, developers using Spring Framework had to manually configure most aspects of their applications, from XML configuration files to managing dependencies. While Spring was powerful, it required a lot of boilerplate code and setup. Boilerplate code refers to reusable sections of code that require minimal modification to fit various contexts. The term comes from the printing industry, where boilerplate refers to the pre-made metal plates with standard text that could be reused in different publications, similar to how templates are used for different scenarios. In 2014, Pivotal introduced Spring Boot to solve these problems. Pivotal is a software and service organization known for developing tools to streamline the creation of cloud-native applications. The Spring Boot framework embraces convention over configuration, meaning it assumes sensible defaults for most setups, allowing developers to get started with minimal effort. The goal was to simplify development, reduce boilerplate code, and create a more seamless integration between coding, configuration, and deployment. Let's explore the key features of Spring Boot. First up is its auto-configuration. This feature automatically configures your application based on the dependencies you include, eliminating the need for long configuration files. For example, if you include a database dependency, Spring Boot will automatically configure a connection to that database without you needing to write any additional setup code. Auto-configuration speeds up development by reducing the amount of manual work required to get an application running. The next key feature of Spring Boot is its embedded servers. Before Spring Boot, developers had to manually set up and configure external servers like Tomcat or Jetty to run their web applications. Embedded servers allow you to bundle the server directly with your application. Whether you use Tomcat, Jetty, or Undertow, Spring Boot handles the server configuration for you. This means your application can be packaged as a single jar or WAR file, which you can run directly without installing or configuring an external server. Spring Boot also provides starter dependencies that bundle commonly used libraries and tools. These starters, such as Spring Boot Starter Web or Spring Boot Starter Data JPA, are pre-configured to speed up development. Instead of searching for individual libraries and handling version compatibility, you simply add the appropriate starter and Spring Boot pulls in everything you need. Spring Boot offers Spring Initializer to simplify starting new projects. This web-based tool helps you generate a project structure quickly by selecting your Spring Boot version and the dependencies you need. You can then download a ready-to-go project, which saves you from manually setting up the structure. Spring Initializer is a quick and convenient way to kickstart development without worrying about initial setup. Spring Boot is not just for development, it's designed with production in mind. It includes features like externalized configuration, which allows you to manage settings like database URLs or API keys outside your code. This makes it easier to adjust settings across environments, such as development, staging, and production, without changing the code. One of Spring Boot's most powerful production-ready tools is the Spring Boot Actuator. Actuator provides built-in endpoints to monitor your application's health, track metrics, and expose key information about your app. For example, a simple HTTP endpoint allows you to access metrics like memory usage, request counts, or database connection details. These features make it easier to manage and monitor your application once it's deployed and provide crucial insights for maintaining performance and stability. Finally, the last feature you will learn about today is Spring Boot's dependency management. Managing dependencies can be challenging in large Java applications. Spring Boot simplifies this with its dependency management system. Spring Boot manages version compatibility between libraries through a bill of materials or BOM, ensuring that all dependencies work well together. When you include a Spring Boot starter, you don't have to worry about resolving version conflicts. Spring Boot takes care of it for you. In this video, you learned about Spring Boot and its key features. It simplifies application setup with auto-configuration, embedded servers, and pre-configured starters. You can set up and start working on your application within minutes. Spring Boot packages your application with an embedded server, so you don't need to configure external servers like Tomcat or Jetty. Actuator and externalized configuration make it easier to monitor and adjust your application in different environments, supporting smooth transitions from development to production. Finally, Spring Boot ensures that all your dependencies work well together, reducing the likelihood of version conflicts and compatibility issues. Spring Boot has changed the way developers build Java applications by streamlining configuration, reducing boilerplate code, and making it easier to get started. With embedded servers, auto-configuration, and excellent production-ready features, you can focus more on writing business logic and less on setting up infrastructure. Whether you're new to Spring or a seasoned developer, Spring Boot is a powerful tool that makes Java development faster, easier, and more efficient. Imagine you're driving up to a drive-thru window at your favorite fast food restaurant. You place your order by speaking into the microphone, and a few moments later you get your food from the window. In this interaction, you're making a request and the restaurant is providing a response. This is a lot like how RESTful web service works. In software development, a RESTful service listens for requests from clients, like your order at the drive-thru, and sends back a response, like your food. Creating these RESTful services using Spring Boot is straightforward because the framework does a lot of the heavy lifting for you. Previously, you have learned about RESTful services. Now you're going to create a simple REST controller in your Spring Boot project that responds to a request with a welcome message. REST controller is a Java class that handles HTTP requests, like GET, POST, etc., and responds in a standard format like JSON. Spring Boot makes it easy to create these controllers using built-in annotations like @RESTController and @GetMapping. In your Spring Boot project, navigate to the src/main/java/org.amazon.example package and create a new Java class named Welcome Controller. Open the Welcome Controller class and add the code from the Solutions Lab. The @RESTController annotation tells Spring Boot that this class will handle HTTP requests. It automatically converts the return values of methods to JSON, making it easy for clients to consume the data. The @GetMapping, open bracket, quote, /welcome, quote, close brackets, maps the HTTP GET request to the GetWelcome message method. This method is used when a user visits the /welcome URL on your server. The GetWelcome message method returns a welcome message as a response in JSON format. Run the application and on a browser, try to access http://localhost:8080/welcome. This output shows the welcome message. Spring Boot takes away much of the complexity of creating RESTful web services by providing built-in annotations, like @RESTController and @GetMapping, which handle a lot of the setup for you. In addition, it automatically configures your project so you can focus on writing your application logic instead of boilerplate code. And finally, Spring Boot effortlessly converts your Java objects into JSON, which is a standard format for API responses. Creating RESTful services in Spring Boot is as easy as placing an order at a drive-thru window. With just a few lines of code and the help of Spring Boot's built-in tools, you can quickly set up endpoints that respond to requests in a clean, structured way. By using simple annotations like @RESTController and @GetMapping, you create a clear path for your application to handle requests and send back responses. This makes your web services easier to understand, build, and scale. Now that you've mastered the basics, you're ready to expand your Spring Boot project into a full-featured RESTful API. Imagine you're running a busy restaurant. In the kitchen, the chef is in charge of preparing dishes according to specific recipes and ensuring the food is perfectly cooked. The chef's expertise in food preparation is much like the business logic in a web application. It's where the core work happens, transforming raw ingredients into a complete meal. Meanwhile, in the dining area, the waitstaff focuses on taking orders and delivering dishes to the customers. They don't handle any of the cooking, but instead serve as the link between the kitchen and the customer. In web development, the waitstaff's role is similar to the controller, which simply passes requests to the business logic and returns responses to the user. By keeping these roles separate, the chef focusing on the cooking and the waitstaff handling orders and delivery, the restaurant runs smoothly and efficiently. Likewise, in full-stack development, a service layer allows the controller to focus on handling requests, while the business logic manages complex operations behind the scenes. This clear separation of duties keeps the application organized and allows each component to work efficiently without overlapping responsibilities. In the same way, when building a Spring Boot application, you separate the business logic from the controller by creating a service layer that focuses on handling the core logic of your application. In this video, you are going to learn how to create a simple service in your Spring Boot project that encapsulates the value of the welcome message from the controller. In your Spring Boot project, navigate to the src/main/java/org/amazon/example package. Create a new Java class named Welcome Service. Open the Welcome Service class and create a Welcome Service class annotated with @service having getWelcomeMessage method, which returns the welcome message string, Welcome to the Spring Boot REST API. Let's explore the code. The @service annotation marks the class as a service component, indicating that it contains the business logic of your application. Spring Boot will automatically manage this class as a bean, an object that is instantiated, assembled, and managed by a Spring IOC container, making it available for use throughout the application. The getWelcomeMessage method contains the logic that returns the welcome message. Keeping this logic in the service layer allows you to maintain a clear separation between the logic and the controller. Now let's explore how to use the service in the controller. Update the Welcome Controller class by opening and modifying it to use the new Welcome Service. The @AutoWord annotation tells Spring Boot to inject the Welcome Service dependency into the Welcome Controller class automatically. This process is called dependency injection, and it helps manage the connections between different parts of your application without you having to create the objects manually. You use the constructor to inject the Welcome Service into the controller. This is a preferred method because it makes the dependency explicit, promoting better testing and cleaner code. Now run the application, and on a browser try to access http://localhost:8080/welcome. This output shows the welcome message. So why use a service layer? Here are 3 essential reasons why. The first is separation of concerns. Separating the business logic from the controller keeps your code organized and easier to understand. The second is reusability. The service layer can be reused across multiple controllers or other parts of your application. Finally, it results in cleaner code. The service layer promotes cleaner code by keeping the controller focused on handling requests and delegating the core logic to the service layer. In this video, you learned that creating a service layer in your Spring Boot application is like bringing in a chef to handle the cooking in your restaurant, while the waitstaff focuses on serving customers. This separation of responsibilities leads to a smoother operation and cleaner code. By using dependency injection with the @auto-wired annotation, you connect your service to the controller effortlessly, making the code more modular and easier to manage as your application grows. Great job! You've now taken a big step towards building a well-structured Spring Boot project. You drop into a small local shop to buy 3 items, but only one is available because the shopkeeper hasn't restocked the shelves. Then when you get to the checkout, they've left the till unattended so you can't pay. A little irritated, you decide that you might not be a repeat customer. The shopkeeper should have avoided the issues you experienced. In the digital world, an e-commerce application needs the same kind of care. If you open an online store, you need to ensure that all available products are displayed and that customers have a safe and secure way to pay and purchase items. There are 3 features that can enhance your e-commerce platform's functionality, security, and monitoring. These are Spring Security, Spring Data, and Spring Boot Actuator. Let's explore these in more detail. Transferring sensitive data on the internet carries an inherent risk. So, in an e-commerce store, security is everything. In your application, you need to ensure that only authorized users can access sensitive areas, like payment details or customer information. Spring Security functions like a security system for your online store. It can handle authentication and confirm that the user is who they say they are. It can also deal with authorization, making sure users have permission to do what they're trying to do. It can manage user roles, encrypt sensitive data, and even defend against attacks. For example, it protects against cross-site scripting, where malicious scripts are added to content on trusted websites, or session hijacking, which is often referred to as cookie hijacking. This compromises a session and allows an attacker to take over an internet session by stealing the session token. So when a user logs into their account on your online store to place an order, Spring Security is working to protect their information and safeguard your store. It ensures that only users with the correct credentials can log in and that they are accessing the correct account information. It also ensures that the user can view only their own information. As you expand your online store, wouldn't it be good to have a digital assistant who keeps track of everything happening in your store, so you can focus on the big picture instead of worrying about every individual transaction? Spring Data can help your e-commerce application store and manage its data efficiently. Spring Data simplifies database operations. It makes it easy for you to work with various types of databases, such as MySQL or MongoDB. With Spring Data, you avoid having to write code to do this. With Spring Data, you can quickly save, update, and retrieve data, such as customer information, order histories, and product inventories. A satisfied customer on your online store has just added a product to their cart. Behind the scenes, Spring Data takes care of storing that cart information in the database. Because of this, it's ready when the customer proceeds to checkout. The store owner you encountered earlier had a lot of physical details to keep track of in their store. Where the customers were coming in, if the cash register, lighting, or air conditioning was working. Spring Boot Actuator monitors your e-commerce application to make sure your online store runs smoothly. Spring Boot Actuator provides a set of tools for monitoring and managing your app in real time. It provides insights into how your application is performing. It presents information such as memory usage, active user sessions, whether the servers are up, or if there are any problems you need to fix. For instance, if your site experiences a sudden spike in traffic during a sale, Spring Boot Actuator can alert you to potential slowdowns or crashes, allowing you to take action before your customers notice any issues. These tools can be invaluable because in a real-world e-commerce platform, security, data management, and monitoring are critical for smooth operations. Spring Security ensures that your customers' sensitive information, like payment details, is protected from hackers and unauthorized access. Spring Data allows you to efficiently manage large amounts of product and customer data, helping you provide a seamless shopping experience. Spring Boot Actuator helps you stay on top of your application's health, ensuring that your store remains operational and responsive even under heavy traffic. These 3 tools will help you build an e-commerce platform that functions smoothly. They will also play another important role, which is to improve the customer's experience by making them feel secure and cared for. In this video, you were given an overview of the 3 advanced features available in Spring Boot: Spring Security, Spring Data, and Spring Boot Actuator. You explored the importance of these features in real-world applications and examined how they can enhance functionality, security, and monitoring. Together, these tools provide the foundation for a robust, secure, and well-functioning e-commerce platform. Using them will help you deliver a great experience to your customers. By leveraging these Spring features, you can confidently scale your store and meet the demands of a fast-paced, competitive online marketplace. It's your afternoon off and you're in your favorite computer game store in the mall. The game you want isn't on the shelf. Do you rush behind the counter, go into the storeroom and start rummaging around? No, of course you don't, because stores have areas where customers aren't allowed. Only staff members can access areas such as the storeroom or the cash register. Similarly, in your e-commerce application, not every user should have access to all areas. Some actions, like viewing sensitive customer data or managing inventory, should be restricted to authorized users. This is where authentication and authorization come into play. In this video, you'll learn what these terms mean. You'll also explore how to set up Spring Security and use basic authentication to protect certain parts of your application. Doing this will ensure that only authorized users can access those areas. First, what is meant by authentication? Authentication is the process of verifying who a user is. In essence, it's similar to checking someone's ID before they enter a restricted area. For example, in the game store mentioned earlier, you would have to have a staff ID badge to go into the storeroom to find something. Next, what does authorization mean? Imagine that not every member of staff can process refunds or cancel orders. This is because they don't have the authorization to carry out those tasks. Authorization determines what an authenticated user can do. This means that even if someone is identified and authenticated, they may not be allowed to do certain things, such as managing orders or accessing sensitive information. This is true in both a physical store and in an online scenario, such as your e-commerce application. Let's explore a step-by-step example of how to add Spring Security and configure basic authentication. Basic authentication involves sending a username and password with each request to confirm a user's identity. First, reopen the project begun in the item, adding a service layer in the previous lesson. Using Maven, open the pom.xml file and add this dependency. Type open angle bracket dependency close angle bracket, then open angle bracket group ID close angle bracket org.springframework.boot open angle bracket / group ID close angle bracket. Next add open angle bracket artifact ID close angle bracket spring boot starter security open angle bracket / artifact ID close angle bracket. Close with / dependency. By default, Spring Security will secure all endpoints, requiring authentication to access any URL. Let's configure basic authentication in a simple way. First, create a class called securityconfig in src /main /java /org /amazon /example package to configure security settings. In this configuration, all users are being given access to the root URL /. All other endpoints require authentication. Basic authentication is enabled using HTTP basic parentheses. For simplicity, the username user and the password have been used to define an in-memory user. Next, create a simple REST controller called home controller in src /main /java /org /amazon /example to test the security configuration. In this controller, the / endpoint is accessible to everyone. The / secure endpoint is protected and requires authentication. Next, you can now run the application using an IDE. Alternatively, you could execute the Maven command, mvn spring-boot:run. Now let's test the security configuration. open your browser or use a tool like Postman to test the endpoints. Visit http://localhost:8081/. Notice that the message "Welcome to the public page" is displayed without any authentication. Visit http://localhost:8081/secure. You'll be prompted to enter a username and password. Using the credentials of user for username and password for password will allow access. Because the authentication has been successful, the message "You are viewing a secure page" appears. With these simple steps, a basic level of security has been added to the e-commerce application. In this video, you learned how to add Spring Security to a project. It also demonstrated the difference between verifying identity with authentication and granting access using authorization. In addition, it made you aware of how to secure an application with basic authentication to protect specific endpoints. Now your e-commerce application has a basic level of security, ensuring that only authorized users can access sensitive areas. As you continue building your app, you'll likely want to explore more advanced security features, but for now, you're off to a great start. Imagine this. You've set up a physical store from scratch. You've carefully arranged the products and set up a smooth checkout process. And now it's time to open those doors to your customers. In the same way, once you've developed your Spring Boot application and built all its features, the next step is deployment, getting it ready for users in the real world. In the previous reading, you explored how to add Spring Boot Actuator to your project and use its endpoints for health checks, metrics, and performance monitoring. Now that you can monitor your application and keep track of its health, it's time to check out the next step, packaging and deploying it. In this video, you'll dive into creating an executable jar file for your Spring Boot app and explore how to deploy it across different environments, including traditional servers. Alright, let's get started with building your Spring Boot application into an executable jar file. Spring Boot makes this process straightforward by packaging everything your application needs. Yes, even the embedded web server, like Tomcat, into a single jar file. So to make sure Maven builds your project as a jar, you'll need the Spring Boot Maven plugin in your pom.xml file. Don't worry, this plugin is usually already there if you set up a typical Spring Boot project. It takes care of packaging everything, from dependencies to configurations, so you get a fully runnable jar. Once that plugin is in place, you can build the executable jar by running this command in your project directory. Java --jar target /example -0.0.1-snapshot.jar. After Maven finishes building, you'll find your jar file in the target / directory. It'll have a name like example-0.0.1-snapshot.jar. This file contains everything your app needs to run. Pretty cool, right? Now that you have our jar file, let's get it up and running. To start your Spring Boot application using the generated jar, just run java -jar target /example -0.0.1-snapshot.jar. Once you run this command, Spring Boot will automatically start the embedded Tomcat server, and your application will be available on the default port. You can head over to http://localhost:8080 to check out your app in action. With your jar file ready, let's consider different ways to deploy your Spring Boot application. One straightforward option is to copy your jar file to a server, like a cloud server or virtual machine, and simply run it using the java -jar command. This approach is easy to manage, especially for smaller applications, and is ideal if you have a lightweight, standalone app. However, if your organization uses a traditional server setup, say with multiple applications running on Apache, Tomcat, or JBoss, you can deploy your Spring Boot application there too. Even though Spring Boot includes an embedded server, you can package your app as a WAR file to work with traditional servers. To do this, modify the Maven configuration to produce a WAR file instead of a jar. Then run java -jar target /example -0.0.1-snapshot.jar. Now your target directory will contain an artifact named example-0.0.1-snapshot.war. You can deploy this WAR file on a traditional application server like Tomcat or JBoss. This option is great if you're working with an existing server environment or need to run multiple applications on the same server. If you're looking to scale your application easily, deploying on a cloud platform is a fantastic way to go. With your Spring Boot jar ready, you've got some powerful cloud options at your fingertips. First up is Amazon Web Services, or AWS. Here you can use Elastic Beanstalk for automatic scaling. AWS takes care of the heavy lifting, so you can focus on your app. Or if you want more control, you can deploy directly on an EC2 instance. Then there's Heroku, a platform as a service that's especially easy to work with for Spring Boot apps. Just push your code to Heroku and it handles the deployment for you. Simple and effective. And of course, there's Google Cloud Platform, or GCP, where you can use Google App Engine or Compute Engine to get your application live and ready for users. The best part about cloud deployment? It scales automatically with your application's needs, offers straightforward management, and integrates smoothly with DevOps tools. Everything you'd want for a modern, flexible application setup. And that's it. By following these steps, you've successfully packaged your Spring Boot application into an executable jar file, ready for deployment. Now, whether you decide to run it directly on a server, use a traditional application server, or go with cloud platform, Spring Boot gives you the flexibility to get your app up and running in a real production environment. Just like opening the doors of your physical store to customers, deploying your application means users can finally access and use it smoothly. Next up, you'll get the chance to test your knowledge about Spring Boot's best practices and features. Good luck. Congratulations on completing the Java Web Development module. In this module, you strengthened your web development skills by mastering tools and techniques that help you build dynamic, responsive, and secure applications. You explored Java server technologies that streamline web application management, simplify rapid development and deployment, and ensure your applications are secure and dynamic. Let's take a few moments to reflect on your accomplishments and how each topic prepares you for real-world development as a full-stack professional. You began by examining Java server technologies like Java Server Pages or JSP, Java Servlets, and Spring Boot, which are essential for building dynamic, interactive web applications. You now know how to leverage these technologies to power interactive, maintainable, and scalable applications, as they are the backbone of many enterprise-level platforms, from online stores to social networks. Next, you learned the Model View Controller, or MVC architecture, a foundational framework for organizing web applications. MVC separates an application into three distinct components. The model handles data and business logic. The view manages the display of information, and the controller manages the input of information. This structure keeps your code organized and scalable, allowing you to build adaptable and ready for future growth applications. After grasping the fundamentals of MVC architecture, you moved on to setting up your own Spring MVC project using Spring Initializer. With this web-based tool, you configured your project's dependencies, such as Spring Web and TimeLeaf, allowing you to begin building dynamic web applications quickly. You then created a model class representing a to-do item, complete with fields like ID, name, and status to manage and store the relevant data in your application. Next, you developed a controller to manage HTTP requests, linking user interactions to the appropriate model and view. This hands-on experience with Spring MVC laid the foundation for creating fully interactive web applications that respond to user input and display dynamic content. You expanded your skills by learning how to create dynamic views using two versatile templating engines, TimeLeaf, which integrates seamlessly with Spring, and the more traditional JSP. These tools enable your application to render HTML dynamically, providing users with real-time content during interactions. Whether displaying to-do lists or rendering personalized content, these technologies make user interfaces more dynamic and engaging. Handling user input is a crucial aspect of any web application. In this module, you learned how to manage form submissions in Spring MVC. forms that allowed users to add items, such as to-do list entries, and connected form data to model objects seamlessly. A key takeaway was learning how to validate data before processing it. By leveraging Spring's validation framework and using annotations like @valid and @notnull, you ensured that only complete and correct data was submitted. This validation step is essential for keeping your application stable and error-free. Next was Spring Boot, a powerful tool designed to accelerate Java development. Spring Boot eliminates much of the manual setup by providing auto-configuration, embedded servers, and pre-configured templates, making development faster and more efficient. You used Spring Initializer to create a Spring Boot project. You explored its structure, including key files like application.java and application.properties, which allow you to configure your project settings with ease. And remember, you also built a simple REST API with Spring Boot. Now you know how to develop REST controllers that handle HTTP requests and return JSON responses. These skills will be valuable as you build applications communicating with external systems through APIs. In the final part of this module, you focused on some of Spring Boot's more advanced features. You learned how to implement security in your applications by adding authentication and authorization, ensuring that only authorized users can access certain parts of your web app. Another more advanced feature is Spring Data JPA, which simplifies database operations by allowing you to carry out CRUD actions without writing complex SQL queries. This will make all your data management moving forward much more efficient. And to keep your apps running smoothly in production, you also used Spring Boot Actuator to monitor your application's health and performance. Incorporating these advanced features equips you to build applications that are not only secure, but also scalable and easy to manage. The aim of this module was to prepare you for Java web development using MVC architecture and Spring Boot, key tools for creating dynamic, secure, and scalable web applications. These advanced skills will be invaluable as you explore more complex projects with confidence. Congratulations again on completing Module 2 of the Full Stack Web Development course. Keep building, exploring, and enjoy the journey toward becoming a skilled full-stack developer. Think of RESTful services like ordering food at a restaurant. You, the client, place an order, which is your request, and the kitchen, the server, prepares and delivers your meal, the response. In software, REST works the same way. Clients send requests to interact with server resources, and the server processes them and sends back a response, all through HTTP or Hypertext Transfer Protocol. In this video, you'll learn the foundational principles of REST, or Representational State Transfer, its architecture, and how it enables web services to communicate efficiently over the web. Earlier, you learned about traditional Java web applications. These apps are all about generating dynamic HTML pages and managing user interactions through web browsers. They usually track user data using stateful HTTP sessions and rely on tools like servlets, JSP, and Spring MVC for server-side rendering and handling forms. Since they return fully rendered web pages and managed sessions on the server, they're not as scalable as more modern approaches. Let's explore how traditional Java web apps work. Here's a diagram of the flow of a traditional Java web application. Traditional Java web applications primarily focus on generating dynamic HTML pages and managing user interactions through a web browser. This approach emphasizes server-side rendering to deliver the complete user interface. To support user-specific interactions, these applications use HTTP sessions. Sessions enable servers to store and track information, like login credentials, shopping cart contents, or user preferences, allowing the server to maintain continuity between requests. Examples of traditional Java web applications include online stores, banking platforms, and content management systems. These applications rely on servers to process user inputs and render fully structured web pages, combining HTML and CSS. Tools like servlets, JSP, and Spring MVC are commonly used to manage server-side rendering and process user inputs. These tools enable the generation of dynamic content tailored to individual users. When a browser sends a request, such as submitting a form, the server processes the input and responds with a fully rendered HTML page. This cycle ensures that all interactions between the browser and server are managed seamlessly. Despite their effectiveness, traditional Java web applications face scalability challenges due to server-side session management, which complicates horizontal scaling. They prioritize rendering full web pages over exchanging lightweight formats like JSON or XML, limiting their suitability for modern scalable systems. While traditional Java web applications focus on rendering full web pages, RESTful services handle interactions differently. They focus on resource-based interactions and stateless communication. More on that later, but first, what exactly is REST? REST is an architectural style that enables scalable, stateless communication between clients, such as web, mobile, or desktop apps, and server-side resources like data or functionality using HTTP. RESTful services focus on resource-based interactions, where resources are identified by URIs, Uniform Resource Identifiers, and exchanged in formats like JSON or XML. Instead of rendering user interfaces, these services provide APIs for efficient data exchange. Let's explore the core principles of RESTful architecture. These are resource, statelessness, HTTP methods, URIs, resource representations, client-server architecture, and layered system. Let's go through each in more detail. In REST, everything is considered a resource, and these resources are identified by URIs. Each resource is represented in a format like JSON, XML, or HTML. Examples of resources include users, products, and orders. In this diagram, representing the basic interaction between a client and server in a RESTful architecture, a user, product, or order would be treated as a resource. Statelessness is another key principle. RESTful services are stateless, meaning each client request to the server contains all the information necessary for the server to understand and process it, without needing to rely on previous requests. The server does not retain any client state between requests, making the system more scalable. Each request is handled independently of others. Every time you make a request, you send all the information the server needs. It's like ordering a coffee. Each time you tell the barista precisely what you want, without relying on what you ordered last time. HTTP methods are key to RESTful services, as it relies on standard HTTP methods to interact with resources. The key HTTP methods include GET, which retrieves a resource or a collection of resources, POST, which creates a new resource, PUT, which updates an existing resource or creates a new one if it doesn't already exist, and DELETE, which removes a resource. URIs are another key concept in RESTful services. URIs, which uniquely identify resources in REST, should be clear, intuitive, and human-readable. RESTful URIs focus on nouns rather than verbs, representing resources, for example, /users or /products/123, rather than actions. The next key principle is client-server architecture. REST follows a strict separation of concerns between the client and server. The client manages the user interface and user state, while the server is responsible for back-end processing and data storage. Let's consider layered systems next. A layered system organizes components hierarchically to create a scalable, flexible, and maintainable architecture. Each layer has a specific role, and they communicate through standardized interfaces. Layers include a presentation layer, in other words, the front end, the routing layer, the application layer, the service layer, and the data layer. Finally, let's explore resource representation. A resource can have multiple representations, such as JSON, XML, or HTML. Clients and servers communicate using these formats. Resources can be anything from text and images to videos or other media types. This flexibility allows RESTful APIs to serve different types of clients, like browsers that may prefer HTML or mobile apps that often use JSON. RESTful services offer a robust, scalable, and flexible architecture for building web services by adhering to core principles, like resource-based interactions, stateless communication, and the use of standard HTTP methods. URIs uniquely identify resources and can be represented in various formats, such as JSON or XML, enabling seamless data exchange between clients, like web browsers and mobile apps and servers. The client-server model ensures a clear separation of concerns, while the layered architecture supports scalability and maintainability. These features make RESTful services ideal for modern web applications that prioritize simplicity, flexibility, and efficiency. By understanding these principles, you'll be well equipped to design and build scalable, efficient, and modern web applications using RESTful services. Happy coding! Imagine you're on a team building an online electronics store, needing to connect to third-party inventory API. Testing product listings, inventory levels, and orders would require custom scripts or back-end code just to verify the API's response. This approach is slow and error-prone, making early issue detection challenging. But what if a tool lets you interact with the API quickly and easily? No extra code needed. With Postman, you can send a GET request to fetch products and check details like prices and availability. You can also use a POST request to simulate adding products or placing orders. This video shows how to install, configure, and use Postman to send requests to HTTP endpoints. So what is Postman? It's a platform for developing and testing APIs, especially RESTful APIs. Postman offers a simple way to build, test, and document APIs, no coding required. Its interface lets you easily send HTTP requests, check responses, and perform various API testing tasks. To start using Postman, let's install it on your system. To download Postman, visit the official website at www.postman.com/downloads. Here you'll find the correct installer for your operating system. Once the download is complete, go ahead and run the installer. After the installation is finished, the Postman application will automatically start. To sign up for Postman, click the Sign Up for Free button. You can create an account using your email address or Google account. After entering your details, follow the instructions to complete the process. Once you've completed the setup, you'll land on the Postman application's home interface. Good job! You've successfully installed Postman. Now let's explore its interface. When you open Postman, you'll see a few options at the top: the hamburger icon, Home, Workspaces, and API Network. Click on the hamburger icon to access the File, Edit, View, and Help menus. These menus provide options for managing files, making edits, adjusting your view, and finding help resources. In the center, under Get Started, you'll find the Home interface, where you'll find the New Request button. This is where you can start sending and testing API requests. Here you'll also see the Import button. This lets you bring in existing APIs, collections, files, and folders to start working with them directly in Postman. In the header toolbar, click on the Workspaces button and you'll see My Workspace, the default workspace provided by Postman. You'll also have the option to create a new workspace by clicking on the Create Workspace button. Click on My Workspace to open it. Here you can start sending API requests and organizing your work. With My Workspace open, locate the left sidebar. Here you'll find sections for collections, environments, history, and options to configure the Workspace sidebar. At the top, the New and Import options are available. The New button lets you create a fresh API request, while Import allows you to bring in and use existing requests. Once set up, you can send HTTP requests to RESTful endpoints. Here you'll use the Fake Store API, a free public REST API with realistic e-commerce data, to send requests and view responses. With Postman open, click on the Workspaces in the header toolbar and then select My Workspace. Now that you're in the My Workspace interface, click the New button. A pop-up will appear on the screen. Select the HTTP icon to create a new HTTP request. After selecting the HTTP request, an Untitled Request tab will open. To start setting up your HTTP request, click on the text box at the top of the Untitled Request tab. The Fake Store API, a free-to-use public API, is not provided by Postman itself. Instead, it is an external resource that simulates a real e-commerce setup. Using this API in Postman, you can send GET requests to retrieve data on products, categories, and users. This gives you access to endpoints that return information like product names, prices, and categories, making it a useful tool for testing and learning. In Postman, enter the API endpoint URL in the request bar. For a simple GET request, you can use a public API URL like fakestoreapi.com/products. Select the appropriate HTTP method from the drop-down menu. For this request, choose GET, which is selected by default for all new requests. Click Send to initiate the request. The server's response will appear in the response section at the bottom of the interface. Now that the API's response is in the response section, let's explore what you might find there. The status code indicates whether your request was successful. For instance, 200 OK means the request was successful. Headers are metadata provided by the server, including details like content type, caching policies, and so on. The body section displays the actual data returned by the API. For this response, the data appears in JSON format. The response body can appear in other formats too, such as XML, HTML, or plain text. You can view the response in different modes, such as raw, preview, or pretty printed JSON. Postman also shows how long the request took to complete. Hover over the time to see a pop-up with more detailed timing information. You can also see the size of the response. Hover over the size to open a pop-up with more detailed information. Now let's spend some time creating and organizing collections. Collections help manage your API requests, letting you group related ones and save them for quick access later. In Postman, click on the Workspaces button in the header toolbar. Then select My Workspace to open it. To create a collection, click on the Collections tab on the left-hand side of the Postman interface. Click the plus icon to create a new collection. Name the collection My API Tests. Now that your collection is created, you can either save an existing request to it or create a new one. To add requests to the collection, right-click on your collection and select Add Request. Now a new HTTP request is created. Enter the API endpoint URL in the request bar. For this example, you can use a simple GET request with the fake store API you used earlier. Now, save the request by clicking on the Save button. Let's wrap up by setting up environments. In Postman, environments allow you to save variables and switch smoothly between setups, like development, staging, and production. In Postman, open My Workspace, then click on the Environment tab on the left sidebar. Click the plus icon to create a new environment. Your environment is now created. Name your environment Development. Add key value pairs for environment variables, such as base URL with an initial value of https://fakestoreapi.com. When sending a request, select the environment from the drop-down menu in the top right corner of the request interface. Use variables in your requests by referencing them with variable name. For instance, you can use base URL/products instead of hard-coding the full URL. With environments set up in Postman, you now have a flexible way to manage different configurations for your API requests. In this video, you learned how to send HTTP requests, interpret responses, organize them into collections, and set up environments for different scenarios. Postman is a flexible tool that simplifies API testing and development. Whatever API you're working with, Postman makes the process efficient and intuitive. When you create a profile on a social media app, your information is stored instantly and ready to use immediately. However, these interactions rely on RESTful APIs behind the scenes. These APIs handle actions like creating, reading, updating, and deleting data. In this video, you'll handle these tasks by building a Spring Boot application. You'll create an API and set up endpoints to cover everything from adding new users to updating profiles. By the end, you'll have a foundation for confidently building dynamic, data-driven applications. Let's begin with the controller layer. The controller layer handles incoming HTTP requests and returns responses. It maps web requests to specific methods that carry out your desired actions. In your IDE, right-click on the COM example demo package to create a new package named controller. Right-click on the controller package and create a new class. Name it User Controller. Add the @REST controller annotation to the class to mark it as a RESTful controller. Then import org.spring-framework.web.bind.annotation.rest controller. Use the @request mapping open bracket double quote / API / users double quote close bracket annotation to set the base URL for the endpoints. Then import org spring framework web bind annotation request mapping. Add the field private final user service and import example demo service user service. This will allow you to use the user service to handle user-related operations. Create a parameterized constructor that accepts a user service argument named user service. Inside the constructor, initialize the user service field with this argument. This setup allows user controller to use the provided user service instance for handling user operations. Annotate the constructor with @AutoWired to enable dependency injection of the user service instance. This way, user controller can access service methods to handle user-related operations. Don't forget to import org spring framework beans factory annotation AutoWired to make this annotation available. Now let's create methods to define the RESTful endpoints. You'll use response entity as the return type for all the endpoint methods. Response entity controls the HTTP response, including status code, headers, and body, creating clear, consistent client responses. In your IDE, define the method response entity open angle bracket user close angle bracket create user open bracket @request body user, which maps to the API user's endpoint and handles post requests. This method takes a user object from the request body, saves it through the service layer, and returns the created user wrapped in a response entity with a HTTP 200 status. Apply @post mapping to handle post requests for creating new resources like a user. The @request body annotation binds JSON data from the request body to the user object. Also, import org spring framework HTTP response entity and org spring framework web bind annotation asterisks to access all the necessary annotations. Define the method response entity open angle bracket list open angle bracket user close angle brackets get all users parentheses, which maps to the API user's endpoint and handles GET requests. This method retrieves all users via the service layer and returns them as a list in the response body with a HTTP 200 status. Use @getMapping to specify that the method handles GET requests for retrieving resources. Additionally, import Java util_list to work with lists of users. Define the method response entity angle bracket user close angle bracket get user by ID open parenthesis @path variable long ID close parenthesis, which maps to the API ID endpoint and handles GET requests. This method retrieves a user by ID via the service layer, returning the user with a HTTP 200 status if found. Otherwise, it responds with a HTTP 404 status. Annotate the method with @getMapping open parenthesis quotation mark / curly brace ID close curly brace quotation mark close parenthesis to specify that it handles HTTP GET requests for retrieving resources by ID, allowing you to fetch individual users by their unique ID. @path variable extracts values from the URI path and binds them to method parameters. Define the method response entity angle bracket user close angle bracket update user open parenthesis @path variable long ID @request body user details close parenthesis, which maps to the API ID endpoint and handles put requests. This method takes an ID as a path variable and user details in the request body. If the user exists, it updates and returns the user with a HTTP 200 status. If not, it returns a HTTP 404 status. Mark the method with @putMapping open parenthesis quotation mark / curly brace ID close curly brace quotation mark close parenthesis to indicate that it handles HTTP push requests for updating an existing resource. This annotation is used here to update user details. Define the method response entity angle bracket void close angle bracket delete user open parenthesis at path variable long id close parenthesis, which maps to the API ID endpoint and handles delete requests. This method deletes the user by ID. If successful, it returns a HTTP 204 no content status, indicating the request succeeded with no content to return. Mark the method with @delete mapping open parenthesis quotation mark / curly brace ID close curly brace quotation mark close parenthesis to specify that it handles HTTP delete requests for deleting a resource. This method is used to delete a user by their ID. By creating the controller layer, you've established how your application responds to client requests. Great job! Now it's time to test each endpoint in Postman. First, to run the Spring Boot application, locate the main application class. For this project, the main class is here. In your IDE, you can find it in src mainjava.com example demo. This class, marked with @springbootapplication, contains the main method that launches the application. Right-click on the file and choose Run to start the app. To test the endpoints, open Postman and navigate to My Workspace. Click on New to create a new HTTP request, then select HTTP from the pop-up to send a request for creating a user. In the Untitled Request tab, change the HTTP method to Post to test the Create User endpoint. Now, in the text box, enter the URL http://localhost:/8080/API/users. Next, select the Body tab to enter the user details. Currently, the request has no body. Select Raw to input the user details in JSON format. Now enter the user details as follows: curly brace name, John Smith, email, john@example.com, close curly brace. Name John Smith. Email and the email address should all be in double quotation marks. Click on the Send button to send the request. Now review the response. A status code of 200 OK indicates that the request was successfully processed. Click on New to create a new request, then select HTTP from the pop-up to create a request for testing the Get All Users endpoint. In the Untitled Request tab, enter the URL http://localhost:/8080/API/users and keep the method as getToFetchAllUsers. Click the Send button. Then check the response. A 200 OK status confirms the request was successful. With all endpoints tested and verified, you have a fully functioning RESTful API. Let's review what you've accomplished. In this video, you built a RESTful API with endpoints for managing user data, tested each endpoint, and practiced CRUD operations on users. With these skills, you're ready for more complex data-driven applications. Great coding. Imagine you're hosting a big event, and everything seems to be running smoothly, until issues start popping up. Some guests misplace their invitations, others show up on the wrong day, and a few bring along extra friends. Without a strategy to handle these surprises, things could quickly spiral. In a RESTful API, managing errors is much like handling surprises. Clients might send requests with problems, like missing information or incorrect format. By implementing effective error handling, you provide clear feedback, keeping your service reliable and easy to use. In this video, you'll review a simple event management project, explore common errors to understand why handling them is important, and set up a global error handler using @controller advice and custom exceptions. Let's jump in. The event management application includes a simple event model, which represents an event with fields for an ID, name, and date. The application has an event service class that manages the business logic and uses an in-memory map to store events. This service includes two methods: getEventById for retrieving event details by ID, and addEvent for adding a new event to the collection. The event controller class is responsible for exposing REST endpoints that allow access to event data. It handles API requests, enabling clients to retrieve details of an existing event or add a new event to the system. Now that the application's basic structure is set up, let's move on to testing for potential errors. Let's run the app and test the API in Postman to see how the application behaves when things don't go as planned and there's no error handling. When you send a GET request for a non-existing event, like one with ID 99, the response returns blank. This provides no information about what went wrong. When you send a POST request to add an event with a past date, such as 2024-0101, the API accepts it without any issues. This lack of validation lets invalid dates into the system, compromising data consistency. Logical errors like these leave users without guidance on what went wrong or how to fix it, making effective error handling essential. With this in mind, let's enhance the API with structured error handling by creating a global exception handler using the @controller advice annotation. This will enable consistent exception management and allow custom exceptions for specific error scenarios. Right-click on the com.example.event management package to create a new class called Global Exception Handler. This class will be responsible for catching and responding to various errors across the application. The controller advice annotation to the Global Exception Handler class and import it from org.spring-framework.web.bind.annotation. This setup allows the Global Exception Handler to catch exceptions from any controller in the application. Think of controller advice as an error receptionist that centralizes all error handling in one place. It ensures that errors are managed consistently throughout the application. Create a handle global exception method that returns an error message as a response entity, which lets you include a HTTP status code with the response. The exception argument in this method gives access to details about the specific exception encountered. Add the exception handler annotation to the handle global exception method, passing exception.class as the argument. This setup enables the method to handle generic exceptions, as well as their subclasses. Use the exception reference to return an error message and set the HTTP status to internal server error. For unexpected errors, this handler ensures your API provides a clear, consistent message, instead of leaving users with a blank response. With the global handler in place, let's take error handling further by creating custom exceptions for specific scenarios. At your metaphorical party, some guests need special handling, like those arriving without an invitation or coming too early. Custom exceptions let you address these specific situations. For example, resource not found exception is used for missing resources, such as an event with ID 99 that doesn't exist, while bad request exception is used for invalid requests, like trying to create an event with a past date. IDE, create an exceptions package under com.example.event management, and within it, add a new class named Resource Not Found Exception. This class will handle cases where a requested resource is missing. Extend the Resource Not Found Exception class from runtime exception. Then, add a constructor that takes a string argument and calls the superconstructor, passing in this argument. This setup allows you to provide a custom error message when this exception is thrown. Next, create a new bad request exception class in the same exceptions package and have it extend runtime exception. This class will allow you to handle invalid requests with customized error messages, similar to resource not found exception. These custom exceptions extend runtime exception, allowing them to be thrown during runtime for specific errors, like missing data or invalid values. Next, let's add specific handlers for each exception. By adding handlers in the global exception handler, each error type receives a unique response, providing clear feedback on what went wrong. Inside the global exceptions handler class, create the handle resource not found exception method. This method takes the matching exception as an argument and returns a helpful message with a not found status, signaling that the client made an invalid request. Add the specific exception class in this method's exception handler annotation. Similarly, define a method to handle bad request exception, setting the HTTP status to bad request to indicate an invalid request. This approach gives each specific issue in your application a tailored response, helping users understand the problem. Finally, let's update event service to throw these exceptions in error cases. In the getEventById method, store the found event in a reference variable. Check if the found event is null. If it is, throw a resource not found exception for the specified ID. Return the found event to complete the method. In the addEvent method, check the event date before creating it. Use compareTo to verify that the date is not in the past. If it is, throw a bad request exception with a relevant message. The final step is to test the error handler with Postman to make sure it responds correctly to different issues. Now sending a GET request for a non-existing event, like one with ID 99, returns a not found status, along with the message, event with ID 99 not found. Using a post request to add an event with a post date now returns a bad request status and the message, event date cannot be in the past. These responses offer clearer guidance, providing users with helpful information about the issues encountered. With structured error handling in place, your API can now deliver helpful messages whenever something goes wrong. Instead of cryptic errors, users receive helpful feedback, making the API far more user-friendly and reliable. That's the real impact of effective error handling in a RESTful API. Imagine you're running a system for creating and tracking events. When users submit an event, essential details, like the event name and date, must be complete and accurate to keep your data reliable. To keep everything running smoothly, you need a way to make sure all event details are correct before they're saved. In this video, you'll explore how to validate data in a RESTful API to ensure it meets the necessary standards. You'll set up validation rules in the event model and use the @valid annotation to enforce them. You'll also use automatic ID generation and exception handler to streamline the process. To begin, implement automatic ID generation in the custom event service class. This class manages event-related operations in this example. In real-world applications, servers usually generate IDs through a database, so they don't typically require validation. To replicate this, manage ID assignments manually, because this project uses an in-memory map instead of a database. An in-memory map is a data structure that stores data directly in memory rather than persisting it in a database. While this approach simplifies the setup, it requires handling tasks like ID generation manually, since there's no database to automate these processes. In your IDE, configure the event service class to automatically generate unique IDs. Start by declaring a private ID counter variable of type atomic long to serve as a counter for each new event. Set its initial value to 4, so the IDs will start from 5, since the map already contains 4 entries. Using atomic long ensures safe ID generation, even when handling multiple requests at the same time, preventing any overlap in IDs. Modify the addEvent method to call idCounter.increment and get to generate a unique ID, then store this value in a long variable named GeneratedID. Next, use the setID method to assign GeneratedID as the event's ID and apply this ID when adding the event to the map. Comment out the date check in the method, as Spring Boot's validation within the event class will now take care of it. With basic ID handling in place, the next step is to enable validation. Adding the Spring Boot Starter Validation dependency to the project enables validation in the Spring Boot application. This includes the Validation API, which allows annotations like @notNull and @valid to be used. In your IDE, right-click within the pom.xml file, select Add Dependency, and then search for org.springframework.boot:/Spring Boot Starter Validation. Choose this dependency and add it to the project. Click Load Maven Changes to update the project with the new dependency. With validation enabled, the next step is to add specific validation constraints to the event model. These validation rules will ensure that each event includes a name, has a valid date, and that the date is set in the future. Add the @notNull annotation to the name and date fields in the event class to ensure these fields are provided when creating a new event. You can also add a custom message within @NotNull to display if validation fails. To ensure the event name is at least 3 characters long, add the @size annotation to it. Set the min argument to 3 and include a message to display if this rule is violated. Apply the @future annotation to the date field with an appropriate message to ensure the event date is set in the future. All of these annotations are part of the jakarta.validation.constraints package. They ensure that any event data submitted meets your specified criteria before processing. The @future annotation requires a date type, so you'll need to change the field type from string to local date from the java.time package. Right-click on string next to the date field. Select Refactor and choose Type Migration. In the Migrate Type String of Field Date 2 box, type local date and then select it from the drop-down. Click Refactor to apply the changes. Refactoring the data type this way ensures that the type is updated everywhere this field is used. Next, click on View Usages. Confirm type migration by clicking the Migrate button. Be sure to reapply the @NotNull and @future annotations if they were removed during the type migration. The refactoring of data type from string to date will cause errors in the event service class because there are currently 4 events with dates stored as string values. To fix this error, convert the date strings using the localDate.parse method. With validation constraints now set up, the next step is to trigger validation through the event controller to enforce these rules when new events are submitted. In the event controller class, apply the @valid annotation to the event argument in the addEvent method. This tells Spring Boot to validate incoming data based on the constraints set in the event model. If validation fails, Spring Boot will intercept the request and return an error message automatically without executing the method logic. This setup ensures that basic validation happens at the model level, verifying data standards before further processing. To manage validation errors more effectively, you can use the Global Exception Handler to customize how these errors are handled and presented to users. Since the Global Exception Handler class is already in place, let's enhance it to provide user-friendly responses to validation errors. Within the Global Exception Handler class, create a Handle Validation Exceptions method to catch method argument not valid exception. This exception occurs when an argument annotated with @valid fails validation in a controller method. The error message is built using getBindingResult to access validation results, getFieldError to retrieve the first field-specific error, and getDefaultMessage to extract the error message from the annotation, such as event name cannot be left blank. This custom response gives users clear feedback on validation errors, helping them adjust their input accordingly. Finally, let's test validation in Postman to ensure the API responds correctly to both valid and invalid inputs. When you send a valid post request to create an event, you should receive a 201 created status and the event data confirming that validation was successful. Sending a post request without the name field results in a 400 bad request, along with the error message, event name cannot be left blank. Finally, sending a post request with a past date returns a 400 bad request, along with the specified error message. To end, let's explore how validation and exception handling work together to manage errors and ensure smooth data handling. Validation focuses on data quality. The @NotNull, @size, and @future annotations enforce rules on incoming data, preventing incomplete or incorrect data from processing and ensuring data quality. Exception handling, on the other hand, focuses on consistent responses. The Global Exception Handler catches unexpected errors, like missing resources, and provides helpful messages. When validation fails, Spring Boot automatically returns a bad request with specific error messages. By applying data validation techniques, automatic ID generation, and exception handling, your event management API becomes both reliable and user-friendly. Validation rules in the event model ensure data quality, automatic ID generation simplifies event creation, and exception handling provides clear feedback, guiding users and ensuring helpful responses in any situation. With these validation and exception handling techniques, you're well equipped to build reliable, user-friendly APIs. Keep up the good work. You've already explored Spring Boot, RESTful APIs, and connecting databases with Spring Data JPA. In this video, you're taking it further by learning how to build a more advanced RESTful API with Spring Boot, adding a powerful new tool to your developer toolkit, Hateoas. Hateoas, or Hypermedia as the engine of application state, is a REST API design where each response includes links guiding clients through the next steps based on the current data state. Picture a digital library. If a book's available, you see borrow. If it's taken, you see return. The system guides you like Hateoas helps clients navigate an API by following links. Without Hateoas, clients need to know all routes in advance. But with it, they simply follow links, making APIs easier to use and more adaptable. In a Hateoas-enabled API, responses often include several types of links: a self-link, action, transition, and collection links. Let's go through each. A self-link points back to the current resource so clients can easily re-access or check updates. For instance, after borrowing a book, a self-link lets clients quickly retrieve its updated status. Action links indicate actions clients can perform on a resource, like borrow or return in a library, or create, update, and delete in a shopping cart. Transition links lead to related resources, guiding clients through different sections. In a library API, this might include links to related books or an entire collection. Collection links are used when multiple resources are returned, like a paginated book list, helping clients navigate with links like first, last, next, and previous. In this video, you'll explore self-links and action links and show how they guide clients based on each book's availability. Let's dive into how a digital library API with Hateoas functions, using Spring Boot, MySQL, and JPA. The digital library project has several dependencies: Spring Web for creating the RESTful API, Spring Data JPA for database interactions, Spring Hateoas to enable Hateoas functionality, and MySQL for the database. The project includes a book entity that represents each library book, with properties such as ID, title, author, publication date, and is available, which indicates if a book is available or already borrowed. The repository layer provides methods for interacting with the database, while the service layer handles business logic, like finding books and updating their availability. You will focus on developing the controller layer, where Hateoas is implemented to guide clients with relevant links for actions like borrowing and returning books. In your book controller, you'll add links to each response based on the book's current state. When a book is available, the client receives a link to borrow it. If it's borrowed, they'll get a link to return it. We'll begin with the basic setup, building the method step by step and adding Hateoas links to guide the client. Define the book controller class and use @AutoWord to inject book service to access book data. Add @RESTController to enable REST request handling, and @RequestMapping to set /books as the base URL. Next, let's create the getBookById method to fetch a specific book by ID. Wrap the book data in an entity model to enable adding Hateoas links. Use the @getMapping annotation to map it to a getRequest@/books/ID. BookService.findBookById calls the service layer to retrieve a book by ID. If no book is found, an error is returned. Otherwise, EntityModel.of wraps the book data in an entity model named resource, enabling links to be added with resource.add. Link2, combined with method on, creates a self-link to the getBookById method in book controller. The .withSelfRel method labels this link as self, pointing to the book's details. When testing this endpoint for book ID 1 in Postman, observe that the self-link directs to the getBookById endpoint, allowing the client to retrieve the book's details by following it. Next, let's enhance getBookById by adding conditional links. If the book is available, it includes a borrow link. If already borrowed, it provides a return link. The if condition checks if the book is available. If so, resource.add adds a borrow link. Link2 with method on generates the URL for borrowing, and withRel labels the link as a borrow action for the client. If the book is unavailable, it similarly adds a return link, pointing to Return Book. Testing this endpoint again in Postman shows a different output. A borrow link is provided for an available book. For an unavailable book, it gives a return link. These conditional links create a context-aware experience for the client. Instead of needing to know when or how to borrow or return a book, the client simply follows links based on the book's current state. The self-link is essential for a navigable API, allowing clients to directly access the resource whenever needed. Next, let's add the borrow book and return book methods to handle these actions, each including a self-link to the updated book. The borrow book method lets a client borrow a book if available. The method returns an error if the book has already been borrowed. If the book is available, borrow book updates its availability to false and returns a response with an updated self-link. Let's borrow the book with ID 1 as it's available. The response now shows the book's availability as false. Now let's check the self-link for updated details. It displays a return link, indicating the book has been borrowed. The return book method allows a client to return a book if it's borrowed. If the book is already available, it returns an error. Let's return the book with ID 1. The response now shows the book's availability as true. If we check the self-link for updated details, it displays a borrow link, indicating the book has been returned. Now that you've seen Hateoas in action, let's explore some of its strengths and limitations. Hateoas offers several advantages. It provides self-descriptive responses with links to guide clients on the next actions based on the resource's current state. It also enhances flexibility by allowing APIs to change without disrupting clients who follow links instead of fixed routes. It also improves user experience by simplifying navigation and making API interactions more intuitive. Hateoas brings some drawbacks. It adds complexity to API design and client response handling, requiring additional development and maintenance. Including links can also increase response sizes, potentially impacting performance with large datasets. Not all clients fully support Hateoas. Some clients might completely ignore the embedded links. For instance, a lightweight IoT device fetching API data might parse the resource but skip the links altogether, making them less effective. In this video, you learned how Hateoas adds dynamic, context-aware links to RESTful APIs, making them more intuitive. Using self-links and conditional actions like borrow or return, the book controller guides clients based on each book's availability, creating a user-friendly, adaptable API. While powerful, Hateoas requires careful design and may be overkill for simpler APIs. Nonetheless, with this tool in your toolkit, you're well equipped to build smarter, more flexible APIs. Happy coding! Think about the last time you added an item to your shopping cart on an online store. The cart updated instantly. No page refresh, no delays. Pretty cool, right? Ever wondered how that works? This smooth interaction is powered by APIs, application programming interfaces, that allow the front end, what you see and interact with, to communicate with the back end, where the data and logic live. In this video, you'll learn how front-end applications leverage APIs to retrieve and update data from back-end services, creating web experiences that are more dynamic, responsive, and engaging. To get started, let's break down the term API. It's essentially a set of rules and protocols that allow different software applications to talk to each other. Imagine you're at a restaurant placing an order with the waiter. Here the waiter acts like the API, taking your request to the kitchen, the back end, and bringing your food back once it's ready. Even if your table orders items from different kitchens within the restaurant, the waiter ensures it all arrives together. Similarly, the API ensures that the front end receives exactly what it requested from the back end, even though both systems may use different languages or run in separate environments. With that basic understanding of APIs, let's now focus on how the front end and back end communicate using them. The front end of a website is what the user interacts with, the buttons, text, and layout. Meanwhile, the back end is where the data is stored and processed. Think back to visiting an online store. The back end holds the product listings, prices, and your shopping cart data. When an item is added to the cart on the front end, an API request is sent to the back end to update the cart. This communication ensures that the changes are saved and reflected accurately across the application, creating the seamless experience users expect. The front end doesn't access the database directly. Instead, it sends a HTTP request to the backend through an API, either requesting specific data or sending new information. The backend processes the request, retrieves or updates the data, and sends a response back to the front end. This response is usually in JSON format. Why JSON? It's lightweight, easy to read, and simple to work with. This structured exchange ensures smooth communication between the front end and back end, keeping everything responsive and up to date. You've been tasked with building the front end for a shopping application. The product data is stored in a server, and instead of constantly refreshing or manually updating it, the front end uses an API to request the latest product information from a back-end service. Here's how this might look in JavaScript using the Fetch API, a popular tool for making HTTP requests from the front end. This example uses a public API that provides sample product data, ideal for building and testing applications. In the code, the fetch function sets a HTTP request to the product API. If the request is successful, the response is converted to JSON format using the .json method. This JSON data can then be used to update the front end dynamically, for example, displaying the current product list directly on the page. With APIs in place, the front end can stay fast and responsive even as it pulls fresh data from the back end. But while APIs unlock powerful features and enable seamless interactions, they also introduce some trade-offs developers need to consider. Let's explore both the advantages and challenges of working with APIs. APIs are the backbone of modern web applications, enabling real-time data updates. Instead of loading static pages, APIs allow websites to update dynamically based on user interactions. This is essential for applications like social media platforms, e-commerce sites, and news outlets, where content is constantly changing. Think of it this way. APIs give developers the tools to build flexible, interactive applications, keeping the front end fast and responsive even though the data is stored or processed on the back end. Without APIs, the web would feel much more rigid and slow. However, integrating APIs into web applications introduces technical challenges due to this dependency on the back end. Every time an API call is made, there's a small delay as the data travels back and forth between the front end and back end. This is called network latency. On top of that, the back end needs time to process the request, which can add a bit more overhead. These delays, while often small, can add up and impact the application's overall performance. Development also becomes more complex, with different APIs using varying formats, protocols, or data structures that need to be carefully handled. Security is another key consideration. APIs expose endpoints that must be protected against threats, requiring strong authentication and authorization mechanisms. Finally, maintaining and updating APIs presents an ongoing challenge. Any changes to the backend or API specifications often require front-end updates to ensure everything continues to work smoothly, adding to maintenance efforts. As you move forward, it's important to think about how to navigate these trade-offs effectively. In this video, you explored how APIs connect the front-end and back-end to create dynamic, responsive web applications. From fetching product details to updating shopping carts, APIs make real-time communication possible. With these tools, you're ready to build smooth and responsive applications, just like the shopping apps you use daily. In the last video, you explored how APIs enable websites to update instantly, like adding an item to a shopping cart without refreshing the page. This seamless interaction is possible because APIs let the front end pull data from the back end in real time. Now imagine you're building a similar feature, instantly displaying product details or reviews when a user hovers over a product. How can you make that happen? This is where JavaScript's Fetch API comes in. The Fetch API allows you to request information from a server without reloading the page. By sending a GET request to an API endpoint, you can pull in data like product details or user reviews exactly when needed. A GET request is the most common way to retrieve information from a server, similar to asking a salesperson for details about a specific product. The Fetch API handles this process smoothly, returning data you can display on your webpage to create a responsive and engaging experience. Before diving into the front-end code, let's revisit the back-end API you developed with Spring Boot in creating Restful endpoints. This API will serve as the data source for your fetch requests. The Spring Boot backend provides two main endpoints. /API/v1/products returns a list of all products, and /API/v1/products/open curly brace ID close curly brace returns the details for a specific product by its ID. These endpoints rely on a product entity that contains details like ID, title, price, description, category, image URL, and rating. Each field in this class maps directly to a column in the database table. The @column annotation connects each field in the product class with its corresponding database column. This mapping allows the API to retrieve structured data for each product. The product controller class handles GET requests and returns product data in JSON format, ready for the front end. To allow the front end to access the backend APIs, the @cross-origin annotation is added to the product controller class. This prevents CORS errors, which occur when the backend server blocks requests from a different domain. CORS, or cross-origin resource sharing, is a browser security feature that controls cross-domain data requests. By adding @cross-origin, you enable smooth data flow between the front end and back end. If strict CORS handling isn't necessary, setting the request mode to no CORS can bypass this restriction, but it limits the data accessible to the front end. With the back end set up, let's ensure it's working correctly before connecting it to the front end. Using Postman, send a GET request to http://localhost:/8080/API/v1/products. If everything is configured correctly, you'll see a list of products in JSON format. This confirms that the backend is ready for the Fetch API. Next, let's go over the front-end setup. This HTML file includes a main element with an ID of product container. This is where the products will display dynamically once they're fetched from the backend API. Notice that the body element has a link to an external JavaScript file, index.js. This file will contain the Fetch API code that retrieves product data from the Spring Boot API and updates the page. Now, here's how the Fetch API comes into play. In the index.js file, there's a function called fetchAllProducts. This function sends a GET request to the backend using the Fetch API. Here's a step-by-step breakdown of what the code does. The fetchAllProducts function sends a GET request to the backend API's URL. Await fetch pauses the code until the response is received. The response is then converted to JSON using await API response.json. If everything works as expected, the function calls display products to update the page with the fetched product data. If there's an error, it logs the message to the console. Now, let's review the display products function. This function takes an array of products and dynamically creates HTML elements to display each one. Here's how it works. The function loops through the products array, creating a div for each product. Inside each div, an image, title, price, and rating for the product are added. Finally, it appends each div to the product container, so they're displayed on the page. This approach lets you render all the products dynamically, making the homepage interactive and responsive to the data from the backend. With the display function ready, let's ensure the products load automatically. To ensure products appear as soon as the page opens, the fetchAllProducts function is called when the window loads. This way, as soon as the page loads, fetchAllProducts runs and retrieves the product data. It then calls displayProducts to dynamically display each product on the page. In this video, you learned how to set up a Spring Boot backend to serve product data, test the API with Postman, and use JavaScript's Fetch API to pull that data into the front end. With these tools, you updated a web page, creating a responsive experience. Think back to the online shopping example, how product details load instantly without a page refresh. Now you have the skills to create that same seamless experience. These techniques are essential in real-world web development, letting you build applications that feel fast and interactive. In the last video, you explored how to retrieve data from a server using the Fetch API's GET request. But what if you need more than just viewing data? This time, the focus shifts to handling data changes, adding, updating, and deleting data directly from the front end. These interactions rely on post, push, and delete requests with the Fetch API. In this video, you'll use these methods to manage an online shopping list, making it easy to control what's on the list without refreshing the page. By the end of this video, working with data on the server will feel familiar and straightforward. Before diving into the code, it's important to note that this source code builds directly on the previous video, using Fetch API for GET requests. This video focuses on adding functionality for handling the shopping cart's push, post, and delete requests. Currently, the product controller class supports GET requests to retrieve product data with two endpoints. /API/v1/products returns all products, and /API/v1/products/open curly brackets ID close curly bracket returns a specific product by ID. But what about adding, updating, or deleting items? For that, you'll need a few additional endpoints. Post endpoint allows adding a new product by sending a JSON object in the request body. Push endpoint updates a specific product's details by ID, and delete endpoint deletes a product by its ID. Here is the updated product controller class, now with methods that expose, post, push, and delete endpoints. Notice that simply adding these methods to the controller doesn't actually enable the create, update, or delete operations. These are just the entry points. To make these operations work, the product service class also needs updates. It will use methods from product repository to handle the actual data processing for creating, updating, and deleting products. Here is the product service class, now updated with methods to handle different requests. The create product method processes post requests, allowing new products to be added. The update product price method handles push requests to update a product's price. Finally, the delete product method takes care of delete requests to remove products. Each method relies on the product repository interface to interact with the MySQL database, so you can work directly with the data. To add a new product, start with a form on the add.html page. This form collects important information such as the product's title, price, description, category, image URL, and rating. Each field is given an ID, like title, price, or description. These IDs make it easy for JavaScript to capture and work with data from each input. To capture and send data from the form, an event listener is added to the Submit button. This listener waits for the user to submit and then gathers the input values. Using document.get element by ID, each field's value is retrieved by its ID. These values are stored in an object, structured to match what the API expects. In the try-catch block, the code sends a post request to create a new product in the database. The data captured from the form is sent in the body of this request. If the request is successful, the server responds with the details of the newly created product. By checking if response.OK is true, the code alerts the user that the product was added successfully. Next, how would you handle updating a product? On the edit.html page, there's a form similar to the one for adding a product. The edit.html file displays a product card by first fetching the product's existing details from the database. These details are then populated into a form, allowing the user to update them. Each input field in the form matches a product field in the database except for the ID. Since the ID is the primary key, allowing edits could lead to invalid or duplicate IDs. For this reason, the ID field is not editable. To pre-fill the form with existing product details, the populate form function in edit.js fetches the data. It retrieves the product information from the API using the product ID found in the URL. After making changes in the form and submitting it, a push request is sent. This process is similar to the post request, but now the method is set to push, to update existing data. The updated product information is sent to http://localhost:/API/v1/products/$ open curly bracket product ID close curly bracket, targeting the specific product by its ID. Finally, what if the user wants to delete a product? In product.html, there's a delete button that triggers the delete product by ID function. In this part, the method is set to delete to target a specific product by its ID. Once the product is deleted, the user is redirected back to the main page. This code is located in the product.js file. It adds the delete function with an on-click event, which is triggered when the delete button is dynamically added to each product card. In this video, you learned how to create, update, and delete products using the Fetch API with post, push, and delete requests. These skills enable you to build responsive web applications that interact smoothly with the backend API. Imagine an online store where users can add, edit, or remove items instantly. Now you have the skills to build that experience. Have you ever encountered an app that just freezes or crashes when something goes wrong with a network request? For users, it disrupts their experience. For developers, it's a common and solvable problem. Handling errors in API requests is essential to preventing such issues and building reliable, user-friendly applications. This approach ensures that when something goes wrong, like a network failure or an unexpected server response, the app can respond instead of breaking. In this video, you will learn how to handle errors in API requests, which is essential for building reliable, user-friendly applications. You will also learn how to detect HTTP errors, cache network issues, and create custom error messages so users know exactly what's happening. Let's start with the basics. Network requests are a fundamental part of most web applications, and JavaScript's Fetch API is a popular way to handle them. It allows JavaScript to interact with RESTful APIs, pulling in data, sending updates, and more. However, there's a catch. The Fetch API only throws errors for network failures, like a lost connection. It won't alert for HTTP errors such as 404, not found, or 500, server error. So a request might appear successful even if the response signals a problem. To manage this, it becomes essential to check the response's status code. This allows you to catch these issues early and decide how the app should respond. Let's examine the code and explore how basic error handling works with the Fetch API. This example calls the Pokemon API to fetch details about a Pokemon based on its ID. Notice the structure here. It starts with a try block that attempts to fetch data from the API. If the response is successful, it's returned in JSON format. However, things get interesting when checking response.ok. This line is crucial for error handling. If response.ok is false, a HTTP error occurs, like a 404, not found, or 500, server error. In that case, the code throws a custom error with the response status, so issues don't slip through undetected. The catch block at the end handles any errors, whether from network failures or our custom errors. It logs the error, giving a clear indication of what went wrong. This structure ensures that the app doesn't crash unexpectedly and can inform users when something goes wrong. Now that you've covered handling HTTP errors, let's move on to managing network errors. Network issues, like a lost connection or a request timeout, don't provide a response object, so there's no status code to rely on. An API promise represents a value that may be available now, in the future, or never. This is where the .catch method comes in. It captures all errors from the fetch promise, allowing the app to handle network issues. This code uses .catch to identify and respond to network problems. For example, if the error type is type error, it's likely due to a network issue, such as a failed connection. This makes it easier to display a custom message like network error, helping users understand what went wrong. So far, you've explored handling general HTTP errors and network issues. But not all errors are alike. Different status codes indicate different problems. Handling each code individually can help users understand what went wrong. For example, a 404 status code means not found, indicating the requested resource doesn't exist. Meanwhile, a 500 status code points to a server error, suggesting an issue on the server's end. In this example, custom messages are thrown for 404 and 500 status codes. This approach provides users with feedback tailored to the issue they're facing. If another status code arises, it's captured in a general error message. To wrap up, here are some best practices for handling errors with Fetch API requests. Always check response.ok. This helps catch HTTP errors like 404 or 500, ensuring they don't go unnoticed. Use .catch for network errors. Network-level issues like a lost connection are handled here. This way, users aren't left wondering what went wrong. Providing specific messages for different status codes can improve the user experience and make issues easier to understand. By applying these strategies, errors in API requests can be managed effectively, creating a more reliable and user-friendly application experience. In this video, you explored essential techniques for handling errors in API requests using JavaScript's Fetch API. You learned how to check for HTTP errors, catch network issues, and manage different status codes to give users clearer feedback. Think back to the app that freezes or crashes when a request fails. By implementing these practices, you can prevent those frustrating moments for your users. These techniques make your applications more resilient, keeping them responsive and informative, even when things don't go as planned. Accessing and managing data is a cornerstone of any modern web application. Users expect apps to be dynamic, responsive, and capable of updating in real time, often based on remote data. For a front-end app to deliver this experience, it needs to fetch, update, and manage data from external sources, typically RESTful services. While JavaScript's Fetch API can handle these requests, another tool often provides a smoother experience: Axios. Axios is a JavaScript library designed to simplify HTTP requests, offering a more readable syntax and automatic JSON handling that many developers find essential when working with RESTful services. This video covers using Axios to perform the full range of HTTP requests: GET, POST, PUSH, and DELETE. With Axios, connecting to RESTful services becomes efficient and adaptable, setting the foundation for dynamic and user-friendly web applications. To get started with Axios, make sure your project includes it. The simplest way is to link to a Content Delivery Network or CDN, which loads Axios directly into your application, making it ready for HTTP requests. To add Axios to the project, insert this line in the head section of your HTML file. Start with the script tag, and for the src attribute, use the CDN link for the Axios library. Add the async attribute, then close the script tag. This link is a Content Delivery Network or CDN URL that provides a fast and reliable way to include Axios in your project. If you ever need to locate this link, visit the official Axios documentation or search for Axios CDN online. Reputable CDN providers like JSDeliver or Unpackage will have the latest version of Axios ready to use. With Axios now set up in the project, it's ready to handle various HTTP requests. So how do you actually retrieve data from an external API with Axios? For this example, let's retrieve a list of Pokemon from the Poke API using a GET request. Here's how easy it is to fetch data with Axios. Notice how clean and readable this code is compared to Fetch. Axios automatically converts the response into JSON format, so there's no need to call response.json. The .then method handles successful responses, while .catch captures any errors, whether HTTP related or network issues. Now that Axios can handle GET requests, it's time to explore how it can send data back to the server. Let's say you want to add a new Pokemon to your app. Here you'll send a JSON object with the Pokemon details. In this example, Axios sends a post request with Pokemon data as the request body, automatically setting the content type header to application/JSON. On a successful response, the added Pokemon's data is logged to the console. Axios simplifies post requests by handling JSON stringification and headers for you. You can observe the Axios.post function that sends the post request using the URL and post data. Note that the actual Poke API is read-only and does not support post requests, but you could create your own database backend with a post endpoint if needed. Let's keep building on this by examining how to modify data with a put request. Updating data is essential when something in your app changes. Let's say you want to update a Pokemon's details. With a put request, Axios can modify specific data for an existing Pokemon. In this put request, you send the updated Pokemon details along with the Pokemon ID in the URL. Axios again simplifies handling the request, body and headers, making the code more concise. So what about removing data? Let's dive into the delete request. Sometimes data needs to be deleted, especially in admin tasks where certain items or records like Pokemon need to be removed from a catalog. With a delete request, Axios makes this process straightforward. In this example, you'll remove a Pokemon by its ID, sending the Pokemon ID in the URL. If successful, a confirmation message appears in the console. Like the other methods, .catch captures any errors, such as if the Pokemon ID doesn't exist. With Axios, handling tasks like updating or deleting data becomes clean and efficient. By now, you've examined how Axios manages GET, POST, PUT, and delete requests, each with simplified syntax and built-in features that streamline your code. So what makes Axios a strong choice over the Fetch API in these scenarios? Let's explore some key advantages that make it a go-to option for developers. Axios automatically parses JSON responses and converts request bodies into JSON format, reducing repetitive code. Axios requires less code for setup and error handling, making requests more readable and maintainable, especially in complex applications. Axios allows you to distinguish between server response errors and network issues directly in the .catch block. Axios supports older browsers that may lack full fetch support, making it versatile for applications with a wide user base. These features make Axios a valuable tool for developers who want efficient, readable code for managing RESTful services. In this video, you learned how to use Axios to handle HTTP requests, covering GET, POST, PUT, and delete methods to interact with the RESTful API. Axios simplifies these interactions, making your code more readable and manageable. With these techniques, you're well equipped to create dynamic, maintainable applications, a vital skill as you advance in your development journey. You commute to work by public transport. To pass the time, you usually log onto a streaming service and watch movies on your phone. No downloads are necessary, just open the app and watch. The streaming service handles everything, so you don't need to worry about storage space. The movie you're watching is physically on the service provider's server, and you can access it and stream it on your device from any location. This is how cloud deployment works. Cloud deployment refers to using cloud providers to run apps, store data, or provide services over the internet. Amazon Web Services, or AWS, is an example of a cloud service provider. Instead of having to tie up time, money, and resources in managing physical servers, you stream computing resources from them as needed. As a user, you have no expensive hardware to maintain and manage, and you only pay for what you use. In the past, companies owned physical servers. They would have to estimate traffic, buy servers, and hope for no surprises. If demand fell short, costly servers went unused. Scaling took weeks and they had to manage repairs, maintenance, and updates. All of these factors could lead to downtime and added costs. Cloud deployment solves these issues. With cloud services, businesses no longer need to worry about buying and maintaining physical servers. The cloud provides several benefits, the first of which is scalability. With the cloud, businesses don't have to worry about servers crashing. The cloud scales automatically, adding the power needed to keep every user's experience smooth. The next benefit, particularly for startups and small businesses, is cost efficiency. With the cloud, businesses only pay for what they use. For example, the cost of streaming bandwidth will be based on the number of viewers. This means that they can avoid huge upfront costs, like buying a server, and instead focus on growing their business. Another key benefit of cloud deployment is flexibility. By using cloud providers, businesses ensure that their systems stay online and ready to handle customer needs, such as traffic spikes or service requests, and their content or services remain accessible to customers from anywhere. And those customers know that they can rely on the business. Cloud providers have data centers around the world. If one server fails, another takes over instantly. Let's examine the different types of cloud services more closely. Each service model offers unique benefits to a business, which can select a specific cloud service based on the control and customization it wants. Imagine you're building your own streaming service, and you want complete control over how movies are stored and streamed and the servers that power them. Rather than buying and maintaining your servers, you rent these resources from a cloud provider like AWS. This is infrastructure as a service, known as IaaS. With IaaS, you rent virtual servers, storage, and networking from a cloud provider. With IaaS, you control everything about your service, from how content is stored and streamed to how the virtual servers are configured. Opting for this model will avoid issues with hardware. You get complete flexibility to manage your service without worrying about fixing or maintaining the physical hardware. But what if you want to launch your streaming service without dealing with servers or storage? You just want to upload movies and focus on user experience. Then the model you should choose is Platform as a Service, or PaaS. With PaaS, the cloud provider handles all technical details including servers, operating systems, and scaling, so you can focus on your app. In essence, PaaS gives you a ready-to-use platform where everything is set up for you. This saves you time and effort. You only need to focus on the final result, your app, and on uploading your movies and delivering a great user experience, while the provider manages all the technical infrastructure. And when your app becomes more popular and more users join, you don't need to manage this manually. The PaaS model provides automatic scaling and management. Imagine you're a business or developer who wants a ready-to-use solution without the need to set up servers, apps, or configurations. For example, using a pre-built platform to run your services without worrying about the infrastructure. Then software as a service, or SaaS, is the correct choice. With this service, the cloud provider manages everything. SaaS is a fully built service and completely ready to use, so no setup is needed. You simply log in and enjoy the content without worrying about storage or delivery. The cloud provider handles server maintenance, upgrades, and tech issues, so you, the user, do not have to perform any maintenance or management. And with SaaS, you can access the services at any time, from any device, and from any location. Cloud deployment allows modern businesses to be fast, scalable, and always available. Traditional infrastructure struggled to provide this due to limited flexibility and high costs. Businesses can choose a cloud deployment model that suits their needs. If they want access to fully scalable virtual servers, storage, and networking with complete control, they can choose infrastructure as a service. If they don't need that level of control, they can opt for the ready-to-use platform as a service option. If their focus is entirely on usage with no setup, they can select software as a service. Cloud deployment offers scalability, cost efficiency, flexibility, and reliability. Whether using IaaS, PaaS, or SaaS, the cloud lets you focus on what matters, growing your business while leaving the technical heavy lifting to cloud providers. In the next lesson, you'll dive deeper into these cloud service models and explore how AWS makes deploying applications in the cloud even easier. Let's stick with our video streaming analogy. Imagine your streaming service, streaming app, is growing fast. More users are tuning in daily, and you need more computing power to handle the demand. But instead of buying physical servers to manage all those streams, you rent virtual servers from Amazon. These virtual servers, known as Elastic Compute Cloud or EC2 instances, let you run your streaming service in the cloud without needing to manage physical hardware. In this video, you'll explore how to launch an EC2 instance, how to choose the right instance type, and gain an understanding of the hardware specifications. First, let's answer the question, what is Amazon EC2? Amazon EC2 is a service that lets you run virtual servers, called instances, in the cloud. Instead of owning and maintaining physical servers for your streaming service, streaming app, you rent these virtual servers from EC2. This allows you to scale up or down based on demand without investing in expensive hardware. Think of EC2 as the backbone of your streaming service, providing the computing power to store and stream videos. You can choose different types of instances depending on your service needs, and the best part is you only pay for what you use. EC2 ensures your service runs smoothly no matter how much traffic it gets, all without the hassle of managing physical servers. Imagine your streaming app is growing fast, but your current setup can't handle the load. Videos are buffering and users are dropping off. This is where EC2 helps. Launching an EC2 instance lets you quickly rent a virtual server from AWS, scaling up to handle more users without investing in physical hardware. Now, let's see how to launch an EC2 instance and prepare the streaming app to handle all those viewers. The first step is creating an EC2 instance, which is one of the core tasks in cloud computing. Let's get started. First, go to the AWS Management Console and log in. It's like opening the dashboard for a streaming app, but here, you're about to create the virtual server that'll power your streaming app. Once logged in, type EC2 in the search bar at the top and click on EC2. Think of this as finding the section where you can rent the virtual server for the streaming app. Under Resources, click on Instances Running 0. This will show whether any EC2 instances are running. Now click the Launch Instance button. This is like clicking Start to get your new server up and running. You'll be prompted to choose some settings for your virtual server. Give your instance a name, like Streaming App. This helps you keep track of it, especially if you launch multiple instances later. Next, choose an Amazon Machine Image or AMI. The AMI is like a template for your instance. It includes the operating system and software you want. At the initial level, you can select the Amazon Linux free tier, which is a good starting point for most use cases. Next, choose your instance type. This determines the power and performance of your server. The T2.micro instance is a good choice for basic tasks and is eligible for the AWS free tier. To securely access your EC2 instance, you'll need a key pair. If you don't have one, click Create New Key Pair. In the dialog box that appears, give your key pair a unique name. Choose RSA as a type and select .pem for the file format. Click Create Key Pair and don't forget to download the .pem file to your computer. Keep it safe. You'll need it to connect to your instance later. This is where you set up additional instance options, but at initial level, you can keep the default settings. You'll specify the number of instances you want, usually just one, networking options, and more. There is no need to change much here. Just stick to the defaults for now. Review all the settings you've selected so far. Once you're happy with them, click Launch. After launching the instance, you will be redirected to a page displaying a Success dialog box. To view the list of instances, click on the instance ID. Choosing an EC2 instance type is like deciding how many lanes a highway needs for traffic. If only a few cars are driving, a single lane road might be enough. But if hundreds of cars are traveling at the same time, you'll need a multi-lane highway to handle the load. Similarly, selecting the right instance ensures smooth performance for different levels of demand. Let's explore the various EC3 instance types and specifications, one by one, and in which scenarios each would be most useful. First, there's general purpose. Think of this as a versatile tool, like a Swiss Army knife. It's well balanced and works for a variety of tasks, offering a mix of processing power and memory. If your streaming app is just starting out, this instance type is a great choice for handling general workloads efficiently. Next, there's compute optimized. Imagine needing super fast processing, like playing a game in 4K with no lag. Compute optimized instances give you more virtual CPUs or vCPUs for tasks that require heavy computing, like video encoding or advanced data processing. It's like choosing a higher resolution and faster streaming for complex tasks. Memory-optimized instances are perfect if a streaming app needs to store and handle a lot of data, such as offering thousands of movies. These instances provide extra random access memory, or RAM, to handle massive data loads efficiently. This is the right choice for managing huge video libraries without buffering. But what if you need extra power for advanced streaming, like handling real-time visual effects or machine learning for video recommendations? Accelerated computing instances provide special hardware like graphics, processing units, or GPUs, which are great for tasks requiring super fast processing. It's like adding a turbo boost to the streaming app to handle advanced tasks faster. Finally, if your streaming platform needs to store a considerable amount of video content and quickly access it, you choose storage-optimized instances. They provide high-performance storage for large data loads, like a massive hard drive that allows the streaming app to store and retrieve data quickly. Every EC2 instance type comes with specific hardware specifications, just like choosing a video device with its own features. Let's break down the specs. Think of vCPU as the brain power behind your EC2 instance, similar to how a processor powers your computer. If you're streaming a movie solo, standard quality works fine, like using a single vCPU for basic tasks like small apps or websites. More viewers or bigger tasks would need more vCPUs, just like HD or 4K streaming requires more power. Memory is like your server's short-term storage, where it quickly stores and processes data. More memory allows you to handle more video streams at once. Instant storage is like the hard drive for your EC2 instance. It's where you store your data, just like you save movies on a device. The more storage you have, the more data or files you can keep. Network bandwidth determines how fast your server can send or receive data, similar to how quickly a streaming app can stream videos to your users. Finally, EBS bandwidth is the speed at which your instance can access storage volumes, like hard drives connected to it. This bandwidth is important for reading and writing data quickly. When creating a key pair to access your EC2 instance, it's essential to save the .pem file securely. If you lose this file, you won't be able to access your instance using Secure Shell or SSH. AWS does not allow you to download it again, so it's best to keep it as a backup. In this video, you learned how to launch an EC2 instance for a streaming app successfully. Your virtual server is up and running in the cloud, ready to handle your streaming needs. You can connect to it, install software, and start managing your app all from this cloud-based server without the hassle of managing hardware. You've built this amazing platform for seamlessly streaming videos, but now it needs to be accessible globally. Running it on a local machine won't cut it anymore. You need something that can handle many users simultaneously and is available 24/7. This is where AWS EC2 comes in. Just like renting a virtual server to stream videos from anywhere, you can deploy your streaming application to the cloud to achieve the same flexibility and scalability. Consider EC2 a virtual control room where the streaming app is managed and scales to meet user demand, no matter how many viewers tune in. To make the video streaming app accessible globally, the next step is to deploy the Spring Boot application to an EC2 instance, turning the local project into a cloud-based service that can grow as it becomes more popular. How do you run your Spring Boot application on an AWS EC2 instance? AWS EC2 refers to Elastic Compute Cloud, a service that allows you to rent virtual servers in the cloud. This makes it easy to deploy applications without managing physical hardware. It provides flexibility, scalability, and reliability for applications like your streaming platform, ensuring it can handle more users as your app grows. EC2 is ideal when you need complete control over your server environment, such as choosing the operating system, installing software like Java, and deploying custom applications like your Spring Boot app. Now that you understand why EC2 is so valuable, let's dive into the deployment process. You'll set up the EC2 instance, install Java, transfer your Spring Boot application, and finally run it in the cloud. Let's break it down step by step. The first task is to launch an EC2 instance during deployment. You'll learn how to do this in a previous lesson. If you've not done so, please set it up as instructed. Now that your EC2 instance is running, it's like having a virtual server ready to power the streaming app. However, just like you need access to a control room to manage your streaming service, you need to connect to your EC2 instance to start configuring it. Once connected, you'll have complete control over installing software, managing files, and running your app. It's like stepping behind the scenes of a streaming app to make sure everything runs smoothly. Let's explore how you can connect to your EC2 instance using Secure Shell, or SSH. To select your instance, navigate to the EC2 dashboard in your AWS Management Console and click Instances to view your running instances. Select the instance you want to connect to. You'll see details about the instance, including its public IP address. Next, click the Connect button at the top of the instance details page. Depending on whether you're using a Linux or Windows instance, this opens instructions on connecting. On the next screen, you'll see several connection options like EC2 Instance Connect, Session Manager, and SSH Client. Click the SSH Client tab. When selected, SSH displays details like the public DNS and instructions to ensure your key pair is secure. Copy the command and run it in your terminal to connect to your instance. Next, open your terminal or command prompt and run the command provided by AWS. Since you're using a Windows system, open your Windows command prompt and run the equivalent command to set the proper permissions for your key file. Instead of the Linux chmod 400 command, use the following in Windows: ICA-CLS streaming app k.pem /inheritance :r /grant:/r $username $r SSH-i your -key -file.pem username at your -instance -public -IP. Replace your -key -file.pem with the name of your key file username with your server's username and your -instance -public -IP with the public IP address of your instance. If everything is set up correctly, you'll be logged into your EC2 instance. You'll know you're connected if you see the instance's IP address and the terminal is ready for commands. This means you've successfully connected to your EC2 instance and can start managing it. Since this Spring Boot application is built in Java, you must install Java on your EC2 instance. Let's explore how to do this in more detail. To install Java, run the following command: sudo yum install java -21 -amazon -corretto -devil. Verify the installation by checking the Java version with java-version. You should see an output showing that Java is successfully installed. To move the Spring Boot application to your EC2 instance, use the scp command. This command transfers files securely using the SSH protocol, which creates an encrypted connection between your machine and the remote server. Here's what the scp command involves. The -i flag specifies the private key file used for authentication. The file path identifies the jar file you want to transfer. The combination of the EC2 user and the instance's public IP address specifies the target machine. Run the command with these details, and your jar file will securely transfer to the directory specified on your EC2 instance. Now that the jar file is on your EC2 instance, it's time to run your Spring Boot application. In your EC2 terminal, navigate to where you transferred the jar file. cd/home/ec2-user. Run the Spring Boot application using the following command: java-jar streaming app -0.0 0.1-snapshot.jar. Your application should now be running on the EC2 instance. You can access it using the public IP address of your instance and the port your Spring Boot app is configured to use. Imagine your EC2 instance has a public IP and your Spring Boot app is running on port 8080. To access your app, simply open a browser and enter http://your-ip-address:8080. This link allows you to view your Spring Boot application running on the EC2 instance from any device with internet access. If everything is set up correctly, you should see the message you've programmed confirming the app deployed successfully. Be mindful of your security group settings. Ensure that your SSH port 22 and the application port, for example 8080 for Spring Boot, are properly configured to allow traffic only from trusted IP addresses. Opening these ports to all traffic 0.0.0.0/0 can expose your instance to security risks. You should also check your application logs. If the Spring Boot application doesn't start as expected, use the tail command with the appropriate option to monitor your log file. Specify the location of your application log file to see real-time updates. This will help you identify any issues with the deployment. In this video, you learned how to deploy a simple Spring Boot application on an EC2 instance using AWS. You explored how to set up the EC2 environment, connect to your instance using SSH, install Java, transfer your Spring Boot application, and finally run it in the cloud. By following these steps, you've made your application accessible online using the EC2 instance's public IP address. This process allows you to leverage AWS's scalability and flexibility, ensuring your Spring Boot application can grow and be accessible to users worldwide. With these skills, you now have the foundation to deploy more complex applications and manage them efficiently on the cloud. Picture the social media platform Pixosa, where millions of users upload photos and videos every day. Managing this vast amount of content on local servers would quickly become overwhelming and costly. Amazon Simple Storage Service, or AWS S3, offers a solution for this type of scenario. Each photo and video that users upload is securely stored in S3's cloud storage, allowing Pixosa to scale seamlessly. With S3, Pixosa can handle unlimited media while keeping everything secure, accessible, and instantly delivered to users around the world. In this video, you'll learn how to store files in AWS S3 and retrieve them when needed, all through the AWS console. By the end, you'll know how to create an S3 bucket, upload files, and manage your S3 configuration directly from the AWS console to interact with S3 effectively. So what is AWS S3 and why is it important for your application? AWS S3 is a cloud-based storage service that allows you to store and retrieve any amount of data at any time from anywhere. It handles large-scale file storage like videos, images, or documents. S3 is also scalable, so as your app grows and needs more storage, S3 expands without any performance loss. Imagine you now have Pixosa all set up and ready to go. The design is stunning and the features are exciting, but there's one crucial step left before users can start uploading their favorite photos. You need to create an S3 bucket using the AWS console. An S3 bucket is a scalable storage solution provided by AWS. It acts like a container where you can store and manage your application's files, such as images, videos, or any other data. For Pixosa, this bucket will hold the user's uploaded photos securely, ensuring they are accessible whenever needed. Log into your AWS console. In the search bar, type S3 and select it from the results to open the S3 console. Click Create Bucket. Give it a unique name like Pixosa Bucket and choose your AWS region. Before creating this name, read the rules mentioned. You can stick with the default setting, but remember to check permissions to control file access. Options like versioning, tags, encryption, and object lock are also available, but there is no need to change anything. Just select Create Bucket. After that, a confirmation banner will appear if successful. Now that the S3 bucket has been created, think of it as an empty photo album waiting to be filled. The next step is to start adding content. In Pixosa's case, this means uploading the photos and videos users eagerly share. Let's learn how easy it is to upload these images and videos. Once the bucket is created, it will be in the S3 console. Click on the bucket's name to start uploading files. Here is your bucket's homepage. Choose the files you want to store, such as videos or photos for Pixosa, and hit Upload to store them in the cloud. To upload a file, click Add Files or Add Folder and choose the file or files you want to store. You can also drag and drop the file directly into the upload box. Once selected, your files will appear and be ready for upload. Leave everything as default and just click Upload to store your file. After this, you will find your object on your bucket's home screen. To get a public URL for your file, start by adjusting its permissions. Select the bucket you created earlier, navigate to Permissions, then Public Access, and click Edit. If Block All Public Access is checked, uncheck it and save your changes. Since the bucket's enforced settings restrict ACLs, which are rules that define who can access objects within the bucket, you can still make your files public by adding a bucket policy. A bucket policy is a set of permissions written in JSON format that allows fine-grained control over access to your bucket and its contents. Here's how to do it. Go to your Bucket's Permissions tab, scroll down to Bucket Policy, and click Edit. Now add a policy that allows public read access. Save the policy. This will allow public access to all objects within the bucket. To get the URL, open the Properties tab of your file. You'll find an object URL there, which will read something like https://your-bucket-name.s3.amazon.aws.com/your-file-name. Just copy the link, and if your permissions are set up right, you can now share it for public access. Amazon S3 is not just any storage solution. It's a service designed to grow with individual needs and keep data safe. Let's explore two advantages of S3 using Pixosa, namely S3's scalability and durability, starting with scalability. When Pixosa first launches, you might start with just a handful of users uploading a few pictures here and there. But as word spreads and more people join, suddenly you have thousands, maybe even millions of photos flooding in. AWS S3 is built to scale as your needs grow. You won't have to worry about running out of space or managing complex storage systems. S3 grows with you. Now let's think about durability. Imagine the panic if, one day, some of those precious photos just disappeared. With S3, you don't have to worry about that. It automatically backs up your data across multiple regions, which means your files are safe and always available when your users want to access them. If something happens to one server, your photos are still safe on another one. This reliability is crucial for an app like Pixosa, where users expect to find their pictures whenever they log in. You can trust that S3 is working behind the scenes to keep those memories safe and sound. By now, you've learned the fundamentals of using Amazon S3 to store and retrieve files through the AWS console. You successfully created a bucket, uploaded files, and managed your S3 configuration directly from the console. Amazon S3 is a powerful tool for scalable and reliable file storage, making it essential for applications like Pixosa that need to handle large volumes of media. Imagine you've built a Spring Boot application called Pixogram, where users can upload and share photos. You've set it up on an EC2 instance, giving you control over performance and scalability. However, as more users join and upload their pictures, your EC2 server starts to feel the strain. To handle all those images effectively, you decide to use AWS S3 for storage, which lets you securely save and access photos from anywhere. But wait, there's more. You want a feature that automatically resizes uploaded images to improve the user experience. That's where AWS Lambda steps in. Instead of juggling another server just for image processing, you can create a Lambda function that kicks in automatically whenever a photo lands in S3. This setup saves resources and keeps your workflow smooth, allowing you to focus on what matters most and delivering a fantastic experience for Pixogram users. AWS Lambda is a service that lets you run code without managing any servers. It kicks into action when something happens, like a user uploading a photo to Pixogram, and handles tasks such as resizing images or processing data. You only pay when your code runs, so keeping servers running constantly is unnecessary. So why use Lambda? It automatically scales with your workload, perfect for apps that need quick and efficient processing, like when someone uploads a picture or triggers an API. It's a smart way to save resources while keeping your app flexible. Let's explore some use cases. Firstly, Lambda can automatically process files, resize images, convert file formats, or extract data whenever they are uploaded or modified, saving time and effort. Lambda can also execute background tasks, like when an API request comes in or something happens on your app. For example, it can send an email or update data without you needing to manage it. Instead of one extensive program doing everything, Lambda can handle small, independent tasks. For example, when a user clicks a button to get a report, Lambda runs that task quickly and separately from the rest of your app. This makes things faster and easier to manage. What if you want to resize user-uploaded photos automatically? Instead of writing complex code to manage servers, you can use AWS Lambda. It can be triggered each time a photo is uploaded to S3, automatically resizing it. This way, the process becomes efficient and cost-effective, and you don't have to worry about managing any servers. Now let's explore how you can create a Lambda function. First, sign into the AWS Management Console and open the AWS Lambda console at https://console.aws.amazon.com/lambda. Or in the search bar, type Lambda and select AWS Lambda. To create a new Lambda function, click Create a Function, then select Author from scratch. Name your function, for example, Image Resizer. For the runtime, select Java 17 or the version you use to create your zip or jar. In the Permissions section, select Create a new role with the required permissions. Click Create Function. Next, to deploy a jar file as a Lambda function, scroll down to the function code section in the Lambda function console. Under the code source, click the Upload button. Choose the .zip/.jar file and select the zip file you created earlier. Once uploaded, you will see a message confirming that your zip has been uploaded successfully. To set the handler for the Lambda function, find the handler field in the Settings section of the Lambda console. Enter the handler name for your Lambda function in the format com.lesson.image resizer lambda followed by double colons and then handle request. After entering the handler, click the Save button at the top right or bottom of the page to save the changes. Next, set up an API gateway to trigger the Lambda function. In the AWS console, search for and navigate to API Gateway. Choose Create API and select REST API, then click on the Build option and add the API name Resize API. Next, in the left-hand panel, under API, select Resources and select the root directory or an existing resource. Go to the Actions menu and select Create Resource. Enable Proxy Resource. Add the resource name that you've given in your code, Image Resizer. The path, open curly brace, proxy plus close curly brace, is set automatically to handle any subpath. Next, click Create Method, set the HTTP method to get, and specify the Lambda function you want to invoke. Enable the proxy option. Now that your root is integrated with the Lambda function, you need to deploy the API. After creating the methods, you will see the gateway dashboard displayed as shown. Next, deploy your API by creating a new stage, generating a unique invoke URL for accessing your API. Click Deploy API. You can then deploy your API by setting up a new stage, which generates a unique invoke URL for accessing the API. After deploying, you'll be given an endpoint URL or invoke URL. This URL will be in the following format: https:// followed by angle bracket API -ID angle bracket, then .execute -API followed by angle bracket region angle bracket .amazonaws.com/dev. As you have learned in previous lessons, you can use tools like Postman to test the Lambda function using the GET request. Open Postman, create a new request, and set the method to GET. There's no need to pass any parameters since it's a GET method. In the URL field, enter the API Gateway endpoint URL. In this video, you explored AWS Lambda and learned how it can run code without the need for managing servers, making it an ideal solution for dynamic, event-driven tasks. You created a simple Java Lambda function that resizes images and sets up an API gateway to trigger the function when users upload images to Pixelgram. With Lambda, scaling your application becomes effortless, and server management is no longer a concern. Congratulations on completing Module 3 of the Full Stack Web Development course. In this module, you expanded your knowledge of web APIs and cloud deployment, critical for creating dynamic, scalable applications. By focusing on building, consuming, and deploying RESTful services, you've acquired key skills that will enable your applications to communicate effectively across the front end and back end. Let's reflect on the essential concepts and techniques you've learned and why they matter in your journey as a developer. You began with RESTful services in Spring Boot, a crucial architecture for building APIs that enables seamless communication between web applications. REST, or Representational State Transfer, emphasizes principles like statelessness, client-server interaction, and resource representation. You also worked with key HTTP methods like get, post, push, and delete, which dictate how data is retrieved, submitted, updated, or deleted in your applications. Building on this, you constructed RESTful endpoints using annotations like @getMapping, @postmapping, @putmapping, and @deleteMapping to handle various user actions. In doing so, you created a user API capable of managing CRUD operations, allowing for the creation, retrieval, updating, and deletion of user data. This hands-on work showed you how to structure APIs that manage requests and return relevant data effectively. You also honed your understanding of HTTP methods and their appropriate uses within REST APIs, mapping requests to specific endpoints, capturing path variables, and handling query parameters with @request mapping, @path variable, and @request param allowed you to efficiently route and process data. Handling errors is, of course, essential for maintaining reliable APIs. So you implemented global exception handling with @controller advice and custom exceptions, making sure your application returns clear and meaningful error messages. Alongside this, you applied data validation using @valid and @notnull annotations to ensure only valid input reaches your system, safeguarding the integrity of your data. Lastly, you incorporated Hateoas, or the Hypermedia, as the engine of application state to enrich your APIs. By adding navigable links within your responses, you made your services more intuitive and self-descriptive, enhancing the overall user experience. Once you built your APIs, the next focus was learning how to consume them from the front end, a vital step in creating dynamic, data-driven web applications. You started by using the Fetch API to send get, post, push, and delete requests, allowing your front end to communicate effectively with your API. This enabled you to retrieve data and update the DOM, making your web pages more interactive. In addition, you applied error handling strategies using .catch method and status checks, which ensured that your applications could gracefully handle network issues without compromising user experience. To enhance your workflow, you moved on to Axios, a more robust alternative to Fetch. Axios simplifies API requests, providing more readable code and additional features, which streamline the process of managing API calls. Finally, you integrated APIs with front-end frameworks like React or Vue.js, creating components that dynamically retrieve and display data. This integration is essential for building modern, seamless user experiences in full-stack applications. In the final part of the module, you turned your attention to cloud deployment using Amazon Web Services, or AWS, a critical skill for scaling and managing modern web applications. You began by setting up an AWS account and launching an EC2 instance, gaining hands-on experience with running virtual servers in the cloud. From there, you deployed your Spring Boot application on EC2, connecting your backend to a scalable cloud infrastructure. You then integrated Amazon RDS, a managed relational database service, with your Spring Boot application. This ensured your backend could handle data operations efficiently, even as your application scales. You also worked with Amazon S3, using it to store and retrieve files securely. This integration provided a robust solution for managing data storage in the cloud. AWS Lambda allows you to run code without managing servers. By setting up Lambda, you enable your application to trigger backend operations efficiently. And to simplify deployment and scaling, you used AWS Elastic Beanstalk, which, thankfully, automates much of the management process. Finally, you learned how to monitor your application's performance and health using AWS CloudWatch, equipping you with the tools to track and optimize application stability in real time. Organizations today need developers who can build and consume RESTful services, using Spring Boot, integrate APIs with front-end frameworks, and deploy applications in AWS. Why? These web API abilities are critical for creating scalable, secure, and cloud-ready full-stack applications. The goal of this module was to equip you with the skills to develop a user API, consume APIs with front-end frameworks, and deploy applications in the cloud. By mastering these skills, you're positioning yourself to build robust applications that can handle any modern business demands. Congratulations once again on completing this module, and best of luck as you continue to explore the power of APIs in your development journey. Congratulations! You've successfully completed Course 5, a major step forward in your full-stack web development journey. You've progressed from mastering the fundamentals of web development to constructing advanced full-stack applications with cutting-edge technologies. Software powers the modern world, and now you have the skills to better build and shape it. Let's take a moment to reflect on the journey you've undertaken and the essential skills you've gained throughout this course. You began your full-stack journey in Module 1 by mastering the fundamentals of front-end development. This involved gaining proficiency with the 3 core technologies, HTML, CSS, and JavaScript, which form the backbone of any web project. Starting with HTML, you learned how to structure content using headings, lists, tables, and forms. By understanding how to use tags effectively, you ensured that your pages were not only organized, but also accessible and logical. Next, you enhanced the user experience by styling your pages with CSS. From selecting colors and fonts to aligning text and adding dynamic backgrounds, you explored various techniques to customize your designs. You also practiced responsive design using Flexbox and Grid, making sure your layouts looked great across devices, from desktops to smartphones. Finally, you brought your web pages to life with JavaScript, adding interactivity through features like event handling, dynamic forms, and DOM manipulation. These skills allow you to create engaging, responsive pages that deliver a seamless user experience. In Module 2, your focus shifted to back-end development using key Java server technologies. You explored Java Server Pages, JSP, Java Servlets, and Spring Boot, powerful tools that streamline the creation of dynamic web applications. A major highlight of this module was mastering the Model View Controller architecture. This design pattern separates an application's data, logic, and user interface, making your code easier to maintain and scale, especially for larger projects. You applied this by setting up a Spring MVC project, creating models for data and controllers for HTTP requests. These skills will support real-world projects like managing user data, processing transactions, or building scalable content management systems. Additionally, by integrating dynamic views with TimeLeaf and JSP, you gained the ability to serve real-time content and create interactive user experiences. Recall you also used Spring Boot to build a REST API, which is how to manage HTTP requests and return JSON responses efficiently. Pushing beyond the basics, you explored advanced Spring Boot features. With Spring Security, you learned how to manage authentication, and Spring Data JPA streamlined your data handling. Experience with both equips you to build secure, scalable backend systems, critical for robust, real-world applications. In Module 3, you expanded your skill set by mastering RESTful services and cloud deployment, key components of modern web development. You learned how REST architecture enables seamless communication between front-end and back-end. It does this using HTTP methods like GET, POST, PUT, and DELETE to manage data. With Spring Boot, you built a user API to handle CRUD operations, and on the front end, you used Fetch API and Axios to dynamically interact with your backend. You then ventured into cloud deployment with Amazon Web Services. What you did was deploy Spring Boot applications on EC2 instances, manage databases with Amazon RDS, and leverage Amazon S3 for file storage. AWS Lambda helps you efficiently run backend code, while Elastic, Beanstalk, and CloudWatch simplify deployment and monitoring. These industry-leading tools equip you to build scalable, cloud-native applications with ease. In today's fast-paced tech landscape, organizations rely on high-performance solutions to manage everything from real-time data processing to large-scale transactions, skills you now possess. For your course project, you built a full-stack to-do list web application, integrating a weather API to make task management smarter. You combined HTML, CSS, and JavaScript for the front end, while using Spring Boot for back-end logic and RESTful APIs to connect both sides seamlessly. This project put all your skills to the test, demonstrating your ability to build a dynamic, real-world application. Great work. What does this course mean for your career? Full-stack developers are in high demand, whether building apps from scratch as startups or managing back-end services and cloud infrastructure for major enterprises. With experience of Spring Boot, APIs, front-end frameworks, and AWS, you're now equipped to take on anything from e-commerce platforms to cloud-native applications that require both scalability and top-tier performance. Congratulations once again on completing the course. I hope you're excited to dive into real-world projects and continue pushing your full-stack skills even further. Best of luck on the exciting journey ahead. Congratulations! You've successfully completed Course 5, Full Stack Web Development. Your hard work and dedication have paid off, and you're now equipped with the skills to build robust, dynamic, and scalable web applications. In this course, you learned how to implement the essentials of modern web development. The goal was to equip you to develop full-stack web applications with confidence, no matter the project. Organizations need developers who can build interactive web pages, implement RESTful services, and design responsive, user-friendly layouts using HTML and CSS. With a little HTML, you can now construct interactive web pages that meet modern businesses' demands. Using HTML tags, lists, links, anchors, tables, forms, and more, you should feel confident structuring and organizing web pages and applications. With your current HTML and CSS skills, you can consistently style any page or app you work on with selectors and properties. Colors, fonts, and text styling all help enhance the aesthetic appeal of your work for users. And because users in the real world don't all use the same devices, you can now deploy responsive design techniques using media queries for the best layouts possible, no matter how users interact with your page or app. With some advanced JavaScript functions in your toolkit, like declaring variables, managing data types, and using operations like concatenation, your applications will be able to handle user actions and respond appropriately. With these front-end skills, you can tackle a wide range of real-world challenges, from creating feature-rich websites for small businesses to developing scalable web applications for large enterprises. On the back end, developers need to be able to build dynamic systems and handle HTTP requests. As you learned, Java server technologies like Spring Boot and the MVC architecture are the tools for such jobs. A major milestone was creating RESTful APIs, which enable seamless communication between the front end and back end, essential in modern development. Of course, organizations need their web pages and apps to be secure and efficient, which you can now do with Spring Security and Spring Data JPA. Your journey didn't stop there. You also deployed applications in the cloud with AWS using EC2, RDS, and S3, which are skills highly valued in today's industry. You also practiced implementing RESTful services with Spring Boot, such as constructing APIs that connect your front-end and back-end systems, essential for building dynamic web applications. You gained hands-on experience integrating HTML, CSS, and JavaScript with your back-end logic, handling HTTP requests, and managing dynamic data interactions using Fetch API and Axios. To top it all off, you deployed these full-stack applications in the cloud using AWS, working with EC2, RDS, and S3 to scale and manage them efficiently in real-world scenarios. With these skills, you're now better equipped to tackle the demands of API-driven development and deploy robust, scalable applications in the cloud. Great work! These tools power the digital world, and now you can leverage them to make an impact. With your newly developed skills, you are now equipped to build full-stack web applications using Java technologies like Spring Boot, implement server-side logic, and manage HTTP requests with RESTful services, and integrate front-end technologies like HTML, CSS, and JavaScript to create interactive user experiences. You've made incredible strides throughout this course, and your achievements demonstrate your ability to tackle complex web development challenges. By completing this course, you're another step closer to earning the Amazon Professional Certificate in Junior Software Development. This certification and the experience you've gained will open doors to exciting opportunities in full-stack web development. While you've completed this course, your learning journey is just beginning. Build your strong foundation by diving into more advanced topics and real-world projects. To keep your career moving forward, consider taking the next meaningful step by registering for the next course in the program. Thank you for your time and commitment. Congratulations again on your achievements, and best of luck as you continue honing your skills. Writing code is inherently complex because it involves understanding requirements, translating them into logical structures, and ensuring the program functions as intended. Developers often spend hours debugging, optimizing, and refining code to meet specifications, and even minor errors can lead to significant challenges, consuming time and resources. Addressing errors correctly requires not only technical skills, but also deep problem-solving skills and attention to detail. Now imagine having a tool that not only writes code for you, but also detects bugs, suggests improvements, and even helps you design complete software solutions. In this course, you'll learn about AI tools that can do just that. AI is transforming industries, and software development is no exception. AI can streamline software development, reducing the time and effort needed for manual coding and enabling developers to focus on higher-level design and innovation. By the end of this course, you'll know how to use AI to write and optimize your code faster, detect and fix bugs quickly and efficiently, and build projects using generative AI. These skills are in high demand across tech companies and industries relying on software innovation. So, how could you leverage AI now and in the future? AI will help you to turn your logic or pseudocode into real programs. It can also help you to learn new programming languages and frameworks by providing instant suggestions and corrections to your code. And AI can modernize and update outdated code efficiently, making it easier to work with. AI can generate test cases automatically to ensure your programs are functional. It can find and fix bugs in your code, saving you from spending hours searching for mistakes. AI can also optimize your code to run faster without the need for manual rewrites. And finally, AI can offer coding exercises and tips to help you enhance your job readiness. For example, you could use it to simulate a mock interview, engage in conversation with you, and provide you with feedback. What will you learn in this course? You'll explore what generative AI is and how tools like ChatGPT, Amazon Q Developer, and Copilot are shaping the coding world. You'll get hands-on experience using Amazon Q Developer and GitHub Copilot to write, refactor, and debug Java code. Lastly, in your final project, you'll build a chatbot using Amazon Q Developer. It's a chance to put your skills into practice. When you master these skills, you'll not only improve your productivity as a developer, but also enhance your problem-solving abilities. This course is designed to give you a competitive edge by teaching you how to leverage generative AI to improve your coding. You will learn to write code that is faster, more efficient, and contains fewer runtime bugs. So, what are you waiting for? Let's get into the exciting realm of generative AI. Discover how it can revolutionize the way you write, understand, and optimize code, or even prepare for interviews. Your journey to becoming an AI-enhanced developer begins now. Welcome to the exciting world of generative artificial intelligence, or Gen AI. In this revolutionary domain, computer programs have become creators, capable of crafting stories, composing music, generating images, and even writing code. But what does generative artificial intelligence actually mean? To understand that, let's start with the foundation: artificial intelligence, or AI. AI refers to machines or software programmed to replicate human intelligence. For example, AI can recognize human faces, understand and respond to spoken language, or even navigate complex environments like a self-driving car on the road. Unlike traditional AI, which primarily focuses on predicting outcomes or classifying data, generative AI is dedicated to the creation of entirely new content. It trains machines to generate unique outputs, such as text, images, music, or even code, by learning patterns and structures from existing data. While our primary focus in this course will be on generative AI, it's helpful to contrast it with another type of AI known as discriminative AI. Discriminative AI excels at making decisions or predictions by analyzing and classifying data. For example, it can determine whether an image depicts a dog or a cat. Discriminative AI acts as an evaluator. In contrast, generative AI is the creator, capable of producing entirely new content based on what the generative AI had learned during training. While both types of AI are powerful and serve distinct purposes, generative AI radically stands out due to its ability to innovate. Whether composing novel music, generating realistic but synthetic voices, or designing new product prototypes, generative AI is transforming industries. So what are some examples of Gen AI's capabilities? If trained on thousands of stories, Gen AI can create new ones with unique plots and characters while maintaining the style of the training data. AI models capable of this include ChatGPT, Claude, Microsoft Copilot, Google Gemini, and Jasper AI. For example, here ChatGPT is tasked with creating a poem based on the user's requirements, writing about Java and Spring Boot in a rhyming prose style. An AI model, like DALL-E, trained on vast collections of images, can conjure new visuals from even the most complex or imaginative text prompts. For example, when asked for a smiling dolphin repairing a space shuttle while orbiting Earth, AI can bring this fantastical scene to life, turning a wild idea into a vivid image, as demonstrated here. This ability to create precise and tailored visuals on demand makes AI an invaluable tool for simplifying complex ideas, enhancing understanding, and supporting learning across diverse fields. For example, when ChatGPT is prompted to generate a detailed visualization of an MVC architecture, which uses different technologies like HTML, Spring Boot, MySQL, and JavaScript, it transforms the prompt into a clear and engaging image while keeping the technical details accurate. Let's take it a step further. Have you ever wondered if a computer could compose music? Gen AI tools can now generate unique melodies or even emulate the style of famous composers. This capability opens up exciting possibilities, from creating original symphonies to enhancing creative workflows in music production. For example, tools like Beethoven.ai and Brev.ai empower artists and innovators to explore new frontiers in musical expression. Now for the part most relevant to you. Can Gen AI write code? Gen AI tools like GitHub, Copilot, Amazon Q Developer, and Microsoft Copilot are designed to generate programming code based on prompts provided by the developer. These tools can produce code snippets, complete methods or functions, or even entire programs, making development faster and more efficient. ChatGPT, as a general-purpose generative AI, can handle tasks like code generation. For instance, it can generate the code for a program to generate the Fibonacci series, showcasing its versatility and practical application in programming. It not only generates the code, but also provides a detailed explanation of how it works, which enhances the understanding of the logic and serves as a valuable teaching tool. Additionally, it suggests improved alternatives to optimize memory utilization. Both text and code generation rely on similar underlying principles: language models that learn patterns in data. However, the output differs. The output of code must be in line with the correct syntax of the programming language, and other considerations, like the optimization of catching runtime bugs, need to be included. Now let's reconnect all this information to your programming journey. Generative AI tools are transforming how developers work. Imagine needing to write a complex function in Java. Instead of starting from scratch, a Gen AI assistant could generate most of the code for you based on a brief description. For example, let's say you're building a chatbot. You could describe how it should respond to different user inputs, and an AI tool can help generate the Java code for those responses. This not only saves time, but also enables you to learn new coding patterns by example. Let's explore a basic example using Amazon Q Developer, this time to create a program that greets users based on the time of day. Using a descriptive prompt, such as give me the code for a class named greetUser, with a main method which greets users based on the time of day in a very basic way using strings, will produce the code you need to do it. It not only gives you the code, but also explains it, making it a valuable tool for understanding the logic behind the solution and applying it effectively in other similar contexts. Let's wrap up. Gen AI is changing the way we code and solve problems. Its power lies not just in generating content, but in empowering you to think critically, logically, and creatively. Learning how to use tools like Amazon Q Developer and refining your prompting techniques will help you unlock new levels of productivity and innovation in your software development journey. Teaching a chef to cook is about more than following recipes. It's about understanding how ingredients and techniques come together to create something new. They learn to innovate by mastering the art of cutting, mixing, marinating, and blending ingredients to craft unique meals. This approach mirrors the essence of Gen AI. Like the chef, Gen AI learns from existing data, combining elements in creative ways to produce novel outputs. The training data consists of massive data sets, which could be text, images, or even lines of code. Just like the chef learns patterns from recipes, Gen AI learns patterns and features from the data it's fed. For example, training an AI model with thousands of gigabytes or petabytes of Java code enables it to understand how Java programs are structured. It can then use this knowledge to generate new code snippets that fit specific needs, much like the chef creating a new dish from familiar ingredients. How does it all work? Large datasets serve as the foundational building blocks. Gen AI identifies patterns, learns rules, and extracts important features to create patterns for new content. It is similar to how a chef might notice patterns in recipes, like pairing certain spices or knowing that cakes usually need flour, eggs, and sugar to create a new type of cake pastry. Once trained, the model can take a small input, like a prompt, and generate meaningful output based on what it learned. For example, if you give it a partially written Java method, it can complete it or even suggest improvements. It can also identify potential runtime bugs in the code and optimize it for improved performance and efficient resource utilization, such as memory. Let's investigate how this works in the real world. Using Amazon Q Developer, imagine you need to write a method that calculates the total cost of items in a shopping cart. Instead of coding it from scratch, you could provide a prompt describing what the method should do. You could use the following prompt. Write a method to calculate the total price of items in a shopping cart, which generates the following output. The code snippet is generated based on the patterns the AI has learned from its training data. Here, you will observe that Amazon Q Developer has generated a static inner class named cart item and a method calculate total price in a class named price calculator, which calculates the total price of cart item collection passed to it. You can use the copy button to copy the code and paste it manually, or use the insert a cursor button to insert the code directly at the cursor's current position in your Java file in IntelliJ. You'll notice that Amazon Q Developer includes instructions on how to use it in the main function and also explains the code's functionality. In addition, it provides insights into why the code is good and what could be done to enhance it further. At the very end, it includes the source from which the solution was taken. Keep in mind that while the generated code may vary between runs, the working code and its output will remain consistent. They will all contain the method and calculate the total cost of items in a shopping cart. This is akin to a chef preparing a cake. Whether the dry ingredients are mixed first and the eggs are added later, or everything is combined at once, the result is still a cake. Gen AI is changing the way developers work. Instead of spending hours writing boilerplate code, they can focus on solving more significant problems. Imagine how much faster a chef could create a menu if they had a system that suggests new recipes based on available ingredients. Similarly, Gen AI boosts productivity in software development by suggesting efficient code based on your specific needs. In this course, you'll learn how to harness this power to enhance your coding skills and create smarter, more efficient solutions. Next, you'll get some hands-on experience using Gen AI. Are you ready to get coding? Imagine you have a personal assistant who works at lightning speed. You hand them a task and moments later you have a draft. However, there's a trade-off. Their work isn't flawless. You'll need to review, correct, and sometimes provide additional guidance to refine the output. This personal assistant is much like using Gen AI tools in software development. Tools like Amazon Q Developer rapidly generate code and insights, but they require thoughtful oversight and analysis before use. Gen AI is transforming software development, making processes faster and more efficient. However, like any tool, it comes with challenges and limitations. This video explores the impact of Gen AI and demonstrates how it can be used in software development. First, let's break down how Gen AI fits into the software development lifecycle, or SDLC. In the planning phase, Gen AI can analyze documentation or user feedback to identify functional requirements. It can also suggest design patterns or architectural styles based on the project's needs. During the development phase, Gen AI tools like Amazon Q Developer can generate boilerplate code, assist in writing complex algorithms, and even optimize your code. During testing, Gen AI helps automate unit and integration tests by generating test cases and identifying edge cases. During deployment, Gen AI recommends configurations for deployment and monitors for potential issues. And finally, during maintenance, Gen AI assists in bug detection, performance monitoring, and automatic documentation updates. Let's explore how Gen AI boosts productivity in software development in further detail. First, it provides code suggestions. For example, suppose you're working on a Java program and need to write a method that formats dates. Instead of manually searching for the right solution, Amazon Q Developer can suggest the most relevant snippet based on your input. Second, Gen AI can complete the code for you. You might begin by typing the start of a function and then request Gen AI complete it for you. Finally, it can generate methods. You provide a brief description, and the Gen AI generates a complete method or function. Let's investigate how Amazon Q Developer can build an item class for a shopping cart, which will store items using an array list. First, create a blank file named item.java. Before using Amazon Q Developer, you need to ensure that the auto-suggestion of Amazon Q Developer is running. If the option to pause auto-suggestions is available, it means it's running. Now, add a comment describing the class, such as create a class item which is capable of storing the item name and price and have the setters and getters. Depending on the speed of your internet connection, a possible solution might be suggested as soon as you press the Enter key. You could also first type public below the comment and then after pressing the spacebar, wait for some time for the suggestion from Amazon Q Developer to appear. Click on Insert Code or press the Tab key on your keyboard to accept the suggestion or select another suggestion from the pop-up by clicking Next or Previous. Now the suggested code has been inserted into your file. The tool quickly generates the foundational structure of the class, which could have taken you much longer if you did it manually. But here's the thing, like the assistant, Gen AI isn't perfect. It finds the best pattern or perspective based on your input. For example, it doesn't validate if the data is correct or if the best practices or optimizations are used. So it's up to you as a developer to fix it. Select the code and right-click on it. Then go to Optimize Code. You'll observe that the Amazon Q Developer chat window is displayed with the optimized code. Accept all the suggestions. If the current code is already selected, you can click Insert at Cursor to overwrite the changes and accept the suggestions. You might have to import some classes, like the rounding mode, as demonstrated here. In fact, Amazon Q Developer also reminds you to add these imports at the top of your file. This time, the code is much better and safer to use, but it could still benefit from further validations, like checking for edge cases and runtime issues, for example. Using a Gen AI like Amazon Q Developer has other advantages. For example, after optimization, Amazon Q Developer mentions the benefits you would get from the optimization. While Gen AI can boost productivity, it's essential to be aware of its limitations. Sometimes Gen AI generates code that appears correct but contains bugs. Gen AI might fail to handle scenarios like empty carts, invalid inputs, or rounding inconsistencies, writing a method that calculates the total price of items in a shopping cart. Developers must thoroughly test for edge cases and debug, as these tools can miss such nuances. Since Gen AI tools are trained on vast datasets, which could include proprietary or sensitive code, this can lead to potential copyright violations if the generated output resembles copyrighted material. For example, a Gen AI might generate a code snippet that mirrors a proprietary algorithm from a public repository, creating legal and ethical dilemmas. Something else to consider is that relying too much on AI might reduce your own problem-solving skills over time. For example, instead of figuring out how to optimize an algorithm or debug a complex issue, you might be tempted to use Gen AI generated suggestions, losing opportunities to deepen your technical expertise, and, over time, completely lose touch with the technical skills needed to find issues. These limitations highlight the need for a balanced approach. Use the AI for efficiency, but don't skip the human oversight and ensure the generated code meets your project standards. So, think of Gen AI as your assistant, a tool that helps you speed up your work by automating repetitive tasks and generating initial drafts. It's not about replacing developers, but about enhancing your productivity and creativity. To wrap it up, with tools like Amazon Q Developer, you'll not only save time, but also gain new insights into coding patterns and problem-solving techniques. However, remember, just like any assistant, the Gen AI needs your guidance and expertise to deliver the best results, because you need to give it the exact context and prompt to get the best output. You're working on a big Java project, but instead of diving into the exciting parts, you're spending hours on repetitive tasks, writing boilerplate code, troubleshooting common errors, and managing endless details. Imagine if these tasks could be streamlined. In this video, you'll discover how generative AI, particularly tools like Amazon Q Developer, transforms Java development by tackling these everyday challenges head-on and opening up new possibilities for creative coding. So, how does generative AI work? And what makes it so powerful for Java developers? Generative AI creates code, content, or ideas by learning from large datasets. In Java, tools like Amazon Q Developer use it to make coding easier. Say you need a function to calculate the area of a rectangle, just ask, and the AI will quickly generate the code. It also catches errors as you code, suggests improvements, and takes care of repetitive tasks like setting up templates. This means less time on the basics and more on the creative parts. For beginners, it's like having a guide. Real-time feedback, helpful suggestions, and clear explanations make it easier to learn Java fundamentals and best practices while coding. It's a hands-on way to build skills faster. With the basics covered, let's dive into a real-world example to explore generative AI in action. Meet Alex, a developer at a small retail company. Alex's latest task? Building a Java inventory app to manage stock. The app must handle basic operations, adding, displaying, and deleting items. So, Alex sets up a new Java project in IntelliJ and creates 3 main classes. The item class represents individual items, the item manager class manages item operations, and the main class runs the program. To speed up the setup process, Alex uses the Amazon Q plugin in IntelliJ to generate some initial code. First, Alex types a simple prompt into Amazon Q. Create a main class for the application that prints "Welcome to the Item Manager." Within seconds, Amazon Q Developer provides the code for a basic main class that displays a welcome message. This gives Alex a quick and functional starting point. Satisfied, Alex copies and pastes the code into the main class, replacing the existing code. Next, Alex needs an item class to represent each item in the inventory. So, Alex prompts Amazon Q again. Create a basic item class with ID and name. Amazon Q Developer provides a well-structured item class with fields for ID and name, plus constructors, getters, setters, and a toString method for easy display. This generated code matches Alex's requirements for representing items in the inventory. Accepting this code saves him from writing it manually, keeping his focus on more complex logic. Now, Alex needs a way to manage the items in the inventory. He prompts Amazon Q once again. Add functionality to the Item Manager class by implementing methods that add, display, and delete items from an array list. Amazon Q generates the Item Manager class with methods to add, display, and delete items, as well as to retrieve an item by ID and count the total items. Additionally, Amazon Q Developer automatically suggests new code for the main class to help Alex test the program. The AI provides guidance saying, you can use this Item Manager class in your main program like this. This integration allows Alex to immediately test the Item Manager's functionality, adding items, displaying the inventory, and removing items. With Amazon Q support, Alex can seamlessly manage the workflow without needing to write everything from scratch. Alex runs the program to verify its functionality. The main method performs the following tasks: adds items to the inventory, displays the current list of items, deletes an item by ID, displays the updated list after deletion, and shows the total item count. When executed, the program confirms that each feature works as expected, displaying outputs that guide Alex through the current state of the inventory. With Amazon Q Developer, Alex quickly generated the foundational code for managing items in an inventory application. This saved time and effort, allowing Alex to focus on refining the app's functionality. In the future, Alex could further enhance the app by connecting it to a database for persistent storage, extending beyond the in-memory array list currently used. However, it's worth noting that generative AI, like Amazon Q, isn't just a simple code generator. Each prompt can yield different responses, requiring developers to carefully review and adjust the code to ensure it aligns with their project goals. AI assists in the creative process, but the final decisions and customizations remain in the developer's hands. In this video, you explored how generative AI tools like Amazon Q Developer streamline Java development by automating repetitive tasks and catching errors in real time. Through Alex's journey building an inventory app, you saw how AI empowers developers to focus on core functionality. Imagine using these tools to improve your workflow, boost code quality, and tackle complex challenges. With generative AI, you're not just coding, you're enhancing your creativity and efficiency in every project. Ever wish coding could feel less like troubleshooting and more like creating? What if you had a tool that suggested improvements, flagged errors as you typed, and guided you toward the best practices, all seamlessly integrated into your Java IDE? That's where Amazon Q Developer comes in. In the previous reading, you explored how to get started with Amazon Q Developer and learned about its different versions. Now let's dive deeper into how it supports your Java development by helping with writing, debugging, and optimizing code in real time. Amazon Q Developer is designed to make coding faster and easier. As you write, it offers smart, contextual suggestions to complete your code, saving you time and improving accuracy. But it's not just about suggestions. It detects potential errors as you type and provides fixes on the spot. This means fewer interruptions to your workflow and more time spent building. The tool also focuses on code optimization. If there's a better way to structure your code, Amazon Q Developer suggests alternatives to ensure your program runs smoothly and efficiently. Why spend time tracking down errors or tweaking your code manually when you could focus on building solutions instead? Let's explore it in action. Imagine you're tasked with creating a simple Java program that takes two numbers from the user and performs basic arithmetic operations: addition, subtraction, multiplication, division, and modulus, the remainder of a division operation. In this example, you've already set up a program in IntelliJ called Simple Calculator with a Java class named calculator.java. To define the main method in the calculator class, you can start by using this prompt. In the calculator class, create a main method, declare two integers with assigned values, perform addition, subtraction, multiplication, division, and modulus operations, and display the results. Amazon Q Developer will generate code suggestions based on this prompt. Alternatively, you can type the method manually. For instance, start typing static void main, open parentheses, string array args, close parentheses, inside the class body. Amazon Q Developer will recognize the context and suggest code to complete the main method, including the calculations. Once suggestions appear, you can scroll through them using the next and previous tabs. This lets you explore different suggestions. When you find a suggestion that works, click Insert Code to add it. If none fit your needs, you can write the code manually or use the chat feature to generate something more tailored. Remember, the output from Amazon Q Developer is based on what it has learned, so you may need to tweak the inserted code to match your requirements. If the first suggestion meets your needs, you can accept it after reviewing it. For example, if the suggestion includes code to perform the 5 required arithmetic operations and appears to fit your requirements, click Insert Code to accept it. The accepted code will be inserted directly into your calculator class. This code is ready to run without any modifications, and you can execute it by clicking the Run button or selecting Run Calculator.main from the project pane. The results of the arithmetic operations, sum, difference, product, quotient, and remainder, will display in the console. Congratulations, you've created your program with minimal manual coding effort. However, using fixed input values means the output is always the same. To make it dynamic, you can update the code to accept user input. Start by declaring a scanner object inside the main method to read user input. You'll add this line at the beginning of the main method. Scanner equals new scanner open parentheses system.in close parentheses semicolon. As soon as you type scanner, Amazon Q Developer will detect the context and suggest code to set it up. Once you encounter a suggestion that includes all the steps required, such as creating the scanner object and reading user input, you can accept it. This suggestion handles setting up dynamic input so you can replace the fixed values in the program. Next, replace the fixed values in your program with variables that read numbers entered by the user. Make sure the scanner class is imported at the top of your file. If it's not already there, you'll need to add import java.util.scanner. If you miss this step, Amazon Q Developer will prompt you to include it automatically. The program is now ready to accept user input and calculate results dynamically. In IntelliJ, click the Run button or right-click the calculator class and select Run Calculator.main. When the program runs, it will prompt you in the console to enter two numbers, for example, 75 and 54. The program will then display the sum, the difference, the product, the quotient, and the remainder. Amazon Q Developer isn't just about writing code, it also ensures you follow best practices. For example, if you forget to close the scanner object at the end of your program, the tool will detect this and suggest adding the following line to prevent resource leaks. Scanner.close. Let's test this. Omit the scanner.close line from your code. Amazon Q Developer will suggest adding it. Moreover, explore how Amazon Q Developer enhances efficiency by suggesting better alternatives for improved performance. What about division by zero? This common error could cause the program to crash. Amazon Q Developer detects the risk and suggests adding a condition to check if the divisor is 0. By including this, the program can handle the situation gracefully, displaying an error message instead of crashing. At this point, the program is complete. It dynamically takes user input, performs calculations, and includes safeguards like preventing division by zero. Amazon Q Developer has not only streamlined the coding process, but also helped ensure the program is efficient and error-free. This demonstrates how Amazon Q Developer is more than just a coding tool. It's a reliable assistant that simplifies your workflow, helps you follow best practices, and lets you focus on creating great solutions. Amazon Q Developer empowers you to code smarter and faster. In this calculator example, Amazon Q Developer not only streamlined the coding process, but also prompted a crucial non-zero check for division, preventing runtime errors. By practicing these techniques, you build skills that make your code more efficient, reliable, and ready to handle real-world challenges. Coding often comes with its fair share of challenges. Whether it's tracking down a tricky bug or trying to understand a new concept, the process can feel overwhelming. What if there were a tool that could explain concepts, offer guidance, or even help you write code right when you need it? That's where ChatGPT comes in. ChatGPT is an advanced AI language model built by OpenAI. It's designed to understand and generate text in a way that feels natural, almost like you're talking to a colleague. For developers, though, it goes a step further. ChatGPT can explain complex programming ideas, help debug issues, and even write code tailored to your needs, all in a matter of seconds. So how does it work in practice? Let's dive in. Say you're learning Java and trying to understand inheritance. You could dig through documentation or tutorials, but that takes time. Instead, you could ask ChatGPT, can you explain Java inheritance with a real-world example? It might respond with a simple explanation, using a vehicle class and a car subclass to show how inheritance works. Along with that, it'll provide code you can use or adapt, helping you connect the concept to something practical. What about debugging? Picture this: you're frustrated by a null pointer exception and can't figure out what's wrong. Instead of scrolling through forums, you copy your code into ChatGPT and ask, why am I getting a null pointer exception in this code? It'll identify the issue and explain why it's happening. You'll get suggestions to fix it, and you'll understand what went wrong, so you can avoid it next time. Need code generated for you from scratch? You could ask for a program that performs basic arithmetic by saying, write a Java program that takes two numbers and performs addition, subtraction, multiplication, and division. However, it's important to review the code to ensure it's accurate and meets your requirements and expectations. As you may have noticed in the previous example, ChatGPT generates a complete program and explains each step. So you don't just copy and paste, but also learn how it works. Once you have the basics, you can ask ChatGPT to refactor the code for better readability using functions, suggest optimizations for improved performance. With ChatGPT, you can solve problems faster, learn new concepts more easily, and spend more time focusing on writing great code. But to really unlock its potential, it's important to consider how to interact with ChatGPT. The way you ask questions makes a big difference. Being specific, like mentioning the programming language or including a snippet of code, gives ChatGPT the context it needs to provide clear and accurate answers. And if the response doesn't quite hit the mark, you can always ask follow-up questions to dig deeper. That conversational flow is one of its strengths, helping you refine your understanding as you go. Of course, ChatGPT isn't perfect. It might miss details in complex scenarios, struggle with vague questions, or suggest outdated solutions for newer technologies. For example, it might list a certain code using Java 7, whereas it would be optimal to use Java 8. That's why it's important to use ChatGPT as a support tool, not a replacement for your expertise. Clear prompts and a critical eye can make all the difference, helping you get the most out of what this AI can offer. You've learned about tools like Amazon Q Developer, which flags errors and guides best practices, and ChatGPT, which helps explain concepts and troubleshoot issues. These tools have shown how AI can support coding in powerful ways. Now it's time to explore GitHub Copilot, a tool designed to help you write smarter, faster, and more efficiently. Built on OpenAI's Codex model, GitHub Copilot generates suggestions as you code. Whether you need a quick snippet, a complete function, or even an entire class, it works seamlessly within IntelliJ IDEA and VS Code, adapting to the unique context of your project and workflow. In this video, you'll explore how GitHub Copilot integrates with IntelliJ, learn about its features, and understand how it can simplify your Java development process. Start by ensuring your GitHub Copilot subscription is active. Sign into your GitHub account by navigating to the GitHub website and locating the sign-in button. If you don't have an account, select Sign Up and follow the prompts to create one. Once you've logged in, go to the GitHub Copilot product page. You'll find details about the available plans and options to activate your subscription. Review the available plans, including the individual plan for personal use and the business plan for teams. If you're new to Copilot, you can take advantage of a 30-day free trial to explore its features before subscribing. After you activate your plan, you're ready to set up GitHub Copilot in your IDE. Let's install GitHub Copilot in IntelliJ IDEA. Open the Settings menu, then navigate to the Plugins section. Search for GitHub Copilot in the Marketplace. Select it and install the plugin. After installation, restart IntelliJ IDEA to complete the setup. Once IntelliJ restarts, a prompt will appear asking you to sign in with your GitHub account. Enter your credentials to authenticate the connection and activate Copilot. When the setup is complete, GitHub Copilot is ready to assist you with real-time coding suggestions and context-aware help. Now let's test it out by creating a simple Java method to calculate the factorial of a number. Inside the main class, begin by typing the method signature, public int factorial, followed by an opening parenthesis, the parameter int n, and a closing parenthesis. Then, add an opening curly brace to start the method body. You'll notice that Copilot begins suggesting the complete method, including its logic. To accept the suggestion, press the Tab key. The entire function is inserted automatically, saving you time and effort. Now your factorial method is ready to use. Next, test the method by writing code in the main method. Copilot often suggests test cases automatically based on the context of your code. If it doesn't, use the inline chat feature. Ask Copilot to create a test case for calculating the factorial of 5. Within seconds, Copilot generates the test case. Review the suggestion, accept it, and run the program. The output matches the expected result, confirming that the code works as intended. Copilot also makes it easy to generate code from comments. Clear the class and type a comment like // calculate the factorial of a number recursively. Copilot analyzes the comment and suggests a method that matches your description. Accept the suggestion with the Tab key, and the method is added to your code. Testing code often appears automatically, but if not, adding a comment like // generate test cases for this method will guide Copilot to provide relevant code. Review and accept the suggestion to include the test case in your program. Beyond generating and testing code, Copilot can help debug issues. Imagine encountering a null pointer exception in your code. Copilot can detect the issue and suggest solutions, such as adding null checks to prevent the error. For instance, if you type "fix the null pointer exception" in the inline chat, Copilot will analyze your code and propose a fix. Apply the suggestion and the error is resolved quickly. So why is GitHub Copilot a game changer for Java developers? It speeds up coding by handling repetitive tasks like boilerplate code, freeing you to focus on bigger challenges. Its autocomplete feature predicts what you need, whether it's a simple method or a complex class, and its context awareness ensures suggestions fit seamlessly into your project. Copilot also helps with documentation by generating clear comments and explanations, making your code easier to understand. And if you're learning Java or exploring a new library, it offers examples that make concepts easier to grasp. You've now explored how GitHub Copilot integrates seamlessly with tools like IntelliJ IDEA to transform your Java development process. So, as you apply what you've learned today, think about how Copilot can help you build smarter solutions and take your Java projects to the next level. Picture this. You've just written a loan application program that checks user eligibility based on age and loan amount. While it works, it may lack input validation or have unclear variable names. Traditionally, you'd rely on a senior developer to review your code, but this can be slow, especially for larger projects. Now imagine Amazon Q Developer, an AI-powered tool designed to streamline code reviews. Integrated with IntelliJ IDEA, it analyzes your code in real time, flags issues, and offers actionable suggestions. More than just identifying bugs, Amazon Q Developer teaches best practices, helping you write cleaner, more efficient, and maintainable code. When writing code manually, common issues like missing input validation, ambiguous variable names, and lack of error handling can lead to bugs and poor readability. Let's compare a basic program written without and then enhanced using Amazon Q Developer. The program works, but has notable shortcomings. For example, first, there is no input validation. Users can input invalid or negative values without any checks. Second, the variable names are ambiguous. Names like age and loan amount must be more descriptive, making the code harder to understand. And third, lack of error handling. The program doesn't handle unexpected inputs, such as non-numeric values, which could cause it to crash. Let's explore how to enhance the code with Amazon Q Developer. Highlight or select the code by placing your cursor within the code block. You can also highlight the code in IntelliJ IDE. Now you can either run a code review by selecting Amazon Q's explain code or fix code. Amazon Q Developer will analyze the selected block. Lastly, you can interact with Amazon Q Developer by using the inline chat to request things like enhance the Java loan application code by adding input validation for positive age and loan amounts, with error messages for invalid input. Rename variables to user age and requested loan amount. Implement error handling with a try-catch block to handle non-numeric input and guide the user to enter valid data. The program should check if the user is 18 or older to accept or reject the loan. The AI will offer tailored suggestions to enhance your code. Let's break down the suggestions Amazon Q Developer provides for improving the code. First is input validation. You have to add validation to ensure inputs are meaningful. For instance, check that the age and loan amount are valid and positive numbers. This prevents errors or unexpected behavior later in the program. The second is improved variable names. The current variable names like age and loan amount must be more descriptive. Clear variable names make the code easier to read and maintain, especially for other developers or your future self. You can rename the age to user age and the loan amount to requested loan amount. These names are more descriptive and improve readability. The third is error handling. The code assumes users will always enter valid inputs, but what if they don't? For example, the program will crash if a user enters a non-numeric value. Add error handling to manage such scenarios gracefully. You can add a try-catch block to catch invalid inputs and guide the user to enter the correct data. The final and improved code looks something like this. The program starts by asking the user for their age and the loan amount they want. Then it checks if the inputs are valid. If the age or loan amount is negative, it shows an error message and stops right there. If the inputs are valid, it checks if the user is 18 or older. If yes, it accepts their loan application. If not, it informs them they're ineligible. It also handles mistakes, like entering letters instead of numbers, guiding the user to input valid data. Finally, it closes the scanner to clean up resources. Simple, robust, and user-friendly. So why do these suggestions from Amazon Q Developer matter? If you apply these improvements, the program becomes more robust, handles edge cases gracefully, and is easier to read and maintain, thanks to better variable names. The updated program also avoids crashes caused by invalid inputs and adheres to best practices by managing resources properly. In short, these changes collectively enhance the quality and reliability of your code. In this video, you learned how AI-powered tools like Amazon Q Developer can automate code reviews, making the process faster and more effective. You also learned how AI identifies missing input validation, poor variable naming, and resource management problems, and provides actionable suggestions to improve your code. By using these tools, you save time and write cleaner, more reliable, and maintainable code. This lesson highlighted how integrating AI into your workflow helps you focus on development while continuously learning and applying best practices. You're developing a loan registration feature for a banking application. Users submit details like their name, income, and loan amount, and your application processes this information to assess eligibility. Now consider this. Multiple parts of your application access and update this data simultaneously. Imagine it's like two people writing on the same piece of paper at the same time. One person might accidentally overwrite the other's work, or the final result could end up garbled. This is called a race condition. It happens when two or more parts of the system compete to update shared data at the same time. These race conditions can lead to issues like data discrepancies or errors without proper synchronization. For instance, two updates happening at the same time might overwrite each other, causing incorrect loan counts or eligibility results. Synchronization ensures updates happen in the right order, keeping your data accurate and your application reliable. This is where Amazon Q Developer comes in. As your AI-powered assistant, it scans your code, identifies potential bugs, and offers fixes to ensure your loan registration system remains accurate, secure, and efficient. In this video, you'll learn how AI tools like Amazon Q Developer detect and resolve synchronization issues and other bugs, ensuring reliability in critical systems. Even a small bug can disrupt a loan registration system, leading to errors in data processing or failed registrations. Identifying these issues early is critical for data integrity, reliability, security, and efficiency. Data integrity ensures that loan application details like income or loan amount stay accurate and unaltered. Bug detection prevents errors and ensures smooth processing. Reliability means a dependable loan system processes applications accurately, like a well-run train, and smoothly delivers passengers to their destination. Efficiency ensures a smooth application process by using bug detection to identify bottlenecks early for faster, seamless loan processing, while security helps protect sensitive loan application details, such as personal and financial data, with bug detection to prevent breaches. Amazon Q Developer can help you achieve all this by proactively detecting and resolving critical issues before they affect your application. Here's how it works. Spotting patterns means the AI detects non-thread safe operations, like multiple threads updating a loan count simultaneously, that might cause bugs. Detecting anomalies happens when the AI flags unusual behavior, such as skipped validation for certain loan applications. Lastly, understanding context allows the AI to analyze how threads interact with shared data, identifying synchronization issues that could lead to race conditions or errors in loan counts. By identifying these issues early, Amazon Q Developer ensures your loan registration feature remains accurate, secure, and reliable for users. In a loan registration system, multiple threads handle tasks like verifying user details, calculating eligibility, and updating loan counters to improve speed and efficiency. Without proper synchronization, two threads updating shared data simultaneously can overwrite each other's changes, causing errors like incorrect loan counts. Synchronization ensures only one thread modifies shared data at a time, preventing race conditions and keeping the system accurate and reliable. In a loan registration system, multiple threads process applications simultaneously, verifying details and updating the loan count to improve efficiency. However, issues can arise if threads update shared data like the loan counter simultaneously. For example, two threads may read the same loan count, increment it, and write back simultaneously, causing a race condition and leaving the loan count incorrect. Let's explore a simple loan processor class. The loan processor class uses the loan counter variable initialized at 0 to track the number of processed loans. Each time the processed loan method is called, the counter increments by 1, displaying the updated counter along with the user ID. In the main method, thread_1 and thread_2 are created, each processing loans for different users. The issue arises when both threads run simultaneously and access the loan counter simultaneously. For example, both threads might read the loan counter as 0, increment it, and write back 1 instead of 2. This happens because the increment operation isn't thread safe, causing a race condition that results in an inaccurate loan count. To fix this, you must synchronize access to the loan counter and ensure only one thread can update it. When you run Amazon Q Developer on this code, it identifies loan counter ++ as a potential issue. Here's what the AI uncovers. First, shared variable access occurs when the tool detects that the loan counter is being accessed by multiple threads simultaneously, creating a high risk of synchronization issues. The AI flags that loan counter ++ is not thread safe. For instance, both threads might read the same initial value, such as 0, increment it to 1, and write it back. This causes the counter to remain at 1 instead of increasing to 2, leading to a classic race condition. Here's how it unfolds. If the loan counter starts at 0, both threads read the value 0, increment it to 1, and each writes 1 back to the counter. As a result, the counter ends up at 1 instead of 2, illustrating the race condition clearly. Amazon Q Developer doesn't just identify the issue. It helps pinpoint exactly where things could go wrong, making it much easier to fix the problem and ensure your loan registration system runs smoothly. Amazon Q Developer recommends adding synchronization to the process loan method to fix the issue. This ensures that only one thread can access the loan counter at a time, preventing race conditions. Here's the updated code. Adding the synchronized keyword ensures threads access the loan counter one at a time, allowing accurate updates. Even if both threads attempt to process loans simultaneously, one will wait for the other to finish, effectively eliminating the race condition. In this video, you learned how Amazon Q Developer can identify and resolve critical code issues, like synchronization problems and race conditions. Therefore, you save time with automated bug detection and enhance the reliability and accuracy of your code. By integrating AI-driven tools into your development workflow, you ensure that your applications are robust, well-synchronized, and capable of handling real-world concurrency challenges effectively. This proactive approach strengthens your code and builds trust in your high-stakes applications. Are you working on a large Java project with inadequate documentation? Figuring out what and how it was done can be frustrating and time-consuming. Writing method documentation is tedious and often overlooked, leading to confusion and bugs. Imagine an AI assistant that reads your code, understands methods, and generates accurate, up-to-date documentation effortlessly. That's Amazon Q Developer. Documentation is key to project success. It helps developers understand code, track changes, and prevent issues. While JavaDoc supports basic manual documentation, it's time-consuming and quickly becomes outdated. Amazon Q Developer transforms this process by using AI to create precise, current documentation. It saves time, ensures consistency, and keeps your project running smoothly. In this video, you'll learn how tools like Amazon Q Developer automate Java documentation, improving code readability and boosting team productivity. For example, in a loan application where methods handle sensitive data and complex calculations, adding a method like calculate loan amount becomes seamless. Amazon Q Developer analyzes the method's name, parameters, and comments to generate clear, consistent documentation automatically. This AI-driven tool keeps documentation up to date, simplifies the codebase, and saves developers time. It even allows adding extra details, such as explaining key calculations, for enhanced clarity. With Amazon Q Developer, your code stays organized, easy to understand, and ready to grow with your project. Let's compare creating documentation with the traditional JavaDoc and Amazon Q Developer. First, you must understand the method of calculating the eligible loan amount for each user based on their income and desired loan term. The method is straightforward. Multiply the user's income by the loan term and apply a 5% rate to determine the loan amount. This method takes two parameters, income and term in years, and returns the calculated loan amount. However, to make this function more understandable for future developers, clear documentation needs to be provided that explains the purpose, parameters, and calculation details. With traditional JavaDoc, you would manually add comments. For example, the documentation indicates the method's purpose as calculating a loan amount based on two inputs, income and term in years. The @param tags indicate that income represents the user's income, and term in years refers to the loan term duration in years. The @return tag specifies the method will return the calculated loan amount. This documentation provides a basic overview but lacks detail. It doesn't explain the calculation fully or specify that the method applies a 5% rate to the income over the term. Future developers would benefit from clearer specifics. For example, a lack of detail in the description, unclear parameter descriptions, incomplete, and no calculation example. Let's unpack this more. First, the documentation omits the 5% multiplier in income, term in years, 0.05, a crucial detail for understanding how the loan amount is calculated and why the method functions as intended. Second, the parameter income isn't clearly defined, leaving it ambiguous whether it refers to annual income or something else. Similarly, term in years isn't explained as representing the loan's duration in years, which can confuse developers unfamiliar with the context. Third, the documentation explains the return value but needs to mention how the 5% multiplier influences the result, leaving the calculation process unclear. And fourth, including an example calculation like $50,000 multiplied by 5 multiplied by 0.05 is equal to $12,500 would make it much easier to understand how the method operates, especially for developers reviewing the code for the first time. These omissions make it challenging to quickly grasp the method's purpose and functionality, underscoring the importance of more comprehensive documentation, which could be significantly improved with tools like Amazon Q Developer. Let's analyze the documentation generated by Amazon Q. The updated documentation clearly explains how the calculate loan amount method calculates the loan amount using income and term in years, providing a step-by-step understanding of the process. The documentation provided a detailed breakdown of scenarios where 1. With an income below $50,000, the loan amount is 0. 2. An income between $50,000 and $100,000 results in a calculation of 5 multiplied by income multiplied by term in years. And 3. An income of more than $100,000. The calculation is 10 multiplied by income multiplied by term in years and then multiplied by 0.05. The enhanced documentation clarifies the formula return income multiplied by term in years multiplied by 0.05, explaining the 5% rate and simplifying the calculation logic. In short, the new documentation saves time by clearly explaining the method's purpose, inputs, and output, eliminating the need to analyze the code in detail. In this video, you've discovered how Amazon Q Developer automates documentation, keeping it accurate and up-to-date as your project evolves. This saves time, boosts productivity, and ensures code is clear and accessible for all developers. This is especially valuable for software developers managing complex projects. It reduces the effort required to document and understand intricate code bases, allowing them to focus on building robust and efficient solutions. Adopting AI-driven documentation leads to a more efficient and maintainable codebase. Have you ever felt like designing software architecture is like piecing together a puzzle, with half the pieces missing? Structuring code, defining how components interact, ensuring scalability and maintainability, it's a lot to juggle, right? That's where AI tools come in. Think of them as your personal assistant for software design, offering insights, suggesting design patterns, and helping you optimize workflows. In this video, you'll explore how AI can revolutionize the way you approach software architecture, from structuring projects to fine-tuning workflows. You'll observe how these tools turn daunting tasks into manageable steps. Ready to check out how AI can be your co-architect? Let's jump in and discover its capabilities, one project at a time. Have you ever wondered what holds a software system together? What makes it scalable, secure, and maintainable? Well, that's where software architecture steps up. Software architecture is like the blueprint of a building, but for your software. It's all about the big picture, the components, how they interact, and the design decisions that shape your system's performance, scalability, and security. Let's break it down. First up, components. These are the building blocks, like controllers, services, repositories, and other components. Next, interfaces. They define how components communicate with each other. Then there are design patterns. Think of these as reusable solutions to common design challenges. And finally, architectural styles. Frameworks like microservices, monoliths, or layered architecture that guide your design approach. Understanding software architecture isn't just for big projects. It's the foundation of every successful system. It provides clarity, reduces technical debt, and supports future development. So, let's explore further and learn how it all comes together. Let's face it, designing software architecture isn't exactly a walk in the park. There are so many decisions to make, and each one feels like it could make or break your project. First, there's figuring out the right level of abstraction. How much detail is too much? Then, you're balancing trade-offs like performance, scalability, and simplicity. And don't forget the challenge of picking the right design patterns. On top of that, there's handling changes without over-engineering and managing dependencies to keep your system modular. Sound familiar? Here's the good news. AI tools can make these challenges a lot less intimidating. Whether you're a seasoned pro or just starting out, they guide you through tough decisions and keep your architecture on track. Next, let's explore how these tools tackle these challenges head on. Ever open a project folder and thought, where do I even start? Structuring code efficiently is key to creating scalable and maintainable software, but it can be a real challenge. That's where AI tools come in. Using machine learning and large language models, or LLM, these tools don't just analyze your code. They guide you in organizing it like a pro. Here's how. First up, code-based analysis and refactoring. Tools like SonarQube scan your entire project to pinpoint inefficiencies, redundant code, and even architectural bottlenecks. They might suggest coding styles, redundant codes, and following best practices. Next, there's AI tools like GitHub, Copilot, or Amazon Code Whisperer used to generate code. These generate standard templates for architectural patterns like Model View Controller or MVC, or RESTful APIs, saving you from repetitive setup tasks. And when it comes to organizing your Java projects, AI can even recommend a clean, scalable folder structure. This e-commerce project is a good example. Here's how it could be represented. A clear separation of models, services, controllers, and utilities. Organized resources for configurations and templates, and dedicated test folders to keep testing code separate from your main application. With AI's help, your project can go from chaos to clarity, making it easier for your team to navigate, debug, and extend. So why struggle when AI can simplify the process? Software projects can get complex fast. From managing dependencies to optimizing performance, there's a lot to keep track of. That's where AI tools step in to simplify your workflow. Let's start with dependency management. Tools like Dependabot monitor your project's dependencies, flagging outdated or vulnerable packages. For example, if you're using an old version of Lodash, it'll recommend an upgrade, keeping your project secure and up to date. Then there's continuous integration and deployment, or CI/CD. AI-powered tools like CircleCI Insights analyze your build pipelines, spotting inefficiencies and suggesting ways to speed up tests and deployments. AI can also assist with code reviews. Tools like AWS Code Guru provide real-time feedback on pull requests, flagging potential issues, and even recommending improvements to your code. But what about performance? AI tools can simulate system loads and pinpoint bottlenecks. They might suggest adding caching layers, horizontally scaling databases, or even sharing data for distributed systems. For instance, if you ask, how can I scale a web application to handle traffic spikes? An AI might suggest adding a load balancer, caching with Redis, and setting up auto-scaling groups for dynamic resource allocation. And let's not forget error handling. AI tools can recommend defensive programming techniques like try-catch blocks, logging strategies, and effective monitoring tools to keep your app running smoothly. At the end of the day, AI tools do more than streamline your tasks. They bring efficiency by reducing repetitive work, consistency, ensuring best practices are followed, learning support, explaining suggestions for those still building their skills, and scalability, providing guidance for handling growth. With AI as your co-pilot, structuring code becomes faster, smarter, and more scalable. But here's the thing, AI isn't perfect. While it's a powerful assistant, it's not without its limitations. Let's take a moment to talk about where AI falls short and why your judgment as a developer still matters. First, there's the issue of context. AI often suggests generic solutions that might not align with your project's unique needs. For example, it might recommend a database sharding strategy when a simple caching layer would do the job. Then there's the danger of over-reliance. If you blindly implement AI recommendations without fully understanding them, you could end up with suboptimal solutions, or worse, new problems. And finally, let's talk about creativity. AI is great at working within established patterns, but it struggles with thinking outside the box. If your project needs an innovative or unconventional approach, that's where you shine. AI tools work best when they're used as collaborators, not replacements. They take care of repetitive tasks, offer valuable insights, and even suggest solutions you might not have considered. But ultimately, the creativity, judgment, and context, that's all you. By blending AI's efficiency with your expertise, you can design software that's robust, scalable, and uniquely tailored to your needs. So, Are you ready to combine the power of AI with your own ingenuity? Let's keep innovating together. If you've ever felt overwhelmed trying to decode Java programs, especially those real-world examples that seem to go on forever, you're not alone. The good news is that AI tools like Amazon Q Developer can be your coding buddy, simplifying explanations and tailoring them to any experience level. In this video, you'll discover how to use Amazon Q Developer to understand and explain Java code. And trust me, this will level up your learning game. All right, let's address the big why first. AI isn't just a cool tech buzzword. It's your new best friend for simplifying complexity, break down dense Java code into bite-sized, understandable pieces, providing context. Confused by unfamiliar syntax? AI's got your back. Offering tips? Get instant suggestions to improve or optimize your code. For learners, this means faster learning with instant clear explanations, deeper comprehension since there's an understanding of not just the how, but the why, and skill growth due to the exposure to best practices and alternatives. Now, let's explore an example. Bank account management. Here's a simple Java program for managing bank account balances. If this seems a little intimidating, don't worry. Let's break it down with AI. Here's where Amazon Q comes in. Follow these steps to get detailed insights. Start with a right-click. Inside the class in IntelliJ, right-click and select Amazon Q, Explain Code. Then get the overview. Amazon Q summarizes the entire code in its chat box. Now dig deeper. Ask, explain each method in detail for someone new to Java programming. Expect explanations about constructors, deposits, withdrawals. Every method is broken down step by step. And finally, verify clarity. Ensure AI is explaining like a true newbie-friendly teacher. Want to push it further? Ask Amazon Q, how can this code be improved? You'll get gems like better error handling with specific exceptions, input validation for all operations, better encapsulation with private methods, and proper getter methods for accessing account information. And there's a whole lot more where those came from. Like any tool, AI works best when you know how to use it effectively. Here are some hacks you'll love. First tip, be specific. Don't just ask, what does this code do? That's too broad. Instead, try something like, can you explain the purpose of the loop in this code? Precision helps AI zero in on exactly what you need. The more targeted your question, the more meaningful the response. Here's the thing, AI is an assistant, not a replacement. It's here to complement your knowledge, not to do all the thinking for you. Remember, it can't replace your critical thinking or domain expertise, so use it to enhance your skills, not bypass them. Not getting the answer you need? No problem. Refine your question. Let's say the explanation feels unclear. Ask the AI to simplify it or give examples. Think of it as a conversation. The more you engage, the better the results. Context is king. AI can help you understand how small pieces of code fit into the bigger picture. For instance, you might ask, how does this function contribute to the overall application? This way, you're not just learning syntax, but understanding design. When the AI explains concepts or suggests improvements, don't stop there. Ask for examples. Checking out the suggestion in action, like a code snippet, can turn abstract ideas into something concrete and actionable. Are you a beginner or a seasoned developer? Let the AI know. You can ask for simplified explanations if you're starting out, or deeper insights if you're more advanced. Tailoring the response makes the learning experience more effective. Here's a pro tip. Always verify. AI isn't infallible. It might miss context or make incorrect assumptions. So cross-check the explanations or code it generates to ensure accuracy before implementing it. Want to level up? Ask the AI how to make your code faster, cleaner, or more efficient. Questions like, are there better algorithms for this? Or, can you suggest a best practice? Can take your skills to the next level. Don't forget, use AI's insights to document your codebase. It saves time and ensures everyone on your team understands the project better. Plus, you'll thank yourself later when revisiting the code. Finally, embrace the process. Using AI is all about experimenting and learning. Try its suggestions, implement changes, and see what works. Over time, you'll hone your skills and make this tool a seamless part of your workflow. So there you have it, 10 tips to make AI your ultimate coding assistant. Now let's wrap things up. You've explored how AI tools like Amazon Q Developer can become your secret weapon for decoding Java code. Whether you're just starting out or you've been coding for years, these tools are designed to meet you where you are and provide insights that truly make a difference. They simplify complex code, explain tricky syntax, and even suggest ways to optimize your work. From understanding functionality to improving your design patterns, these tools bridge the gap between confusion and clarity. What's great is their versatility. Beginners can grasp the basics, while advanced developers can fine-tune their skills and tackle sophisticated challenges. The actionable insights you gain go beyond just understanding the code. They help you build confidence to solve real-world problems. But remember, it's not just about the tool, it's how you use it. Pairing these AI insights with hands-on practice is the key. That combination lets you break down complex Java code, understand its finer details, and even share your knowledge with others. So, what's next? Dive in, experiment, and let these tools guide you. With practice, you'll unlock a deeper understanding of Java and gain the skills to confidently tackle whatever comes your way. Thanks for watching, and as always, happy coding. Congratulations on finishing this module. Over the past lessons, you've explored how Generative AI works and applied its capabilities to real-world Java development. This wasn't just an introduction to theory. You've had hands-on experience with tools like Amazon Q Developer, ChatGPT, and GitHub Copilot. These coding assistants have helped you streamline your workflows, solve problems, and save time on repetitive tasks. From setting up these tools to using them effectively, you've built a solid foundation for integrating AI into your development process. You've learned that generative AI isn't just a trendy concept. It's a practical tool that analyzes massive amounts of code, learns from it, and provides actionable insights. For instance, you've seen how it can generate boilerplate code like getters and setters, suggest algorithms when you're stuck, and even refactor a nested loop into a cleaner, more efficient solution. These tools are designed to handle routine tasks so you can focus on the bigger challenges. Take a moment to imagine working on a project where deadlines are tight. Through this module, you've experienced how AI tools can flag potential bugs, like resource leaks or null pointer exceptions, in real time. You've also seen how they can automate documentation, keeping it up to date with the latest changes in your codebase. These tools don't replace your skills, they amplify them, helping you deliver better results faster and with fewer headaches. A key takeaway has been the importance of crafting effective prompts to guide AI. Let's say you're trying to refactor a loop for better performance. A simple prompt like, "Rewrite this loop using streams," could instantly provide you with a cleaner, more efficient solution. If the initial response doesn't quite fit, you can refine your instructions like, "Focus on improving readability while keeping the same functionality." Iterative prompting allows you to guide the AI toward exactly what you need. Each tool brings something unique to the table, and you've explored how to leverage them effectively. Amazon Q Developer, for instance, is great for generating boilerplate code or catching syntax errors while you code. ChatGPT acts like a coding mentor, explaining complex logic, brainstorming solutions, or even generating pseudocode. And GitHub Copilot integrates directly into your IDE, offering real-time, context-aware suggestions tailored to your specific project. Beyond saving time, you've experienced how these tools enhance code quality. Imagine working on a large project with multiple contributors. AI tools can detect inappropriate code, like overly long functions or inconsistent naming, and suggest best practices to keep the codebase maintainable. They're particularly handy during code reviews, flagging potential issues before they escalate into bugs. This module also emphasized the importance of ethical considerations when using AI. You've reflected on challenges like ensuring proper attribution for open source code and protecting sensitive information. While AI offers incredible benefits, you've learned that your judgment and critical thinking remain essential. Reviewing and validating AI suggestions is crucial to aligning them with your project's goals. The benefits of these tools go beyond writing code. They enhance every stage of development. Need to build a database integration? AI can generate DAO classes to handle CRUD operations. Working on a complex front-end, back-end interaction? It can create glue code to connect the two seamlessly. But you've also recognized that maintaining your core problem-solving skills is key. AI helps, but it's your expertise that shapes the final product. The big takeaway? Generative AI is here to make your job easier, not to take it over. It's about automating the repetitive parts, catching potential errors early, and leaving you free to focus on designing robust, scalable solutions. By mastering these tools, you're not just adopting new technology, you're setting yourself up to be more productive and innovative in your work. This is just the start of what you can do with AI in your development toolkit. Keep experimenting, keep learning, and let these tools empower you to build better software. AI is part of your daily life, often in ways you might not even notice. When your email inbox filters spam, it's learning from your actions, adapting to recognize patterns, and improving over time. This ability to evaluate and adapt mirrors how humans learn from experience and make evaluations. In this video, you will learn about machine learning, or ML, a branch of AI that teaches systems to mimic this ability by learning from data. As you have learned, AI refers to the simulation of human intelligence by machines. The goal of AI is to enable computers to perform tasks that typically require human intelligence, such as recognizing patterns, understanding language, and making decisions. Think of Alexa or Siri. These AI assistants process your voice commands, convert voice to text, analyze the intent and context of what you're saying, and take action to respond appropriately. This image illustrates how machine learning is a specific area of study within the broader field of artificial intelligence. Unlike traditional programming, where you explicitly tell the computer what to do, machine learning allows computers to learn from examples and apply that learning to new tasks. The way it works is relatively simple. You provide the program or machine with lots of data, like historical records, images, or emails, and it identifies patterns within that data. Once it learns these patterns, the machine can make predictions or decisions without needing explicit instructions for every scenario. Let's go back to the example introduced at the beginning, email spam detection. How would a machine decide which email is spam and which one is not? Suppose, first, you feed the machine learning model with thousands of emails, each of which is labeled. Some are marked as spam and others are marked as not spam. The model studies patterns in the data or email. Some spam emails might contain phrases like "win a gift" or "urgent, claim your prize." It also reviews other features, like the sender's address, the number of links in the email, or even the URL that these links point to. It finds patterns in emails marked spam and not spam. Once the model is fully trained, it can classify new emails as spam or not spam based on what it has learned, by comparing the new email to the patterns that are common for spam. The following diagram illustrates the process of training a spam filter using machine learning. It consists of 4 key steps. It begins with training data, where labeled emails, for example spam and not spam, are collected. Next, the data is pre-processed through cleaning and normalization. The cleaning process removes the irrelevant data or noise, and normalization ensures that the data input is in a consistent structure and format, which is treated uniformly by the model. The model is then trained to learn patterns from the labeled data. Finally, the output is a trained spam filter, which can utilize patterns learned during training to identify and filter spam emails effectively. The next diagram illustrates the classification process of a new email using a trained spam filter. It is important to remember that a spam filter model would primarily be used as a part of a larger system rather than in isolation. When a new email is received, the system has no predefined judgment on whether the email is spam or legitimate. Now the model can be used to separate the spam emails from those which are not spam. The model compares and analyzes the email using the patterns it learned during training to analyze features such as subject lines, keywords, links, and sender information. If the features of the new email match the spam filter's learned patterns, which are similar to the patterns of a spam email, it is then classified as such. If the features do not match the patterns for a spam email, the email is classified as not spam. Now let's consider an important limitation of machine learning: false positives. In the example of spam filters, this happens when a legitimate email is mistakenly flagged as spam because it shares characteristics or patterns of a spam email, as learned by the model during the training phase. For instance, a genuine email with a subject like "claim your prize" might be classified as spam based on patterns the model learned during training. No machine learning model is perfect. Errors could occur. You must understand the importance of balancing precision and recall to reduce such errors, improve training processes by refining data and features, and, in the case of this example, regularly check your spam folder to catch misclassified emails and update the model if this type of error in classification is reoccurring. Machine learning is an essential advancement in software because it learns and adapts over time as it processes more data. This capacity to learn and adapt is crucial because it allows the system to stay effective by learning from new patterns and changes in an environment. The email filter is just a minor example of AI use. AI, for example, is also used in healthcare to detect diseases early, in finance to detect fraudulent transactions, on the computer network to detect entry into a computer network by a malicious hacker, and even in entertainment to recommend movies or songs based on your preferences. This is made possible by ML. By learning from past data, machine learning models can improve the accuracy of predictions, enhance user experiences, and solve complex problems faster than traditional programming methods. Machine learning improves as it processes more data, identifying patterns and adapting to meet specific needs. It helps make faster, data-driven decisions, but it's important to critically evaluate its outputs since it lacks the deeper understanding and perspective of humans. As you continue this course, you'll explore how AI, including machine learning, can transform software development and experience its capabilities in action. Suppose you want to predict tomorrow's weather. Instead of relying on a single weather app, you decide to gather forecasts from multiple weather apps to get an average of the predictions for a more reliable result. This approach mirrors the process used by random forest algorithms. It combines the outputs of multiple decision trees to enhance accuracy and stability. In this video, you'll build on the earlier example of predicting whether a student will pass or fail using a random forest implementation. You'll discover how using multiple trees instead of one can lead to better, more reliable predictions. But first, let's define a random forest. A random forest is a group of individual decision trees whose results are collected together to arrive at a prediction. The decision trees that form the group are called a random forest. While a single decision tree can provide an answer quickly, it may become overly confident with specific data, resulting in overfitting. Remember, overfitting happens when a model focuses too much on the specific details and patterns in the training data, even if they're just random noise. It makes the model perform well on the training data, but struggles to handle new or different data, failing to generalize. Random forests solve overfitting by training on many different decision trees. Let's investigate this concept in a bit more detail. Each decision tree in the forest is trained on a different subset or portion of the data. This ensures that each tree learns unique patterns or relationships in reference to a single feature or characteristic of the data in consideration. The input data is then applied to these different decision trees. Since each tree will focus on a specific part or feature of the data, having been trained to focus only on that specific feature or aspect of the data, the results would vary. You will discover this in an example shortly. The result is derived by averaging the output of each tree into a single final prediction. In this way, this model can generalize better and perform well on unseen data. Again, this will become clear in the example that follows. The last key concept you need to know is that a random forest is based on two main principles: bagging and feature randomness. The technique of each tree in a random forest being trained on a different random subset, characteristic, or feature of the data is called bagging, which reduces the chance of overfitting by ensuring that each tree has a unique perspective on the data. At each split in a tree, only a random subset of the features is considered. This adds a layer of randomness, ensuring that the trees don't all appear the same and rely too heavily on specific features. Now let's explore the process diagrammatically. Assume that a decision you want to make depends on 4 characteristics or features, A, B, C, and D. This example uses letters to keep the explanation simple, but features could also include attendance, age, or academic results. The first tree focuses on features A and C, the second tree focuses on features B and D, and finally, the third tree focuses on features A and B. The model had some training data, and then bagging and feature randomness were applied. With regard to bagging, each tree is trained on a different subset of the original data, ensuring diversity in the training process. For feature randomness at each split, only a random subset of features is considered. For example, tree 1 uses features A and C, preventing trees from focusing too much on a single dominant feature. In the diagram, the 3 trees together make the random forest. Each of the 3 trees would give its prediction based on its training data, which would result in 3 different predictions. The result would be the average of the predictions of the individual trees in the random forest. So, in a random forest, the first step involves creating multiple decision trees, and the second step combines the results to derive a more accurate prediction. Let's now revisit the pass-fail example using random forests. Here's how it would work. Each tree in the forest trains on a different subset or feature of the student data. One tree might prioritize study hours. Another might focus on attendance. A third might emphasize assignment scores and attendance. Each tree makes its prediction, and the random forest averages these predictions to make a final decision, reducing the risk of overfitting and improving accuracy. In this case, tree 1 focuses on study hours and predicts pass. Tree 2 focuses on attendance and predicts fail. And tree 3 combines assignment scores and attendance and predicts pass. By averaging the predictions of the individual trees, the final prediction is pass. By learning random forests, you have taken another step towards building a stronger foundation for your understanding of AI. Random forests have several advantages. By averaging multiple trees, the model is less likely to overfit the training data. The combination of predictions from multiple trees usually results in more accurate outcomes. Random forests work well for both classification, for example pass or fail, and regression tasks, for example predicting scores. They are also adept at handling missing data and can deal with both numerical and categorical features, making them highly flexible. Let's consider an illustrative example. A random forest for predicting house prices based on location, size, and number of bedrooms could use any number of independent decision trees to derive a conclusion, based on the features or combination of features being taken into consideration, for independent evaluation by a single decision tree. Here you'll be taken through this example, which uses 4 individual decision trees for taking individual decisions and contributing these decisions for the final predictions. Suppose the prediction of the trees are: tree 1 predicts $320, tree 2 predicts $450, tree 3 predicts $300, and tree 4 predicts $350. Then the resultant price for a house would be the average of the 4 predictions from each of the 4 trees, which is $355. If you move back to the pass or fail example, you will observe that since a random forest would consider multiple aspects of student performance, like study hours, attendance, and assignment scores, it ensures that no single feature dominates the prediction. This leads to more accurate and fair predictions about whether a student will pass or fail. Just like checking multiple weather apps gives you a better forecast, using a random forest combines the strengths of multiple decision trees for more accurate prediction. While this might seem complex at first, with practice and persistence, you'll soon deepen your understanding and appreciate the true power of these models. Remember, it's okay to take your time and revisit concepts as needed. Neural networks are a fascinating topic. To understand how they work on a basic level, consider this scenario. You're rummaging through an old attic and stumble upon a blurred, time-worn photograph. You think it's a picture of Tony, but how can you be sure? Naturally, you'd examine a few key features: the shape of the face, the color of the hair, whether or not glasses are present, and the distinctive curve of the nose. Each clue builds a clearer picture. A neural network works in a similar way. It examines an image, breaks it into smaller details, and combines them to recognize the person. A neural network is a computational model inspired by the human brain. It processes data in a series of steps and has three main components. The starting point, where raw data, like an image, enters the network, is called the input layer. Once data passes through the input layer, it moves to intermediate stations, called hidden layers, where the data is processed and transformed. The final step is the output layer, where the network produces a result. Each of these layers consists of neurons, or nodes, which are interconnected and work together to process the input. A neuron is the smallest computational unit in a neural network. It mimics the biological neuron in the brain by taking inputs, processing them, and producing an output. A neuron receives input either from the input layer or previous neurons, processes data, and makes decisions on whether the result should be sent forward to the next layer or not, or sends the output to the next layer, or stores the result for the final prediction. Let's put this concept into an example of recognizing a person in an image. The first step is to break the image into pixels at the input layer. When an image is fed into a neural network, it is not interpreted in the same way as by the human eye. Instead, it is processed as a grid of tiny dots called pixels. Each pixel is assigned a number representing its brightness. For simplicity's sake, consider the image to be in grayscale, comprising black, white, and shades of gray, with the pixels having the following values: 0 for black, the dark areas, 255 for white, the bright areas, and numbers in between 0 and 255 for shades of gray. For example, in a neural network, a small image may be interpreted as a simplified 3x3 grid where each cell corresponds to a pixel in a grayscale image. Each pixel is labeled with a numerical value ranging from 0 to 255, indicating its brightness. Essentially, the computer program interprets an image as a set of numerical data rather than visual content. The second step involves detecting features in the hidden layers. Hidden layers are responsible for processing the input data and extracting patterns or features that help the neural network make accurate decisions. Let's make this more concrete by returning to the analogy of the blurred image. Imagine making 3 copies of the same photo and sharing them with friends to help determine if the person is Tony. Each friend specializes in recognizing a specific feature. Friend A can identify noses, friend B can identify eyes, and friend C can identify hair. If most of your friends agree that the features match the characteristics of certain distinctive features, there's a strong possibility that it is indeed a human being's face and not something else. In this way, the process functions in parts, with each friend contributing to the overall identification of the parts of a human face. Let's revisit the grid. In a neural network, one neuron might specialize in detecting an eye. The grid shown here represents how the eye pattern might be analyzed. Each cell corresponds to a segment of the image where the network examines traits, such as edges, colors, or shapes. When a match is detected, it identifies the pattern as resembling an eye, with dark edges and a bright center. The neuron then sends a signal, eye detected. Another neuron might search for hair. In this example, the top row corresponds to dark pixels, likely representing hair. The bottom row displays bright pixels, which could represent a lighter region, such as the forehead. The neuron examines the image for a row of dark pixels at the top, which could indicate hair. When a match is found, it sends a signal, hair detected. Other features are identified in a similar way. Once neurons in the hidden layers detect features like eyes, a nose, and hair, the hidden layer combines their findings into a single object, in this case a face. This combination could be another neuron or a layer within the hidden layer. The output layer makes the final identification. If the neural network has been trained to recognize specific individuals, like Tony and others, such as Alex, Sam, and Nancy, the output layer uses the combined output from the hidden layer to check for the probability of the image being matched to the image of Tony. The output layer will assign probabilities to each possibility, as it learned during its training. Now the system compares the combined features to stored patterns in its database. The output layer assigns probabilities to potential matches, ranking them by likelihood. Here, Tony has the highest match probability, indicating Tony is the most likely identification. In the same way that friends collaborate to identify a person in a photograph, layers of neurons in a neural network work together to recognize patterns in an image. However, just as friends might struggle to identify Tony if he presented with a beard, but they had only ever seen him beardless, a neural network may also find it challenging to recognize unfamiliar variations. However, once trained on new details, such as the addition of a beard, the network becomes better equipped to recognize these changes in the future, improving its accuracy and adaptability. You've just taken your first step into understanding neural networks. While this is just the beginning of your journey into neurons and neural networks, each new concept you learn will build on this foundation, opening more insights into how machines can learn and think. Wouldn't it be incredible to walk into a store where everything feels tailored just for you? Imagine your favorite snacks displayed right up front, your exact shoe size ready in the latest style, and your phone notifying you of a discount on the jacket you checked out online last week. How could this happen? Behind the scenes, technologies like artificial intelligence, predictive analytics, and automated workflows collaborate seamlessly to create such a personalized experience. This is digital transformation in action, revolutionizing how businesses operate and how customers experience the world around them. Digital transformation isn't just a buzzword, it's reshaping industries and redefining possibilities. In this video, the focus will be on understanding digital transformation, its impact on businesses, and how software development and AI drive these changes. Digital transformation integrates digital technology into every part of a business. But it's more than adopting the latest gadgets or software. It's about rethinking how organizations operate and deliver value. Consider Netflix. What began as a DVD rental service has evolved into a global streaming leader. By leveraging data and AI, Netflix creates personalized recommendations, ensuring every viewer finds content they love. This reinvention has not only transformed user experiences, but established Netflix as a powerhouse in entertainment. Why is digital transformation critical? The world is changing at a pace like never before. Today's customers demand more than quality products. They want speed, convenience, and experiences tailored to them. Businesses that resist change risk falling behind. Those that embrace digital transformation gain an edge, thriving in an ever-evolving marketplace. It's no longer optional. It's essential for relevance and growth. Examples of digital transformation are everywhere. Take Amazon. By introducing personalized recommendations, one-click purchasing, and ultra-fast delivery, Amazon didn't just meet customer expectations, it shaped them. Or Spotify, which analyzes listening habits to craft personalized playlists, turning casual users into loyal subscribers. These businesses illustrate how digital transformation unlocks growth and redefines possibilities. At the core of digital transformation is software development. Software developers build the systems that power these innovations, from mobile apps connecting businesses to customers to algorithms processing vast amounts of data. Telehealth apps are a prime example. Platforms like Teladoc make healthcare accessible and convenient. Patients consult doctors virtually, view test results, and manage prescriptions all from home. These solutions not only improve convenience, but also extend care to underserved areas. In retail, platforms like Shopify help small businesses establish online storefronts. Developers create tools for secure payments, inventory management, and customization, empowering entrepreneurs to thrive in the digital space. AI is a driving force in accelerating digital transformation. It transforms massive data into actionable insights, automates repetitive tasks, and enhances decision-making. For instance, chatbots answer customer questions efficiently, while predictive AI prevents equipment failures before they occur. Automation is one way AI is shaping transformation. By handling repetitive tasks, AI allows teams to focus on strategic and creative work. Predictive analytics is another. AI identifies patterns and trends in historical and real-time data, enabling proactive decision-making. Decision-making tools powered by AI go further, transforming raw data into insights. Platforms like HubSpot, for example, recommend optimal times for marketing campaigns, ensuring better engagement and results. Digital transformation is about reimagining how businesses operate, innovate, and connect with customers. It's a strategic overhaul touching every part of an organization. Software development serves as the engine driving these innovations, while AI accelerates the journey, unlocking new levels of efficiency, personalization, and growth. You've been tasked with modernizing an online bookstore that's struggling to keep up with customer expectations. Complaints are piling up, checkout is clunky, delivery delays are frustrating loyal readers, and competitors are offering personalized recommendations that draw customers away. To turn things around, the bookstore needs more than a quick fix. It requires a transformation focusing on 4 key areas: technology, data, processes, and change management. These areas are the building blocks for delivering seamless experiences, efficient operations, and long-term growth. This video explores these 4 domains through the lens of a bookstore, offering practical insights and real-world applications. Let's dive in. Digital transformation brings together 4 interconnected areas, each with a specific role in driving change. Technology fuels innovation, data empowers decisions, processes enhance efficiency, and change management ensures people adopt new ways of working. Together, they create a framework that helps businesses thrive in an evolving digital world. Technology is the enabler. Think about AI-powered chatbots answering customer questions instantly, or cloud-based systems keeping online stores operational 24/7. These tools not only speed up tasks, but also improve customer experiences. Data is the foundation for making informed choices. It's not just about gathering data, but analyzing it to uncover trends. Platforms like Netflix, for instance, recommend content based on what users enjoy, creating a highly engaging experience. Processes define how things get done. By optimizing them, businesses can save time and resources. For example, automating workflows can turn weeks-long processes like loan applications into hours-long tasks. Finally, change management ensures people, the real drivers of transformation, embrace these changes. A great example is how schools shifted to remote learning during the pandemic, supported by training for teachers and students. Now let's return to the bookstore evolving into an omni-channel retailer. This transition isn't just about technology. It's about reimagining how the store operates, interacts with customers, and innovates. To succeed, you suggest that the bookstore focus on 4 areas: customer experience, operational processes, business models, and cultural changes. Customer experience is all about personalizing and simplifying interactions. For instance, analyzing customer behavior can uncover patterns. If customers browsing artbooks online often buy supplies in store, this insight can guide cross-merchandising strategies. Digital tools like chatbots provide 24/7 support, while features like wishlists allow seamless transitions between online and in-store shopping. Personalized recommendations, such as suggesting fantasy novels to sci-fi readers, deepen engagement and loyalty. These efforts don't just satisfy customers, they drive sales and retention. By using data and technology effectively, the bookstore transforms into a brand that understands its audience. Digital operations focus on efficiency. Automated inventory systems ensure popular titles are always stocked, while real-time pricing tools maximize profits by adjusting for demand. Digital tools also enhance employee productivity. For instance, in-store staff can use tablets to check inventory or recommend books, creating a smoother experience for customers. Efficient operations not only save costs, but also ensure customers get what they need without delays, turning potential frustrations into positive experiences. Business models evolve to create new value. The bookstore could expand into digital products, offering ebooks or audiobooks to reach more readers. Subscription services like curated monthly book boxes can provide steady revenue. Collaborating with coffee shops for book clubs or hosting hybrid events where attendees join in person or online also adds value and accessibility. Reimagining the business model allows the bookstore to stay competitive, tapping into diverse customer bases and revenue streams. Cultural organizations ensure that transformation is embraced across the organization. Employees might receive training on digital tools or be encouraged to bring innovative ideas forward, like creating promotional bundles for holidays. By fostering a data-driven and agile culture, teams can adapt quickly to new opportunities, ensuring long-term success. Each of these areas, customer experience, operational processes, business models, and cultural changes, is powered by the core domains of digital transformation. For example, a chatbot or technology uses purchase history or data to recommend books. Automated inventory systems or process ensure availability, and staff training or change management equips employees to deliver excellent service. Together, these elements create a seamless experience for customers and staff alike. Digital transformation is more than adopting new technology. It's about building a system that evolves alongside business needs. By aligning technology, data, processes, and change management, businesses can adapt and thrive in any environment. Thanks to your suggestions, the bookstore is now thriving, with seamless shopping, personalized recommendations, and efficient operations. Complaints are down, loyalty is up, and you've led the way, proving how technology, data, processes, and change management can drive lasting success. Imagine this, walking into a hospital, and before you even meet the doctor, AI predicts your diagnosis. Or picture a city where traffic moves effortlessly, thanks to sensors in every streetlight. No traffic jams, no frustration. Now, think about your workplace, where collaboration happens seamlessly across the globe on cloud-powered platforms. These scenarios aren't just futuristic. They're real, happening today because of the technologies fueling digital transformation. This video dives into these innovations and how they're reshaping industries and your daily life. Technology is at the core of how businesses adapt and thrive in today's fast-paced world. For example, a luxury hotel could completely redefine guest experiences with artificial intelligence or AI personalizing room settings, Internet of Things, or IoT devices adjusting lighting and temperature in real time, and cloud computing managing bookings and data across locations. These tools don't just enhance operations, they create unforgettable experiences. Let's explore the technologies driving this transformation. Artificial intelligence, or AI, is a game changer. It enables computers to mimic human thinking, streamlining processes and driving smarter decisions. AI has 3 key features transforming businesses: predictive analysis, automation, and personalization. Imagine a retailer forecasting product demand with precision. AI leverages predictive analytics to optimize inventory, reduce waste, and keep shelves stocked with exactly what customers need. Automation takes over repetitive tasks like sorting emails or running chatbots, ensuring they're handled efficiently while saving time and reducing errors. And have you ever noticed how streaming platforms seem to know exactly what you'll enjoy next? AI uses personalization to analyze your preferences and deliver recommendations that keep you engaged. AI is the silent force behind faster, smarter, and more personalized operations, revolutionizing how businesses work. Now let's talk about the Internet of Things, or IoT, a technology that connects everyday devices into smart networks. Imagine a thermostat that adjusts the temperature automatically based on your schedule, saving energy while keeping your home comfortable. In factories, IoT sensors predict maintenance needs, preventing costly breakdowns. Some IoT systems even take proactive steps, shutting down equipment to avoid hazards. IoT connects the physical and digital worlds, making systems smarter, more efficient, and responsive. It's as though the world around us is learning to think. Next is cloud computing, the backbone of modern collaboration and scalability. Instead of relying on physical servers, businesses can access computing resources like storage, databases, and software online. Here's why it's transformative. Businesses can store massive amounts of data without relying on bulky hardware. And as data needs grow, scaling up happens instantly. No delays, no hassle. It's also incredibly cost efficient. Instead of sinking money into expensive infrastructure, companies only pay for what they actually use, making it flexible and budget friendly. But perhaps the most impactful aspect is how it enables seamless collaboration. Teams can edit shared documents in real time, host virtual meetings, and manage projects from anywhere, all thanks to the cloud. Cloud computing is more than just storage. It's the enabler of flexible, connected, and future-ready operations. These technologies don't just sound impressive. They're solving real-world problems every day. Take healthcare, for instance. AI-powered tools analyze X-rays and MRIs to detect diseases early. delivering faster, more accurate diagnoses. Platforms like PathAI are already helping doctors reduce errors and make life-saving decisions more quickly. Or consider IoT in smart cities. Traffic lights equipped with IoT sensors adjust in real time to prevent jams, while air quality monitors gather data to improve urban planning. Barcelona uses IoT sensors to track pollution and optimize waste collection. Trash bins signal when they're full, cutting unnecessary trips and reducing emissions. Cloud computing keeps businesses running even in the face of significant challenges. For example, during the COVID-19 pandemic, platforms like Microsoft Teams and Google Workspace enabled employees to collaborate in real time from home, demonstrating that remote work doesn't have to mean disconnected teams. Step back and take a moment to reflect. These technologies, AI, IoT, and cloud computing, are powerful tools driving digital transformation. But technology alone isn't the answer. Its true potential lies in how it's used, combined with human creativity and strategic thinking to solve real challenges and unlock opportunities. Digital transformation is about more than adopting new tools. It's about creating meaningful change. The question is, how will you use these technologies to shape the future? A small e-commerce business is struggling to keep up with its rapidly growing customer base. Emails are piling up, customer service is delayed, and marketing campaigns are falling flat, missing the right audience entirely. The business owner feels overwhelmed, searching for a way to offer personalized customer care without overwhelming the team or blowing the budget. Sound familiar? This is where AI steps in and changes everything. In this video, you'll dive into how AI is transforming CRM systems and why it's become a game changer for building strong customer relationships and driving business growth. Let's start with the basics. Customer Relationship Management, or CRM, systems are like command centers for businesses. They keep all your customer information, contact details, purchase history, communication logs, and preferences in one place. They're designed to streamline workflows, improve communication, and help deliver a better customer experience. Traditional CRMs organize data and track interactions well. They make it easier to follow up with customers and run marketing campaigns, but they have their limits. They can't dig deeper into the data or predict what a customer might need next. That's where AI comes in, taking CRM systems to a whole new level. With AI, CRMs don't just store data, they analyze it. They process massive amounts of information from sources like emails, social media, website activity, and transaction histories. And what do they do with all that data? They create experiences that feel tailored to each customer, anticipate their needs, and deliver exactly what they want, often before they even ask for it. For example, AI can predict what a customer might want to buy next or when they might need help. Using pattern recognition and trend analysis, it helps businesses act at just the right moment, offering recommendations or solutions proactively. This isn't just reactive customer service anymore, it's personalized and seamless. AI also handles repetitive tasks like sorting inquiries, generating reports, or flagging customers who might be at risk of leaving. By automating these processes, teams have more time to focus on big picture strategies, boosting retention rates and driving growth. Let's bring this to life with a few examples. In e-commerce, AI-powered CRMs create highly personalized customer journeys. Recommendation engines suggest products based on browsing or purchase history, while virtual assistants handle common tasks like answering frequently asked questions or processing returns. If someone abandons their cart, AI can send a follow-up email with a discount to nudge them toward completing their purchase. Every step of the shopping experience feels smooth and intuitive. In banking, AI chatbots provide 24/7 support. Need to check your balance, apply for a loan, or explore savings options? These virtual assistants guide you through it all. They even use predictive analytics to offer proactive tips, like suggesting better savings plans based on spending habits. It's personalized financial advice, always available. Retail takes personalization even further. AI tracks customer buying habits to send targeted discounts or recommend complementary products. Loyalty programs also benefit. AI analyzes behavior in real time to offer rewards that actually matter to the customer. Every interaction feels personal and valuable. So what's next? AI is evolving fast and the future is looking pretty exciting. Let's talk about hyper-personalized marketing. You've probably seen emails with your name or product recommendations based on past purchases. But imagine AI analyzing your behavior in real time and adapting campaigns instantly. Think of offers or ads so tailored they feel like they've read your mind. Like being offered an installment plan for the gaming desktop you've been eyeing but haven't bought yet. Voice-activated service could take another big leap. Imagine Siri or Alexa, but designed for customer support. Instead of navigating menus or typing out questions, a customer could simply say what they need. The AI would listen, understand, and respond intelligently, making the whole process effortless. It would feel like having a personal assistant always ready to help. And then there's predictive engagement. AI wouldn't just react to what customers do, it would anticipate their needs. Imagine being notified about a deal on a new coffee maker before your old one breaks down, or a business re-engaging a less active customer with a special offer before they even consider leaving. It would take your customer loyalty to a whole new level. Now, here's where it gets really interesting: emotional intelligence. AI could analyze tone, word choice, or even facial expressions to understand how someone is feeling. Frustrated? It might escalate the issue to a human agent or adjust its tone to be more empathetic. The goal? Make customers feel genuinely understood. AI could also connect every interaction seamlessly. Start a conversation on social media, pick it up over email, and finish it on a call without losing any context. It would create a connected experience that saves time and reduces frustration. And as AI gets smarter, it could take on even more complex tasks. Lead nurturing, sales forecasting, onboarding new customers, it could handle these independently. But that doesn't mean humans are out of the picture. Teams will be able to focus on creative, strategic work while AI takes care of the busy work. For example, imagine a marketing team spending less time sorting through customer data and more time designing innovative campaigns that connect with their audience. AI could handle the repetitive tasks like segmenting customer lists or scheduling emails, while the team focuses on what truly drives growth and engagement. AI is transforming CRM systems into intelligent tools that strengthen relationships, build loyalty, and give businesses a competitive edge. With machine learning, natural language processing, and predictive analytics, these systems anticipate customer needs, respond quickly, and make every interaction meaningful. So, how could AI take your customer relationships to the next level? A company develops an AI tool for hiring, promising to streamline the process and boost efficiency. At first, it seems like a win, until complaints start rolling in. The tool is favoring male candidates over equally qualified female candidates. This isn't just a technical glitch, it's a serious ethical problem. Beyond reputational harm, it risks legal trouble and reinforces systemic biases. In this video, you'll explore why ethical and regulatory compliance is critical when deploying AI systems. Deploying AI responsibly isn't just a good idea, it's essential for ensuring fairness, transparency, and trust. So what are the most pressing ethical concerns? Let's unpack them. AI algorithms are only as good as the data they're trained on. If that data is flawed, biased, or incomplete, the AI reflects those imperfections. Imagine an AI system used for bank loan approvals. If it's trained on historical data with discriminatory practices, it could perpetuate those same biases, denying opportunities to individuals based on inherited prejudice. Even if the system works efficiently, is it fair? How can anyone trust a system that amplifies past inequalities? Addressing bias requires proactive steps. Think about diversifying datasets, auditing outputs regularly, and involving diverse teams in the design process. These measures help uncover and address hidden biases before they cause harm. Now let's talk about transparency. Imagine being denied a bank loan by an AI system but not knowing why. This is the black box problem: AI decisions that are too complex or opaque to explain. Without clarity, trust erodes, and without trust, accountability disappears. In areas like healthcare or law enforcement, where decisions can change lives, transparency is non-negotiable. Would you trust a system that couldn't explain its reasoning? Techniques like explainable AI or XAI can help by making AI decision-making more transparent and understandable. For example, in law enforcement, an XAI system might justify its risk assessment of a suspect by pointing to relevant data patterns rather than leaving the decision shrouded in mystery. On the regulatory side, laws like the General Data Protection Regulation, or GDPR, govern how organizations handle personal data. GDPR requires AI systems to process data lawfully, transparently, and for legitimate purposes. If an AI system uses personal data for training or decision-making, it must meet these high standards. And GDPR isn't alone. Similar regulations are popping up worldwide. The California Consumer Privacy Act, or CCPA, gives residents control over their data, including access, deletion, and opting out of sharing. India's Digital Personal Data Protection Act regulates data usage while safeguarding individual privacy. Brazil's General Data Protection Law, or LGPD, mirrors GDPR with its focus on data subject rights and organizational responsibilities. Organizations must stay ahead by conducting privacy impact assessments, enabling data correction or deletion, and auditing systems regularly. These regulations aren't just about avoiding penalties. They build trust by respecting privacy and individual rights. Let's explore how this plays out in real-world scenarios. In healthcare, AI-powered tools are transforming diagnostics, spotting diseases like cancer earlier than traditional methods. But what happens if an algorithm is biased or flawed? A misdiagnosis could delay critical treatment or even endanger lives. In finance, AI streamlines loan approvals and trading decisions. But compliance with anti-money laundering or AML laws is critical to prevent fraud. A non-compliant AI system could enable illegal activities, causing both legal and reputational damage. These examples show why ethical guidelines, diverse datasets, and transparent AI models are essential. Regular audits and collaboration with regulators are key to deploying AI responsibly. There's another layer to this challenge. AI operates globally, but regulations vary by country. This creates gaps and risks. Cross-national agreements, while vital, are often fragile, just like international climate commitments. Frameworks like the Organization for Economic Cooperation and Development, AI Principles, UNESCO's AI Ethics Recommendation, and the European Union AI Act provide a strong foundation. Integrating these into national laws with international cooperation can help address cross-border issues effectively. In this video, you explored how ethical and regulatory compliance shapes trustworthy AI systems. By applying these principles, you ensure your projects are fair and transparent. Every decision you make brings us closer to a future where AI benefits everyone. Ever notice how, while scrolling through your Facebook feed, a video pops up as a recommendation and starts playing right away? Within moments, you're drawn in, all thanks to an artificial intelligence or AI system working behind the scenes to deliver that recommendation. Now, imagine millions of people experiencing the same thing at the same time. How do companies like Facebook and Google ensure their AI systems keep running smoothly, handling enormous amounts of data and millions of users without skipping a beat? It all comes down to scalability. In this video, you'll explore some challenges of scaling AI systems and how tech giants tackle these hurdles to deliver the social media experiences we often take for granted. But what is scalability? Scalability, put simply, is a system's ability to adapt to changing workloads or grow without losing its efficiency or functionality. For AI, scalability means ensuring that the system can handle vast amounts of data, serve millions of users, and maintain top-notch performance without crashing or slowing down. Since AI continues to expand across industries, from healthcare to entertainment, it's important to ensure that these models can process growing volumes of data while delivering quick and accurate results. Scalability is key, not just for maintaining current performance, but also for enabling future innovations, allowing AI systems to adapt, and tackling more complex tasks over time. Several key scalability challenges exist. These include handling large volumes of data, real-time data processing, managing high user demand, optimizing computational resources, maintaining low latency, model deployment and updates, data privacy and security, and lastly, algorithmic efficiency. Let's focus on data volume, processing and latency, user demand, and model deployment and updates, as these directly impact the performance, reliability, and user experience of AI systems in real-world applications. Let's start with the challenges of handling large volumes of data. AI models, like those behind Google Search or Facebook's recommendation engine, rely on massive amounts of data to make accurate predictions. The more data these systems receive, the better they can learn and improve. However, managing such large volumes of data comes with its own set of challenges. One of these is data storage. Storing petabytes of data demands advanced storage systems. For companies like Google and Facebook, ensuring this data is not only stored, but also easily accessible and ready for fast processing is a significant hurdle. The other challenge is data processing. AI models often need to analyze data in real time, which requires powerful computing resources and scalable algorithms capable of handling the intense workload. The next scalability challenge is ensuring fast processing and low latency. Latency refers to the time it takes for a system to respond to a user's action or request. Think about using Google Maps to get real-time traffic updates. The AI system has to process vast amounts of data, live traffic conditions, user inputs, and historical patterns to give you fast, accurate recommendations. This requires low latency, meaning the system must respond almost instantly without delays. Achieving this means solutions like parallel processing and enhanced algorithms. In parallel processing, AI systems run multiple calculations simultaneously across different machines. This requires a well-coordinated infrastructure and smooth communication between systems. The algorithms powering these AI models must be optimized for both speed and scalability. As data increases, these algorithms must keep delivering real-time results without slowing down. Next, let's consider managing high user demand. When millions of users access an AI-powered platform simultaneously, the system must manage thousands or even millions of user requests at once without crashing or slowing down. To achieve this, companies rely on key strategies to maintain smooth performance, load balancing, and elasticity. Load balancing is a technique companies use to distribute user requests across multiple servers. It ensures that no single server becomes overwhelmed and that users experience smooth, uninterrupted service. Elasticity is the ability of AI systems to scale resources up or down based on demand. For example, adding more servers during peak times like holidays to handle increased traffic and scaling down during off-peak times to reduce costs while maintaining efficiency. Finally, let's explore model deployment and updates. As AI models evolve, they require regular updates with fresh data and insights. Scaling these updates in real time for millions of users presents a major challenge. A newly deployed AI model must function reliably across various devices, platforms, and user conditions. In many cases, updates are rolled out gradually to minimize disruptions. To streamline updates, companies rely on continuous integration, continuous deployment, or CI/CD pipelines. These pipelines ensure that AI models are trained, tested, and deployed in a consistent, automated process, making updates smooth and efficient. Another way to manage updates is through A/B testing. Before rolling out updates to all users, new AI models or features are often tested with a small group. This approach allows companies to evaluate performance and make adjustments before a full deployment, reducing the risk of widespread issues. Now let's focus on how companies like Google and Facebook overcome common scalability challenges. To scale its AI solutions, Google leverages a combination of cloud infrastructure and distributed computing. For instance, Google Search handles billions of queries daily, and to manage this workload, Google's cloud infrastructure spreads the tasks across thousands of servers worldwide. Using MapReduce, a powerful algorithm for processing large datasets, Google distributes computations across multiple servers, allowing it to handle massive volumes of data efficiently. Additionally, Google relies on TensorFlow, its open-source machine learning framework, to ensure scalability. TensorFlow is optimized for distributed systems, enabling Google to train and effectively deploy large AI models across its vast infrastructure. With its massive user base, Facebook faces similar challenges in scaling its AI systems. To ensure scalability, it uses a combination of distributed databases, a system where data is distributed across multiple locations, load balancing, and content delivery networks, or CDNs, distributed servers that deliver web content and media based on users' geographic locations. Facebook also uses Hadoop, a framework for handling large-scale data processing. Hadoop allows Facebook to manage and process massive datasets across many machines. Additionally, Facebook employs caching systems to ensure that frequently accessed data, such as user profiles, is readily available, minimizing latency. Scaling AI systems is no easy task. As companies like Google and Facebook continue to grow, their AI solutions must be able to handle vast amounts of data, high user demand, and the need for real-time processing. By leveraging advanced software, algorithms, and cloud computing, amongst other things, these tech giants have managed to meet scalability challenges head-on. As AI evolves, scaling effectively will be vital to providing flawless, personalized experiences to millions of users worldwide. Imagine you're a hospital patient waiting for the results of a complex medical test. A machine learning model analyzes your data and predicts your condition, guiding the doctor's treatment plan. But here's the issue. No one fully understands how the AI reached its conclusion. This lack of transparency can create uncertainty and hesitation. Can you trust the decision? This is why interpretability and transparency in AI are essential. In generative AI, interpretability and transparency are crucial for understanding how decisions are made, especially in critical areas like healthcare and finance. Without them, AI decisions can have unintended consequences, eroding trust and causing harm in sensitive situations. In this video, you'll learn what interpretability and transparency mean, why they're important, and how they impact the adoption of AI in high-stakes fields. First, let's define interpretability in this context. Interpretability is the ability to explain or understand how a machine learning model makes its decisions. An interpretable AI system allows humans to trace the model's steps and see how it reached a particular outcome. This not only helps developers identify and fix issues within the model, but also fosters trust by enabling users to rely on its predictions and make informed decisions. Through a diagram, let's examine how interpretability helps build trust in AI systems. Trust building starts with decision tracing, which shows the steps the AI takes to reach a decision. This transparency makes it easier to spot and fix problems, a process called issue identification. From there, these insights lead to continuous improvement, where the model is refined for better accuracy and reliability. All of this ultimately fosters user trust, making AI systems not just powerful, but also dependable in critical applications. Transparency goes hand in hand with interpretability, but takes a broader perspective. It ensures that the inner workings of an AI model are clear and understandable to all stakeholders. Beyond explaining individual decisions, transparency involves providing insights into how the model was built, the data it relies on, and how it may evolve over time. Achieving fair and unbiased generative AI when developing AI models means documenting data sources, outlining model architectures, and explaining decision-making processes while adhering to standards. Now that you understand interpretability and transparency in terms of generative AI, let's explore why they are so important, particularly in healthcare and finance. To this end, AI experts speak of the pillars of AI trustworthiness, which include trust, accountability, fairness, and regulatory compliance. Let's look at each in more detail. First, trust. People are more likely to trust AI systems when they understand how decisions are made. In healthcare, for example, patients need confidence that AI recommendations are based on clear reasoning rather than inscrutable mathematical processes. Next is accountability. When errors occur, such as a misdiagnosis or an unfair loan denial, transparency makes it easier to trace the issue, understand what went wrong, and identify which factor contributed to the error. In terms of fairness, transparent models enable stakeholders to identify and address biases. For instance, if an AI system disproportionately denies loans to certain groups due to biased training data, transparency allows these issues to be detected and corrected. Finally, for regulatory compliance. In highly regulated industries like healthcare and finance, interpretability and transparency are essential for meeting legal requirements. Clear and fair decision-making processes ensure compliance with industry standards and regulations. While interpretability and transparency are essential for fostering trust, accountability, fairness, and compliance, not all AI models are designed with these features in mind. This highlights the critical distinction between interpretable AI models and black box models. A model is considered interpretable and transparent when you can clearly follow its decision-making process to understand how it arrived at a particular result. Examples include interpretable algorithms, like decision trees, which split data into branches based on features to predict outcomes, and linear regression, which models the relationship between inputs and a target variable by fitting a straight line. These algorithms are considered transparent because their reasoning can be clearly explained. The main advantage of interpretable models is their simplicity and ease of understanding. This makes them ideal for applications where decisions must be explained clearly to users. In healthcare, an interpretable AI model might use a decision tree to predict the likelihood of a patient developing diabetes. The model could evaluate factors like age, weight, and medical history, clearly showing how each contributes to the outcome. This allows doctors to understand the prediction and make more informed decisions. On the other hand, black box models are complex AI systems whose decision-making processes are difficult, if not impossible, for humans to interpret. With these models, you see the outcome but can't trace the steps that led to it. These models often include deep and shallow neural networks, computational models inspired by the human brain that process data through interconnected layers of nodes to recognize patterns and make predictions. These models excel at identifying patterns in data but lack transparency in how they arrive at their conclusions. The strength of black box models lies in their exceptional performance, particularly in complex tasks like image recognition or natural language processing, where interpretability is not always a priority. However, their lack of transparency presents significant obstacles in high-stakes applications. This means that in healthcare, using black box models can be risky. If an AI system recommends a specific treatment for a patient, for example, doctors need to understand why that recommendation was made. This lack of interpretability can cause doctors to second-guess AI recommendations or even avoid using AI systems altogether, limiting their potential to improve healthcare outcomes. In finance, too, transparency is crucial to ensuring fairness and preventing discrimination in decisions like credit approvals. For instance, if an AI model denies a loan, transparency allows applicants to understand the reasons behind the decision. It also helps stakeholders identify and address biases if the model disproportionately affects certain groups. Black box models, though powerful, can introduce risks in sectors like healthcare and finance, and others as their opaque nature makes it difficult to detect and correct unfair practices or errors. Interpretability and transparency are essential for the responsible use of AI, especially in critical sectors like healthcare and finance. When AI systems are understandable, accountable, and fair, they inspire trust and confidence in their recommendations. As AI continues to advance, balancing high performance with interpretability will be crucial for ensuring safe and effective use. Integrating AI into existing business systems has the power to reshape operations, boost efficiency, and unlock predictive insights. But it's not always smooth sailing. Businesses often face hurdles like compatibility, data management, budget constraints, employee training, and privacy concerns. What do these challenges involve in practice? Let's break it down through real-world scenarios. AI and customer relationship management, or CRM systems, go hand in hand, enhancing customer relationships, sales pipelines, and marketing campaigns. A CRM is software designed to help businesses manage customer interactions and track sales and marketing activities. Imagine a mid-sized retail company using an outdated CRM. It can track customer interactions and run marketing campaigns, but it falls short when it comes to predictive analytics or personalized marketing. Integrating AI completely transforms this scenario. With AI integrated, the CRM can now identify high-value leads using predictive analytics, making sales efforts more efficient. Automated marketing campaigns deliver personalized messages, boosting customer engagement. And with real-time insights, customer support becomes faster and more responsive. Of course, these benefits don't come without challenges. One challenge: system compatibility. Outdated CRM architecture and APIs may not work seamlessly with modern AI platforms like ChatGPT or Amazon Q Developer. Developers often tackle this by creating middleware to bridge the gap and enable smooth data flow. Another issue is data silos. Customer data may be scattered across sales databases, email platforms, and support tools. By consolidating all this information into a unified data lake, businesses ensure AI has a complete data set to work with. There's also change management. Employees might resist switching from a familiar system to an AI-powered one. Hands-on training and demonstrating the clear benefits of AI tools can help ease the transition. Finally, privacy is a major concern. AI analysis often raises questions about GDPR compliance, rules that govern how personal data is collected, processed, and stored in the European Union region. Techniques like data anonymization and secure AI pipelines can address these concerns. But AI integration isn't limited to CRM systems. Supply chain management is another area where AI can make a huge impact, from improving demand forecasting to optimizing inventory and streamlining logistics. Take a retail chain that struggles with frequent stockouts and overstocking due to poor demand forecasting. Introducing AI changes the game. Demand patterns are predicted with precision, stockouts decrease, and inventory costs drop. AI can even optimize delivery routes, reducing transportation costs. Still, challenges arise here too. For example, legacy systems in supply chain management often lack modern APIs. Upgrading these systems or developing custom connectors is one way to address this. Data quality is another issue. Supply chain data might be scattered across spreadsheets, making it inconsistent and hard to analyze. A structured database with clean, integrated data solves this problem. Cost and scalability can feel overwhelming, but starting small, like implementing AI for demand forecasting in specific regions, can improve ROI before scaling further. And let's not forget employee training. Warehouse managers and planners need to understand AI-generated forecasts. User-friendly dashboards and role-specific training go a long way in addressing this. AI integration, whether in CRM or supply chain management, is part of a bigger ongoing journey. Systems need regular updates to stay in sync with advancing technology. A few strategies can help keep things on track. Collaborative planning between IT operations and business teams ensures alignment with overall goals. Starting with pilot programs uncovers challenges early and refines the process. Regular monitoring, combined with user feedback, keeps improvements on track. And partnering with vendors for training and best practices adds extra support along the way. In this video, you explored how businesses can tackle challenges like outdated systems, data silos, training, and privacy concerns to unlock the potential of AI. From improving CRM systems with predictive analytics and personalized marketing to transforming supply chains with better forecasting and logistics, AI paves the way for innovation and efficiency. By addressing these challenges step by step, you're ready to help businesses fully harness the power of AI integration. Imagine this. You are working on a food delivery platform that includes an AI system to predict meal demand. It's a game changer, reducing waste for restaurants, boosting profits, and delivering meals faster. But just before the big launch, a legal advisor raises critical questions. Does this AI comply with food safety regulations? Could it be prioritizing certain restaurants unfairly? Suddenly you start to panic. What if the system promotes mislabeled dishes that trigger allergic reactions, or misses regional food safety standards? Trust is everything, not just in the food industry but across all sectors using AI. With technology that makes decisions for us, people remain cautious, even skeptical. Mishandling these challenges could not only harm customers, but also erode confidence in AI itself and tarnish your brand. So how do you ensure your AI is both ethical and compliant? Ethical and regulatory compliance acts as a moral compass for AI. It ensures systems protect privacy, avoid bias, and remain transparent. In industries like food or healthcare, compliance isn't just a good practice, it's essential. Let's explore the key components of ethical and regulatory compliance. First, privacy and data protection. When AI handles sensitive information, like allergy or dietary preferences, mishandling it could expose users to risks or violate their rights. Protecting privacy is critical to maintaining trust. Next is fairness and bias mitigation. Imagine an AI that consistently favors high-end restaurants over budget-friendly ones. This creates inequality and alienates users. Fairness ensures that all customers feel represented and treated equally. Now, explainability. Users often wonder, why did the AI recommend this? If decisions seem arbitrary or mysterious, trust erodes. Explainability means making AI decisions clear and understandable so users feel confident in the system. Then there's safety and security. In industries like food delivery, safety isn't optional. Mislabeling dietary recommendations or mishandling allergy information could lead to serious harm. Safety measures are vital to protect users and maintain reliability. Finally, accountability and governance. Mistakes happen, but what matters is how they're addressed. Clear accountability ensures there's a process to identify and fix issues, and governance frameworks provide oversight to prevent future problems. Together, these components, privacy, fairness, explainability, safety, and accountability, form the foundation of ethical AI. Addressing each ensures your platform operates responsibly while building user trust. But what happens if these standards aren't followed? Let's talk about the implications of non-compliance. Imagine your food delivery platform is growing quickly. Then an audit reveals that your AI system isn't fully compliant with GDPR and it shows bias in its recommendations. What happens next? Ethical lapses can cause reputational damage. Picture a platform that consistently promotes high-end restaurants, ignoring budget-friendly options. It might appear biased or elitist. Public perception shifts, and your brand could be labeled as unfair or unsafe. Restoring a tarnished reputation is an uphill battle, and customers may never see your platform the same way again. But it doesn't stop there. Non-compliance can lead to financial penalties. For example, mishandling sensitive allergy data or failing to obtain user consent might result in fines that could cost your business millions. These aren't just one-time hits, they can drain resources and affect long-term growth. Then there's the ultimate consequence, loss of customer trust. Mislabeled dishes or unmet safety standards could lead to serious harm, alienating users entirely. Trust is hard-earned but easily lost, and in competitive industries, customers will quickly switch to alternatives they perceive as more ethical and reliable. The stakes are clear. Non-compliance doesn't just hurt finances, it puts your platform's credibility, trust, and future on the line. So how can you make your food delivery platform ethical and compliant? Start with user data protection. Data privacy is critical, especially when handling allergy or dietary preferences. Collect explicit consent, encrypt sensitive data, and let users delete their information when needed. Regular updates keep you compliant and trustworthy. Next, promote fairness by training your AI on diverse datasets. For instance, if your system tends to favor high-end restaurants, conduct bias audits to identify and correct this. Inclusivity ensures all users feel valued, whether they're ordering from a budget-friendly eatery or a high-end one. Fairness makes your platform a space where everyone feels represented. Then focus on transparency. Customers trust what they understand. When recommending a dish, explain why. This matches your vegan and low-calorie preferences. Explainable AI tools make decisions clear and build user confidence. Finally, educate and train teams. From developers to support staff, everyone should understand and uphold ethical and regulatory standards. Ongoing training ensures risks are identified early and accountability is shared across the team. A well-informed workforce strengthens the ethical backbone of your platform. By following these steps, protecting data, promoting fairness, prioritizing transparency, and educating teams, you'll create a platform that's not just compliant, but trusted and valued by users. In this video, you've seen how ethical and regulatory compliance isn't just a legal requirement, it's the foundation for building trust. By addressing challenges like data protection, fairness, and safety, you ensure your platform operates responsibly and reliably. Compliance allows your AI to thrive while protecting users and strengthening your brand. In today's digital era, aligning innovation with responsibility isn't just smart, it's essential. Congratulations on completing this module on AI and digital transformation. This module introduced essential concepts that reveal how artificial intelligence and digital transformation work together to solve complex business challenges, optimize operations, and drive innovation in today's enterprises. The module began by laying the foundation for understanding AI's role in decision-making. AI was introduced as a powerful tool for analyzing data, identifying patterns, and making informed predictions. Practical examples such as classifying customer behavior or automating routine tasks like sorting emails or managing inventories demonstrated how AI enhances efficiency and supports business processes. Remember, AI excels at tasks where data patterns are clear and consistent, but it also relies heavily on the quality of data you provide. For instance, a recommendation engine will perform poorly if the dataset lacks variety or is outdated. Next, you explore decision-making models, which are at the heart of AI's practical application. These models enable businesses to make accurate predictions, solve problems, and enhance decision-making strategies. By understanding the logic and structure behind these models, you gained insight into how they are applied to solve real-world problems and improve organizational outcomes. Imagine a logistics company using AI to decide the fastest delivery routes. Decision-making models analyze traffic, weather, and package priority in real time, optimizing operations and improving customer satisfaction. This is how AI transforms theoretical concepts into tangible benefits. The focus then shifted to digital transformation, highlighting its importance in reshaping business operations and improving competitiveness. You learned about the 4 critical domains of digital transformation: technology, data, processes, and change management, and how they intersect to enable meaningful innovation. These domains don't operate in silos. For example, implementing AI technology without considering how it integrates with existing processes or how it impacts change management could lead to inefficiencies or resistance from stakeholders. Effective digital transformation is always holistic. Each domain plays a vital role in helping organizations adapt to evolving markets and leverage the power of AI effectively. A retailer, for instance, might use AI-powered analytics to predict customer trends or data, implement these insights into their e-commerce platforms or technology, streamline order fulfillment or processes, and train their teams to embrace this new approach or change management. The module also covered ethical and regulatory considerations, emphasizing the importance of responsible AI practices. Practical scenarios and examples demonstrated how businesses navigate complex compliance landscapes, ensuring their AI systems are transparent, interpretable, and aligned with legal and ethical guidelines. How would a lack of transparency in AI affect trust? Think about applications in healthcare or finance, where decisions impact lives or finances directly. This is why regulations like GDPR exist, to ensure AI operates responsibly. Scalability and integration were key focus areas as well. Discussions highlighted the challenges of implementing AI solutions that can handle large-scale operations while remaining adaptable to changing needs. Examples illustrated how businesses integrate AI into existing systems, ensuring smooth workflows and maximizing the return on investment. A streaming platform like Netflix scales its recommendation algorithms to millions of users by using AI to predict preferences based on viewing history. This not only improves the user experience, but also demonstrates how scalable AI systems drive business growth. Finally, the importance of transparency and interpretability in AI systems was underscored. Tools and techniques that enhance modern transparency were discussed, showing how these are critical in fields like finance, healthcare, and any area requiring trust and accountability in AI-driven decisions. Imagine a credit scoring AI determining loan approvals. Without transparency, customers and regulators cannot understand why certain decisions are made. Using interpretability tools helps explain the rationale behind each decision, building trust and ensuring compliance. So where do you go from here? The key takeaway is that AI, when paired with a thoughtful digital transformation strategy, is a game changer. It empowers organizations to be proactive, innovative, and resilient in today's competitive landscape. Great job! This module has provided a strong foundation in understanding how AI supports digital transformation and solves real-world challenges. These concepts are essential for leveraging AI effectively in a business context. Revisit any items if you want to refresh a topic, and then move forward to the module quiz to solidify your understanding. Best of luck. Congratulations! You are just about to complete Generative AI for software development. Suppose you've just been hired to design a rule-based chatbot to enhance customer support with personalized responses. Thanks to this course, you now have the knowledge and skills to navigate the creation of such a project, leveraging the power of Gen AI. What an incredible step forward in your journey as a software developer. In this course, you've taken great strides in your understanding of AI. Specifically, you've gained foundational knowledge of AI principles and hands-on experience with tools like Amazon Q Developer, ChatGPT, and GitHub Copilot. Throughout the course, you've explored and understood how AI streamlines routine software developer tasks like code reviews, bug detection, and fixing. You also have an understanding of prompting and its usage in software development. Equipping yourself with AI skills will give you a competitive edge in your software development career, enabling you to build faster, maintain quality, and drive innovation. You also entered the realm of machine learning, a specific area of study within the broader field of artificial intelligence. You discovered how machine learning allows computers to learn from examples via a process called training, and that it can apply that learning to new tasks. For example, you explored how machine learning can enable spam filters to analyze patterns in emails, such as specific keywords, sender behavior, and formatting. Over time, the filter adapts to new types of spam using techniques like natural language processing and anomaly detection. Within machine learning, you also learned about models, such as decision trees, random forests, and neural networks. And you now understand at a basic level how these models enhance productivity, decision-making, and quality in software development, making processes more efficient and reliable. Digital transformation is another important topic you explored. Digital transformation is revolutionizing industries by integrating technologies like AI, predictive analytics, and automated workflows into every aspect of a business. Companies like Netflix, Amazon, and Spotify use digital transformation and AI to enhance user experiences, drive growth, and shape customer expectations. Importantly, software developers are the driving force behind these innovations, creating the systems and algorithms that enable personalized recommendations, efficient operations, and new services like telehealth platforms. You now understand how using AI accelerates transformation by automating tasks, analyzing data, and improving decision-making, making digital transformation essential for staying relevant in a fast-changing world. You learned that digital transformation involves 4 domains: technology, data, processes, and change management. Technology drives innovation through tools like AI and automation, while data provides insights for informed decision-making. Optimizing processes ensures efficiency and consistency, and change management fosters a culture of adaptability, helping employees embrace new tools and ways of working. Together, these domains enable businesses to innovate, optimize, and thrive in a digital-first world. You now possess the foundational knowledge to explain how digital transformation is powered by 3 key technologies: AI, the Internet of Things or IoT, and cloud computing. These technologies are already solving real-world problems in healthcare, smart cities, and workplaces. For example, you explored how AI transforms CRM to strengthen customer relationships, boost loyalty, and provide a competitive edge. Finally, you explored some of the challenges in the adoption of AI and the ways people and companies are trying to address these issues. Scalability is crucial for AI systems to enable handling of massive data volumes and serve millions of users while maintaining performance. You can now identify some of the challenges in this area, which include managing large-scale data storage, ensuring real-time processing with low latency, handling high user demand, and deploying frequent model updates. Companies like Google and Facebook address these issues by leveraging cloud infrastructure, distributing computing, and optimizing algorithms. Techniques like parallel processing, load balancing, and elasticity ensure systems remain efficient under varying workloads. Tools like TensorFlow, Hadoop, and CI/CD pipelines streamline operations and updates, enabling these tech giants to deliver seamless, personalized experiences to millions of users globally. Next, you learned about why interpretability and transparency are essential in AI, especially in high-stakes fields like healthcare and finance. Interpretability ensures that AI decisions can be traced and understood by users, fostering trust, accountability, and fairness. Transparent systems provide insights into how models are built, the data they use, and their decision-making processes, helping detect and correct biases and errors. You now understand the basic concepts as to why interpretable models like decision trees are easy to understand and ideal for critical applications, whereas black box models such as neural networks excel at complex tasks but lack transparency. Striking the right balance between these models requires a careful consideration of their strengths and limitations, alongside the ethical implications of their use. Factors such as business needs, regulatory compliance, and the level of trust and explainability required must guide these decisions, ensuring responsible and effective deployment of AI systems. Techniques like LIME and SHAP demystify complex models by explaining how decisions are made. LIME provides quick, instance-based insights using simpler models to explain individual predictions, while SHAP offers consistent, fair explanations for both local and global model behavior using game theory principles. These tools enable users to understand AI outputs, detect biases, and ensure fairness, helping create trustworthy systems that balance performance with interpretability for responsible deployment. Finally, you explored how ethical and regulatory compliance ensures AI systems operate responsibly by protecting privacy, avoiding bias, and maintaining transparency. You can now list and explain on a basic level the key components to address issues of AI systems, which include privacy and data protection, fairness and bias mitigation, explainability, safety and security, and accountability and governance. Together, these elements build trust and safeguard users in industries. For example, in the food delivery industry, an AI error omitting peanut warnings on a label could pose serious health risks to individuals with allergies. Prioritizing data protection, transparency, and fairness is essential to maintaining user confidence and meeting regulatory standards. That's a lot of knowledge you've gained in a short amount of time. Mastering AI's potential and ethical implications takes time, but understanding these fundamentals is the first step toward becoming innovative, responsible, and forward-thinking developers. You're about to wrap up this course with an exciting project. You're going to build a web and rule-based chatbot using Amazon Q Developer, which users cannot connect over any network using a browser. This will be your opportunity to showcase the skills you've learned and step into the role of a professional software developer. It's time to take everything you've learned and bring it to life. Let's get started. Congratulations! Completing this course is a significant accomplishment, and you should be proud of the skills and knowledge you've gained in generative AI for software development. In this course, you delved into the transformative world of Gen AI, learning essential concepts and tools that are reshaping the software development landscape. You began by exploring the principles of generative AI, understanding its unique ability to generate new data and distinguish it from other AI models like discriminative AI. You developed your knowledge with leading tools in the AI industry like Amazon Q Developer, ChatGPT, and GitHub Copilot, learning how to automate repetitive tasks such as code generation, bug detection, and documentation updates. Utilize AI tools to enhance productivity and streamline your development workflows. Critically evaluate Gen AI outputs and refine them to achieve the desired result. Apart from these, you also learned about the ethical implications and limitations of AI in real-world scenarios. Building on this, you explored how AI supports digital transformation in software development and beyond. Through lessons on decision-making models, neural networks, and digital transformation domains, you gained insights into how AI works internally to solve problems. These insights are the foundation for your understanding of how AI solves complex challenges in industries ranging from customer relationship management to data analytics. In the final project, you demonstrated your ability to integrate Gen AI into your software design and development process by creating a rule-based chatbot. This project showcased your proficiency in designing, coding, and refactoring software with AI assistance, implementing effective workflows using AI-driven automation, reflecting on the benefits and limitations of AI tools to make informed decisions regarding the suggestions of the code given by Gen AI during software development. You've equipped yourself with the skills to harness the potential of generative AI, empowering you to work smarter and more efficiently as a developer. This achievement is a testament to your motivation, resilience, and ability to learn new technologies, qualities highly valued by employers. While this course marks a major milestone, it's only the beginning of your journey with generative AI. Consider applying the skills you've gained to personal or professional projects to reinforce your learning, and staying updated on the latest developments in AI to maintain a competitive edge in the industry. You're now one step closer to achieving Amazon's professional certificate in junior software development, a credential that prepares you for entry-level roles and demonstrates your commitment to growth and mastery in software development. Thank you for your hard work and dedication. Now on to the last course in your program, Application Development. Picture this. Every line of code you write has the power to shape the future of technology. Welcome to the Application Development course, part of the Amazon Junior Software Developer Professional Certificate Program. This course is designed to help aspiring programmers develop into capable developers ready for the fast-paced tech industry. It offers practical learning with real-world scenarios, hands-on projects, and skills that reflect the work environment at companies like Amazon. As part of the Amazon Junior Software Developer Professional Certificate, this course is tailored to meet the demands of entry-level software development roles. By completing this course, you'll gain the confidence to ace job interviews, tackle technical challenges, and thrive as a valuable team member. With a curriculum that combines theoretical foundations and project-based learning, you'll bridge the gap between knowledge and action and emerge as a ready-to-contribute developer. So, what's in store? Let's take a quick dive into the topics we'll explore together in this course. What's a key aspect that dictates a project's success? Planning, of course. To start, you'll learn to set the stage for any successful project by honing your planning and design skills. You'll begin with requirement analysis and specification, where you'll break down project needs, document requirements using the INVEST criteria, and distinguish between functional and non-functional aspects. Hands-on activities will guide you in crafting user stories and organizing them into epics. Next, you'll move on to system design and architecture, where you'll uncover the fundamentals of design patterns and UML, or Unified Modeling Language, diagrams, giving you the framework to build scalable and efficient systems. You'll wrap up the first module with user interface design, exploring color theory, wireframing, and mockups to create intuitive, user-friendly experiences. Next up, the Software Development Lifecycle, or SDLC. Here you'll learn about the phases of Sdlc Models, compare Agile with traditional approaches, and dive into Agile frameworks like Scrum. Through activities, you'll learn to select the best Sdlc model for various projects and manage rapid development cycles, including integrating DevOps practices. Next, get your hands dirty with coding best practices. Here you'll master writing clean, maintainable Java code and refine real Java classes to meet professional standards. Then, step into testing and debugging, where you'll gain hands-on experience with tools like JUnit and techniques for resolving complex bugs. You'll test your applications controller and service layers and explore logging with Simple Logging Facade for Java, or SLF4J, which lets you monitor and enhance your software's performance. From here, you'll move to version control, an essential skill for any developer. You'll start learning how to set up Git, navigate GitHub, and manage repositories. You'll practice committing changes, pushing and pulling updates, and mastering Git flow to simulate real-world development workflows. After this, you'll put your skills to the test in the final project. This isn't just an assignment, it's a standout piece for your professional portfolio. You'll apply Java principles step by step in a real-world context, completing the project while reviewing best practices and reflecting on key lessons from your coding journey. And that's not all. This module also aims to connect learning to career readiness. To this end, you'll explore how to prepare for technical interviews. You'll also tackle online coding tests, explore behavioral interview techniques based on Amazon's leadership principles, and participate in realistic interview simulations. Practice quizzes and resume refinement will help you build confidence and make a strong impression on employers. This course is more than a step. It's a leap into your future in software development. You'll gain a comprehensive understanding of the development lifecycle, refine your coding and design skills, and prepare to tackle the industry's technical challenges with confidence. Whether pursuing your first role or aiming to enhance your expertise, this course will empower you to succeed as a junior software developer ready to make an impact. Are you ready to take the leap? Your journey starts here. As you work through the modules in this course, you'll be on an exciting journey that will transform your understanding of software development. You'll learn about project planning and the core frameworks and life cycles that guide software projects. On a practical level, you'll explore best practices for writing clean, maintainable code in Java and examine the crucial role of version control. Then, in a fitting finale to this learning journey, you'll complete a comprehensive project. It will combine all aspects of this course with the skills and knowledge you gained in previous courses. You'll plan, design, code, and test a full application called To Rails Elite Solution. In creating this, you will showcase your ability to develop a functional software solution. In fact, this capstone project is not just an assignment, but a real-world simulation of professional software development. As a result, it will give you the opportunity to build a portfolio piece that reflects your expertise and readiness for the industry. In the project, you will be asked to create an organizer app called To Rails Elite Solution that allows users to track and prioritize their tasks. Completing the project will give you practical experience in building a secure and scalable backend for the personalized task management system. You will be required to create a strong application that works with an API. You'll focus on important backend development practices such as writing clean code, checking for errors, and conducting testing to ensure that everything works correctly. Here are some of the important concepts and features that you will include as you build the application. The application that you create must protect sensitive data using appropriate authentication and authorization methods. You will have to make security a key element in your design by incorporating role-based authentication. As you design your application, you will also have to incorporate efficient user management. It should allow users to register, log in, and securely access their personalized task data. You'll be using Spring Security to protect your application and manage user logins and permissions. Once you have created the application, the users must be able to organize and track their to-do tasks through a safe and user-friendly system. Your design must allow them to create, read, update, and delete tasks with robust error handling. As part of this project, you will design a Restful API to build the functions that will let you create, read, update, and delete tasks and users. The project will also require you to implement validation and logging to make sure the data is correct and to give clear feedback to users and developers. By adding data validation, you will ensure data integrity. Your application should not allow incomplete inputs and should reject invalid data. Code quality is important in building a reliable application. Another of your key tasks will be to design and write tests to assess the code quality, check for errors, and confirm that everything works as it should. You will design unit tests, which are small tests of individual pieces, and integration tests, which test how all parts work together. Throughout this project, you'll work hands-on with backend technologies and frameworks. For example, you will implement role-based authentication using Spring Security for secure access control. You will develop a RESTful API that performs full CRUD operations for tasks and users. In addition, you will use JUnit and Mock MVC to write unit and integration tests to ensure functionality and error handling. By the end of this project, you will have gained valuable practical experience creating a scalable, secure, and production-ready backend solution. You will have mastered key concepts while emphasizing clean coding and testing best practices. The completed project will be an important portfolio piece that shows how far you've come in your software development journey. Imagine planning a road trip where you follow incorrect directions. Despite all your preparations, you realize halfway through that you missed the right exit. The same thing happens in software development if the requirements are misunderstood or incorrectly identified. It can derail the entire project. In software, eliciting requirements means gathering and defining what the software must do. Gathering refers to collecting information from stakeholders, users, and sources to understand the software system's needs, expectations, and constraints. Misunderstanding or missing requirements leads to wasted time, increased costs, and a product that doesn't meet the client's needs. In this video, you'll explore the common challenges faced during the requirements gathering process and explain how incorrect or missing requirements can lead to project failure. Eliciting accurate requirements can be difficult, as several challenges can arise during this phase. Let's explore these challenges in more detail. Tacit knowledge refers to insights users gain through experience but may struggle to articulate. These insights are often taken for granted and not explicitly shared during the requirements phase. For example, a warehouse manager knows that certain items, like temperature-sensitive goods, need special handling, but may not clearly explain this to the employees. If this tacit knowledge isn't captured, the system may fail to manage inventory properly. Critical system functionality can be missed when tacit knowledge is overlooked, leading to costly mistakes. Sometimes, both the client and the development team assume certain things without explicitly confirming them. These unspoken assumptions can cause misalignments. Let's say a development team assumes the system will be built using the latest version of Java, but the client's legacy systems only support Java 8. The result is a system that doesn't work with the client's infrastructure. This assumption could lead to costly rework, delays, and a product that doesn't meet client needs. Different stakeholders often have conflicting requirements. Balancing competing interests can be difficult, especially when the project involves multiple departments or teams. Take, for example, a healthcare system project in which doctors want easy access to patient records, but security-conscious administrators demand additional encryption. These requirements can conflict, as easier access might compromise security. Conflicting requirements lead to compromises, resulting in a system that doesn't fully meet any stakeholders' needs. Resolving these conflicts early helps prevent issues down the line. Next is ambiguity, which occurs when requirements are unclear or open to multiple interpretations. This lack of clarity can cause the development team to build the wrong features. If a client requests an app that's fast and responsive, but does not define what fast means, for example, load time or data retrieval speed, multiple team members might interpret this differently, leading to inconsistent results. Ambiguous requirements such as this cause confusion, and the final product may fail to meet expectations or deliver the required quality of service. Incorrect or misunderstood requirements can have serious consequences. The project can suffer significant setbacks when key details are overlooked or misinterpreted. Imagine a software development team building an employee scheduling system. The client asks for a feature to easily adjust schedules, but doesn't specify that it should also track employee preferences, overtime, and integrate with payroll. As a result, the delivered system can only make basic schedule changes, and the client is dissatisfied. Let's examine the impact of these incorrect requirements. First is increased costs. Rework and bug fixes consume valuable time and resources. Next is project delays. Missing requirements can delay the project, frustrating both developers and clients. Another impact is poor user experience or UX. The system may fail to meet user needs, leading to dissatisfaction. And finally, there's reputation damage. A failed project can harm the development team's reputation, making it harder to secure future contracts. Let's explore some strategies to avoid the pitfalls of inaccurate or misunderstood requirements. Engage stakeholders early. Regular communication ensures everyone's needs are addressed and assumptions are identified. Be specific. Ask stakeholders for clear, measurable criteria that define success. Avoid vague statements like fast and responsive. Prioritize requirements. Some requirements are more important than others. Resolve conflicts early and focus on the most critical features. Use visual aids. Prototypes, wireframes, or mockups help clarify ambiguous requirements and serve as a reference for discussion. Document assumptions. If there are assumptions about the system's capabilities, technology, or scope, document them and get confirmation from stakeholders. And finally, iterate. Requirements should be revisited regularly, and changes should be tracked to ensure the project stays on course. In this video, you learned that eliciting correct requirements is essential for the success of any software project. You also examined how the challenges of tacit knowledge, assumptions, conflicting needs, and ambiguity can lead to misunderstandings that result in delays, increased costs, and unsatisfactory products. By addressing these challenges, engaging stakeholders, clarifying requirements, and documenting assumptions, you can minimize the risks of incorrect or missing requirements. Ensuring clear, detailed requirements from the outset leads to smoother development, satisfied clients, and successful projects. Have you ever wondered why some software projects run smoothly while others face delays and confusion? A key factor is having well-defined functional requirements. These requirements outline what a system must do to meet user and business needs, making them essential for any software project success. This video explores the different types of functional requirements with simple examples to make them clearer. So what exactly are functional requirements? Essentially, a functional requirement specifies what a system should do. It outlines the behaviors, functions, and operations the software must perform to meet user needs. Focusing on user interactions and system processes, functional requirements describe how the system responds to inputs, ensuring predictable and effective behavior. They guide developers in building features that provide value to users and align with business goals. Defining functional requirements ensures all necessary features are included, keeps development tasks on track, and gets everyone on the same page. It also helps avoid misunderstandings, reduces the chance of missing important details, and makes testing and validation much easier. Functional requirements cover a range of needs, each playing a role in defining how a system works. Functional requirements include user interface requirements, data requirements, business rules, functional processes, external service requirements, authentication and authorization, and validation requirements. Let's look at each with examples from a fictional online bookstore project. First, user interface requirements. These outline how users will interact with the system. They define the elements users will see and interact with, such as buttons, forms, and menus. This means providing a smooth interface experience for the online bookstore. The search bar should accept at least 3 characters and return results within 2 seconds, while navigation should include a shopping cart icon showing the item count. Search results should display 20 books per page with sorting options for price, title, publication date, and real-time product availability. The next type is data requirements. These specify the data the system needs to store, retrieve, and manipulate, ensuring all necessary data is handled correctly. For the online bookstore, data requirements mean the system should accurately manage customer profiles and book records. Customer profiles should include a unique ID, full name, email, phone number, and billing and shipping addresses. Book records should include a unique ISBN 13, title, authors, price, count, category, publication date, and publisher. Next, let's consider business rules. These define the logic that governs how data can be created, stored, and changed. They enforce the policies and procedures of the organization. For the bookstore, this could mean automatic pricing and order management rules. Orders shouldn't exceed available stock, and shipping costs should be calculated based on order weight, destination zip code, and chosen shipping method. Next is functional processes. These describe the specific processes the system must perform, often outlining step-by-step workflows. This means that the bookstore system follows a clear workflow for orders: verify stock, calculate the final price, including discounts, shipping, and tax, process payment within 3 seconds, and create an order record upon success. Next are external interface requirements, which specify how the system will interact with other systems, services, or hardware. For the bookstore, this means the system should integrate with payment and shipping services. Payments should support major credit cards, provide transaction IDs, and handle refunds. Shipping integration must retrieve rates, support tracking, and update delivery status every 4 hours, with all communications secured by encryption. A further type is authentication and authorization. These define how users will access the system and what permissions they have. For the online bookstore, users should register using a valid email and password. There should be 2 roles, customer and admin. Customers can browse and purchase books, while admins can add or remove books, manage orders, and view sales reports. Finally, validation requirements specify the rules for ensuring data entered into the system is correct and relevant. The bookstore system should validate that registration emails follow standard formatting and that passwords are 8 characters long and include letters, numbers, and special characters. And now you know some of the key functional requirements. Before you move on, let's briefly review some of the benefits of proper functional requirements. Clear, well-documented functional requirements simplify testing by specifying exactly what to verify. They also make project cost and timeline estimates more accurate. Think of them as a checklist that keeps everyone aligned, allowing developers to focus on building the right features instead of seeking clarifications. They also simplify system maintenance and updates. New team members can quickly understand the system by referring to these requirements, which act like a manual that explains every feature and process. Managing functional requirements effectively is essential for project success. Clearly defining what the system should do helps the development team meet user expectations. Understanding different types of functional requirements ensures a smoother development process and a final product that meets its goals. Functional requirements tell us what a system should do, but there's another equally important piece to the puzzle: non-functional requirements. These focus on the system's performance and whether it meets key quality standards. Think of them as the behind-the-scenes factors that ensure your software isn't just functional, but also delivers strong performance, robust security, and a great user experience. In this video, we'll explore the various non-functional requirements and use some examples to make these concepts easier to grasp. Before we do this, let's define non-functional requirements. In essence, non-functional requirements, or NFRs, describe how a system should operate and set limits on its functionality. While functional requirements focus on what a system does, NFRs deal with the quality attributes and performance standards it must meet. They're crucial for ensuring the software doesn't just get the job done, but does so in a way that aligns with user expectations and business goals. NFRs fall into several categories, each focusing on different aspects of a system's performance and quality. This includes performance, security, usability, reliability, scalability, maintainability, compatibility or portability, and legal requirements. Let's explore these further using the online bookstore project as an example. First, performance requirements. These outline how well the system should perform under certain conditions, focusing on speed, responsiveness, and efficiency. In the online bookstore, this could mean that the home page loads within 2 seconds and the site supports up to 10,000 users simultaneously without any issues. Think of it like ensuring the store can handle the holiday shopping rush without slowing down. Next, security requirements. These outline how the system safeguards data and ensures only authorized users can access certain features. For the bookstore, this could mean encrypting all user data during transfer and storage and using multi-factor authentication for admin accounts. Think of it as a robust security system, protecting the online store, just like a well-guarded physical shop. Let's look at usability requirements next. These focus on how easy and intuitive the system is for users to navigate and use. For example, the bookstore could have an intuitive interface that allows users to buy a book in only 3 clicks. It should also support multiple languages and provide the same features on phones or computers. Reliability requirements specify the system's ability to operate consistently without failures and recover quickly from any issues. This would mean the online bookstore should have a system uptime of 99.9% and should be able to recover from system errors or failure within 5 minutes. Maintenance should occur during quiet periods, and backups should be scheduled regularly to ensure quick recovery. Next up are scalability requirements, which specify how the system can grow and manage higher workloads without sacrificing performance. A scalability requirement for the online bookstore could be the ability to scale horizontally to support a 100% increase in traffic during peak hours. Scaling horizontally means adding more servers or instances to distribute the load across multiple systems, enhancing performance and availability. It's like ensuring the store shelves can hold more books when stock grows. Maintainability requirements focus on how the system can be updated, fixed, and/or improved over time. What does this mean for the bookstore? Its codebase should follow standard coding practices and include thorough documentation in order to plan maintenance and future enhancements. Compatibility or portability requirements outline how well the system integrates with other systems, platforms, tools, or devices. For the online bookstore, this could mean compatibility with all major web browsers across different servers. The code should also easily deploy to different cloud services. It's like having a store that can easily move to any shopping mall without rebuilding. Finally, there are legal requirements. These ensure the system complies with the relevant laws, regulations, and standards. For instance, the online bookstore must adhere to data protection regulations, ensuring user data is managed and stored in compliance with legal standards. So there you have the key types of non-functional requirements, aligned with an example from the online bookstore. Clearly defining non-functional requirements helps project teams ensure the system meets quality standards, works efficiently in various conditions, and stays secure from potential threats. This prevents problems like sluggish performance, security risks, and poor user experiences, issues that can seriously affect project success. By clearly defining how the system should perform, the development team can better meet user expectations and deliver a high-quality product. Great work. Imagine you're part of a team building a new feature for a website, maybe an online shopping cart. You're tasked with explaining what needs to be done, but how do you clearly communicate the requirements? The answer? User stories. User stories are a powerful tool for defining and communicating requirements in software development. While they are a crucial element in Agile methodologies, they can also be helpful in various other fields, where clear, user-centered communication is essential. In this video, you'll explore the critical components at the heart of every user story, the 3 Cs: card, conversation, and confirmation. Let's break these down and see how they can help you create simple, actionable user stories that everyone can understand. A user story often starts as a simple, short description written on a card, either physical or digital. This card contains the basic details of the feature from the user's perspective. It should be clear and to the point, addressing 3 main questions. Who is the user? What does the user want to do? And why do they want to do it? For example, a user story for an online shopping cart might be, as a shopper, I want to add items to my cart so I can purchase them later. This brief statement helps everyone understand the general goal, but it's just the beginning. The card gets the conversation started. Once the card is written, it's time for the conversation. This is where the real discussion happens. The user story alone is rarely enough to answer all questions about the feature. The conversation is a collaborative process in which the team, product owners, developers, and designers discuss the details. During the conversation, fundamental questions are asked. What happens when the cart is full? Can the user add items later or change quantities? What should happen if the user tries to check out with an empty cart? The conversation allows the team to flesh out the specifics and ensure everyone is aligned on what needs to be built. It also helps the team identify potential challenges or edge cases that might not have been obvious from the card alone. The last C is confirmation, which refers to the acceptance criteria for the user story. These are the clear, measurable conditions that must be met for the feature to be considered complete. The confirmation answers the question, how will we know when this is done? In the shopping cart example, the confirmation might include criteria like the cart should save items even after the user logs out. The user should receive a confirmation message when an item is added to the cart, and the cart can hold up to 10 items at a time. These confirmation criteria ensure that the development team knows exactly what is expected and provide a clear way to verify that the feature works as intended. The 3 Cs, card, conversation, and confirmation, are a simple yet effective framework for writing and discussing user stories. They provide a structure that helps teams communicate clearly and efficiently. Here's why they're important. First, there's clarity. The card focuses on the user's needs while the conversation fills in the details to avoid misunderstandings. Next is collaboration. The conversation ensures everyone is involved in shaping the feature, fostering teamwork and alignment. And finally, there's precision. Confirmation provides clear criteria to determine when a feature is complete, reducing ambiguity. Whether you work in software development or any other field, the 3 Cs can help ensure that your project is aligned with user needs, understood by all team members, and ready for delivery. In this video, you learned how user stories are an essential tool for communicating requirements, and the 3 Cs, card, conversation, and confirmation, form the foundation of effective user story writing. By starting with a simple card, having collaborative conversations to clarify the details, and defining clear confirmation criteria, you can create user stories that guide your team to successful outcomes. So next time you're faced with defining a feature, try using the 3 Cs to structure your approach. This simple framework will ensure that everyone involved is on the same page and that your project is set up for success. Have you ever tried assembling a jigsaw puzzle? Picture this. Each piece represents a small, manageable task. When they fit together just right, they create a beautiful, cohesive picture. But what happens if some pieces are too big, too vague, or just don't fit? Frustrating, right? The puzzle becomes almost impossible to finish. Now think of a project in the same way. Each requirement is like a puzzle piece. If they're unclear, overly complex, or impossible to test, your team will struggle to deliver a successful outcome. And that's where the Invest model steps in. It's a simple framework to make sure your project requirements are clear, valuable, and easy to manage. In this video, you'll dive into how it works. All right, let's talk about Invest. Not in stocks, but in creating great project requirements. Invest stands for independent, negotiable, valuable, estimable, small, and testable. These 6 attributes are like a checklist to make sure your user stories or requirements are top-notch. Why? Because when requirements are clear, actionable, and flexible, they make your project smoother and more manageable. By sticking to the Invest criteria, you ensure that your team can adapt to changes while keeping everything on track. So let's break it down and explore why each attribute matters. Let's start with the I in Invest, independent. Imagine working on a project where every task is tangled up with something else. It's a nightmare, right? That's why making a requirement or user story independent is so important. It means the story can be developed, tested, and delivered on its own without being overly tied to other tasks. Independence helps avoid bottlenecks that can derail your timeline. Here's an example. Say you're adding a login feature to an app. This should be independent. It shouldn't depend on completing user profiles first. That way your team can develop the login functionality without waiting on the profile system. Keeping tasks independent keeps things moving smoothly. Next up, the N in Invest, negotiable. Think of a requirement like a draft. It's not set in stone. Instead, it's flexible and open to discussion. The idea is to collaborate with stakeholders, refine the details, and adjust as needed to meet both user needs and project goals. For example, say your user story is about adding a real-time chat feature. It doesn't have to lock in specifics, like the exact technology to use or how fast messages need to be delivered. Those details can be worked out together, based on what's realistic, given your resources and technical constraints. Negotiability keeps things adaptable, so your team can focus on finding the best solution. Let's talk about the V in Invest, valuable. Here's the deal. If a requirement doesn't deliver real value to the user or the business, why even build it? Every feature or user story should solve a problem or seize an opportunity. Otherwise, it's just wasted time and effort. For instance, imagine you're working on an e-commerce site. A user story might describe adding a wishlist feature. Why is this valuable? Because it enhances the user experience, letting customers save items for later, and it boosts sales potential. The takeaway? Make sure every requirement earns its place by providing genuine value. Next, let's dive into the E in Invest, estimable. Imagine being handed a requirement like, make things better. How would you even begin to estimate the time or resources needed for that? You can't. That's why a requirement needs to be clear and specific enough to estimate the effort involved. Here's an example. A vague requirement like improve site performance is tough to estimate. But if you break it down into tasks like optimize image load time or implement caching for frequently accessed pages, suddenly it's manageable and you can make a reasonable estimate. Tools like story mapping or assigning story points can also help simplify complex requirements. The goal? Make every requirement clear enough to plan effectively. Now let's explore the S in invest, small. When it comes to user stories, smaller is better. A requirement should be something your team can complete within a short time frame, usually a single sprint or iteration. Why? Because small stories are easier to understand, estimate, and finish without overwhelming the team. For example, instead of a massive task like redesign the entire website, break it down. Create smaller stories like redesign the homepage header or improve the product page layout. These bite-sized tasks are much more manageable and keep progress steady. Think of it as taking small steps to climb a big mountain. Easier, right? That's the power of small. Finally, let's talk about the T in invest, testable. A testable requirement is one that you can verify through clear, measurable tests. To make this happen, you need solid acceptance criteria. These are the rules that define when a requirement is successfully implemented. Without them, how do you even know if you've hit the mark? Here's an example. Let's say you have a user story like, the user should be able to reset their password. The testable criteria might be something like this. The system sends an email with a reset link. The user can reset their password within 15 minutes. The new password works for logging in. By having criteria like this, everyone from developers to stakeholders knows exactly what success looks like. And that's the key to staying on track. So why does the invest model matter? Simple. It's all about setting your project up for success. Using invest ensures that each requirement is clear, manageable, and, most importantly, valuable. When you follow these principles, your user stories are more likely to be delivered on time, stay within scope, and truly meet user needs. For example, think about dependencies. If requirements aren't independent, one feature might get stuck waiting for another, creating bottlenecks. Or take size. If a requirement isn't small, it can lead to vague goals, missed deadlines, or incomplete features. And here's the best part. When requirements are negotiable and testable, you create space for continuous feedback. This means you're not just building blindly, you're adapting to ensure you're delivering the features users actually want. In short, invest keeps your team focused, flexible, and on track to deliver value. In any project, especially in Agile, defining clear, actionable, and valuable requirements is the key to delivering quality software. And that's where the invest model shines. By ensuring your requirements are independent, negotiable, valuable, estimable, small, and testable, you're setting the stage for tasks that are manageable, achievable, and laser-focused on user needs. The result? Smoother project execution, better collaboration, and a product that truly delivers value. So, next time you're crafting requirements, keep the invest principles in mind and watch your project transform into a well-oiled machine. How do you go about building a home? You wouldn't just start laying bricks or installing doors at random, would you? Instead, you'd consult an architect, share your vision and requirements, and ask them to draft a blueprint. This plan outlines where the rooms, doors, and windows should be, ensuring your home is both functional and built to last. Developers follow a similar strategy when working on software projects. They rely on design patterns as blueprints to tackle common coding challenges. In this video, you'll explore design patterns, what they are, how they differ from system architecture, and how they speed up development and help make software more maintainable. So what are design patterns? Simply put, a design pattern is a reusable solution to a specific type of software design problem. These patterns represent best practices for writing code that is both structured and scalable. It's important to understand that design patterns are not software libraries, but rather templates or blueprints to guide you in crafting your code. There are many advantages to using design patterns in software development. First is reusability. Since design patterns are proven solutions, they help you avoid redundant code, save time, and streamline the development process. Another advantage is scalability. Design patterns are flexible, making it easy to adapt to changing needs and plan for future growth. This scalability lets your software evolve without requiring major changes. A third advantage is maintainability. Design patterns make your software more modular and easier to manage, so you can tweak specific components without affecting the rest of the application. The final key advantage is collaboration. The standardized terms used in design patterns make it easier for team members to communicate and collaborate effectively. Now you know some of the advantages design patterns bring, let's dig into the different types. Design patterns can be broadly classified into 3 categories: creational, structural, and behavioral. Structural patterns offer ways to design and organize classes, making your code more flexible and promoting reuse. For example, in a Java application, the adapter pattern can be particularly useful for integrating third-party libraries that aren't naturally compatible with your system. Creational patterns focus on object creation strategies, ensuring flexibility and reusability. Object creation patterns rely on delegation, while class creation patterns use inheritance during instantiation. For example, the factory method pattern is common in Java's Spring Framework to dynamically create and configure beans, objects managed by the Spring Framework that represent the core building blocks of a Spring application. Another example in Java is the builder pattern, commonly used to create complex objects like HTTP requests in libraries like Apache HTTP Client. Finally, behavioral patterns focus on managing object communication and defining the responsibilities between objects. An example in Java is the observer pattern, commonly implemented in Java FX. In this pattern, changes in the model automatically update the view, enabling smooth synchronization between components. Another example is the command pattern, which is often used to implement undo or redo functionality in desktop apps. By appropriately and effectively applying these design patterns, Java developers can easily tackle recurring design challenges. For instance, in a microservice architecture, you might use the singleton pattern for managing shared resources or the proxy pattern to streamline service communication, simplifying the overall implementation. Now you might be thinking, so far so good, but software design sounds very similar to system architecture. What are the differences between them? Software design focuses on detailed blueprints for solving specific problems within the code. In contrast, system architecture takes a broader, high-level perspective, defining how various systems and technologies communicate and work together to form a complete solution. Let's consider a Java e-commerce app as an example. The architecture outlines how key components, such as the front-end, database, and payment gateway, integrate and interact. Meanwhile, the design delves into specifics, such as structuring the internal logic of the shopping cart. In summary, design patterns are like blueprints for tackling common coding challenges. They help you build software that's scalable, maintainable, and ready to adapt to change. By applying these proven solutions, you save time and effort while creating efficient and robust systems. Happy coding! Imagine constructing a massive shopping mall without clear blueprints. Architects, engineers, and workers might miscommunicate, leading to chaos or even a complete disaster. Software development works the same way. It's a team effort that thrives on clear communication and shared understanding. That's where UML, or Unified Modeling Language, comes in. It's like a blueprint for designing software systems. In this video, you'll discover the importance of UML, learn about the notations and symbols used to create UML diagrams, and see how they relate to the shape class hierarchy you studied earlier in the course. So, what exactly does UML do? UML uses standardized notations to ensure that everyone involved interprets the system design in the same way. It helps bridge communication gaps between developers, testers, and stakeholders. By using UML diagrams, teams can catch design flaws early, saving time and money in the long run. UML has many types of diagrams, but they are generally classified into 2 categories: structural and behavioral UML diagrams. Structural UML diagrams are visual representations of the static components of a system. They illustrate elements like classes, objects, components, and the relationships between them. You'll focus on structural diagrams in this video. On the other hand, behavioral UML diagrams focus on the dynamic aspects of a software system. They showcase how the system behaves and undergoes state changes during runtime. There are several tools available for creating UML diagrams, and one popular choice is Draw.io, now known as Diagrams.net. Diagrams.net is an open source, free online tool widely used for building not just UML diagrams, but also flowcharts, network diagrams, organizational charts, and more. It provides ready-to-use components for UML diagrams, such as classes, interfaces, associations, and arrows. You can easily design all UML diagram types, including class, sequence, activity, and use case diagrams. You'll learn more about these later. When you visit app.diagrams.net, the interface opens directly in your browser. It's an easy-to-navigate workspace where you can start building diagrams immediately. Diagrams.net supports a wide range of diagram types beyond UML diagrams. These include flowcharts, tables, and Venn diagrams, making it a versatile tool for various diagramming needs. To start creating UML diagrams in Diagrams.net, select the UML category from the toolbox on the left of the homepage. This will load a variety of UML symbols, including classes, interfaces, associations, arrows, and more, which you can use to build your diagram. Let's focus on class diagrams. A class diagram is a type of structural UML diagram. It represents the static structure of a system by showing its classes, interfaces, and the relationships between them. Each class in the diagram includes key components, such as the class name, attributes, and methods or operations, making it a handy tool for visualizing and designing the architecture of a software system. In UML, a class is represented as a rectangular box divided into compartments. The class name is typically displayed in the top compartment, centered and written in bold to distinguish it clearly. To represent a class as an interface in UML, the rectangular box includes the notation interface at the top, above the interface name. This clearly identifies it as an interface rather than a standard class. Attributes, also known as properties or fields, represent the data members of a class in UML. These are placed in the second compartment of the class box, right below the class name. Methods, also called functions or operations, define a class's behavior or functionality in UML. They are placed in the third compartment of the class box, beneath the attributes section. In Java, data members and methods include their data type and visibility, such as public or private, which defines their access level. UML uses specific notations to represent these visibility levels. These include the plus symbol for public, the minus symbol for private, the hash symbol for protected, and the tilde symbol for package or default visibility. The UML representation of the shape class includes a string attribute named color with protected visibility, denoted by the hash symbol, and two public methods, a constructor, shape, and an area method, which returns a value of type double. Classes in Java may have different types of relationships, such as inheritance, aggregation, composition, and implementation. In UML, inheritance is represented by a solid line with an arrow pointing from the derived class to the base class. It signifies an is-a relationship. Aggregation is represented by a hollow diamond on the aggregate class and a solid line connecting it to its parts. This represents a has-a relationship, where the aggregate class is made up of the parts. Composition is shown using a filled diamond on the container class with a solid line connecting it to the contained class. This indicates a strong contains-a relationship, where the contained class cannot exist independently of the container. Finally, implementation is depicted by a dashed line with an open arrowhead pointing from the class implementing the behavior, the client, to the class specifying the behavior, the supplier. Let's look at an example. Here the circle class inherits from the shape class, represented by a solid line with an open arrowhead pointing from circle to shape. Shape has a protected color attribute, a constructor, and a public area method. Circle adds a private radius attribute, its own constructor, and overrides area. The arrow indicates the inheritance relationship, allowing Circle to extend Shape's functionality. In this video, you learned about the importance of UML, its role in software design, and the key symbols and components used in UML diagrams. UML is a key part of software design. It fosters collaboration, enhances implementation, and strengthens team communication while enhancing your dev skills. And if you want to create UML diagrams, Diagrams.net is a great option. It's free, user-friendly, and perfect for quickly building and sharing diagrams. Happy coding! Imagine a library system. Each book can only be borrowed by one member at a time, but a member can borrow multiple books. Or think about a social media app where one person can have many followers, and those followers can follow many others. These types of relationships, how things are connected and interact, are known as cardinality. Understanding cardinality is crucial for software developers. It clarifies how different classes in the system relate to each other, making it easier to understand how data interacts. In this video, you'll explore cardinality, its various types, and how it's represented in Unified Modeling Language or UML. First, a definition. Cardinality defines how many instances of one entity can be connected to another. Put simply, cardinality is about numbers. It shows the quantity of relationships between entities. For instance, in a teacher-class relationship, cardinality might state that one teacher can teach multiple classes, but each class is taught by only one teacher. Cardinality is categorized based on the quantity of relationships between entities. The types include one-to-one, one-to-many, many-to-one, and many-to-many. In UML, cardinality is represented in UML diagrams, visual representations used to model and design software systems. Recall that UML diagrams use rectangles to represent entities or classes and lines to show relationships. Cardinality notations are placed near these lines to indicate the rules of the relationship. In UML, cardinality is represented using notations placed near the relationship line. Here's a quick guide. 1 indicates a strict one-to-one relationship, where exactly one instance of an entity is connected to one instance of another. 0.1 represents an optional relationship, where an instance of an entity can be connected to 0 or one instance of another entity. 0.** shows that an instance of an entity can be associated with 0, 1, or many instances of another entity. 1. ** indicates that an entity must have at least one connection, but it can also have many. Now that you know the notations, let's explore the different cardinality types in more detail. Keep the notations in mind as you learn about each one. First, one-to-one cardinality. In a one-to-one relationship, each instance of an entity is linked to exactly one instance of another entity. For example, a person has their own birth certificate, and each certificate, identified by a unique number, is issued to only one person. However, a variation of one-to-one cardinality occurs when the relationship is optional on one side. For example, a person can have only one passport, but some individuals may not have a passport at all. In such cases, the 0.1 notation is used on the relationship line to indicate this optional relationship. In a one-to-many relationship, one instance of an entity is connected to multiple instances of another. This is depicted with 1 on the single side and 0.** or 1. On the many side, where the asterisk signifies many. For example, a library can hold many books, but each book belongs to only one library branch. On the other hand, in a many-to-one relationship, multiple instances of one entity are associated with a single instance of another. For example, many people can share the same birthplace, but each person can only have one birthplace. In a many-to-many relationship, several instances of one entity can be connected to several instances of another. As you learned, in UML, this is represented by placing 0.** or 1. Near both entities. In database design, a junction table or intermediary class is often used to handle these relationships effectively. For example, many students can enroll in multiple courses, and each course can have several students. Of course, there is also an optional aspect to a many-to-many relationship. This is shown by placing 0.** on the relationship line for both entities. For example, a person may own many books or none at all, and a book may be owned by many people, or it might not be owned by anyone yet. Now that you understand cardinality, you can clearly define how entities interact, making your designs more robust and easier to implement. Now you'll be able to interpret and model entity relationships confidently, whether in a one-to-one, one-to-many, or many-to-many scenario. This knowledge is a key step in creating well-structured and efficient systems. Think about your favorite app or website. Ever wondered what makes it work so smoothly? Behind the scenes, there's a carefully planned system that ensures everything runs steadily, stays within budget, and meets the needs of its users. This is the magic of system architecture. From the hardware it relies on to how the software pieces fit together, it's the blueprint that keeps everything efficient and aligned with business goals. In this video, you'll explore system architecture, its role in shaping software, and why aligning it with business needs like cost efficiency and scalability is essential. When designing a system, it is recommended to use a systematic approach. For software systems, this means carefully choosing hardware, software, workflows, and data flows. System architecture deals with the big picture decisions, how hardware, software, and networks fit together to form a cohesive system. It includes choices like server setups, data centers, cloud platforms, and network configurations. On the software side, the architecture focuses on designing components like modules, services, and data flows to meet specific functional requirements. This is a specialized part of the broader system architecture. Think of planning system architecture as creating a blueprint for a major construction project. It maps out how different elements, databases, servers, and user interfaces come together to meet the software's objectives. However, system architecture isn't just about choosing technologies. It's about aligning with a business's operational needs. A well-planned architecture addresses key questions like, can the infrastructure fit within the budget? What are the costs for maintenance and scaling? Can the system handle thousands of users at once? And will it adapt as the business grows? When architecture doesn't align with these priorities, it can lead to overspending, inefficiencies, or systems that collapse under pressure. That's why developers and architects must balance technical innovation and business practicality. Now let's dive into a project example to better see these concepts in action. Imagine you're designing a system for a food delivery business called Quick Eats. The first step is to outline the business goals. These include process up to 10,000 orders per hour, minimize operational costs since it's a new business, ensure reliability to meet customer expectations for timely deliveries, and support both mobile and web platforms to provide a seamless user experience. To align the architecture with these business needs, you might opt for a cloud platform like AWS to keep upfront infrastructure costs low and enable on-demand scaling. A content delivery network, or CDN, can cache static assets, like images, ensuring fast load times for customers across different regions. Load balancers would then manage incoming traffic, preventing server overload and ensuring smooth performance. These are all system architecture choices that speak to the business goals. On the software side, a microservices architecture would work well. Each feature, such as order placement, payments, and delivery tracking, can function as an independent service, making the system both scalable and easier to maintain. For data management, a hybrid approach could combine SQL for structured data, like user details, and NoSQL for unstructured data, like real-time delivery updates, ensuring a balance of reliability and speed. By implementing these system and software architecture choices, Quick Eats can achieve a cost-effective, scalable, and reliable solution. Each decision, whether focused on cost control, performance, or scalability, directly supports the business's core needs and goals. System architecture is more than just a technical blueprint. It's a strategic tool that drives the success of software. By aligning architecture with business goals, you can build systems that are cost-effective, scalable, and reliable. Whether you're working on a small app or a large-scale system, thoughtful architecture sets the foundation for success. Happy coding! Think about visiting a cafe for the first time. Was it an easy, enjoyable experience, or did unclear menus and uncomfortable seating leave you frustrated? Now imagine the opposite. Clear menus, inviting seating, and flattering lighting. The difference is striking. Just like a well-designed cafe enhances your visit, a good user interface ensures smooth and effective interaction with digital products. In this video, you'll learn 7 foundational principles of good UI design to help you create high-quality user experiences. First things first, A user interface, or UI, is where humans and computers meet. All the buttons, text, and layouts that guide actions on websites, apps, or devices. Just like the digital landscape itself, UI design has evolved from physical controls, like buttons and keyboards, to multimodal interfaces that use touch, voice, gestures, and facial recognition. Despite these advances, the goal of UI design remains the same: to create intuitive, efficient, and enjoyable digital experiences. To achieve these goals, designers and developers rely on 7 fundamental principles of good UI design, each essential for crafting high-quality user experiences. Let's consider each of them now. Great UI design starts with clarity. Every button, icon, and menu should be immediately clear, with no room for doubt. For example, the universally recognized shopping cart icon signals a place to view or manage purchases at a glance. No explanation needed. Clarity is all about simplicity and directness. It ensures users can navigate an interface without second-guessing their next step. When users don't have to pause to interpret or decipher elements, their experience becomes smoother, faster, and more enjoyable. The next principle of discriminability ensures that users can easily tell different interface elements apart. This principle is critical for helping users identify what's interactive and what's not. For example, clickable buttons often change color or highlight when hovered over. These are valuable signals of interactivity that guide the user's decision and actions. Clear distinctions help users navigate quickly, safely, and confidently. Next, concision, which is about keeping things simple, clear, and to the point, no fluff. A great UI avoids overwhelming users with too much information at once. Think of a cafe menu. Too many pages and tiny print make choices frustrating. The same applies to digital interfaces. Clutter leads to confusion. Instead, an interface that embraces conciseness presents only the most essential information, allowing users to focus on what truly matters. Minimal text and straightforward design elements, like a simple save or cancel button, communicate actions effectively without unnecessary complexity. In short, concise design eliminates distractions, enabling quick, confident decisions. The next principle, consistency, is essential for building familiarity and comfort in a user interface. Like a well-designed cafe with a uniform layout, a consistent UI helps users navigate effortlessly without relearning. In UI design, consistency means using familiar symbols, language, and layout patterns across all pages or screens. No surprises. For example, if buttons, colors, and fonts vary drastically, users may feel disoriented, frustrated, or unsafe. Consistency creates a predictable environment, reducing cognitive load and enhancing usability. Next up, detectability, which ensures that users can easily find and identify interactive elements in an interface. Like a cafe clearly marking restrooms or counters, a well-designed UI makes buttons, links, and forms obvious and intuitive. Design elements should stand out in ways that naturally draw attention. For example, a brightly colored button on a neutral background immediately signals that it's clickable. Subtle visual cues, like hover effects or shadowing, reinforce this interactivity, helping users navigate confidently. Ultimately, prioritizing detectability ensures smooth, intuitive user interactions. The sixth principle, legibility, ensures text is easy to read and understand. Like a cafe menu with clear fonts for quick decisions, a well-designed UI prioritizes readable, accessible text. Poor legibility frustrates users and causes task abandonment. To enhance legibility, UI text should be large enough to read easily, use sufficient contrast between text and background, and feature straightforward, uncluttered fonts. Avoid overly stylized or decorative fonts, as they can make reading difficult and slow users down. Interfaces should be smooth, intuitive, and welcoming, helping users stay focused and engaged without unnecessary strain. Last but not least, comprehensibility, which ensures that users can not only read the text on a screen, but also understand it within the given context. Clear communication is key. Every piece of information should make sense and guide users toward completing their task without confusion. For instance, a message like "invalid email address" tells users exactly what's wrong and what they need to fix. In contrast, a vague message like error leaves them guessing and likely frustrated. A comprehensible UI helps users know what to do and why. By ensuring that instructions, feedback, and error messages are clear and actionable, designers can create an interface that feels intuitive and user-friendly. In this video, you learned that while UI design has evolved, the principles of good design remain the same. The goal is to create a UI that makes digital interactions seamless and enjoyable. By following the 7 principles: clarity, discriminability, conciseness, consistency, detectability, legibility, and comprehensibility, designers and developers create intuitive and user-friendly interfaces. In today's digital world, great UI design transforms frustrating tasks into seamless, satisfying experiences. By applying these principles, you can create designs that are not only intuitive and effective, but also leave a lasting positive impression on users. Building an app can feel overwhelming if you don't consider how users will interact with it. A clear plan for the user interface is key to creating a seamless, intuitive experience. Designers and developers rely on proven tools like wireframes and mockups to bring that plan to life. Wireframes and mockups help map functionality and visualize the interface before writing any code. In this video, you'll learn what wireframes and mockups are, how they differ, and when to use each in the design process to create functional and visually appealing user interfaces. First, a wireframe is a simplified visual representation of an interface that focuses on layout and functionality. Like a roadmap, it shows where navigation bars, buttons, and content will go and how users will interact. Wireframes are created early to address key questions like: how will users navigate? What information is most important? They help focus on usability and flow before investing in details or coding, which is why they're so valuable. Wireframes are essential in establishing the framework for your application. A key characteristic is that they break down the interface into core components. Wireframes use basic shapes and placeholders to represent menus, buttons, and text. They also showcase how users interact with the interface, prioritizing usability. To avoid unnecessary complexity during early stages, wireframes omit colors, fonts, and images to focus on structure and flow. They're also used to define feature placement and map user navigation. Wireframes are your best starting point, but once you've set the structure, how do you bring it to life? Mockups build on the foundation of wireframes, transforming basic layouts into visually rich, high-fidelity representations that guide the final design stages. A key characteristic of a mockup is that it brings the interface to life through visual design, combining branding elements like logos, typography, and color schemes for a professional and cohesive look. And by offering a high-fidelity depiction of the interface, mockups provide a realistic preview of the final product that stakeholders can visualize with clarity. Mockups also prioritize user experience, illustrating how the interface will feel and function from the end user's perspective. Designed for collaboration, mockups are feedback-ready and serve as the final visual draft before transitioning into development. Now, when do you use either a wireframe or a mockup? By focusing on the basic layout, wireframes establish the hierarchy of information, showing where key elements like menus, buttons, and content will appear on the screen. This ensures a logical and organized structure right from the start of a project. When mapping out how users will navigate an interface, wireframes provide a clear visual guide. This is because they outline the steps users take to complete tasks, ensuring the experience feels smooth and intuitive. One of the biggest strengths of wireframes is their flexibility. Since they avoid visual details, wireframes are easy to adjust, making them ideal for incorporating new ideas or accommodating stakeholder feedback. With their simple stripped-down format, wireframes encourage discussions about functionality and user experience. They shift the focus away from aesthetics, helping teams collaborate effectively and identify what works best. Mockups, unlike wireframes, are crucial in the latter stages of the design process. They transform the foundational structure into a visually polished and realistic representation of the final interface. Mockups incorporate branding, colors, and imagery, giving stakeholders and team members a clear preview of how the app or website will look. They perfect design elements like colors, spacing, typography, and imagery, ensuring the interface is cohesive and aligns with branding goals. And mockups are excellent for presenting a polished, stakeholder-ready design to get final buy-in before development. Both wireframes and mockups are refined iteratively, evolving through multiple versions to enhance the user interface and achieve the best design. Here's a sketch of the process. Begin with wireframes to outline the basic layout and navigation of the interface, and then share them with stakeholders to gather feedback on functionality and usability. Next, improve the design based on feedback, resolving issues with structure or flow. Then add colors, typography, and imagery for a high-fidelity preview. Finally, refine details based on further feedback to ensure the design is cohesive and ready for development. By iterating on wireframes and mockups, you can create a design that is both functional and visually stunning, meeting the needs of users and stakeholders at every step. And your application's users will love it. In this video, you learned how wireframes define structure and functionality, while mockups refine visuals to create polished designs. By using these tools iteratively and collaboratively, you can ensure your designs are functional, visually appealing, and user-centered. Remember, great designs start with a clear plan and improve through thoughtful feedback. Happy iterating. When developing an application, it's not enough for it to function. It also needs to feel effortless for users. In software, user experience, or UX, is about considering how users interact with an application, how it works, and how it feels. Good UX helps users complete tasks easily and efficiently, while poor UX leads to frustration, confusion, and abandonment. In this video, you'll learn what UX is, why it's critical in development, and how good UX can create intuitive applications that drive user satisfaction and success. First, it's important to point out that while UX and UI are closely related, they serve different purposes. UI focuses on visual elements like buttons, layouts, and colors. In other words, defining how an app looks. UX, on the other hand, is about the overall experience, how intuitive the app feels, how easy it is to navigate, and how well it helps users achieve their goals. Yes, a visually appealing UI is important, but it's not enough. Without a smooth UX, users may become frustrated and abandon the app, and a lot sooner than you think. To create a successful application, UX and UI must ultimately work together to ensure both functionality and enjoyment. A classic example of good UX is the evolution of ketchup bottles. Bottles with lids on the bottom make pouring effortless, unlike older designs that require shaking and sometimes banging, an inefficient and obviously frustrating experience. Similarly, modern phones with touchscreens and contact lists have replaced slow, error-prone rotary phones, revolutionizing efficiency and user satisfaction. Poor UX is effortful, like a confusing website menu. Users can't find what they need, quickly leading to friction and frustration. Poor UX reliably leads to user dissatisfaction, which can directly harm business outcomes. Think of a fitness app, any app really, with a complicated sign-up process. Users must first input personal details, then verify their email, select preferences, and finally agree to multiple terms and conditions. Frustrated by such a lengthy process, many abandon the sign-up midway. Over time, the app experiences a decline in new sign-ups, limiting customer growth and hurting the bottom line. While the app's core functionality might be strong, the sign-up friction drives users away before they even experience it. The takeaway? Remove friction and simplify. Every extra step, confusing layout, or unnecessary action in the user journey reduces engagement and drives customers to competitors. To succeed, businesses must prioritize seamless, intuitive user experiences by eliminating friction at every touchpoint. For developers, this means writing clean, efficient code, optimizing performance, and ensuring accessibility to create applications that feel effortless for end users. Naturally then, good UX can significantly boost a business's performance. When users find an app intuitive and easy to use, they engage with it more, return frequently, and recommend it to others. Apps like Google and Instagram demonstrate how streamlined experiences lead to higher retention rates, increased customer satisfaction, and word-of-mouth referrals that grow the business. And good UX doesn't happen by chance. It's the result of intentional design decisions and iterations. Here are some best practices to help you create applications with excellent user experiences. Make every task as easy as possible by avoiding unnecessary steps and keeping processes intuitive. Features like one-click signups or single-page checkouts can dramatically improve usability. 2. Research your audience. User testing helps identify pain points, preferences, and habits, ensuring your design is both useful and easy to navigate. 3. Optimize your application for all devices, smartphones, tablets, and desktops. A seamless experience across screen sizes is essential in today's multi-device world. Remember to use well-structured menus and clearly labeled buttons to help users find what they need quickly and easily. Confusing layouts will frustrate and alienate users. And as a 5th best practice, provide confirmation for user actions like form submissions or purchases. Make support options easy to access to minimize friction and user fallouts. In this video, you learned why good UX is critical for creating intuitive, user-friendly applications. Just as placing the lid at the bottom of a ketchup bottle improves usability, good UX design ensures smoother, faster, and more enjoyable interactions with an app. Poor UX, like a confusing sign-up process or unclear navigation, can frustrate users and hurt a business's bottom line. By focusing on user needs, developers can create applications that not only meet business goals, but also provide real value. Whether it's a small tweak or a complete overhaul, improving UX is key to building apps that are both effective and well-loved. Congratulations on completing Module 1 of the Application Development course. This module laid the foundation for effective software development by focusing on critical planning and design skills that underpin successful projects. You learned how to document requirements effectively, use UML diagrams and design patterns to build strong systems, and create intuitive user interfaces that prioritize accessibility and usability. These essential skills not only prepare you for the challenges of real-world projects, but also set the stage for building professional, high-quality applications. You began your learning journey into application development with requirement analysis and specification, the process of defining and documenting stakeholder needs to ensure alignment with project goals. You explored how functional requirements outline a system's features, such as performance and interoperability, while non-functional requirements focus on quality attributes like accessibility and usability. This knowledge is essential for shaping system capabilities, meeting standards, and leveraging clear documentation to minimize risks and achieve successful outcomes. Next, you focused on user stories, a practical framework for organizing and communicating project requirements. Guided by the INVEST attributes, independent, negotiable, valuable, estimable, small, and testable, user stories ensure clarity and manageability for both developers and stakeholders. By creating and analyzing user stories, you honed your ability to break down complex tasks into actionable steps. Additionally, you identified how broader epics, such as developing a user authentication system, represent complex requirements that are broken down into multiple user stories, like implementing registration or password reset functionality. This approach equipped you with practical tools to manage complex requirements, prioritize tasks, and ensure steady progress throughout the development workflow. Shifting to system design and architecture, you develop strategies for creating applications that are both maintainable and scalable. You were introduced to key software design patterns, including singleton, observer, strategy, builder, adapter, and proxy, which provide proven solutions to common coding challenges. Specifically, you learned how enum, a Java class used to create enumeration types, simplifies singleton patterns by ensuring a single shared instance across an application. Implementing these patterns demonstrated their practical benefits, from enhancing code clarity to reducing development time. You also worked with Unified Modeling Language Diagrams, a powerful tool for visually representing system components and their relationships. By practicing with UML, you transform abstract concepts into clear designs, essential for building scalable applications, enhancing collaboration, and reducing development misunderstandings. The final part of the module focused on user interface or UI design, a critical element in delivering an exceptional user experience. You studied 7 principles of effective UI design, in sum, clarity for easily understood information, discriminability to highlight differences between elements, conciseness for focusing on essentials, consistency to maintain a unified experience, detectability for making key features visible, legibility to ensure text is readable, and comprehensibility for quickly grasping functionality. These principles, combined with thoughtful UX design, have a direct impact on user satisfaction and business success. Building on this UI foundation, lessons on color theory and accessibility emphasize the importance of creating inclusive, visually engaging designs that accommodate diverse user needs. To bring these concepts to life, you used wireframing to plan and organize the layout and flow of a user interface. Then, with mockups, you translated these ideas into detailed prototypes, refining them step by step to achieve a balance between aesthetics and functionality. Thorough preparation is key to success in software development, and this module was designed to equip you with the tools to plan and design projects that users love. The skills you've gained, analyzing requirements, designing systems, and creating user-centered interfaces, are highly valued in today's job market and critical for your career growth. With these abilities, you're ready to tackle more complex challenges, whether working collaboratively or independently. Remember, effective planning and design are the cornerstones of every successful development process. Congratulations again on reaching this milestone, and best of luck as you continue your journey in application development. On your daily commute, you pass by an area where a house is being built. Over the months, you've observed with interest how the foundations, then the walls were created first. The roof and windows have now been added, and the company is working on the interior. The building company is obviously following architectural drawings and a building schedule to create a finished house. In the same way, the software development lifecycle, or Sdlc, is the plan or blueprint for turning your ideas into polished, ready-to-use applications. Within an organization, Sdlc is a development process that guides the creation of software applications. This process has 7 stages: planning, requirements gathering and analysis, design, development, testing, deployment, and maintenance. Let's examine each of these stages in detail, beginning with planning. The house build that you were following began with foundations. Everything else was built on them. In the same way, planning is the foundation of successful software development, and all other development stages build on this. It involves project scope definition, resource allocation, and risk assessment. In the planning stage, it is important to gather as much information as you can about the customer's requirements using methods such as customer feedback or market research. The more you know about the customer's wants and needs, the better the final product will be. This information will ultimately inform the creation of the main project outline. The next step is to create an analysis of this information. In the analysis stage, customers, market experts, and other key people clearly list and approve the software's needs. All stakeholders are involved in creating a document called a Software Requirement Specification, or SRS, as it is a collaborative effort. The SRS outlines everything that must be defined, designed, developed, and created during the entire project cycle. The SRS document ensures everyone agrees on what the software should do and helps the project meet those goals. The SRS document provides a guide for the next stage, software design. Using the SRS, designers develop different design options, which are recorded in a Design Document Specification, or DDS. Market experts and stakeholders then review this DDS. They must consider various parameters such as risk assessment, product robustness, design modularity, budget, and time constraints. The outcome of this should be the development of the most suitable and logical design. The internal design of all the modules of the proposed architecture should be defined with minute details in the DDS. The design will include the module's communication and data flow with external and third-party modules. The actual development now begins, and the product is built based on the design document specification. A clear and organized DDS leads to a smooth coding process. Developers use programming tools like compilers, interpreters, and debuggers, and of course, must follow their organization's coding guidelines. Depending on the type of software being developed, various high-level languages are used, for example, C++, Java, Python, or others. But the important question is always, does it work, and does it work as expected? And that is why testing is so important. Testing is a continuous and comprehensive process integrated throughout the software development lifecycle. This is to ensure that the product meets the quality standards outlined in the design document specification, the DDS, where the development journey began. A common approach to testing is System Integration Testing, or SIT. In this testing phase, individual modules or components of a software application are integrated and tested as a group. The goal is to verify that the combined modules work together, ensuring that data flows correctly and that interfaces between modules function properly. It is important to document the steps taken and the results achieved at this stage. As each successive module is tested, an information repository is created. This will be vital for future maintenance, development, and user information. Now that the application is successfully created, it is time to deploy it. This can happen in different ways, depending on the organization's business strategy. For example, it may be issued first to a limited audience to test the user's response. This is user acceptance testing, or UAT. Or it may be deployed fully in the appropriate market. Once the software has been released to end users, the maintenance phase begins. Ongoing monitoring of the software is essential to ensure that it continues to work efficiently and effectively. The software may require regular updates to meet changing requirements or security needs. Improvements may have to be made to guarantee long-term functionality and usability. This video has introduced the software development lifecycle and explored its 7 stages in detail. It has also demonstrated the benefits of this approach. Following the SDLC provides a clear plan so that everyone knows their roles and duties. It provides a cost-effective approach. Efficient planning and testing saves time and money and prevents or identifies mistakes. Sdlc helps organizations deliver robust software solutions that satisfy user needs and adapt to changing requirements. Following its stages ensures that the software is reliable, safe, and easy to use. It also provides a roadmap for improving development efficiency and reducing potential risks. The SDLC process helps you to identify problems early, avoiding significant issues. Because all stages of SDLS, but particularly the planning and analysis stages, focus on the user, it will help to improve customer satisfaction. By continuously improving and evolving based on feedback, the SDLC approach contributes to the long-term success of software projects. It is not just a series of steps, but a cycle of improvement that ensures software can adapt and remain valuable over time. The building company followed architectural plans and a project schedule to complete the house you passed on your commute. In the same way, by following the software development lifecycle, organizations can deliver high-quality software that meets user requirements, is cost-effective, and is easy to maintain. You've employed a construction company to build a house, but they began work without discussing it with you. They don't seem to have any blueprints, schedules, or project plans. Naturally, you're nervous about this disorganized approach. You don't know if building tasks will be done in the correct order. You're worried that the construction time might overrun, costing more money. You're not even sure what the finished house will be like. In the same way, software design can't be approached haphazardly. A software development lifecycle model prevents this. It outlines the entire development process, from planning to deployment, and ensures the finished software meets requirements and is on time. There are different SDLC models to choose from, including waterfall, iterative, V-model, incremental, rapid application development or RAD, spiral, prototype, and agile. A bewildering choice at first. However, factors such as risk management, project complexity, flexibility, and customer involvement will influence your decision to use a particular model. With that in mind, let's explore the purpose of each model and the type of situation where you should use each one. As you know, waterfalls flow from top to bottom. In the waterfall model, the phases of development have a similar one-directional flow. The waterfall model is a simple step-by-step process. Each phase, such as planning, design, coding, and testing, is completed before moving to the next. This is a straightforward model with clear deliverables and clear management. It is suitable for projects with precise and fixed requirements, where changes are minimal, such as software for highly regulated industries such as banking. However, it is inflexible and would not suit projects that are complex or constantly evolving. Sometimes the development process is more cyclical, as developers respond to feedback, fix bugs, or adapt to changing requirements. This is an iterative model. For example, when developing an e-commerce platform, core shopping features are implemented first, and additional features are added over time. Each iteration produces a new version, and the process repeats until the final product is complete. The iterative model works best when major requirements are fixed, but some features may evolve. It's adaptable, involves continuous feedback, and offers rapid bug fixes. However, it can be costly in terms of resources, costs, and timelines. The V model, also known as the verification and validation model, is used in areas where rigorous testing is essential. For example, in the development of medical device software, where safety and reliability are so critical. In this model, each phase of development is sequential, starting only after the previous one finishes. A testing phase is linked to each development phase. The coding phase connects both sides, ensuring tightly integrated verification and validation. While this model enables early defect detection and systematic development, it struggles with complex projects and changing requirements. Sometimes software needs to be developed in small, manageable increments using the incremental model. A social media app might first launch with basic posting and profile features, then incrementally add messaging, story features, and advanced sharing options. Initial requirements are gathered, a module is developed, delivered, and refined through feedback, and more modules are added incrementally. The benefits associated with this model are early working software delivery, measurable progress, and easier testing. However, it requires thorough planning, continuous management, and clear initial requirements. Smaller and internal business applications, such as employee management systems, will often use a rapid application development or RAD model. With RAD, projects are broken into smaller, manageable parts and completed sequentially. Requirements are gathered up front, and code, tools, and processes can be reused in each module. This model reduces development time and allows easy modifications, but isn't suitable for complex long-term projects. However, the spiral model is suitable for complex long-term projects such as military and government software or air traffic control systems. Each loop represents a phase of the software development process. The number of loops depends on project size and changing requirements. Each phase includes risk analysis and prototyping, making risk management a key feature. This model provides the benefits of flexibility for changes, early preview, and continuous risk assessment. However, it can also be over-complex, costly, and relies on risk assessment expertise. If software requirements are unclear and early user interaction and feedback are key, then the prototype model is used. An initial prototype is created as a foundation for the final product. For example, a new gesture-based interface for smart home controls. While this approach is effective for requirement clarification, there is a risk of prototype shortcuts being carried into the final product. Also, multiple iterations can be costly. A financial technology company developing a new digital wallet might use the Agile model because requirements will evolve rapidly and close customer collaboration is possible. The Agile model is an iterative process with continuous customer collaboration. Projects are broken into short cycles called sprints. Each sprint delivers working software, incorporating customer feedback and adapting to changing requirements. The model emphasizes individuals and interactions over processes and tools, working software over comprehensive documentation, and responding to change over following a rigid plan. Common frameworks like Scrum, Extreme Programming or XP, and Dynamic Systems Development Method or DSDM provide specific implementations of Agile principles. However, the Agile model requires experienced developers and consistent customer involvement. It can also struggle with initial time estimates. Its success heavily depends on team cohesion and effective communication channels. This video has introduced you to the most common software development lifecycle models. You are now familiar with each model's use case and purpose and with the types of situations and projects for which they are suitable. As you become involved in real-world projects, you can be confident that you will choose the correct development model. You're hosting a large family dinner. You planned the menu, bought lots of ingredients, and cooked all day. But when everyone sits down to eat, there are a lot of complaints. Some family members request different dishes. Another person is allergic to an ingredient in the main dish. You wish you'd worked on the menu and the meal preparation in smaller steps, checking in with the family at each stage and adjusting ingredients based on their needs and preferences. That's the essence of Agile. It's a flexible, feedback-driven approach to getting things done. The Agile software development methodology focuses on flexibility and adapting to change, collaboration, and customer satisfaction. It aims to deliver small parts of the product quickly and often. The Agile methodology is based on the Agile Manifesto, which outlines 4 core values and 12 principles. The Agile Manifesto was written in February 2001 during a meeting with 17 experienced software developers at a ski resort in Snowbird, Utah, USA. These software developers are now known as the Agile Alliance. They came from different professional backgrounds, including software development, project management, and consulting. The goal of their meeting was to discuss alternatives to traditional, overly structured development practices. Despite their differing approaches, they found common ground in their belief that software development should be prioritized, with collaboration, adaptability, and delivering real value to customers. Their discussions led to the Agile Manifesto and its 12 supporting principles, which continue to influence how software is built worldwide. Let's examine the core values first. The first core value of Agile is that individuals and interactions should be prioritized over processes and tools. The next core value is that creating working software should take priority over generating comprehensive documentation. The third core value of Agile is that software developers should focus on customer collaboration over contract negotiation. The final core value is that it is more important to respond flexibly to change rather than rigidly following a plan. By following these values, a software development team can work closely with the customer, eliminate bottlenecks, and ensure that the product meets the customer's needs. Let's break this down into more detailed working principles. The first principle relates to customer satisfaction. You've already learned that working closely with customers is a key core value of Agile. By following Agile principles, you can ensure customer satisfaction through early and continuous delivery of valuable software. As a software development project progresses, it is not unusual for the customer requirements to change. As an Agile proponent, you should embrace changing requirements, even if they occur late in the development process. Another guiding principle of Agile is frequent delivery. If the customer didn't receive the finished product until the end of the project, you would not have the opportunity to continuously adapt it to their feedback. With that in mind, it is important to deliver working software at frequent intervals. Depending on the type of software being developed, this interval could be measured in weeks or months. The key element is frequency. Working closely with and collaborating with the customer is a key element of the Agile approach. For this reason, close collaboration between developers and business stakeholders is vital. But saying that collaboration is needed is not the whole story. The nature of that collaboration and who it is with is also important in the Agile approach. So, as a working principle, build projects around motivated individuals. These are people that you can trust to get the job done. Remember to encourage face-to-face communication where possible. This is not only an efficient and effective method of conveying information, but it also encourages team collaboration. Agile focuses on delivering small parts of the product quickly and frequently, maintaining a consistent work pace to ensure the team remains productive long-term. This also allows teams to measure progress by delivering functional software, not by following documentation. The cycle of frequent delivery and regular feedback allows for other important principles to come into effect. Next, principle number 9 allows the development process to focus on and give maximum attention to technical excellence and good design. By keeping the approach simple and avoiding unnecessary tasks, principle number 10 helps to enhance the agile process. Earlier, you were advised to work with people who you believed could get the job done correctly and work independently. Teams comprised of these types of trusted individuals often produce the best architectures, requirements, and designs. Another important phase of the agile process is regular reflection. By considering how you and the software can become more effective, you can enable continuous improvements. If you are following the Agile methodology when developing software, you may encounter some issues. Because of its more fluid approach, it might be difficult to estimate effort for large projects early in the development process. There may also be a lack of predictability in outcomes, timelines, and budgets. The Agile method's less formal and more loosely structured approach could result in inconsistent processes and oversight issues. And, because it focuses on code, this approach may result in inadequate documentation. The cycle of frequent delivery and regular feedback could cause testing to be overlooked, risking undetected bugs. In addition, junior programmers may struggle with the high decision-making demands. Because Agile relies heavily on customer input, this might lead to unclear visions, which can derail the project. While Agile recommends face-to-face communication, this may not be possible, or it may be challenging in large organizations. However, the Agile method also has several very clear advantages. It promotes faster software deployment and quickly adapts to changing requirements. Immediate feedback improves future increments, which builds customer trust. It is flexible and adaptable to changing priorities or market conditions. The Agile approach promotes technical excellence and good design. It ensures high-quality, reliable software through testing and continuous improvement. Its primary benefit is that it is people-focused. The Agile process enhances collaboration among teams, stakeholders, and customers for better alignment. Agile prioritizes customer satisfaction by delivering value and meeting expectations. It also boosts team morale, motivation, and productivity in a positive work environment. This video has introduced you to the core values of the Agile methodology. You've explored the 12 important principles of Agile and examined its benefits and some of its disadvantages. Agile is a powerful way to approach software development or project management. It can help you to adapt, improve, and succeed in a rapidly changing environment. Consider an image of a rugby scrum. Players huddle together, with each side working as a team to try to move the ball toward their opponent's goal. This name has been given to the Agile framework Scrum because it also emphasizes teamwork and quick adaptation. When applied to product development, the Scrum framework facilitates flexibility, transparency, and continuous improvement. In this video, you'll learn about the Scrum framework, why it's an essential part of Agile development, and how its key elements work together to make teams more effective. Scrum is an Agile framework designed to help teams collaborate and deliver small, achievable goals in short timeframes. Instead of focusing on the entire project all at once, Scrum breaks work into manageable chunks called sprints. The sprint operates on a few core principles. First, it focuses on time-boxed goals. Tasks are limited to a fixed period, and the emphasis is on completing just what was planned for that time. Next is the principle of collaboration. Every team member contributes to the sprint's goals, just like those players on the rugby field passing the ball forward. The final core principle is inspection and adaptation. At the end of every sprint, the team reflects on what went well, what didn't, and how to improve next time. Now let's dig a little deeper and examine the key components of the Scrum framework: Scrum events, roles in Scrum, and Scrum artifacts. There are 5 sprint events that create structure and rhythm in Scrum. The first is the sprint itself. A sprint is a fixed time frame that lasts a minimum of 1 week and a maximum of 4 weeks. During the sprint, the team focuses on achieving a specific goal. The next event is a planning meeting, which happens at the beginning of each sprint. In the meeting, decisions are made on what can be delivered in the sprint and how the work will be achieved. The result should be a clear sprint goal, which is a concise statement of what the sprint aims to provide. Once the sprint goal is set, the process moves on to the work to be carried out. During the sprint, the team focuses entirely on completing the chosen tasks. Daily stand-up meetings help to keep everyone aligned, and any roadblocks can be addressed. The next event is a sprint review. The sprint review includes demonstrating the sprint's work to stakeholders to confirm that it meets their expectations. The feedback received is then noted. The fifth and final event is a sprint retrospective. The sprint retrospective is a session where the team can reflect on the sprint and identify areas of improvement. The repeating sprint cycles of planning, working, reviewing, and reflecting ensure continuous improvement. But who drives this process? There are 3 defined roles in Scrum. The first role is the Scrum Master. The person occupying this role serves as a facilitator to the larger team and removes any roadblocks. They also ensure that the Scrum Framework is followed. The Product Owner is the next key role. The Product Owner represents the stakeholders. The person in this role organizes the work in the sprint. They prioritize the backlog and ensure that the team works on the most valuable tasks. The final role is that of the development team. This is a cross-functional group responsible for delivering a potentially shippable product increment at the end of each sprint. Scrum artifacts are created during the sprint processes. Their benefit is that they provide transparency. They may also highlight opportunities for inspection and adaptation. First is the product backlog. This is an evolving list of tasks or features prioritized by the product owner. Then there is a sprint backlog. This is a subset of the product backlog selected for the current sprint. Finally, the increment artifact is the sum of all completed backlog items during a sprint. It represents the latest version of the product. Tracking progress is key to the success of any project. To do this, Scrum uses a metric called team velocity. Team velocity measures how much work the team completes in a sprint. It's typically calculated in story points. These are units of effort assigned to tasks. Over time, this helps teams predict how much work they can realistically tackle in future sprints. For example, if a team consistently completes 30 story points per sprint, it can more accurately plan future work based on this capacity. The Scrum Framework provides several benefits. The first is speed. The team can quickly deliver functional product increments because the work is done in short bursts in a sprint. The Scrum approach is also more flexible and adaptable. Because of the iterative nature of the sprints, development teams can adapt to changes more efficiently. The Scrum approach also increases collaboration within the project team. Continuous communication, required in successive sprints, fosters teamwork and alignment with the sprint goals. Scrum can also contribute to the delivery of a high-quality product. Frequent testing and feedback ensure that the product meets user expectations. Finally, one of Scrum's most important benefits is that it is entirely customer-focused. The iterative nature of sprints, with customer feedback being sought in each one, involves stakeholders at every stage. This helps to ensure that the product aligns with the customer's needs. In this video, you learned how Scrum breaks large goals into smaller achievable steps. You also learned about the key components of the Scrum framework and the benefits in using it. As you incorporate Scrum into your working life, keep in mind these best practices. Provide training in Scrum to team members, set clear goals, encourage open communication, use agile tools, and focus on continuous improvement. In this way, you can harness the power of Scrum, which will help you move the project forward one sprint at a time. A piece of self-assembly furniture you ordered has arrived. You're nervous opening the box because you expect lots of parts and hours of your time to put it together. To your delight, the manufacturer has provided a few easy-to-handle components that click together smoothly without tools. What if creating software could be just as quick, efficient, and collaborative? That is exactly what the Rapid Application Development Methodology, also known as RAD, offers. In this video, you'll explore what RAD is. You'll learn that it uses prototypes, user feedback, and adaptability to revolutionize how businesses and developers approach building software. The RAD methodology focuses on speed and flexibility. It follows a circular process of quick iterations, user feedback, and continuous refinement of the product. This is unlike the rigid step-by-step process used in traditional models. With RAD, developers quickly create prototypes, which are working models of the application, and refine them based on user input. The philosophy behind RAD is simple. Build fast, get user feedback early, and adapt quickly. Typically, RAD follows 4 key stages: planning and requirement gathering, prototyping, user feedback and iteration, and finalization. In the first stage, planning and requirement gathering, stakeholders discuss and agree on the project goals. They also outline the user needs and the technical requirements. In the second stage, developers create quick, functional prototypes. The aim at this stage is to demonstrate features to stakeholders and obtain feedback. Users test the prototype and provide feedback on how it functions. They can also suggest changes. Developers use this feedback to improve the application. They implement the suggestions and submit the amended prototype for further testing. The last stage of development is finalization. The application should now meet all user needs, so it undergoes final testing and deployment. RAD offers many benefits, especially for teams looking to deliver results quickly without compromising on quality. Let's explore the benefits of RAD and discover why so many organizations love it. The first and most obvious advantage of RAD is how quickly applications can be developed. By using prototypes and focusing on iterative improvement, the development team can bypass the lengthy planning associated with traditional methods. The RAD approach to product development encourages better user involvement. In fact, RAD places the user right at the heart of the development process. Their frequent feedback ensures the application meets their real-world needs. This helps to reduce the risk of developers building something users don't want or need. Another key benefit of the RAD methodology is flexibility. Because RAD focuses on continuous iteration, it's easier to make changes at any stage of development. This flexibility is particularly useful for projects where requirements evolve. Costs are always an important factor in project development, and the RAD methodology is cost efficient. Because issues are caught early and RAD focuses only on features users need, it can help save money. Avoiding unnecessary features or rework means resources are used more effectively. Finally, RAD can help to produce a high-quality product. This is achieved by the frequent testing and feedback loops, which are central to the RAD approach. Developers can quickly address bugs or design flaws before they escalate. Of course, no methodology is perfect, and RAD is no exception. It is important to understand its challenges and limitations before you decide that it is appropriate for a project. One of RAD's benefits, its focus on user involvement, could also be a challenge in certain situations. RAD relies heavily on regular input from end users, which may not always be possible. Users can be unavailable or disengaged, or they may not fully understand the process. The RAD model is designed around the quick building and adjustment of prototypes. Because of this, developers working on a project that uses the RAD methodology need to be experienced and adaptable. They also need to have technical skills and creativity. Because RAD uses an iterative process focused on quick development and rapid feedback, it works best for smaller, well-defined applications. It may not be the best choice if a project has rigid requirements, complex integrations, or long-term goals. The RAD iterations of prototype development, testing, and adaptation focus on speed and can often not be fully documented. This may cause issues in the future for maintenance or further development. These iterations also require dedicated resources, including time, skilled developers, and engaged users. For smaller teams with limited resources, this can be a bottleneck. RAD isn't a one-size-fits-all approach, so what projects would it work well for? RAD's emphasis on speed means that it works well for projects with short timelines. The iterative process also works well for projects where users' needs are clear but might evolve. Managing the quick iterations and user feedback essential to RAD is easier on small, focused projects. Because it centers around creating prototypes, it can also be ideal for projects that require proof of concept before further development. The continuous user feedback in the RAD process means that it works well in the development of customer-facing applications. Finally, because RAD can pivot easily based on what works, it is ideal for innovative or experimental projects. But RAD's iterative approach isn't suitable for high-risk, error-intolerant projects, such as developing aircraft or medical software. It would also not be suitable for projects with rigid requirements, such as government systems. This video has introduced you to how the RAD methodology works and to its benefits and challenges. You've also learned the type of projects it is suitable for. Knowing RAD's strengths, challenges, and ideal use cases can help you decide whether it's the right approach for your next project. This ability and the other knowledge you've gained on RAD is another strong addition to your developer skill set. A large manufacturing plant contains two distinct sections. The workers in one area design the product, while those in the other section package and ship it. If these two groups don't collaborate, the process slows down, errors creep in, and the customers are left waiting. DevOps is the software world's solution to this problem. It is a seamless way to connect development and operations for faster, high-quality delivery. This video explains the DevOps methodology, outlines its core practices, and explores its benefits. In the factory example, the collaboration between the design and shipping teams would become seamless if they shared tools, followed common practices, and automated routine tasks. In the software development lifecycle, DevOps can perform similar functions. It eliminates bottlenecks between developers and IT teams so that features reach customers more quickly and with fewer issues. It emphasizes collaboration and communication between developers, IT operations, quality assurance teams, and other stakeholders. The DevOps approach seeks to build a culture of shared responsibility. Its focus is on reducing the time between developing the code and delivering an end result and value to the customer. As a result, at its core, DevOps forms a bridge between two key areas. These are development, where code is written and features are built, and operations, where code is deployed, monitored, and maintained. To achieve this, DevOps relies on several key practices. Let's examine them in more detail. The first principle is continuous integration. Developers add code to a shared code repository. This happens frequently, sometimes several times a day. Whenever new code is added to the repository, automated tests run to ensure that it doesn't cause anything to break. Continuous delivery is another key principle of DevOps. Code that passes testing is automatically deployed into production or staging environments. This reinforces the concept of continuous delivery. The goal is to always have deployable code, even during active development. As you have realized, automation is a key feature of DevOps. In the DevOps methodology, routine tasks like building code, running tests, and deploying applications are automated. This automation saves time, reduces errors, and ensures consistency. Monitoring applications and logging information is another key principle of DevOps. In the DevOps methodology, development teams monitor applications constantly in real time. This allows them to measure performance and quickly identify issues. As a result, monitoring logs are created, which provide detailed insights into what is happening in the system. These logs help the teams to quickly identify and address any problems. One of the keys to success for the manufacturing plant already mentioned was communication. Collaboration and communication are also important principles in DevOps. It is important that developers and other IT professionals communicate effectively. This will help to ensure that they work together efficiently during planning, testing, and deployment. There are a variety of communication tools that the team can use. Examples are Slack or Jira. If these tools are used correctly, they can foster and increase communication between teams. This helps them to monitor progress and to establish and track shared goals. Another key principle in DevOps is infrastructure as code. Rather than manually setting up servers and networks, DevOps teams define infrastructure in code. Because of this, it is possible to reproduce environments. It is also easier to manage them. Naturally, security is also an important facet of DevOps. Security is integrated early in the lifecycle. This ensures that any vulnerabilities detected are addressed before deployment. If you work with or research DevOps, you may come across the phrase DevOps toolchain. This is a collection of specialized software tools. These tools support the principles outlined in this video and enable teams to implement them. Git can be used for version control. Teams can use Jenkins or GitHub Actions for automation. For running applications in lightweight and isolated environments, they can use Docker and Kubernetes. For monitoring, Prometheus or Grafana can be used. Now that you understand more about DevOps and how it is implemented, let's examine its benefits as a methodology. The continuous development approach of DevOps ensures that there is faster delivery of software and updates. It also minimizes manual intervention and reduces deployment risks. Continuous integration helps to produce higher quality products that have fewer errors in production. The constant monitoring that is an integral part of this methodology helps detect anomalies, reduce downtime, and improve user experience. And finally, infrastructure as code reduces configuration drift, enhances consistency, and enables version control for infrastructure. Overall, DevOps is a methodology that increases team collaboration and morale. Customer satisfaction should also be higher because of rapid, reliable releases. This video introduced you to the core concepts behind DevOps and explained the different stages and tools involved. You now know that DevOps excels at reducing the time between the development lifecycle and the delivery of customer value. An important thought to take forward with you in your professional career. Congratulations on completing Module 2 of the Application Development course. This module introduced you to the essential methodologies that drive modern software development, preparing you to navigate projects with efficiency and confidence. By understanding the stages of the software development lifecycle, or SDLC, and exploring different approaches such as Agile and DevOps, you gained the ability to choose the right framework for any project. Whether it's prioritizing flexibility through Agile frameworks like Scrum, or achieving seamless collaboration with DevOps practices, you now have the tools to deliver quality software that meets user needs and business goals. Let's use this time to reflect on some of the key topics and takeaways from the module, which started with an introduction to the software development lifecycle. Recall that SDLC is a structured framework consisting of 7 stages: planning, analysis, design, development, testing, deployment, and maintenance. These stages provide a roadmap that keeps projects aligned with their objectives. You became comfortable not only with these stages in the SDLC, but also with the nature and importance of key documents, the software requirement specification, and the design document specification. This understanding of the software lifecycle provides a foundation for applying methodologies that enhance collaboration and deliver solutions. For example, in e-commerce, following SDLC stages ensures seamless planning of features like shopping carts and secure payment systems, effectively addressing challenges and meeting user needs. Next, you studied specific SDLC models, including Waterfall, V-Model, Spiral, and Agile, each tailored to specific project needs. The Waterfall model is ideal for straightforward projects with clear, fixed requirements, such as developing a static company website. The V-Model, emphasizing rigorous testing at each stage, is often applied in safety-critical projects like medical software. For complex projects requiring risk assessment and iterative refinement, the Spiral model offers flexibility, making it a preferred choice for experimental systems or new product development. Finally, the Agile model, known for its adaptability and collaboration, excels in dynamic environments like creating a mobile app with rapidly changing user needs. Through practical activities, you honed your ability to evaluate project scenarios and confidently select the model best suited to ensure success. In particular, Agile Methodology stood out as a dynamic framework that emphasizes flexibility, collaboration, and meeting customer needs. Built on principles of continuous improvement and responsiveness, Agile is well suited to projects with shifting requirements. You examined popular frameworks such as Scrum, which structures work into focused sprints, Kanban for visualizing workflows for ongoing delivery, and Extreme Programming, which prioritize disciplined engineering practices and delivering customer value. Additionally, feature-driven development focuses on stakeholder-driven priorities, while the dynamic systems development method offers a structured yet flexible approach to iterative development. These frameworks equip you to adapt agile approaches to diverse team structures and project needs, ensuring efficient and effective development processes. Given its effectiveness in managing complex projects through iterative progress, the Scrum Framework was a key focus. Inspired by a team playing rugby, Scrum emphasizes collaboration with defined team roles, structured sprint planning, and retrospectives that drive continuous improvement. Sprints in this context are time-boxed work periods, typically lasting 1 to 4 weeks, ensuring manageable goals and adaptability to changing requirements. And by using so-called velocity metrics to measure work completed during sprints, you gained a practical foundation for tracking progress, planning effectively, and ensuring project alignment. You also explored Rapid Application Development, or RAD, a flexible methodology that prioritizes quick iterations, adaptability, and user feedback over rigid planning. RAD is particularly effective for projects like ongoing software updates, addressing evolving user needs, or developing prototypes. RAD could be used to quickly prototype a new e-commerce feature, like a recommendation engine, allowing teams to gather user feedback and make adjustments before full-scale implementation. By identifying when RAD is most applicable, you are now better prepared to leverage this approach to deliver fast, iterative results in dynamic development environments. The module concluded with DevOps, a transformative methodology that bridges the gap between development and IT operations. By focusing on practices like automation, rigorous testing, and continuous monitoring, DevOps reduces bottlenecks and accelerates the delivery of customer value. This approach fosters collaboration across teams, ensuring seamless workflows and high-quality software delivery. Crucially, with DevOps, businesses can align technical execution with strategic goals, delivering reliable applications faster and more efficiently. To ensure your learning sticks, this module translated modern development methodologies into practical activities. By mapping Sdlc models to real-world scenarios, analyzing agile workflows, and applying RAD and DevOps principles, you gained confidence in tackling real-world challenges. These skills are essential for thriving in diverse environments and meeting industry demands, and now you have them in your toolkit. As you move forward, remember that flexibility, collaboration, and delivering value are key to success. Congratulations, and best of luck as you continue your journey in application development. Imagine you've just joined a new company as a developer, and you're excited to contribute. Your first task? Fix a bug in a core feature. You dive into the code but soon realize it's like reading a mystery novel with half the clues missing. The developer who wrote it left the company months ago, and there's almost no documentation. Every change you make seems to break something else. Frustrating, right? This common scenario highlights one of the biggest challenges in software development: maintainability. In this video, you'll explore the essential practices for software maintainability, learn why detailed software documentation is so important, and examine the benefits of Javadoc and JSDoc comments. Let's get started. Software doesn't stay static. Features are added, bugs are fixed, and performance is improved over time. Maintaining software means ensuring it can be understood, modified, and improved even by people who didn't initially write it. It's a critical part of a developer's job to build reliable software today and for the future. Many practices help make code easy to understand and modify, such as clear naming conventions, modular design, use of design patterns, regular code refactoring, and thorough testing. These practices make code more readable and adaptable. For this video, however, you'll focus on documentation comments as one of the simplest and most powerful ways to support maintainability. Good documentation means that even if you or another developer return to the code months or years later, the purpose, inputs, and expected outputs are all clear. Let's explore a fictional scenario to understand why documentation is so essential. Imagine a team developing an e-commerce app. Last year, a developer named Sam added the critical payment feature. Sam didn't leave any documentation or comments, trusting they'd be around to help if anyone had questions. But a few months ago, Sam left the company. The team wants to add a discount feature that interacts with the payment system. A new developer is tasked with implementing it, but can't figure out how Sam's code works. There are no comments, and Sam's logic is complex. After a few failed attempts, the new developer makes a change they think will work, but it accidentally breaks the checkout process. Not only is an outage costing the company revenue, but now the team must spend extra time undoing the change, understanding Sam's code, and re-implementing the fix, all because maintainability wasn't prioritized from the start. So, what could Sam have done differently? One powerful tool developers have to make code maintainable is documentation. Documentation comments make code easy to understand by describing its purpose, inputs, and outputs in a structured, readable way. A well-documented codebase helps ensure that knowledge stays with the code rather than walking out the door with any single developer. In Java, Javadoc comments are a special type of comment that allows you to document methods, classes, and variables in a standard format that's easy for others to read. Two essential tags in Javadoc comments are a param and an @return. @param describes each argument a method takes so other developers know what information they need to provide. @return explains what the method returns, clarifying the method's result. Let's explore java.comments in more detail using some example code. Suppose you have a method named calculateDiscountedPrice that calculates the final price after applying a discount. Here's how you document it using java.comments. Java comments begin with a slash and 2 asterisks, and end with a single asterisk and a slash. @param price describes the first argument, explaining it's the original price and a positive double value. @param discount rate indicates the discount rate, specifying that it's a positive double value representing a percentage. @return explains that the method returns the price after applying the discount. With comments like these, anyone reading the code will immediately understand the method's purpose, what parameters it requires, and what it returns. Different programming languages have their own style for documentation comments. In JavaScript, JS.comments are like those in Java.doc. Here's how the same method might look if written in JavaScript. Note that @param in JS.doc specifies the type of argument using a pair of curly braces, unlike the @return tag in java.comments, which specifies the function's return value. The @return comment describes the result of the function in a more general way. Documentation comments follow a similar pattern no matter what language you're using. They describe the function's purpose and parameters, making it easier for others to understand. In this video, you learned that maintaining software is about more than just documentation. It involves following clean code practices like clear naming, modularity, regular refactoring, and testing. However, documentation comments, especially in languages like Java with Javadoc, are one of the most potent ways to make code accessible and understandable for anyone working with it in the future. Think of documentation as the difference between walking into a well-organized library and entering a cluttered room with unlabeled boxes. With clear comments, you're helping to organize your code, making it easy for future developers or even your future self to find and understand what's needed. Imagine a well-organized kitchen where everything has its place, labeled spices, neatly stored ingredients, and utensils in drawers. Now contrast that with a chaotic kitchen, filled with random ingredients and unlabeled jars. Which would you prefer to cook in? Clean code resembles an organized kitchen. It's easy to navigate and understand, whether you wrote it or someone else did. A good kitchen setup fosters efficient cooking, and clean code enables efficient coding. In this video, you'll examine key practices for creating clear, maintainable, user-friendly code. Let's get started. Clean code isn't just about functionality, but also clarity, ease of debugging, and scalability. Here are the essential practices to keep your code organized and accessible. Imagine labeling your spice jars with single letters, S for salt and P for pepper. While you might remember what they mean, it wouldn't help anyone else in your kitchen. Similarly, in coding, names should be specific and descriptive to convey their meaning. For example, this method calculates the discounted price for an order, but the variable names TP, D, DP, and the method name are ambiguous and unclear. Renaming variables to total price, discount rate, and discounted price, and changing the method name to calculate discounted price enhances readability. This enables new developers to grasp their meanings quickly, facilitating easier collaboration. Have you ever found a random ingredient in the pantry and wondered, what is this for? That's like encountering magic numbers in code, numbers that appear without explanation. Clean code uses constants with clear names instead. For example, the calculate final price method uses a magic number, making its representation unclear. Using a named constant, discount_rate, instead of 0.10 enhances clarity and reduces guesswork. If the rate changes, you only need to update it once, minimizing accidental errors. Sometimes you might stop to find a missing ingredient in a kitchen before continuing to cook. Similarly, in coding, a fail-fast approach involves checking for issues at the start of a method to handle errors immediately and prevent surprises later. Imagine a method that processes an order without input validation, which can cause errors with invalid values like negative or zero price or quantity. To apply the fail-fast principle, check for invalid inputs at the start and throw an exception if found. This saves time and prevents unpredictable issues. The code continues only with valid inputs, ensuring robustness, while clear error messages aid in diagnosing input problems. Making a sandwich while making coffee, peeling fruit, and washing dishes feels chaotic. Similarly, it's inefficient when a method tries to do too much at once. Clean code breaks complex tasks into smaller, focused methods, each handling one responsibility. The prepare order method calculates the discounted price and total with tax and formats the total as a string with 2 decimal places before returning it. That's quite a lot of work. Dividing the method into smaller, focused methods enhances code clarity and promotes reusability. Smaller methods can be tested individually to pinpoint errors. The apply discount, apply tax, and format price methods can now be reused in other parts of the code, such as the refactored prepare order method. A clean kitchen designates areas for prepping, cooking, and washing. Similarly, in code, the Single Responsibility Principle, or SRP, states that each class, method, or module should handle one task. Suppose you're building an e-commerce system with 3 distinct tasks: processing an order, calculating a discount, and sending a confirmation email. Implementing everything in a single order processor class leads to tight coupling. This can cause issues such as email logic changes breaking order processing, difficulty reusing discount logic, and challenges in independently testing code parts. Separating tasks into distinct classes promotes modularity, ensuring that changes in one area, like email logic, don't impact others, such as order processing or discount calculations. The discount calculator can be reused anywhere discounts are needed, enhancing its versatility. Additionally, testing email service independently from order processor simplifies debugging. Writing down the steps for making coffee from scratch every time will be tiring and wasteful. The don't repeat yourself or dry principle prevents repetition in code by making methods reusable, enabling you to write the logic only once. For example, the discount logic in these 2 methods is repetitive. Refactoring to a single apply discount method centralizes the discount logic, eliminating duplicity and enhancing adaptability for different discount types. It simplifies maintenance by allowing changes in one place, saving time and reducing errors. In this video, you'll learn that clean code practices make your code readable, organized, and easy to maintain. By following principles like meaningful naming, avoiding magic numbers, fail fast, SRP, and dry, you're setting up your code for success in the long term. Clean code today means fewer bugs and less time fixing issues tomorrow. Imagine this. You're part of a development team working on a high-profile e-commerce platform. A critical bug is reported. Customers can't add items to their shopping carts. The pressure is on to resolve the issue quickly, but the problem isn't immediately obvious. Is it the cart logic, the product API, or perhaps something in the database? This kind of scenario introduces common challenges developers face when investigating issues. Bugs or unexpected behaviors can cause slow performance, unhappy users, or even major crashes in production. By tackling these issues effectively, you not only fix problems, but also boost your application's overall quality and reliability. Let's begin by exploring some common challenges in debugging, which isn't always a walk in the park. For instance, in large code bases, identifying the source of an issue can feel like finding a needle in a haystack. Then there are environmental differences. What works perfectly in your development setup might fail in production because of configuration changes or differences in data. Another common challenge is false assumptions. Developers often assume certain parts of the code are working correctly, only to discover those very sections are causing the issue. False positives and negatives from tests can further complicate things, making it hard to trust the results. A false positive might suggest that everything is working when there's actually an underlying issue, while a false negative can indicate a failure where there's none. Finally, let's not forget ambiguous logs. Misleading or incomplete logs can cause you to focus on the wrong problem entirely. But the good news is that tools like IntelliJ IDEA are here to help. IntelliJ is equipped with powerful tools designed to streamline the debugging process. Later, you'll explore how these tools help to investigate issues in a shopping cart program. A key feature to understand is breakpoints. Breakpoints allow you to pause the program at a specific line of code, enabling you to analyze variables, track the flow of execution, and examine the program state at that moment. For instance, if your shopping cart program had a shopping cart class, you could place a breakpoint inside the add product method to pause the program whenever a product is added. This allows you to inspect the state of the shopping cart, verify the product details being added, and ensure the method is functioning as expected. You could also add a breakpoint inside the test add product method in the shopping cart test class to pause execution during the test. This allows you to examine how the method behaves, check the state of the shopping cart during the test, and validate whether the conditions being tested are met correctly. Conditional breakpoints are a good option if you need the program to pause only under specific circumstances. These stop the execution only when a predefined condition is met. For instance, you could use a condition like product get name equals apple to ensure the program halts only for products named apple. Now let's use IntelliJ's debugging tools to debug a test failure in a shopping cart application where the product count in the cart is incorrect. The first step involves running the application to observe the issue. On execution, the test fails with an error indicating a product count mismatch. This error suggests a logical problem in the code, which means a deeper investigation using IntelliJ's debugging process is necessary. The next step involves analyzing the logic in the test add product method. This method is designed to verify that the shopping cart contains exactly one product. However, the test fails because this condition is not satisfied, resulting in an error. To pinpoint the root cause, breakpoints can be set to closely examine the flow of the program. Here's where breakpoints come in. They can be strategically set to further investigate the issue. The first breakpoint can be placed at the condition, where the cart size is evaluated. This pauses execution at a key point, enabling an inspection of the cart state to help identify any mismatches. The second breakpoint can be set within the add product method to monitor the process of adding products to the cart, providing further insights into where the issue might be occurring. To refine the investigation, a conditional breakpoint can also be added in the add product method. This ensures execution pauses only when a product named Apple is added, narrowing the focus to relevant scenarios and simplifying the debugging process. Now let's run the application in debug mode to analyze the issue. After starting the application in debug mode, the debugger pauses execution at the first breakpoint, providing an opportunity to inspect the state of the cart object. Initially, the cart contains one product, which matches expectations. However, when a second product, orange, is added, the cart size increases to 2. This observation highlights the mismatch. Instead of containing only one product, the cart holds both apple and orange, which causes the test to fail. Fixing the issue requires modifying the code to prevent the second product from being added to the cart. This is achieved by commenting out the line that adds the second product. After making this change, the test passes successfully, indicating that all conditions are now met. Now let's review the test conditions to ensure the code behaves as it should. The conditions specify that the cart should contain exactly one product. No items other than Apple should be added, and the product price must be precisely $2.99. Adjusting the test conditions and rerunning the tests can reveal different error messages and provide valuable insights into potential issues. By leveraging breakpoints and debug mode, the product count issue in the shopping cart was fixed. This approach can be applied to similar errors across the application. Effectively investigating issues in code starts with a structured approach and the right tools. This video outlines some common debugging challenges and demonstrated how to use IntelliJ's debugging features, such as breakpoints and conditional breakpoints, to identify and resolve a test failure in the shopping cart application. Applying these techniques regularly strengthens problem-solving skills, ensuring applications perform reliably and meet high-quality standards. Happy coding! Think about your favorite food delivery app. What if your total was wrong or the order didn't go through? That's where software testing comes in, making sure apps work reliably and deliver the experience you expect. Software testing takes debugging a step further by systematically ensuring your code is correct, reliable, and performs well. Let's dive into structured testing by building on what you've already done, like investigating issues, setting breakpoints, and debugging logical errors. You'll use your existing codebase, which includes the library class, book class, and the max function, to learn how to validate individual components, their interactions, and the overall system functionality. In this video, you'll explore some software testing fundamentals. You'll also learn about some best practices and how to leverage tools to enhance and scale testing. So what is software testing exactly? Essentially, software testing verifies that software works as expected in different scenarios. Beyond just checking for correctness, it focuses on ensuring quality, enhancing user satisfaction, minimizing errors, and improving maintainability. Different levels of testing exist, including unit testing, integration testing, system testing, acceptance testing, and regression testing. Each level of testing targets specific goals, ensuring that the system is ready for production and use. Let's go through each testing level in more detail, starting with unit testing. Unit testing focuses on individual methods, like the max function, which calculates the highest value in an array. For instance, testing helps catch logic errors, such as using a less than symbol instead of a greater than symbol in the initial code. By systematically testing, we ensure the function works correctly under a variety of conditions. Unit tests allow you to validate standard cases like curly brace 3, 5, 2, 7, 1, curly brace, which should return 7. It also allows you to address edge cases, such as empty arrays or arrays with negative numbers, and ensure the function gracefully handles invalid inputs. Next, let's consider integration testing. Integration testing is all about ensuring that different components work together seamlessly. For instance, in the library and book classes, adding a book to the library tests the addBook method while ensuring data consistency. Adding multiple books evaluates the scalability of the getBooks method, while testing with invalid inputs verifies the system's robustness in handling unexpected data. By testing scenarios like retrieving all added books, you confirm that the library and book classes collaborate smoothly. Integration testing helps ensure that combined components function as one cohesive system. Amazon Web Services, or AWS Elastic Beanstalk, makes it easy to test these interactions in environments that closely mimic production. Next is system testing, which assesses the entire application by simulating real-world workflows. For the library codebase, this might involve adding multiple books to the library and retrieving their details, or using the max function on hypothetical data, like page counts. Acceptance testing verifies that software meets user expectations and business requirements. Its primary goal is to ensure that the system is ready for deployment and use. Finally, regression testing ensures that existing functionalities work as expected when new features or changes are introduced to the codebase. This comprehensive testing ensures all components work together as expected and meet user needs under realistic conditions. Tools like AWS Device Farm further enhance this process by simulating various environments, such as different operating systems or browser versions, to effectively validate system behavior. Now let's explore how to incorporate AWS testing practices in the testing process. AWS offers several tools and frameworks to extend testing capabilities. This includes on-demand environments where developers can simulate configurations to ensure compatibility. Load testing is another useful tool. It evaluates application performance under heavy usage. Using Amazon CloudWatch, it also helps pinpoint bottlenecks and optimize performance during testing. Another tool is automation with AWS Code Pipeline, which integrates testing into continuous integration and continuous delivery or CI/CD workflows. For example, the library application can be tested on AWS to assess scalability and performance under varying loads. Automating these processes saves time and maintains consistent quality. Indeed, automation is super handy. Luckily, you can use JUnit to automate tests. JUnit streamlines the testing process by automating test execution. For instance, it can validate the max function across multiple datasets without requiring manual input. Similarly, a JUnit test suite for the library class can efficiently verify adding, retrieving, and managing books. When integrated into CI/CD pipelines, JUnit helps developers catch issues early, ensuring a stable and reliable codebase. Additionally, AWS supports automation for regression testing, safeguarding existing functionalities from unintended effects when new features are added. Finally, let's think about some best practices for effective testing. Effective testing begins by prioritizing critical functions, focusing on high-impact methods like the addBook and max methods. Incremental testing is important too, starting with unit tests to verify individual components before progressing to integration and system tests for broader validation. Planning tests early alongside the code development process ensures comprehensive coverage from the outset. Regularly refactoring and improving tests is crucial to reflect new features or changes in functionality, keeping the testing process relevant and effective. Finally, embracing scalability through AWS testing services allows you to dynamically scale test environments, meaning thorough evaluation under various conditions. In this video, you explored software testing fundamentals, including unit integration and system testing, while emphasizing best practices and leveraging tools like AWS and JUnit for efficient and scalable testing. Testing builds upon debugging to ensure software not only works, but performs reliably in diverse conditions. By applying structured testing to the same codebase we debugged earlier, we validate the correctness of critical functions and workflows. Congratulations on completing Module 3 of the Application Development course. In this module, you tackled the essential phase of software implementation, gaining practical skills to write efficient code, debug issues, and deliver reliable applications. These are the building blocks of every successful software project, ensuring that what you create is not only functional, but also robust and maintainable in the long run. Let's take this time to reflect on the key takeaways. The journey began with coding best practices, emphasizing strategies to ensure software remains maintainable and adaptable over time. You learned the importance of clear naming conventions and detailed documentation, such as JavaDoc and JSDoc, to enhance code clarity. Foundational principles like don't repeat yourself, which reduces redundancy, and the single responsibility principle, which keeps classes focused on one task, ensure maintainability. Through practical activities, you explored how neglecting maintainability, such as failing to capture knowledge or manage dependencies, can lead to costly rework and unstable projects. By refining Java classes and leveraging these techniques, you developed clean, professional code that minimizes errors, fosters collaboration, and supports long-term stability. Software maintenance then took center stage as you tackled challenges such as managing dependencies, navigating legacy code, and facilitating seamless team handovers. Real-world examples, such as a team struggling to update a legacy application because outdated documentation and poorly managed dependencies led to costly delays, demonstrated how poor maintainability can drive up costs and extend timelines. This highlighted how investing in maintainable code not only saves time and resources, but also sets the stage for long-term project success. Relatedly, debugging emerged as a pivotal focus, with lessons addressing common troubleshooting challenges faced in software development. You explored obstacles, such as identifying root causes, navigating vast code bases like finding a needle in a haystack, and managing issues stemming from environment differences, false positives, or incorrect assumptions. And using IntelliJ breakpoints, you practiced identifying and resolving errors efficiently, even in extensive and intricate code bases, honing your skills to maintain workflow efficiency and ensure software reliability. The module also emphasized the role of testing in delivering reliable, high-quality software. You explored various testing types, unit, integration, system, and acceptance, each addressing specific aspects of application functionality and user expectations. Unit testing focuses on isolating individual code components, while integration testing ensures that these components work together seamlessly. System testing validates the application as a whole, and acceptance testing verifies that it meets user needs and business requirements. Together, these testing methods form a comprehensive strategy to identify and address issues at every stage, ensuring robust, user-focused applications that align with business goals. Another essential topic was logging, implemented using SLF4J in a Spring application. This highlighted how effective logging aids in monitoring application performance and streamlining troubleshooting. In short, by configuring log levels and interpreting log data, you gained the ability to maintain robust and well-monitored systems. To tie everything together, the graded lab project provided an opportunity to put theory into action. You applied clean coding principles, developed unit tests, and implemented logging to monitor and resolve application behavior effectively. Additionally, using a linter to catch errors and enforce standards further enhanced your ability to craft maintainable, high-quality software. This module equips you with practical tools to tackle real-world development tasks with confidence. You've honed your ability to write maintainable and error-free code, rigorously test, and optimize performance, key competencies for excelling in software development. Armed with these skills, you're prepared to take on more advanced challenges, crafting solutions that are reliable, scalable, and meet business objectives. Once again, congratulations on this achievement and best of luck as you continue to build your expertise and advance your career as a developer. Change in software development, as in life, is a constant. Teams frequently update the codebase to refine and expand their projects. They add features, fix bugs, and improve performance. Without a system to manage these changes, tracking who did what, understanding why, and restoring previous versions when needed can quickly become overwhelming. In this video, we'll explore how version control systems, or VCSs, simplify tracking changes, help identify and investigate issues efficiently, and enable collaboration. Using Git as an example, we'll see how it supports teamwork on projects like the Linux kernel. By the end, you'll understand how version control systems like Git streamline workflows and make collaboration more efficient. First, what is a version control system? VCSs are tools designed to manage changes to your files over time. They track what was changed, when it was changed, and by whom, enabling teams to understand the history of their work. If, or rather when something goes wrong, such as a bug appearing in the code, VCS makes it easy to pinpoint when the issue was introduced and restore the project to a stable state. Beyond troubleshooting, VCS also facilitates seamless collaboration by allowing multiple team members to work on the same project simultaneously without overwriting each other's work. Think of it as a smart time machine that records every change, providing a complete history of your project. One of the most important benefits of version control is tracking changes. For example, every change you make in your project is saved as a commit, which serves as a snapshot of the project at a specific point in time. This makes it easy to review progress, compare different versions, and even revert to an earlier state if needed. Version control systems have evolved and come in different types, each suited to specific needs and project sizes. Before automated tools, managing code changes often relied on manual version control. This approach involves saving different versions of files in separate folders, typically labeled with timestamps or version numbers. While this allowed developers to track changes and restore earlier versions when needed, it was far from efficient. As projects grew more complex, manually organizing files became error-prone and time-consuming. Collaboration was especially challenging, as team members lacked tools to merge changes or work simultaneously on the same files. These critical limitations made manual version control impractical for modern software development, paving the way for more advanced systems. Enter centralized version control systems, or CVSs, which are a significant improvement over manual methods. In a centralized repository, all versions of the source code are stored on a single server, which developers connect to for retrieving, updating, and saving changes. This setup simplifies collaboration by providing a single source of truth for the entire team. A well-known example of a centralized version control system is Subversion, or SVN, developed by Apache. However, centralized systems have a major limitation. If the server goes offline or encounters an issue, the entire project becomes inaccessible and there's a risk of data loss. To handle this concern, distributed version control systems offer a more reliable and efficient alternative to centralized models. In a DVCS, each user has a complete copy of the repository, including the full project history, on their local machine. This allows developers to work offline, making changes and committing them to their local repository. Once changes are ready, they are pushed to a central repository to synchronize with the rest of the team. Teams often work on separate branches, merging changes later. The merging process integrates multiple updates into a unified version, resolving any conflicts along the way. A key advantage of DVCS is its resilience. Since every user has a full copy of the repository, the system is not dependent on a single server. Even if the central repository becomes inaccessible, development can continue locally and the changes can be synchronized once the server is restored. One of the most widely used tools for managing code today in this way is Git. Originally created to support collaboration on the Linux kernel, Git demonstrates how DVCS streamlines workflows and fosters teamwork. And developers love it. With Git, developers can maintain a complete history of their projects locally, create branches for experimentation, and merge successful updates into the main branch, ensuring flexibility and safeguarding ongoing work. A prime example of Git's power is the Linux kernel project, where thousands of contributors worldwide collaborate seamlessly while Git tracks updates and resolves conflicts efficiently. Other DVCS tools like Mercurial and Bazaar provide additional options for specific needs, like ease of use, simplicity, and flexibility in version control workflows. Recently, cloud-based systems like Plastic SCM and Fossil have further expanded version control capabilities for modern development. These tools showcase the evolution of version control from Git's versatility to user-friendly options like Mercurial and cloud-based systems, driving collaboration and adaptability in modern development. In this video, we've explored why and how version control is a game changer for developers. It's more than just a tool. It's your safety net for tracking every change, resolving issues quickly, and collaborating effortlessly with your team. In short, version control saves edits, enabling rewinds and confident troubleshooting. And Git exemplifies this by powering the Linux kernel, where thousands collaborate seamlessly. Whether you're building the next big app or working on a passion project, version control ensures your code is safe, your workflow is smooth, and your collaboration is limitless. Picture this. You're on a dev team working on a critical software project. Everyone's making updates, adding features, fixing bugs, and testing the application, but without a clear plan for managing changes. Before long, files are overwritten, progress is lost, and no one knows which version of the code is correct. In the last video, you learned the basics of version control and why it's essential for software projects. In this video, you'll learn about two key tools: Git, which tracks and manages changes locally, and GitHub, which enables online collaboration and project sharing. Together, they're a powerful duo for managing projects, whether you're working solo or with a team spread across the globe. First, let's understand Git a little more. Git doesn't officially stand for anything, but describes a distributed version control system. Simply put, it's designed to track changes in files and coordinate work across multiple collaborators. Unlike centralized systems, Git gives each user a full copy of the repository, including the project's entire history. A repository or repo in this context is where your project files and their complete history are stored. Every time you commit changes, Git creates a snapshot, allowing you to track and revisit any version. This decentralized approach lets collaborators work offline, keeping the project history safe even if one machine crashes. Git also supports branching, enabling you to work on multiple features or fixes simultaneously without affecting the main codebase. With branching, when a feature is complete, it can be merged back into the main branch, ensuring smooth project evolution. Perfect. Merge conflicts occur when different changes are made to the same file. Thankfully, Git provides tools to manage these conflicts, enabling efficient collaboration even on large projects. In short, Git is the engine that powers version control, empowering you to build, experiment, and grow with confidence. Now that you understand Git, let's talk about GitHub, a platform that takes Git to the next level. While Git manages changes locally, GitHub is a hosted platform for storing, sharing, and collaborating on Git repositories. It essentially provides tools like issue tracking, pull requests, and project management features, making collaboration seamless. One of GitHub's key features is its online repositories, which store project files and version history, making them accessible and easy to share from anywhere. Another key feature is GitHub's collaboration tools, such as pull requests and issue tracking, which enable seamless teamwork for managing changes and resolving bugs. GitHub also serves as a portfolio platform, showcasing coding projects, open source contributions, and skills to potential collaborators or employers. And using GitHub Actions, customizable tools for automation, developers can automate workflows like testing, building, and deploying code. GitHub is widely used in open source projects for its collaborative tools and visibility. It also supports private repositories for personal or business use and integrates with testing tools. This flexibility has made GitHub the home of millions of open source projects, fostering global collaboration and productivity through tools like wikis, project boards, and discussions. How does Git and GitHub work together? Git and GitHub are complementary tools that streamline project management and collaboration. Git helps you track changes locally, while GitHub lets you share your work online, making it accessible to others. For example, when developing a web app, you use Git to manage changes locally and push updates to GitHub, where teammates can review, contribute, and collaborate. This combination keeps workflows organized and efficient. One of the most well-known examples of Git and GitHub in action is the Linux kernel. Developers worldwide use Git to contribute changes, while GitHub facilitates collaboration by enabling code reviews, comments, and merges. In addition to the Linux kernel, GitHub hosts widely used projects such as React and TensorFlow, making it a central hub for discovering projects, contributing code, and learning from the global developer community. In this video, we explored two essential tools: Git for managing changes locally and GitHub for sharing code and collaborating globally. Together, they streamline project management, foster collaboration, and simplify workflows, whether you're coding solo or with a global team. Whether you're building the next big app, contributing to an open source project, or collaborating across industries, Git and GitHub empower you to work smarter, stay organized, and achieve more. You've just joined a new team, and they've shared the code for an important project on GitHub. To contribute, you need to access that code on your own computer. How do you make that happen? The first step is cloning the repository, giving you a local copy to work with. In this video, you'll learn what cloning a repository is, why it's essential, and how to do it step by step using Git and GitHub. In developer circles, cloning a GitHub repository means bringing its entire codebase to your computer, ready for offline work and contributions. With just one command, you gain access to all the project's files, branches, and full history, empowering you to work offline, test changes safely, and contribute effectively. It's one of the most important skills for collaborating on Git projects and ensures you can seamlessly connect your local work with the team's shared repository. Here's why cloning is essential in several key scenarios you might encounter. When joining a new project, cloning gives you immediate access to all project files and history, allowing you to get up to speed quickly. For testing or development, cloning enables you to work on code locally without the risk of impacting the remote repository. If contributing to open source projects, cloning allows you to make improvements or fixes and share them back with the community. Cloning also serves as an important safeguard, creating a local copy of the repository to back up the remote version. And of course, for experimentation, cloning lets you safely explore new ideas or features without affecting the original repository on GitHub. Cloning a repository is quick and easy, whether you're using a HTTPS URL or an SSH key. Let's start by exploring how to clone with HTTPS. First, log into your GitHub account and navigate to the repository you want to clone. Click the Code button above the file list. In the dropdown, select the HTTPS tab and copy the URL that's there. On your local machine, right-click inside your desired folder, like repositories on the C drive, and select Open Git Bash here. The Git Bash terminal will open in that specified location. Perfect. In the terminal, type the following command, git clone, with a placeholder for the repository URL. Then paste the URL you copied earlier here, and hit Enter. Git will create a folder named after the repository in your selected directory, My Repository, so you know where the project is exactly. If you expand this folder to explore its contents, along with the repository files, you'll find a .git folder. Here you'll find essential project information, including remote server details, commit history, branch information, and logs of all commits. Now that you've cloned a repository using HTTPS, let's explore how to do the same with SSH, a secure and efficient method for interacting with GitHub repositories. Cloning a repository with SSH is a secure and efficient option, but you'll need to set up SSH keys before you begin. Make sure your SSH key is configured and added to your GitHub account. Now navigate to the repository you want to clone, like this one. Click the code button above the file list, select the SSH tab, and then copy the SSH URL that's there. On your local machine, right-click inside the desired folder and choose Open Git Bash here to launch the Git Bash terminal. When it opens, type git clone and then paste the URL you copied earlier, then enter. Once the process is complete, a folder named after the repository will appear in your selected directory. Inside this folder, you'll find all the repository files and that .git folder that contains metadata, commit history, branch information, and logs. That's it. In this video, you learned what cloning is, why it matters, and how to do it step by step using both HTTPS and SSH. Cloning a GitHub repository is an essential skill for developers, whether you're contributing to open source projects or collaborating with a team. With a complete local copy, you can work offline, experiment safely, and confidently contribute to your project. Now you're equipped to tackle real-world projects and streamline your workflow. Happy cloning! After cloning a repository and creating a local copy of your project, the next step is managing and saving changes to your code. Whether you're working alone or as part of a team, Git helps you track, organize, and save changes with precision. So how does Git know which changes you want to save? That's where the status, add, and commit commands come in. These essential operations allow you to stage changes in the staging area, a bridge between your working directory and the repository, and save them permanently to your project's history. In this video, you'll learn how to use these commands step by step and why they're critical for effective version control. By the end, you'll be able to organize and track your changes confidently, ensuring a smooth and efficient development workflow. First, though, more on the staging area and how it acts as a bridge between your working directory and your repository history. When you modify a file, Git doesn't automatically save those changes. Instead, you use the git add command to stage changes from your working directory, moving them to the staging area, also called the index, in preparation for a commit. Here, you prepare a snapshot of your project's current state and decide which changes to include in your next commit. Files in the staging area aren't permanently saved until you use the right command. The git commit command records changes to the repository and forms the backbone of version control. Each commit saves the state of your project, including all tracked files, and assigns a unique identifier, a commit hash, to this snapshot. What this does is allow you to keep a detailed record of what changes were made, who made them, and when. Think of git add as preparing your changes and git commit as taking a snapshot of your project at that moment. This snapshot becomes a permanent record in your repository, allowing you to revisit changes whenever needed. Before diving into staging and committing changes, it's important to understand how to check the status of your project. To do this, simply use git status to check the current state of your project. This command shows changes that are staged, changes that are not staged, and files that aren't tracked by Git. By running git status, you gain a clear view of what's happening in your project, helping you decide your next steps with confidence. Now that you understand these essential commands and their role in a GitHub repository, let's work through an example. Start by modifying a file in your repository. To do this, navigate to the My Repository directory where you previously cloned the repository. Open the readme.md file in VS Code, add a new line with the text, Hello World, of course, and save the file. Done. You can now check the current state of your project by opening the Git Bash terminal in the My Repository folder and running git status. The terminal will display that readme.md has been modified, but no changes have been added to the staging area. Stage your changes by adding the modified file to the staging area. Run the following command: git add readme.md. Confirm the changes have been staged by checking the status again using git status. The terminal will now show the file as staged for commit, which is perfect. As a tip, if needed, you can always unstage a file using the git restore command. Commit the staged changes to your repository with a meaningful commit message like updated readme with hello world text. Check the status again with git status, and the terminal should confirm that there's nothing left to commit. Nice. Once committed, your changes are ready to be published to the remote repository. This is done using the git push command, which will be covered in the next video, along with the pull command. Understanding how to use git status to check your project state, git add to state changes, and git commit to record them is fundamental for effective version control. In this video, you learned how to manage and save changes to your code using these 3 essential git commands. Together, they enable you to stage changes in the staging area and save them permanently to your project's history. Start applying these commands and watch your coding process become more organized and efficient than ever. Collaboration in software development relies on effective version control. When working with a team, sharing your changes and staying up to date with your teammates' contributions is critical. In this video, you'll learn how to use the git push and git pull commands to upload changes to a remote repository and fetch updates from it. By bridging the gap between individual contributions and team progress, these commands play a critical role in driving efficient workflows and delivering value to businesses in a competitive landscape. Recall that in collaborative projects, every team member works on a local copy of the code. To keep everyone's work synchronized, Git provides 2 simple but crucial commands, push and pull. Here's how they work. After committing changes locally, the git push command uploads your updates to a remote repository, such as GitHub. This makes your work accessible to the rest of the team and integrates your contributions into the shared codebase. The git pull command then retrieves the latest updates from the remote repository to your local machine. Now developers can be sure they're working with the most current version of the project, which is invaluable for preventing conflicts during collaboration. Before working through an example of push and pull commands in action, you'll need to first understand remotes in Git. A remote is essentially a version of your repository hosted on a source code repository server, like GitHub. It enables collaboration by letting multiple developers work on the same project, even if they're many miles apart. When you clone a GitHub repository, Git automatically assigns a default remote called Origin. This remote is used for both fetching updates from the server and pushing your changes to it. To help demonstrate, let's clone and set up a public GitHub repository. To get started, log into GitHub and search for this test repository. Once located, click on it to open. Now, before cloning, you need to fork the repository to create a copy in your GitHub account. To do this, select Fork and then choose Create a New Fork. Forking duplicates the repository on the server, enabling independent work without altering the original. It's a platform-specific feature, not a core Git command. Once the fork is created, click Create Fork to confirm. With the fork ready, it's time to bring the repository to your local machine. Copy the HTTPS URL of the forked repository. Now, clone the repository via the terminal using the HTTPS URL. Next, change the directory to test repository using the cd command. To check the configured remote for your repository, navigate to the cloned repository and use the command git remote -v. This will display a list of all configured remotes, including their names and URLs. Typically, you will see a default remote named Origin pointing to the repository you cloned. So far, you've successfully forked the repository, cloned it to your local machine, and verified the remotes. Now that a repository is set up, it's time to synchronize the work using the git pull and git push commands. Before making any changes, it's a best practice to update your local repository with the latest changes from the remote. Use the git pull origin main command. Origin refers to the remote GitHub repository, and main is the default branch where the latest updates are stored. What this command does is fetch updates from the remote repository and merge them into your local branch. If there are no updates, Git will kindly let you know that your local repository is already up to date. Perfect. Once your repository is synchronized, you're ready to make local changes. For this example, first open the repository folder in File Explorer. Then locate and open the file readme.md in Notepad or your preferred text editor. Now add a new line of text, such as, "This is a new line for testing purposes." Save the file and close the editor. After editing the file, check the status of your repository to see which files have been modified. The git status command displays a list of changes, such as files that have been modified but not yet staged for commit. To prepare your changes for upload, stage them with the git add readme.md command. Then, commit your changes with a meaningful message, something like updated readme with new content. Great! With your changes committed locally, you're ready to upload them to GitHub. Use the git push origin main command. If it's your first push or your credentials are not cached, Git may prompt you to sign in here. Just choose Sign in with your browser and then authorize GitHub in the Git Credential Manager when prompted. After successful authorization, Git will push your commits to the main branch of the origin remote. Once complete, your changes will appear in the repository on GitHub and will be accessible to your team. Done. Now, when collaborating on a shared repository, conflicts can occur if someone else modifies the same file or files you're working on. For example, you may change the readme.md file in your local repository, while another developer changes the same file in the remote repository on the GitHub server. When you try to push the changes, Git will reject your push to prevent overwriting the changes made by another developer. Resolving these conflicts ensures the repository remains consistent and error-free. To resolve a conflict, start by pulling the latest updates from the remote repository using the git pull origin main command. This command fetches the changes from the main branch of the remote repository and attempts to merge them into your local branch. If a conflict exists, Git will notify you and mark the conflicting parts in the affected file or files. Now open the suspected file with conflicts in your code editor. Git uses special markers to highlight the conflicting sections, which look like this. The section between the left-facing arrows and head contains your local changes. The section between the many equal signs and the right-facing arrows, followed by an alphanumeric string, contains the changes from the remote repository. Edit the file to keep the correct version or combine the changes as needed, removing the markers. After editing the file, stage the resolved changes using git add readme.md. Then, commit the resolved changes with a descriptive message, like resolved merge conflict in the file. Finally, push your resolved changes back to the remote repository using git push origin main. This ensures the repository now includes your updates alongside the previously conflicting changes. Nice work! Mastering the git push and git pull commands isn't just about knowing the syntax, it's also about using them effectively in a collaborative environment. Here are some best practices to keep in mind. Always pull the latest changes before starting work to stay up to date and minimize conflicts. Push small updates often to keep the team informed and avoid large, complex merges. Write concise messages that clearly explain what your changes do, like fix login bug. The git push force command can be used to overwrite changes on the remote repository with your local branch. However, use it only when absolutely necessary and communicate with your team to avoid overwriting their work. In this video, you learned how two essential Git commands, push and pull, keep your code synchronized and your teamwork on track. Along the way, we also explored the importance of remotes in bridging the gap between your local work and the shared repository. These tools are more than commands. They're the foundation for efficient collaboration, helping you stay organized and avoid common pitfalls in a team setting. Now it's time to put these skills into action and see the difference they can make in your projects. Happy coding, and here's to smooth collaboration. Picture this. You're part of a team planning an event, and everyone has their own tasks. Designing invitations, booking a venue, managing schedules. Without a clear plan, chaos unfolds. Tasks overlap, updates clash, and no one knows who's doing what. In software development, Git manages code changes effectively. For seamless collaboration on a shared codebase, Gitflow provides the structured workflow teams need to stay organized. In this video, you'll learn about Gitflow's core components, how its branching model streamlines teamwork, and why developers rely on it to keep their efforts aligned and their codebases efficient and conflict-free. With Gitflow, teamwork isn't just manageable, it's effortless and productive. In Git, branches serve as separate workspaces within a project, allowing developers to work on features, fixes, or experiments without affecting the main codebase. Gitflow builds on this foundational concept by providing a structured branching model that organizes how code is developed, tested, and released. Here's how Gitflow structures the branches. The main branch represents the stable, production-ready version of your codebase. Developers use the develop branch as the central workspace for integrating active development from multiple contributors. A feature branch is created as a temporary workspace for building new features or resolving specific tasks independently. When preparing a new release, teams rely on release branches to finalize changes, polish features, and ensure stability before deployment. For critical fixes, hotfix branches allow urgent changes to be applied directly to the production code in the main branch. This structure allows developers to work independently on different tasks while keeping the workflow organized. Feature branches enable parallel development. Develop serves as a hub for integration, and release and hotfix branches handle stability and urgent issues. By following Git flow, teams can reduce conflicts, streamline collaboration, and ensure projects progress smoothly from development to deployment. To see Git flow in action, let's break down a basic workflow step by step using simple node diagrams. The workflow begins with two primary branches. The main branch, M, holds the stable production code, and the develop branch, D, is where all new code changes are integrated. When a developer begins a new task, they create a feature branch from the develop branch. This keeps their work isolated away from the main branch, ensuring that their changes don't interfere with ongoing development until they're ready to merge. Once the task is complete and tested, the feature branch is merged back into develop, keeping the main workflow organized and up to date. When the develop branch reaches a stable state, a release branch, R, is created. This branch is used to finalize the release, apply bug fixes, and polish the code while active development continues on develop. Once the release branch is ready, it's merged into both main and develop to ensure the latest updates are included in both branches. Occasionally, critical issues arise in the production code. For such emergencies, a hotfix branch, H, is created directly from the main branch. After resolving the issue, the hotfix branch is merged into both main and develop, ensuring the fix is incorporated into the production code and ongoing development. Gitflow's structured workflow addresses common challenges in software development, making collaboration smoother and reducing code conflicts. Here's how. Feature branches provide dedicated spaces for developers to work on specific tasks without affecting others. By isolating changes, Gitflow minimizes the risk of accidental interference and ensures that work remains conflict-free until it's ready to be integrated. The develop branch serves as the central hub for combining all feature branches. This ensures that developers can work independently while having a reliable location to merge and test their changes collectively. Developers can rebase their feature branches to align with the latest updates in the develop branch. Rebasing incorporates recent changes into the feature branch, reducing the likelihood of merge conflicts when the work is finalized. Release branches enable teams to prepare for production with a focused environment for final tweaks and bug fixes. This ensures that release-specific changes don't disrupt ongoing feature development in the develop branch. Hotfix branches allow critical fixes to be applied directly to the main branch. Once resolved, these fixes are merged back into both main and develop, ensuring production stability without delaying other development work. Gitflow is more than just a workflow, it's a strategy for efficient, conflict-free collaboration. In this video, you learned about Gitflow's core components, how its branching model streamlines teamwork, and why developers rely on it to keep their efforts aligned and their code bases efficient and conflict-free. In sum, by structuring branches like feature, develop, release, and hotfix, Gitflow simplifies development, reduces conflict, and ensures a smooth workflow. Whether working in a small team or on a large project, Gitflow keeps your process predictable and productive. Here's to finding your Git-assisted flow. Congratulations on completing Module 4 of the Application Development course. In today's fast-paced development landscape, effectively managing code changes and fostering seamless collaboration are indispensable skills. This module provided you with a solid foundation in version control, a cornerstone of modern software development. Let's take a moment to review the essential Git skills and version control workflows you've built. The module began with an introduction to version control systems, emphasizing their importance in modern software development. You learned how VCS supports tracking changes, investigating issues, and fostering collaboration in development workflows, all of which are indispensable for developing quality apps over time. Think about it. Without a version control system, managing code changes in dynamic team environments would become chaotic, increasing the risk of lost progress, conflicting updates, and difficulty resolving issues efficiently. To help instill order from chaos, Git, a distributed version control system, DVCS, widely used across the industry, was showcased through examples like the Linux kernel project, highlighting how global teams collaborate effectively. You then explored the structure and functionality of Git repositories and their importance in managing project changes in more detail. These repositories maintain a complete history of edits, fostering transparency and accountability. GitHub, a leading platform for hosting repositories, stood out for its versatility in supporting both open source and private projects. Step-by-step tutorials guided you through setting up a GitHub account, creating repositories, and leveraging GitHub's collaborative tools, equipping you to navigate team environments with confidence. Hands-on activities provided practical experience with essential Git operations, including cloning repositories, staging files, committing changes, and pushing updates to remote repositories. Each of these common operations were presented clearly, with a focus on best practices for efficient project management and workflows. Practice makes perfect, and the lab exercises allowed you to apply these commands in a controlled environment, helping you build valuable proficiencies in managing version control tasks effectively. A key feature of Git is push and pull operations, which synchronize local and remote repositories. These operations allow developers to share changes and incorporate updates from teammates effortlessly. Remotes, those external server-hosted versions of a repository, play a vital role in this process. Remotes, remember, enable collaboration by syncing changes and integrating contributions from multiple developers into a unified codebase. Among the highlights of this module was Gitflow, a powerful workflow that brings clarity and structure to collaborative development. Gitflow's systematic approach supports efficient management of feature development, bug fixes, and releases while minimizing merge conflicts. You learned how Gitflow promotes organized workflows by developing features in isolated branches and reintegrating them through rebasing, which maintains a clean project history and preserves code integrity. Hands-on activities reinforce these concepts, giving you practical experience with creating repositories, cloning them, and managing updates to enhance efficiency and organization in development projects. Applications don't come into existence fully formed. They evolve through iterative development. To build quality software, developers need efficient ways to manage changes and control different versions of features. That's where Git and its workflows come in. In this module, you learned to push changes to Git repositories, collaborate using Git's distributed system, and implement Gitflow to streamline workflows. With these skills, you're better equipped to manage code bases effectively, collaborate seamlessly, and maintain project integrity. Every project brings unique challenges, but remember, version control is more than a tool. It's a mindset that ensures precision and fosters collaboration. Congratulations on completing Module 4, and best of luck versioning your way to ever-improving applications. Congratulations on completing Course 7 on Application Development. You've just reached the end of a valuable journey through the Software Development Lifecycle, or SDLC, all the way through practicing the skills that power modern application development. From gathering requirements and designing system architecture, to implementing clean, maintainable code and deploying in the cloud, you've tackled the real-world challenges developers face every day. To begin your journey through the software development lifecycle, this module focused on planning and design, the essential first step in successful projects. Recall that requirement analysis and specification are vital for project success, ensuring functional and non-functional requirements align with stakeholder goals. Using tools like user stories and invest attributes, you gain strategies to organize and communicate project needs effectively. This is valuable in the working world because it ensures clarity, minimizes misunderstandings, and aligns development with business goals. Next, you practice creating UML diagrams, visual tools for mapping system components and workflows. These diagrams will help you transform complex ideas into clear, actionable designs. You also studied software design patterns like singleton and strategy. which enhance maintainability and scalability by simplifying development and reducing complexity. To create user-friendly, visually appealing designs, you focused on user interface or UI design, applying principles of clarity, consistency, and accessibility. Through wireframing, you learned to outline the structure and functionality of interfaces, while color theory taught you how to use colors effectively to enhance aesthetics and accessibility. Designing your own mockups provided the chance to refine these concepts into polished, interactive visuals, enabling you to bring ideas to life while meeting user and stakeholder expectations. With these combined abilities, you're well prepared to approach the planning and design phase of any development project with confidence. Module 2 equipped you with strategies and frameworks essential for managing software projects effectively. You explored the software development lifecycle and its 7 key stages: planning, analysis, design, development, testing, deployment, and maintenance, gaining insights into how each stage ensures successful project outcomes. You analyzed Sdlc models like Waterfall, Agile, Spiral, and vModel, learning when and how to apply them. Agile stood out for its flexibility and collaboration, with frameworks like Scrum focusing on sprints and Kanban emphasizing workflow visualization. This understanding allows you to select the right methodology for any project, ensuring efficient workflows, better team collaboration, and solutions that meet both technical and business requirements. Building on Sdlc models and agile approaches, RAD demonstrated the value of rapid prototyping and user feedback, while DevOps showcased how bridging development and operations accelerates delivery. Hands-on activities helped you apply these methodologies to dynamic scenarios, building the skills needed to excel in today's fast-paced development environments. Module 3 shifted focus to the implementation phase, where you honed critical skills for writing reliable, maintainable software. You learned coding best practices like dry, or don't repeat yourself, and the single responsibility principle, ensuring clean and scalable code bases. Debugging and testing were emphasized as essential techniques for maintaining software quality, because nobody wants or needs buggy software. Issues are bound to come up, so you learn to use breakpoints in IntelliJ to efficiently identify and resolve concerns, even in large, complex code bases. By creating unit tests, you ensured your applications meet functionality requirements and remain stable under varying conditions. And logging, introduced through SLF4J, gave you tools to monitor application behavior and diagnose issues in real time. These practices came together in a graded lab, where you applied clean coding principles, wrote robust tests, and implemented structured logging. Developing quality applications is a team effort, so in the previous module you embraced the power of collaboration through version control with Git and GitHub. You practiced essential Git operations like cloning repositories, committing changes, and managing branches, building your confidence in maintaining organized workflows. The introduction of the Git flow workflow added advanced strategies for managing feature development, bug fixes and releases, minimizing conflicts, and enhancing team collaborations. Through practical exercises, you learn to streamline development, ensure code-base integrity, and confidently manage projects while collaborating effectively in team environments. What does this course mean for your future? By completing this course on application development, you've gained the ability to document and analyze requirements effectively, ensuring project alignment with stakeholder needs. Skills to define system components and workflows using diagramming tools like UML, knowledge of software methodologies such as Waterfall, Agile, and DevOps, and their application to diverse project requirements. Proficiency in implementing version control through Git, including creating repositories, managing branches, and collaborating in team environments. These capabilities position you to excel in real-world software development, adapting to dynamic challenges and delivering high-quality solutions. Completing this course is a remarkable achievement, marking the beginning of an exciting chapter in your development career. The skills you've refined, the projects you've completed, and the confidence you've gained have prepared you to tackle complex challenges and thrive in this ever-evolving industry. Congratulations on this milestone. Best of luck as you continue to grow, innovate, and create impactful applications, one version step at a time.
Hi, my name is Hussam Ismail. I'm a software development manager at Amazon. I have over 20 years experience in software engineering across multiple disciplines, including supply chain, telecommunication, healthcare, mobile applications, education, and more. Your final project is about refining and enhancing the web application you built in Course 5, a personalized to-do list that allows users to add, modify, and complete tasks. Built using a full-stack approach using HTML, CSS, and JavaScript and Spring Boot, you will now elevate the beginner-level app by applying industry best practices. You will need to complete several key tasks to bring your app to the professional standards. In this video, I will share my insights on approaching this project, along with tips to ensure your final project is a polished professional showpiece. Generally, in web applications, we sit with a product management team who hold the requirements, and we infer, talking to them, reading the business requirements documents, what are the functional aspects of the project, what is the project supposed to do. Developing a full stack web application in general requires us to implement both functional and non-functional requirements. Functional requirements would be something like what is the application supposed to do, what are the outcomes of the application, and non-functional requirements are how the application would behave as we release it into production. Like, for example, scalability, how many software development teams will be working on the application. That definitely has an impact on how the application is designed and implemented. Probably the best practice to implement would be version control. Version control will allow you or allow developer to have to tag, to label, to freeze a snapshot of the software as it's being developed. It will also allow multiple users to work on the application at the same time, each with his own or her own branch, and then they merge it when they try to integrate branches together. The second aspect, I would say, then testing. There are several layers of testing for an application. The most basic of which is unit testing. Unit testing is about traversing the branches of your application. You want to exercise all of the lines of code that you've written in the application. That is measured by the code coverage. Then we move on to integration testing, when multiple features are developed and they integrated together. After unit testing or integration testing, we come to the final set of testing, which is UAT testing. We test the functionality. We think that the software is ready to be released. We have addressed all of the unit tests challenges and the integration test challenges as well. And now we will try to leverage a subset of the end users to act as users and accept the final outcome of the application. The first type of documentation is a design document. The design document illustrates exactly the different components of the application, how they work together, the interface and the contract definition between the APIs and the different layers in the application. The second set of documentation is how the application would behave in production. The third set of documentation is a runbook, or also referred to as a playbook, which means if a defect of this kind happened in production, this is the way that you should address that defect. Anything that you can document to make it easier for developers to readily identify and address a defect as the defects as they happen in production. So error handling addresses multiple concerns of a application in production. The first one is introduces fault tolerance. So, for example, a specific exception means that we can retry the API call that created that exception if it's applicable or not. Perhaps the resource wasn't available at the back end, and so we implement an algorithm that retries for a specific number of times, like maybe 3 times, before we can actually give up and expose that exception to the end user. Detailed exception handling also allows the developer to project appropriate and relevant errors to the end user. In real world scenarios, exceptions are also very important to detect defect patterns. So, for example, we log an exception when it happens, and we log it every time it happens. We log also with it the parameters that cause the exception, and those log files would be analyzed by, let's say, another software like Splunk, for example, and it will detect how often those exceptions occur, and then those will be turned into features that will add to the application, perhaps to uh, address the root cause of the exception. Hard code values pose some challenges if the application is to be deployed into production. We have to introduce changes in code for the application, and for it to be deployed again in production, it has to traverse the whole development life cycle, which means that it will take longer to make that change in configuration to production. If that configuration change is frequent, then we will waste a lot of resources, engineers' time, deployment time, and so forth to bring about that change in configuration into production. Another use of a configuration is that uh, it is not owned by developers. Developers develop the app, implement it to satisfaction of the product team, and most likely they are business departments that owns those configurations. And if we push them to a location where they can actually make that change themselves, then we will isolate the SDE time to just for implementation and not necessarily spend on changing configuration during the lifetime of the application. There are multiple levels of logging, and there are multiple components as well that you can leverage to do that logging for you. SLF4J, for example, is one that you can leverage to create the login for the C7 project. Log messages that identify defects, especially defects that arise from um, uh, non-functional requirements like availability of an API. Like if we are throttled by another API, which means we called an external component many times, and then they expect us to. We need to understand those kind of exceptions, and the best way to do that is within logs, right? Then we can analyze the logs and figure out exactly how do we need to address those challenges. On the C7 web application project, most probably you're going to leverage RESTful APIs to communicate to the UI from the service layer of your application. Specifically, in a client server application, HTTP codes are important because on the client, we usually have an end user, um, and we do not want to degrade the user experience if we send a API call, or we call an external component, or we call our API layer, and we get a status code back 404, not available, right? 404 is retriable because the resource might intermittently be not available, and that can change within a second, so we can retry it. However, if the response comes back and say it's 500 internal server error, which means there is something wrong on the server that you've just called, um, and most probably the parameters that we called on that API are not right, and so forth. We would like to give the users as much of a concise and direct and accurate alerts if something wrong happened on the server side. Yeah, I highly recommend that you deploy your application in a Git repository before you actually start on this C7 project. It will be very important for you to be used to using version control. It will also save you a lot of time if you ever have to go back to the original C5 application that you wrote and start afresh. It will also allow you to create snapshots as you introduce features into your application. As for example, you implemented error handling. You created a tag or a label for that branch. You implemented a unit testing. You create another one. So you can go back to the snapshots where you had before and start from there on. This will save you time and will give you more confidence to move ahead faster with your application development. You've got everything you need to take your app from a solid beginner project to a professional level application. So take your time, apply these best practices, and transform your app into something polished and professional. I can't wait to see what you built. Best of luck.
You've completed and submitted your final graded assignment. What an achievement! You should be proud of the knowledge you've gained and of how your skills have grown and matured as you completed these 7 courses. For the final project, you worked on completing a full-stack web application, the To-Do Rails Elite solution, which uses a secure and robust Spring Boot backend. It provides a set of authenticated API endpoints that serve a clean and minimalistic user interface. It was written in HTML, CSS, JavaScript, and Timeleaf. The application stores all user data encoded safely in MySQL database. This video will recap the main tasks you worked on during the project. It will review how the backend services were set up, what their goals were, and how they improved the program. As you worked through the required tasks in this lab, you showcased your Java, Spring Boot, Spring Security, and MySQL skills to deepen your understanding of the backend development. You had 4 main tasks to complete, each designed to build key features of the backend system. First, you needed to secure the application. You configured role-based authentication, protected endpoints, and ensured secure password encryption. The next key area was task management. You implemented operations for tasks, ensuring seamless database interaction and error handling. Your third area of focus was validation and logging. You ensured meaningful validation of user inputs, provided useful error responses, and logged essential application events. Finally, you completed the testing task. For this, you wrote comprehensive unit and integration tests, achieving a high level of test coverage for service and controller classes. Let's go deeper and examine how you successfully completed each of the tasks assigned in the lab. The objective of Task 1 was to secure the backend by implementing Spring Security for role-based authentication and user access control. So how did you accomplish this? You first configured the security config class to define public and protected endpoints. Next, you secured sensitive resources, such as the task management endpoints, allowing only logged-in users to access them. You also used bcrypt password encoder to encrypt user passwords before saving them to the database. By making these additions to the code, you ensured that the roots on the application were authenticated and no unwanted user could access them. This makes a more robust application that can handle errors gracefully. This getAuthorities method fetched the role granted to the user and made role-based access control possible in the application. Another step ensured that the password entered by the user at the time of registration was encoded into a non-human readable format. The password was then saved into the database for added security. Having successfully established and applied security, you then moved on to Task 2, Clean and Format Code. This task involved applying clean coding standards to the project codebase and making it more readable. So how was this achieved? To successfully complete the clean and format code task, you reformatted the code. You also added method comments and gave meaningful names to taskservice.java. Next, you were asked to complete the vital step of ensuring that your code worked as intended. To complete this task, you wrote unit and integration tests, which ensured that the backend was robust and reliable. By adding this code, you implemented your tests for controllers and services. It would be careless not to allow for the possibility that errors might occur. With this in mind, the final task that you were asked to complete was to enable error handling and logging. This task focused on validating inputs and logging application events to ensure reliability and maintainability. Your first step in completing this task was to implement input validation in task service and user service to reject invalid data. You then used SLF4J for logging critical operations and error scenarios. Finally, you logged key events such as user logins, task updates, and error occurrences. By completing these tasks, you successfully finished building the To-Do Rails Elite application. Take a moment or two to reflect on all the skills you've gained that you were able to utilize in this project. You developed a secure and scalable backend. You mastered Spring Boot, Spring Security, MySQL, and more. You implemented authentication, CRUD operations, validation, logging, and testing. But importantly, you gained real-world experience in backend development. This experience and these skills will be invaluable as you continue your journey as a software developer. Great work. Imagine building a house. Someone designs the interiors, choosing the furniture and colors to make it welcoming. Another person ensures the plumbing, electricity, and structure works seamlessly behind the walls. There's the person who manages the storage, organizing and maintaining the pantry, closets, and storerooms. And then there's the person who does it all, managing the decor and the systems. Software development works the same way, with different experts for the visible and invisible parts of applications. Let's explore these roles. In this video, you'll get an overview of the 4 main areas in software development: front-end, back-end, database, and full-stack development. Each role is like a puzzle piece that comes together to build a functional, user-friendly application. By the end, you'll know what these roles entail and how they differ. Let's start with the front-end developer, your software house interior designer. Front-end development focuses on what users see and interact with, such as buttons, layouts, and colors. A front-end developer's responsibilities include designing user interfaces or UIs, writing code to make websites responsive on different devices, and ensuring accessibility so everyone can use the application. Front-end developers use languages like HTML, CSS, and JavaScript. Frameworks like React, Angular, or Vue.js can simplify their work. For example, consider an online store. Front-end developers create the product page with an Add to Cart button. Here's a code snippet that shows how this simple product page might have been built. This example shows how front-end developers create a visually appealing and functional product page. Now let's move behind the scenes to the back-end developer, who handles the plumbing and wiring of your software house. Back-end development involves the server-side logic that powers applications, such as databases and APIs. A back-end developer's responsibilities include managing databases to store user information, writing server-side code to process user requests, and ensuring data security and efficient application performance. Back-end developers often use Java, Python, Node.js, and frameworks like Spring and Spring Boot. Let's look at a simple example of back-end code that handles a product details route. This example uses Spring Boot to create a back-end route. The @REST controller annotation indicates this is a controller handling HTTP requests. The @getMapping annotation maps the /products route to the getProducts method, which sends a response back to the server. Next, let's talk about the database developer, the organizer of your software house, who ensures that all data is stored securely and retrieved efficiently. Database development focuses on designing, implementing, and managing applications' data storage systems. A database developer's responsibilities include designing databases that organize data logically, writing queries to review, update, and delete data, and ensuring database performance and security. Database developers work with both relational databases and NoSQL databases, depending on the application's needs. Relational databases include systems like MySQL and PostgreSQL, which organize data in tables with rows and columns. SQL, or Structured Query Language, queries and manipulates this structured data. NoSQL databases are designed for flexibility, scalability, and unstructured data. Examples include MongoDB and Cassandra, which organize data differently, such as in JSON-like documents or key value pairs. While this course won't discuss NoSQL in detail, it's helpful to know that it exists for specific use cases, such as handling large, diverse datasets. For example, in an online store, a relational database might store user accounts and order histories in structured tables. A NoSQL database like MongoDB could store catalog data with varying product attributes, such as size, color, or brand, in a flexible JSON format. Let's look at a simple SQL query to retrieve product data. This query selects the product name, price, and description and retrieves only products in the electronics category. Database developers write such queries to make data available for use in an application, like showing products on a web page. The backend code would use this query to fetch data in a real-world scenario. Here's how a backend developer might use it in Java with Spring Boot. Finally, you have the full-stack developer, the multitasker who can handle both the front and backend. Full-stack developers are skilled in building the entire application, from UI design to server configuration. A full-stack developer's responsibilities include combining front-end and back-end expertise, debugging across the full application stack, and collaborating with teams to ensure seamless integration between systems. Full-stack developers often use front-end frameworks like React or Angular, paired with back-end tools like Spring Boot or Express.js. Here's an example of a full-stack workflow. Write the front-end HTML for a product page. Create a back-end API route to fetch the product details, and connect the two by calling the API from the front end using JavaScript. Let's explore how this connection is established. This snippet fetches product data from the back-end API route and displays it on the page, showcasing how full-stack developers bridge the gap between the two. Each career path has its unique challenges and rewards. Front-end developers create engaging user experiences. Back-end developers ensure smooth functionality behind the scenes. Database developers organize and maintain the information applications rely on. And full-stack developers bring it all together. Your choice depends on what excites you most: designing user interfaces, solving logic puzzles, working with data, or mastering each aspect. Remember, every role contributes to building fantastic software. Think about your strengths and interests as you explore these paths. Whether you choose front-end, back-end, database, or full stack, your skills will be essential in shaping the future of technology. Happy coding. Imagine you're preparing for a race, not just any race, but one that could land you your dream job. That race is the technical interview. It might feel daunting, but with proper preparation, success is achievable. In this video, you'll take a deep dive into what to expect in Amazon's Software Development Engineer, or SDE, intern interview. You'll learn how interviews assess your problem-solving, technical knowledge, and communication skills. You'll also explore some tips and examples to help you prepare. Let's get started. Technical interviews consist of two main parts: theoretical questions that test your understanding of core concepts like data structures, algorithms, and programming principles, and practical challenges, which involve solving coding problems or debugging code to demonstrate how you apply your knowledge, similar to the example shown on screen. You'll explore some tips to tackle problems like these later in the video. Next, let's gain an understanding of the key skills interviewers evaluate. First are your problem-solving skills. Interviewers want to see if you can logically break down a problem and develop efficient, creative solutions. Next is technical knowledge. Your grasp of core computer science concepts is critical. For Amazon, focus on data structures, algorithms, and object-oriented programming. And finally, they'll evaluate your communication skills. Clear communication is just as important as technical know-how. Explaining your thought process, asking clarifying questions, and collaborating effectively are equally important. Now let's break down the interview process in more detail. Initial screening is the first step, where a recruiter or hiring manager evaluates your general suitability for the role. It takes the format of a phone or video call lasting 20 to 30 minutes. You'll be asked about your background, experiences, and goals. You might also face a few basic technical questions to ensure your knowledge meets the role's requirements. You should use this stage to showcase your enthusiasm for the company and clarify what they're looking for in a candidate. Next is the coding interview. This is the core part of the process, where your ability to solve problems through code is tested. It takes the format of live coding on a shared platform like CoderPad, HackerRank, or an online whiteboard. You'll share your screen while coding and explain your approach. You'll be given problems to solve, such as implementing algorithms, for example, sorting and searching, working with data structures, for example, arrays, linked lists, and trees, and optimizing solutions for time and space complexity. For example, you might be given a problem similar to the one shown on screen. You should explain your approach briefly while coding. For instance, say, I'll use a recursive function to traverse the tree and calculate its height. Behavioral interviews assess how you've handled situations to predict how you'll perform in the future. This takes the format of a conversational style interview with questions based on real-world scenarios. At Amazon, questions often focus on the company's leadership principles. For example, tell me about a time you took ownership of a problem. Describe a time you worked through a disagreement on a team. You should use a structured method to craft your responses. For example, STAR. Highlight the situation, the task you had, the action you took, and the result you achieved. This helps provide a complete picture of your contribution. Another method is SBI. Focus on the situation, your behavior, and the impact of your actions. This approach works well for concise responses when the result is self-evident. Choose the method that best fits the question and your story. Both are great for presenting clear, well-organized answers. System design interviews are typically for advanced roles, but may occasionally appear for internships or junior positions. These take the format of an open-ended discussion in which you design a scalable system, such as a URL shortener or a chat application. You'll be asked to outline the system architecture, choose appropriate technologies, and explain trade-offs. Focus on clarity. If the platform allows it, illustrate your design with diagrams or sketches. Now let's explore some tips to succeed in a technical interview. First, some preparation tips. Brush up on core concepts. Focus on data structures, algorithms, and object-oriented programming. Platforms like Amazon LeetCode and HackerRank are excellent for practice. Next, prepare behavioral stories. Reflect on your experiences and practice framing them with both STAR, which is excellent for detailed answers, and SBI, which is ideal for concise responses. And finally, study leadership principles. For Amazon, it's essential to understand its core principles and align your stories to demonstrate those traits. During the interview, remember to ask questions. If you're unsure, ask for clarification. It's better to understand the problem than to guess. Think aloud. Verbalize your thought process to demonstrate your logical approach. Start simple, then optimize. Write a basic solution first, then improve efficiency. And finally, stay calm. If you're stuck, take a moment to collect your thoughts and try another angle. Next, let's examine the Amazon SDE intern process in more detail. At Amazon, you can expect questions on topics like arrays and strings, dynamic programming, and binary trees. Amazon also emphasizes its leadership principles, so be ready with examples that show you've demonstrated ownership, delivered results, or prioritized customers. Technical interviews are a chance to showcase your skills and potential. With preparation, you'll succeed. Remember, these interviews test more than just your coding. They evaluate how you think, communicate, and solve problems. By practicing coding problems, understanding core concepts, and preparing thoughtful examples, you'll be ready to take on any challenge. Good luck and go ace that interview. Congratulations on completing Course 7, Application Development, the final step in Amazon's professional certificate in junior software development. Completing this course is a tremendous achievement, and you should feel proud of the skills you've developed, the projects you've completed, and the effort you've put in to reach this point. Well done. Throughout this course, you worked through the key stages of the software development lifecycle, from planning and design to implementation and version control. These are invaluable skills that enable modern businesses to build solutions that are scalable, secure, and aligned with user and stakeholder needs. Before you go and grow these skills and apply them to your chosen challenges, let's pause here briefly to reflect and celebrate the last leg of your learning journey in this program. Remember that quality applications begin with sound planning and design. Through requirement analysis, you learned how to align functional and non-functional requirements with stakeholder goals, ensuring that every project starts with clarity and purpose. By mapping out system components with UML diagrams, you gained the tools to visualize workflows and structure development processes effectively. For instance, in a real-world business setting, clear requirements and diagrams can prevent costly rework by identifying potential bottlenecks or misaligned features early in the process. The principles of user interface or UI design were another critical focus. From wireframing initial layouts to applying color theory and accessibility guidelines, you developed the ability to craft interfaces that are not only visually appealing, but also intuitive and inclusive. Whether designing an e-commerce platform or a corporate dashboard, these skills ensure users can navigate applications seamlessly and complete tasks efficiently. Great projects need to be guided, so you then analysed Sdlc models like Waterfall, Agile, Spiral, and vModel, each tailored to specific project needs. These are all important frameworks and methodologies that guide successful software projects. For instance, Agile's iterative approach allows businesses to adapt to changing requirements quickly, making it ideal for software startups or fast-moving industries like retail or finance that innovate often. Integrating development and operations is a key challenge for organizations aiming to accelerate delivery while maintaining quality. This is where DevOps excels, offering methodologies essential in today's fast-paced tech world, enabling businesses to leverage continuous integration and deployment to stay competitive. Software developers are expected to write maintainable and scalable code that supports future growth. Imagine a scenario where a company needs to update its legacy systems. Clean, modular code ensures that changes can be implemented quickly without disrupting the entire system. To prepare you for this responsibility, you honed your coding skills by following best practices like dry, don't repeat yourself, and the single responsibility principle. Now you can ensure your code is maintainable, adaptable, and easy to debug, even as applications grow in complexity. As every developer knows, bugs are inevitable. To ensure you're prepared to build high-quality applications, you practice identifying and resolving issues using tools like IntelliJ breakpoints and unit testing frameworks. These skills are indispensable for maintaining application reliability, whether you're troubleshooting a mobile app or validating an API integration for a global payment system. You're able to debug and test, but now you also have the power to version control with Git and GitHub. You mastered essential Git operations like cloning repositories, committing changes, and managing branches, enabling you to collaborate seamlessly in team environments. With Gitflow, you learned how structured workflows minimize merge conflicts and keep workflows organized, even in complex team settings. The real-world applications of these skills are vast. Whether you're developing applications to streamline business processes, creating customer-facing tools, or managing large-scale system updates, the knowledge you've gained equips you to approach challenges with confidence and precision. But this isn't just about technical skills. It's also about the mindset you've cultivated. You've learned to analyze problems critically, design solutions thoughtfully, and collaborate effectively, all while maintaining a commitment to quality in a complex and dynamic industry. These are the hallmarks of a successful developer and valuable team member. Completing this course and the program is not just a milestone, it's the launch pad for an exciting new chapter in your career. The skills you've honed, the projects you've completed, and the confidence you've built have prepared you to tackle complex challenges and create meaningful solutions in the software development world. As you move forward, remember application development is as much about people as it is about technology. By understanding user needs, fostering collaboration, and communicating effectively with stakeholders, you'll amplify your technical expertise and drive impactful success. Congratulations once again, and best of luck as you continue to grow, innovate, and lead. The future is yours to create, one carefully crafted line of code at a time.